the ultimate SAP SD ECC to S4 HANA Migration Masterclass.
SAP Sales and Distribution, SAP SD, is the absolute revenue engine of your enterprise. In the manufacturing modules, if a process breaks, a machine stops. But if SD fails during an S4 HANA migration, the supply chain paralyzes, the company does not get paid, and financial audits fail. In this series, we are analyzing exactly 290 real-world failure incidents from ECC to S4 HANA brownfield conversions.
The four-part series blueprint.
To make this massive 290 incident list digestible, we have strategically divided the SAP Activate project lifecycle into 4 distinct masterclasses. Part 1, the Blueprint and Data Model Shock, Strategic Scope, Architecture, and Structural Simplifications. Part 2, the IT Crucible, Custom Code Remediation, Data Cleansing, Testing Gaps, and the Cutover Weekend. Part 3, Day 1 Execution, Order-to-Cash Behavior, Logistics and Cross-Module Integration Failures. Part 4, the Revenue Engine, Billing, Finance Integration, HANA Performance, and Post-Go-Live Ghost Issues. By mastering all 4 parts, you elevate your expertise from a standard functional consultant to an elite S4 HANA solution architect.
Welcome to Part 1, the Blueprint and Data Model Shock.
Before you write a single line of ABAP code or migrate a single customer record, your SAP SD migration can fail at the architectural level. In S4 HANA, the fundamental data models for pricing, business partners, and revenue recognition have been completely redesigned. Part 1 covers the first 82 architectural and data model traps that destroy project blueprints.
What we cover in Part 1.
In this video, we will walk through the first 2 critical phases of the migration lifecycle. Phase 1, discover and prepare program, scope, and architecture readiness risks. Phase 2, explore data model simplifications, master data design, and process behavioral deltas. We will provide the exact SAP simplification notes you need to justify these changes to your stakeholders.
The architect's secret, deciphering the notes.
As we go through this list, pay close attention to the SAP note column. This dictates who owns the fix. If a specific SAP note is listed, the system is broken by design and requires an IT or configuration fix. If it says not applicable data governance, do not call your ABAP developer. The legacy ECC data is dirty and the business must cleanse it. If it says not applicable process design gap, the business process itself must be re-engineered to fit S4 HANA standard best practices. Understanding this difference is what separates junior consultants from lead architects. Let us dive right into Phase 1.
Phase 1, discover and prepare.
Phase 1 incidents are driven by poor scope definition and undefined architectural decisions. Because these are strategic failures, they rarely have SAP notes attached. They require strict project governance and early executive alignment.
Phase 1, risk categories.
We will break down the discovery and preparation phase into 2 core risk categories. 1. Program and scope risks, failing to map business variance, data volume, and deployment strategies. 2. Architecture readiness risks, missing critical integration decisions for modules like EWM, transportation management, and advanced ATP. Let us examine the first category in Phase 1, program and scope risks.
Phase 1, Category 1, program and scope risks.
The first set of incidents revolves around underestimating the complexity of the existing ECC landscape. 1. SD scope definition incomplete, missing critical order-to-cash variance. 2. Country-specific SD localization processes not identified. 3. Industry solution SD add-ons not assessed for S4 HANA compatibility. 4. Integration landscape and third-party interfaces not fully mapped. 5. SD data volume assumptions severely underestimated. 6. Business seasonality not considered for the go-live cutover weekend. 7. Global template versus local deviation strategy remains unclear. 8. Brownfield versus selective data transition decision misaligned with SD complexity. 9. Revenue recognition model, classic versus EBR versus RAR, not defined. 10. Governance model for Fiori first operations undefined. 11. Operational KPI model not realigned for real-time reporting. 12. Support organization not trained on embedded analytics. 13. Month-end acceleration impact on SDF, not assessed. Mostly for these incidents, SAP Notes is not applicable because these are scope and project strategy or process design gap failures. The project manager and solution architect own these risks. Finally, let's dive into Scenario 1.
Scenario 1. SD scope definition incomplete, O2C variance missed.
In the discover and prepare phase of ECC to S/4HANA migration, the SD scope overlooks critical order-to-cash variants such as intercompany sales, third-party dropshipping, advanced returns, export scenarios, or complex credit flows. This creates incomplete blueprints that later surface as integration failures, pricing inconsistencies, or compliance gaps during realize, testing, or post-go-live stabilization.
Scenario classification and relevant SAP note, if applicable.
And complexity, medium to high cross-module and revenue impact. 2. Phase, discover and prepare. 3. Frequency, very common in large or multi-country programs. 4. Primary ownership, project manager. 5. Supporting solution architect. 6. Business ownership, sales director. 7. Relevant SAP note, not applicable scope and project strategy. This is a blueprinting and discovery governance failure, not a SAP software simplification. No specific SAP note exists because the issue arises from incomplete business scoping.
Diagnostic dashboard, symptoms and evidence.
How this failure manifests in program delays, scope creep, and integration instability, and how to detect it early. 1. Symptom, integration test cycles reveal missing flows such as intercompany billing, returns, or third-party procurement. 2. Red flag, no test scripts or configuration objects exist for specific O2C variants in test management tools. 3. Business impact, rework cycles extend timelines by 2 to 4 weeks per missed variant, increasing budget burn. 4. Detection process mining of ECC sales documents reveals document types not mapped in S4 scope. 5. Technical proof, missing configuration and pricing procedures, account determination, or copy control for variant flows. Insight, if core sales orders work but edge cases fail in SIT, the scope was incomplete from day one.
Why this happens, scenario analysis and root cause.
1. Discovery workshops prioritize high-volume standard O2C paths and ignore low-frequency but high-risk variants. 2. Regional or product-specific flows are undocumented in legacy ECC environments. 3. Underestimation of SD integration touchpoints with FICO, and external systems. 4. Assumption that ECC customizations automatically translate into S/4HANA compatibility without revalidation. S/4HANA migration requires explicit validation of every O2C branch, not just the main path.
Why this is a migration-exclusive failure.
1. ECC systems evolve organically, allowing hidden variants through custom enhancements. 2. S/4HANA introduces structural shifts such as business partner, advanced ATP, and event-based postings that require explicit scope confirmation. 3. Simplification items remove implicit workarounds tolerated in ECC. 4. Migration forces standardization, exposing undocumented process branches. Migration amplifies what ECC silently tolerated for years.
Financial and customer impact.
1. Delayed go-live increases program cost through extended consulting and testing cycles. 2. Incorrect handling of variant flows can block billing, directly impacting cash flow. 3. Regulatory exposure if export tax or compliance variants are missed. 4. Customer dissatisfaction due to failed returns, partial deliveries, or intercompany delays. In SD, missed scope directly affects revenue realization and working capital.
Governance and accountability, RACI model.
In enterprise ECC to S/4HANA programs, accountability and execution must be separated clearly across functional and architectural roles. 1. Accountable, project manager owns full SD scope completeness and milestone integrity, and gets fired if scope gaps cause program delays or budget overruns. 2. Responsible, SD functional lead extracts ECC data, documents all O2C variants, and ensures no document type or item category is missed. 3. Consulted, solution architect validates scope against S/4HANA simplifications and cross-module dependencies. 4. Informed, sales director confirms business scenario coverage and formally signs off on scope. Accountability carries consequence, Responsibility carries execution.
Ownership, who actually fixes it.
Fixing this requires structured rediscovery and technical validation, not quick configuration patches. 1. SD lead extracts ECC document data from VBAK, VBAP, VBRK, and VBFA to identify all active sales document types, item categories, billing types, and document flow patterns. 2. SD lead analyzes pricing procedures and condition records via T683, KONV, and relevant condition tables to uncover variant-specific pricing logic. 3. Solution Architect runs SAP readiness check and cross-references discovered flows against the Simplification Item catalog. 4. Project team uses SAP Signavio or process discovery to validate real execution paths across regions and business units. 5. Project manager rebaselines scope only after sales director formally signs off on the documented O2C variant matrix.
Who gets blamed versus who owns it.
1. Blamed project manager perceived as poor planning and governance failure. 2. Blamed SD functional lead seen as lacking depth in process discovery. 3. Actual owner joint accountability between project manager and SD functional lead. 4. Root cause, inadequate cross-functional workshops and absence of ECC data-driven validation. Blame is political. Ownership is structural.
What not to do, common wrong fixes.
1. Assume ECC documentation reflects real operational variance without data extraction. 2. Push uncovered variance into future change requests to protect timelines. 3. Rely only on automated tools without business interviews and data reconciliation. 4. Treat low-frequency scenarios as low-risk scenarios. In O2C, low frequency does not mean low financial impact.
Follow-up 1. Why are O2C variants often invisible in large enterprises?
Answer: variants are frequently embedded in regional practices or custom document types that evolved over years. Without process mining and ECC document analytics, these flows remain hidden. Senior architects should mandate ECC data extraction to uncover real execution patterns before blueprint finalization.
Follow-up 2. What governance control prevents this at scale?
Answer: introduce a mandatory O2C completeness checkpoint before entering Realize. Tie blueprint sign-off to documented variant coverage validated against ECC document statistics. Executive steering committees should refuse funding release without this validation.
Follow-up 3. Curveball. Can we migrate core O2C first and add variants later?
Answer: technically possible, strategically dangerous. Variant flows often share pricing, account determination, and credit configuration with core O2C. Deferring them risks retrofitting core configuration later, causing instability and reconciliation failures.
Exclusive pro tip.
Before finalizing SD scope, extract 1 full year of ECC sales document data and map every document type, item category, and billing scenario. Let data define scope rather than workshop memory.
Scenario 2. Country-specific SD processes not identified.
In global ECC to S4 HANA programs, country-specific SD processes such as local tax determination, electronic invoicing mandates, intrastat reporting, or export compliance are not fully identified during discover. This results in localization gaps that surface during integration testing or post-go live, creating compliance exposure and billing disruptions.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high localization and compliance impact. 2. Phase, discover and prepare. 3. Frequency, very common in multi-country rollouts. 4. Primary ownership, global template lead. 5. Supporting localization consultant. 6. Business ownership, regional finance head. 7. Relevant SAP note, not applicable scope and project strategy. This is a project management or blueprinting failure, not an SAP software change. No specific note exists as it is about incomplete localization scoping during discovery.
Diagnostic dashboard, symptoms and evidence.
How localization gaps appear in testing and compliance audits and how to detect them early. 1. Symptom: country UAT fails for tax, e-invoicing, or statutory reporting scenarios. 2. Red flag: no country-specific configuration objects exist in pricing, tax procedure, or output determination. 3. Business impact, invoices rejected by tax authorities or blocked in electronic submission portals. 4. Detection. Compare ECC country-specific pricing procedures and tax codes against S/4HANA configuration. 5. Technical proof. Missing condition types in tax procedure or incomplete assignment in ABAP's and pricing schema. Insight. If global template works but one country fails UAT, localization was not scoped correctly.
Why this happens, scenario analysis and root cause.
1. Global template workshops focus on headquarters processes and ignore regional statutory nuances. 2. Localization consultants are onboarded too late in the program lifecycle. 3. ECC country-specific enhancements are assumed to be standard in S/4HANA without validation. 4. Tax and compliance flows are treated as FI-only topics, ignoring SD pricing integration. Country-specific SD design must be validated per legal entity, not assumed globally.
Why this is a migration-exclusive failure.
1. ECC allowed localized enhancements without strict clean core alignment. 2. S/4HANA introduces international trade simplifications and revised tax integration logic. 3. Electronic invoicing and digital compliance requirements have evolved since ECC go live. 4. Migration forces consolidation of global template with country-level statutory rules. Migration exposes compliance gaps that legacy ECC environments masked.
Financial and customer impact.
1. Regulatory penalties due to incorrect tax calculation or reporting. 2. Revenue delays when invoices are blocked or rejected by authorities. 3. Manual rework in billing and accounting to correct statutory errors. 4. Reputational damage in regulated markets. Localization gaps translate directly into compliance and cash flow risks.
Governance and accountability, RACI model.
In global S/4HANA programs, localization governance must clearly assign consequence-bearing accountability. 1. Accountable global template lead owns completeness of country rollout scope and gets fired if compliance failures occur post-go live. 2. Responsible localization consultant analyzes country tax, invoicing, and statutory SD requirements in detail. 3. Consulted SD functional lead integrates local requirements into pricing, output, and billing configuration. 4. Informed regional finance head validates statutory correctness before deployment. In global programs, accountability for compliance cannot be diffused.
Ownership, who actually fixes it.
Resolving this requires country-level configuration validation and statutory walkthroughs. 1. Localization consultant reviews ECC tax codes, pricing procedures, and country-specific condition types per company code. 2. SD lead validates pricing schema assignments and tax condition integration within S/4HANA. 3. Integration lead verifies e-invoicing interfaces and government portal connectivity. 4. Global template lead updates rollout plan and ensures country UAT sign-off before production cutover.
Who gets blamed versus who owns it.
1. Blamed global template lead seen as overlooking regional statutory requirements. 2. Blamed SD functional lead perceived as misconfiguring pricing or tax. 3. Actual owner localization consultant under governance of template lead. 4. Root cause centralized template design without early regional involvement. Compliance failures are rarely technical, they are governance gaps.
What not to do, common wrong fixes.
1. Assume country tax logic will automatically migrate from ECC. 2. Delay localization workshops until after global design freeze. 3. Rely solely on FI consultants for tax without SD pricing validation. 4. Deploy template to production without country-specific UAT approval. Localization is not an extension, it is a core rollout pillar.
Follow-up 1. Why do global templates frequently fail in specific countries?
Answer: global templates standardize process, but overlook statutory deviations such as mandatory e-invoicing formats or unique tax condition requirements. Without early regional workshops and ECC configuration comparison, these gaps remain hidden until testing.
Follow-up 2. How can executives reduce localization risk early?
Answer: mandate country-specific blueprint validation checkpoints before global design freeze. Require regional finance sign-off, tied to compliance KPIs before approving rollout budgets.
Follow-up 3, curveball. Can we go live globally and stabilize localization later?
Answer: technically possible but legally dangerous. In regulated jurisdictions, incorrect invoicing or tax reporting can result in immediate penalties or invoice rejection, disrupting revenue and audit credibility.
Exclusive pro tip.
Before freezing global SD design, perform a country-by-country ECC pricing and tax procedure comparison against S/4HANA configuration. Let statutory variance drive localization scope, not assumptions.
Scenario 3, industry solution SD add-ons not assessed.
During the discover and prepare phase of ECC to S/4HANA migration, industry-specific SD extensions such as IS Retail, IS Oil, automotive scheduling agreements, or sector add-ons are not evaluated for S/4HANA compatibility. These extensions often depend on legacy transactions, tables, or enhancement points that no longer exist in S/4HANA. The result is late discovery of incompatibilities, forcing redesign of core business flows during realize, or even after go live.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high industry architecture impact. 2. Phase, discover and prepare. 3. Frequency, common in retail, oil and gas, automotive and pharma landscapes. 4. Primary ownership, solution architect. 5. Supporting industry solution consultant. 6. Business ownership, industry process owner. 7. Relevant SAP note, not applicable scope and project strategy. This is a blueprinting failure in assessing industry-specific add-ons during discovery rather than an SAP software change.
Diagnostic dashboard, symptoms and evidence.
How this failure manifests during migration readiness checks and early testing cycles. 1. Symptom: migration readiness checks flag incompatible industry components or obsolete transactions. 2. Red flag: ECC system contains add-on packages like IS Retail or oil and gas without documented S/4HANA migration strategy. 3. Business impact: sector-specific processes such as retail promotions, commodity pricing, or automotive agreements stop working after conversion. 4. Detection: review installed add-on components via Transaction Saint and compare with S/4HANA compatibility matrix. 5. Technical proof: Simplification Item catalog highlights industry components requiring redesign or replacement. Insight: if core SD migrates but sector workflows fail, industry extensions were not evaluated early enough.
Why this happens, scenario analysis and root cause.
1. Discovery workshops focus on standard SD processes while overlooking sector-specific extensions. 2. Industry consultants are brought into the program only during the explore or realize phases. 3. Legacy ECC systems accumulate industry enhancements over years without centralized documentation. 4. Project teams assume add-ons will behave like standard SD and S/4HANA. Industry extensions behave like parallel systems. Ignoring them creates architectural blind spots.
Why this is a migration-exclusive failure.
1. ECC tolerated deep add-on customization through user exits and implicit enhancements. 2. S/4HANA enforces clean core principles that invalidate many industry extension hooks. 3. Migration tools expose compatibility issues that ECC runtime never revealed. 4. Industry solutions sometimes require new S/4HANA modules or redesigned integration patterns. Migration forces the hidden complexity of industry add-ons into the open.
Financial and customer impact.
1. Industry-specific revenue streams become blocked when sector workflows fail. 2. Late redesign of add-on functionality increases project costs significantly. 3. Regulatory compliance risks arise in industries such as pharmaceuticals or utilities. 4. Customer fulfillment processes break when specialized logistics flows are unavailable. Industry systems drive specialized revenue streams. Failures here directly affect business continuity.
Governance and accountability, RACI model.
Industry extensions introduce architectural risk and require strict accountability within the program governance model. 1. Accountable: solution architect, the person who is responsible for assessing system landscape compatibility and gets fired if incompatible industry add-ons derail the migration. 2. Responsible: Industry Solution Consultant analyzes each sector extension and maps it to S/4HANA equivalents or redesign options. 3. Consulted SD Functional Lead validates that redesigned industry flows integrate with core order-to-cash processes. 4. Informed Industry Process Owner confirms that sector operations remain functional after redesign. Architecture failures around industry extensions carry the highest program risk.
Ownership, who actually fixes it.
Resolving this requires systematic identification and compatibility analysis of all installed industry components. 1. Industry Solution Consultant reviews installed add-ons using transaction saint and component hierarchy tables to identify all sector extensions. 2. Solution Architect cross-checks add-ons against the S/4HANA Simplification Item catalog to determine compatibility and redesign requirements. 3. SD Lead maps sector workflows to S/4HANA equivalents such as settlement management, advanced variant configuration, or commodity pricing engine. 4. Integration Architect validates dependencies between industry add-ons and logistics or finance modules.
Who gets blamed versus who owns it.
1. Blamed, Solution Architect executives see it as architectural oversight. 2. Blamed, SD Functional Lead assumed to have missed industry process details. 3. Actual Owner, Industry Solution Consultant under architectural governance. 4. Root cause, industry add-ons were not identified or reviewed during early discovery. Industry extensions require specialized expertise that generic SD teams may not possess.
How this is actually fixed, the right way by a role.
1. Industry Solution Consultant extracts installed add-on components via transaction saint and component tables, such as CVERs, to identify all sector extensions. 2. Solution Architect reviews the Simplification Item catalog and SAP Product Availability Matrix to determine supported industry solutions in S/4HANA. 3. SD Lead analyzes ECC document flows from tables VBA-K, VBA-P, and VBFA to map sector-specific sales scenarios. 4. Integration Architect validates interactions between industry add-ons and modules like TM, EWM, and FI.
What not to do, common wrong fixes.
1. Assuming all ECC industry add-ons will automatically function in S/4HANA. 2. Delaying add-on compatibility assessment until the realize phase. 3. Attempting to replicate obsolete industry transactions through custom development. 4. Ignoring Simplification Item catalog warnings during readiness checks. Industry extensions must be evaluated early. Late discovery creates expensive redesign cycles.
Follow-up 1. Why do industry add-ons create hidden migration risks?
Answer: industry add-ons often embed sector logic deeply within ECC through custom tables, exits, and transactions. These elements may rely on architecture assumptions that no longer exist in S/4HANA. Without early compatibility analysis, teams only discover these dependencies after major design decisions are already locked.
Follow-up 2. How do experienced architects detect industry extension risks early?
Answer: experienced architects review installed software components using system inventory tools and cross-reference them against SAP's S/4HANA compatibility matrix. They also involve industry consultants during discovery workshops to verify that sector-specific processes are mapped before blueprint finalization.
Follow-up 3. Curveball. What if the project decides to temporarily keep ECC add-ons using compatibility packs?
Answer: compatibility packs can extend functionality temporarily, but they introduce upgrade constraints and future redesign risk. Once these packs expire, organizations must still redesign the underlying industry processes. Treat them as transitional tools rather than permanent solutions.
Exclusive pro tip.
Before finalizing architecture, build an inventory of all installed ECC add-ons and cross-check them against the S/4HANA compatibility matrix. Treat industry extensions as architectural components, not simple functional enhancements.
Scenario 4. Integration landscape not fully mapped.
During the discover and prepare phase of ECC to S/4HANA migration, the existing integration landscape around SAP SD is not fully documented. Many ECC systems exchange data with external platforms such as warehouse management systems, transportation management tools, tax engines, e-commerce platforms, EDI gateways, and financial consolidation tools. When these integrations are not identified early, the S/4HANA architecture is designed without accounting for message formats, middleware routing, or real-time data dependencies.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high integration architecture impact. 2. Phase, discover and prepare. 3. Frequency, extremely common in enterprise landscapes with many interfaces. 4. Primary ownership, solution architect. 5. Supporting integration architect. 6. Business ownership, enterprise architecture board. 7. Relevant SAP note, not applicable scope and project strategy. This is an architecture discovery failure where integrations were not mapped during program planning, not an SAP software change. No specific note exists as it is about incomplete integration scoping during discovery.
Diagnostic dashboard, symptoms and evidence.
How incomplete integration discovery appears during early migration activities. 1. Symptom: interfaces fail during integration testing because message structures changed in S/4HANA. 2. Red flag: no centralized interface inventory exists describing inbound and outbound integrations. 3. Business impact: orders, deliveries, and billing documents fail to transmit to connected systems. 4. Detection: review ECC interface configurations using transactions WE20, BD64, and SM59 and middleware monitoring tools. 5. Technical proof: missing integration mapping for IDOCS web services or middleware interfaces. Insight: if testing reveals unknown integrations, the landscape was not mapped during discovery.
Why this happens, scenario analysis and root cause.
1. Integration ownership is distributed across departments and no single inventory exists. 2. Legacy ECC systems accumulated integrations over years through multiple middleware platforms. 3. Discovery workshops focus on internal SAP processes while ignoring external system dependencies. 4. Project teams assume middleware teams already maintain complete interface documentation. Integration knowledge is often tribal knowledge held by senior technical staff.
Why this is a migration, exclusive failure.
1. S/4HANA changes message structures and API behavior compared with ECC. 2. Integration architecture may shift from legacy middleware toward cloud integration platforms. 3. Certain IDOC structures and fields change under the S/4HANA data model. 4. Migration requires validation of every interface connected to order-to-cash processes. Migration forces every hidden integration dependency to be rediscovered.
Financial and customer impact.
1. Order fulfillment fails when e-commerce systems cannot receive sales order confirmations. 2. Warehouse operations stop if delivery documents fail to reach external logistics platforms. 3. Financial reconciliation breaks when billing data does not transmit to finance systems. 4. Customer experience degrades when order status updates are not synchronized. Integration failures interrupt the entire digital supply chain.
Governance and accountability, RACI model.
Integration architecture requires strict accountability because missing interfaces can halt enterprise operations. 1. Accountable, solution architect responsible for complete system landscape architecture and gets fired if undiscovered integrations break production operations. 2. Responsible, integration architect documents every interface and maps message structures across systems. 3. Consulted, SD functional lead confirms which integrations support order-to-cash processes. 4. Informed, enterprise architecture board validates that the integration strategy aligns with enterprise standards. Enterprise integrations must be treated as architectural assets rather than technical afterthoughts.
Ownership, who actually fixes it.
Resolving this requires building a complete enterprise integration inventory. 1. Integration architect extracts interface definitions from ECC using transactions WE20 for partner profiles, BD64 for distribution models, and SM59 for RFC destinations. 2. Middleware team analyzes message routing and integration platforms such as SAP Process Integration, SAP Process Orchestration, or Cloud Integration Services. 3. Solution architect documents system dependencies between SAP SD and external platforms such as e-commerce, warehouse management, and tax engines. 4. Enterprise Architecture Board reviews the final integration landscape before approving S/4HANA architecture.
Who gets blamed versus who owns it?
1. Blamed. Solution architect executives believe the architecture review was incomplete. 2. Blamed. Integration team perceived as not maintaining interface documentation. 3. Actual owner. Integration architect under architectural governance. 4. Root cause. Enterprise integrations were never centrally cataloged. Most integration failures originate from documentation gaps rather than technical errors.
How this is actually fixed, the right way by a role.
1. Integration architect extracts active IDOC interfaces from ECC tables EDIDC and EDIDS to identify message flows. 2. Integration architect reviews partner profiles through transaction WE20 to document external communication partners. 3. Middleware architect analyzes message routing rules within integration platforms to map inbound and outbound flows. 4. Solution architect compiles a complete integration landscape diagram, connecting SAP SD with every external system.
What not to do, common wrong fixes.
1. Assuming the middleware team already maintains a complete interface catalog. 2. Waiting until integration testing to identify missing systems. 3. Attempting to redesign integrations during the conversion weekend. 4. Ignoring external system dependencies during architecture workshops. Integration architecture must be documented before system design begins.
Follow-up 1. Why do enterprises struggle to maintain integration documentation?
Answer: large organizations implement integrations gradually over many years. Different teams deploy middleware, custom APIs, and direct system connections without central governance. As a result, documentation becomes fragmented, and many integrations remain undocumented until a major transformation project exposes them.
Follow-up 2. How do experienced architects map the integration landscape efficiently?
Answer: experienced architects combine automated system scans with stakeholder interviews. They analyze ECC interface tables, middleware monitoring tools, and network connection registries to identify active integrations. This technical inventory is then validated through workshops with operations teams who understand business dependencies.
Follow-up 3. Curveball. What if the organization decides to redesign integrations only after the migration?
Answer: delaying integration redesign creates severe operational risk. Interfaces may fail immediately after go live because message formats change in S/4HANA. Without early validation, supply chain systems, finance platforms, and e-commerce portals may stop receiving critical data.
Exclusive pro tip.
During discovery, build a centralized integration inventory that lists every inbound and outbound interface connected to SAP SD. Treat this inventory as part of the core architecture blueprint, because undocumented integrations are one of the most common causes of migration failure.
Scenario 5. SD volume assumptions underestimated.
In the discover and prepare phase of ECC to S/4HANA migration, assumptions about SD data volumes, transaction loads, and growth rates are too low. This leads to inadequate sizing for HANA infrastructure, causing performance bottlenecks during testing or post-go-live when real volumes hit the system, resulting in slow order processing and reporting delays.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, medium performance, and infrastructure sizing impact. 2. Phase, discover, and prepare. 3. Frequency, common in large transaction volume enterprises. 4. Primary ownership, basis lead. 5. Supporting SD functional lead. 6. Business ownership, IT operations director. 7. Relevant SAP note, not applicable scope and project strategy. This is a project planning and infrastructure sizing failure, not an SAP software change. No specific note exists because the issue arises from inaccurate transaction volume forecasting during discovery.
Diagnostic dashboard, symptoms and evidence.
How underestimated transaction volumes manifest in infrastructure sizing failures and how to detect them early. 1. Symptom: load testing shows slow VA01 order creation or VF01 billing runs exceeding expected execution times. 2. Red flag: ECC workload analysis in SD03N reveals higher peak dialog steps than assumed in HANA sizing. 3. Business impact. Post-go-live system slowdown disrupts order entry, pricing calculation, and billing cycles. 4. Detection. Compare ECC historical transaction statistics from SD03N with projected S4 HANA workload using Quick Sizer. 5. Technical proof. HANA memory utilization or CPU spikes during integration testing exceed planned hardware capacity. Insight. If ECC handles volumes smoothly, but S4 HANA testing struggles under simulated loads, the original sizing assumptions were incorrect.
Why this happens, scenario analysis and root cause.
1. Discovery teams rely on outdated ECC statistics without analyzing real transaction peaks from SD03N workload logs. 2. Business stakeholders provide conservative transaction estimates to minimize infrastructure costs during budgeting. 3. Seasonal peaks such as quarter-end billing or annual contract renewals are ignored in forecasting models. 4. Quick Sizer calculations are executed without validating ECC historical workload patterns. The root cause is incomplete workload analysis during the earliest planning stages of the migration.
Why this is a migration, exclusive failure.
1. ECC systems often mask transaction volume inefficiencies through database buffering and batch scheduling. 2. S4 HANA introduces real-time analytics and simplified data models that increase active memory processing. 3. Migration loads historical data into the HANA column store where memory sizing becomes critical. 4. The issue appears when ECC workloads are moved into HANA without recalculating memory and CPU requirements. This failure does not occur in normal ECC operations, but emerges when ECC workloads are re-executed in the HANA architecture.
Financial and customer impact.
1. Emergency infrastructure upgrades after go-live significantly increase project costs. 2. Slow order processing delays revenue recognition and delivery commitments. 3. Reporting delays affect financial forecasting and month-end closing activities. 4. Customers experience slower confirmations and order status visibility. Incorrect volume assumptions directly translate into operational slowdowns and unexpected infrastructure spending.
Governance and accountability, RACI model.
In ECC to S4 HANA programs, ownership follows a RACI model where authority and execution responsibilities are clearly separated across technical and functional teams. 1. Accountable. Basis lead the person responsible for HANA infrastructure sizing and gets fired if performance failures occur after go live. 2. Responsible. SD functional lead provides accurate transaction volume insights from order processing, billing, and delivery operations. 3. Consulted. Solution architect validates sizing assumptions against SAP HANA hardware guidelines. 4. Informed. IT operations director monitors infrastructure capacity planning and operational readiness. Infrastructure sizing is not just technical planning. It is governance accountability.
Ownership, who actually fixes it.
Resolving this issue requires a new workload baseline based on real historical data and future growth projections. 1. Basis lead extracts ECC workload statistics from SD03N to identify peak dialog and batch processing volumes. 2. SD functional lead analyzes document growth using tables VBAK and VBRK to determine order and billing transaction trends. 3. Solution architect compares workload projections with SAP HANA hardware sizing guidelines and Quick Sizer results. 4. IT operations director approves revised infrastructure capacity planning and procurement.
Who gets blamed versus who owns it.
1. Blamed. Basis lead business assumes infrastructure was incorrectly sized. 2. Blamed. SD functional lead perceived as underestimating real transaction volumes. 3. Actual owner. Basis lead and SD functional lead jointly responsible for workload forecasting and capacity planning. 4. Root cause. Historical ECC workload analysis was skipped during discovery. Infrastructure sizing failures rarely belong to one team. They emerge from combined planning gaps.
How this is actually fixed, the right way by a role.
1. Basis lead extracts workload statistics from SD03N and transaction DB02 to measure ECC dialog and batch activity peaks. 2. SD functional lead analyzes order volume trends using tables VBAK and VBAP to determine active sales document growth. 3. Solution Architect recalculates infrastructure sizing using SAP Quick Sizer and HANA hardware sizing guidelines. 4. IT Operations Director authorizes revised infrastructure procurement based on updated workload projections.
What not to do, common wrong fixes.
1. Accepting vendor default sizing values without analyzing real transaction volumes. 2. Ignoring seasonal peaks such as year-end billing or promotional sales surges. 3. Assuming ECC performance metrics directly translate into HANA performance. 4. Deferring infrastructure scaling decisions until after go live. Underestimating workload volumes is one of the fastest ways to destabilize a new S/4HANA system.
Follow-up 1. How do senior basis architects forecast SD transaction volumes accurately?
Answer: Senior basis architects combine historical workload data from SD03N with business growth forecasts and peak transaction periods. They analyze dialogue steps, background jobs, and batch processing volumes to determine real system usage patterns. This workload baseline is then applied to SAP Quick Sizer calculations to estimate accurate HANA memory and CPU requirements.
Follow-up 2. What governance ensures sizing assumptions are validated before infrastructure procurement?
Answer: Enterprise governance boards require workload baselines and Quick Sizer outputs to be reviewed before infrastructure procurement approvals. Basis leads present ECC workload statistics, while functional leads confirm transaction growth projections. This joint validation ensures infrastructure decisions are backed by real operational data rather than assumptions.
Follow-up 3. Curveball. What if the project intentionally undersizes infrastructure to reduce initial costs?
Answer: Intentional undersizing may appear financially efficient, but often leads to catastrophic performance issues immediately after go live. Emergency hardware upgrades can cost significantly more than proactive sizing due to expedited procurement and downtime risks. A stable S/4HANA deployment always prioritizes realistic capacity planning over short-term cost savings.
Exclusive pro tip.
Extract at least 12 to 18 months of ECC workload data from SD03N and combine it with order volume trends from VBAK before running Quick Sizer. Adding a 20% buffer for peak activity protects the S/4HANA system from unexpected workload spikes.
Scenario 6. Business seasonality not considered for go live.
In the discover and prepare phase of ECC to S/4HANA migration, business seasonality and peak transaction periods are not considered when defining the go-live timeline. Organizations schedule deployment during periods that coincide with fiscal year-end closing, holiday sales spikes, or promotional campaigns. As a result, the migration collides with the highest operational load, creating performance risks and operational instability during the most critical revenue windows.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high revenue and operational stability risk. 2. Phase, discover and prepare. 3. Frequency, common in retail, consumer goods, and seasonal businesses. 4. Primary ownership, project manager. 5. Supporting solution architect. 6. Business ownership, sales and operations planning head. 7. Relevant SAP note, not applicable scope and project strategy. This is a project planning failure, not an SAP software change. No specific note exists because it relates to poor alignment between project scheduling and real business seasonality during discovery.
Diagnostic dashboard, symptoms and evidence.
How ignoring seasonality reveals itself in project planning and testing readiness. 1. Symptom: go-live date overlaps with peak sales seasons such as holidays or fiscal close periods. 2. Red flag: cutover planning ignores historical peak workload trends from ECC. 3. Business impact: operational disruption during the highest revenue periods. 4. Detection: compare proposed go-live window with historical workload peaks using SD03N workload statistics. 5. Technical proof: peak sales volumes in tables VBAK and VBRK align with the planned go-live period. Insight: if go-live occurs during the busiest sales window, the project ignored business seasonality.
Why this happens, scenario analysis and root cause.
1. Project timelines are driven by IT deadlines instead of business calendars. 2. Discovery workshops fail to include sales operations and supply chain planners. 3. Program management prioritizes aggressive schedules over operational safety. 4. Historical transaction peaks from ECC workload data are not analyzed. Seasonality is ignored when business operations are not integrated into migration planning.
Why this is a migration-exclusive failure.
1. ECC systems already run during seasonal peaks with stable configurations. 2. Migration introduces new system architecture, new integrations, and unfamiliar operational behavior. 3. Combining system change with peak business activity multiplies operational risk. 4. The failure appears when the new platform faces extreme workloads immediately after deployment. This issue does not exist in normal ECC operations. It emerges when migration timing collides with seasonal demand.
Financial and customer impact.
1. Revenue loss due to system slowdowns during peak demand periods. 2. Operational disruptions across order management, logistics, and billing. 3. Customer dissatisfaction from delayed order confirmations or shipping. 4. Emergency stabilization costs during the most critical business window. Deploying during peak seasons puts the entire revenue engine at risk.
Governance and accountability, RACI model.
In ECC to S4 HANA programs, ownership follows a RACI model where authority and execution are clearly separated across functional and technical work streams. 1. Accountable, project manager, the person responsible for go-live scheduling and gets fired if the deployment collides with peak business operations. 2. Responsible, solution architect validates that the migration timeline aligns with operational stability. 3. Consulted, SD functional lead provides insight into order processing peaks and revenue cycles. 4. Informed, sales and operations planning head ensures business seasonality is reflected in program planning. Go-live timing must align with operational reality, not just project schedules.
Ownership, who actually fixes it.
Fixing this requires aligning project timelines with real operational cycles. 1. Project manager revises the migration timeline using historical business calendars. 2. Solution architect reviews system readiness against peak operational scenarios. 3. SD functional lead analyzes seasonal order spikes using ECC transaction tables VBAK and VBRK. 4. Sales and operations planning head confirms safe deployment windows based on demand forecasts.
Who gets blamed versus who owns it.
1. Blamed, project manager seen as rushing deployment into peak operations. 2. Blamed, solution architect perceived as approving an unstable rollout timeline. 3. Actual owner, project manager and solution architect responsible for aligning project timing with operational readiness. 4. Root cause, business seasonality analysis was missing during discovery planning. Deployment failures during peak seasons originate from planning mistakes, not technology.
How this is actually fixed, the right way by a role.
1. Project manager analyzes historical workload trends from SD03N before finalizing the go-live window. 2. Solution architect validates infrastructure readiness against peak transaction simulations. 3. SD functional lead evaluates historical sales spikes using tables VBAK and VBRK to identify operational peaks. 4. Sales and operations planning head approves the final deployment window, aligned with business demand cycles.
What not to do, common wrong fixes.
1. Scheduling go-live based only on IT project milestones. 2. Ignoring historical seasonal sales patterns. 3. Assuming the system will stabilize quickly during peak demand. 4. Proceeding with deployment despite business objections. Ignoring business seasonality converts technical migrations into operational disasters.
Follow-up 1. How do experienced project leaders choose safe go-live windows?
Answer: they analyze historical ECC workload patterns using SD03N and align the deployment timeline with the lowest operational demand periods. Business leaders from sales and supply chain validate these windows to ensure operational stability during migration.
Follow-up 2. What governance prevents risky deployment timing?
Answer: executive steering committees require formal approval from both IT leadership and business operations before confirming the final go-live date. This ensures the migration schedule aligns with operational demand cycles and avoids high-risk periods.
Follow-up 3, curveball. What if leadership insists on go live before fiscal year end?
Answer: that decision may appear strategic for financial reporting alignment, but it introduces extreme operational risk. The first peak season after deployment can expose performance issues, damaging credibility with executives and business stakeholders.
Exclusive pro tip.
Always align S/4HANA Go Live with the lowest operational demand window identified from historical ECC workload data. A technically successful migration can still fail if deployed during the busiest business period.
Scenario 7. Global template versus local deviation strategy unclear.
In the discover and prepare phase of ECC to S/4HANA migration, the balance between global SD templates and local deviations for country or business unit needs is not clearly defined. This ambiguity leads to inconsistent implementations, where global processes clash with local requirements, causing configuration conflicts and ongoing harmonization efforts post-go live.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high global harmonization impact. 2. Phase, discover and prepare. 3. Frequency, common in multi-entity or international programs. 4. Primary ownership, global template lead. 5. Supporting regional SD lead. 6. Business ownership, global process owner. 7. Relevant SAP note, not applicable scope and project strategy. This is a project management or blueprinting failure, not an SAP software change. No specific note exists as it is about undefined global versus local deviation governance during discovery.
Diagnostic dashboard, symptoms and evidence.
How template deviation ambiguity shows up in design and deployment. 1. Symptom: regional teams request deviations that contradict global pricing or billing rules. 2. Red flag: blueprint lacks clear criteria for approving local changes. 3. Business impact: inconsistent processes lead to compliance issues and reporting discrepancies. 4. Detection: review template governance documents for deviation approval thresholds. 5. Technical proof: configuration variants emerge across company codes without standardization. Insight: if global SD works but local entities report conflicts, template strategy is unclear.
Why this happens, scenario analysis and root cause.
1. Global teams push standardization without input from regional stakeholders. 2. Deviation criteria like legal mandates or market needs are not predefined. 3. Discovery focuses on core processes and skips governance for exceptions. 4. Lack of escalation paths for resolving global versus local conflicts. Template strategy requires clear rules. Ambiguity breeds inconsistency.
Why this is a migration exclusive failure.
1. ECC allowed decentralized customizations without central governance. 2. S/4HANA Clean Core demands predefined templates with controlled deviations. 3. Migration consolidates entities, exposing unresolved local needs. 4. The issue surfaces when deploying a single system across diverse regions. This is not ECC decentralization. Migration enforces global consistency.
Financial and customer impact.
1. Inconsistent pricing across regions leads to revenue discrepancies. 2. Ongoing deviation maintenance increases support costs. 3. Compliance violations from unharmonized tax or reporting rules. 4. Customer confusion from varying order-to-cash experiences. Unclear templates erode global efficiency and local compliance.
Governance and accountability, RACI model.
In ECC to S/4HANA programs, ownership follows a RACI model where authority and execution are clearly separated across functional and technical work streams. 1. Accountable, global template lead: the person who defines deviation strategy and gets fired if inconsistencies derail global rollout. 2. Responsible, regional SD lead identifies local needs and proposes deviations. 3. Consulted, solution architect ensures deviations fit clean core principles. 4. Informed, global process owner monitors harmonization post-deployment. Template governance prevents regional chaos in global migrations.
Ownership, who actually fixes it.
Resolving this requires formal deviation governance supported by real configuration analysis. 1. Global template lead defines the baseline configuration using global SD pricing procedures and sales document types across company codes. 2. Regional SD lead documents local legal and market deviations such as tax procedures or regional billing requirements. 3. Solution architect evaluates deviations against clean core principles and checks impacts on configuration objects like pricing procedures and partner determination. 4. Global process owner validates the final template governance and approves deviation thresholds for global rollout.
Who gets blamed versus who owns it?
1. Blamed global template lead seen as imposing rigid standards without local input. 2. Blamed regional SD lead perceived as resisting global harmonization. 3. Actual owner global template lead and regional SD lead responsible for joint deviation governance. 4. Root cause no predefined rules for balancing global and local needs. Template conflicts arise from poor global-regional collaboration.
How this is actually fixed, the right way by a role.
1. Global template lead establishes a global baseline using standard SD configuration objects such as pricing procedures and sales document types. 2. Regional SD lead analyzes regional requirements including tax procedures, billing types, and localization compliance needs. 3. Solution architect evaluates deviation proposals to ensure they do not break clean core architecture or cross-company code reporting. 4. Global process owner approves the deviation governance model and enforces it through template design authority.
What not to do, common wrong fixes.
1. Imposing global templates without regional buy-in. 2. Allowing unlimited deviations without governance. 3. Deferring strategy to post-design phase. 4. Ignoring legal drivers for local adaptations. Unclear strategy leads to endless regional disputes.
Follow-up 1. How do senior leaders balance global templates and local needs?
Answer: senior leaders define deviation tiers based on legal, market, and operational drivers, with clear escalation paths. They mandate joint workshops for alignment. This governance ensures scalability while respecting regional realities.
Follow-up 2. What tools help define template deviation criteria?
Answer: use SAP Best Practices Explorer for global baselines and regional variants. Solution architects document criteria in ARIS or Signavio. Regular audits prevent drift. This structured approach supports clean core compliance.
Follow-up 3. Curveball. What if regions demand full local customization despite global push?
Answer: regions may push for autonomy citing local laws, but this fragments the system into silos. Curveball: it creates reporting nightmares and upgrade hell as custom code multiplies. Enforce tiered deviations with legal veto to maintain harmony.
Exclusive pro tip.
Define template deviation rules in the charter. Legal equals mandatory local, market equals case by case, operational equals global standard. Unclear strategy breeds chaos. Govern it from day one.
Scenario 8. Brownfield versus selective migration decision, misaligned with SD complexity.
In the discover and prepare phase of ECC to S4 HANA migration, the migration approach such as brownfield system conversion or selective data transition is chosen without analyzing the true complexity of the SD landscape. Organizations with heavy SD customizations, complex pricing models, or fragmented master data often select brownfield to save time. This leads to inherited technical debt, incompatible processes, and difficult stabilization after go live.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high migration strategy and technical debt impact. 2. Phase, discover and prepare. 3. Frequency, common in legacy ECC landscapes with heavy customization. 4. Primary ownership, solution architect. 5. Supporting SD functional lead. 6. Business ownership, CIO or transformation sponsor. 7. Relevant SAP note, not applicable scope and project strategy. This is a strategic migration decision failure, not an SAP software change. No specific note exists because it concerns selecting the wrong migration approach during discovery.
Diagnostic dashboard, symptoms and evidence.
How an incorrect migration strategy becomes visible during early project phases. 1. Symptom: custom code remediation volume is far higher than expected during ATC analysis. 2. Red flag: simplification item checks reveal extensive incompatibilities in SD processes. 3. Business impact, extended stabilization periods and post-go-live redesign efforts. 4. Detection. Analyze ATC results and simplification item catalog outputs for SD objects. 5. Technical proof. Thousands of findings appear in ATC checks for SD programs accessing obsolete tables. Insight. If system conversion exposes massive remediation work, the migration strategy was misaligned.
Why this happens, scenario analysis and root cause.
1. Executives push for brownfield conversions to shorten timelines and reduce budgets. 2. Discovery workshops underestimate the complexity of legacy SD customizations. 3. Teams assume ECC configurations will function similarly in S4 HANA. 4. Custom code volume and obsolete functionality are not properly analyzed. Migration strategy failures originate from incomplete discovery and unrealistic planning.
Why this is a migration, exclusive failure.
1. ECC landscapes accumulate years of customizations and workaround processes. 2. S4 HANA simplifications remove legacy objects and require redesigned processes. 3. Brownfield conversions carry legacy technical debt directly into the new system. 4. The issue emerges only when legacy structures collide with simplified data models. This is not a normal ECC problem. It emerges when legacy architecture meets S4 HANA simplification.
Financial and customer impact.
1. Extended stabilization costs due to unexpected redesign requirements. 2. Operational inefficiencies caused by legacy SD processes that do not align with S4 HANA. 3. Delayed business value realization from the migration program. 4. Increased consulting and remediation costs. Choosing the wrong migration approach can multiply the total transformation cost.
Governance and accountability, RACI model.
In ECC to S4 HANA programs, ownership follows a RACI model where authority and execution are clearly separated across functional and technical work streams. 1. Accountable. Solution architect, the person responsible for defining the migration strategy, and gets fired if the approach leads to systemic instability. 2. Responsible. SD functional lead evaluates business process complexity and identifies redesign needs. 3. Consulted. ABAP lead assesses custom code remediation scope using ATC analysis. 4. Informed. CIO or transformation sponsor ensures strategic alignment with business objectives. Migration strategy decisions must balance speed, risk, and technical debt.
Ownership, who actually fixes it.
Resolving this requires re-evaluating the migration strategy based on real system complexity. 1. Solution architect reviews migration approach using simplification item catalog and system readiness checks. 2. SD functional lead analyzes SD process complexity, including pricing procedures and order flows. 3. ABAP lead evaluates custom code remediation volume using ATC findings. 4. Transformation sponsor approves revised migration strategy if risks exceed acceptable thresholds.
Who gets blamed versus who owns it.
1. Blamed. Solution architect executives believe the technical strategy was flawed. 2. Blamed. SD functional lead perceived as underestimating process complexity. 3. Actual owner, solution architect and transformation sponsor responsible for choosing the appropriate migration approach. 4. Root cause, strategic decisions were made before understanding system complexity. Migration strategy failures are leadership decisions, not technical mistakes.
How this is actually fixed, the right way by a role.
1. Solution architect performs system readiness analysis using SAP readiness check and simplification item catalog. 2. SD functional lead evaluates pricing procedures, billing flows, and intercompany processes for redesign requirements. 3. ABAP lead runs ATC scans to quantify custom code remediation effort. 4. Transformation sponsor approves migration strategy adjustment such as selective data transition if risk is too high.
What not to do, common wrong fixes.
1. Choosing brownfield migration purely for speed. 2. Ignoring large volumes of legacy custom code. 3. Assuming ECC business processes will work unchanged in S4 HANA. 4. Deferring strategy corrections until after system conversion. Migration strategy mistakes cannot be fixed cheaply after conversion.
Follow-up 1. How do experienced architects decide between brownfield and selective migration?
Answer: they analyze custom code volume, process complexity, and master data quality before selecting the migration approach. Systems with heavy customization or inconsistent master data often require selective migration strategies to avoid carrying legacy technical debt into S/4HANA.
Follow-up 2. What analysis tools help validate migration strategy decisions?
Answer: SAP Readiness Check, ATC Custom Code Analysis, and Simplification Item Catalog reviews provide insight into system complexity. These tools help architects quantify remediation effort and determine whether a system conversion or selective data transition is the safer approach.
Follow-up 3. Curveball. What if leadership insists on brownfield despite technical risks?
Answer: in such cases, the system may technically convert, but stabilization costs explode after go live. Legacy technical debt slows innovation and upgrades. Experienced architects document the risks formally, so leadership understands the long-term consequences of the decision.
Exclusive pro tip.
Never select the migration approach based only on timeline pressure. Always evaluate system complexity using ATC results, readiness checks, and process redesign analysis before committing to brownfield conversion.
Scenario 9. Revenue recognition model not defined. Classic versus EBRR versus RAR.
In the discover and prepare phase of ECC to S/4HANA migration, the organization does not define which revenue recognition model will be used in the future system. ECC systems often relied on classic SD revenue recognition, while S/4HANA introduces event-based revenue recognition and the dedicated revenue accounting and reporting solution. If the target model is not decided early, integration design between SD and finance becomes unstable, and financial reporting logic must be redesigned late in the program.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high financial reporting and compliance impact. 2. Phase, discover and prepare. 3. Frequency, common in subscription services and contract-based businesses. 4. Primary ownership, finance transformation lead. 5. Supporting SD functional lead. 6. Business ownership, chief financial officer. 7. Relevant SAP note. SAP note 2267-319. Revenue recognition simplifications. And SAP note 2225170. Revenue accounting and reporting integration.
Diagnostic dashboard, symptoms and evidence.
How undefined revenue recognition strategy appears during system design. 1. Symptom: SD billing design proceeds without a confirmed revenue recognition model. 2. Red flag: finance and SD teams propose different accounting treatments for the same sales contracts. 3. Business impact: financial reporting becomes inconsistent across regions and business units. 4. Detection: review blueprint documents for explicit decisions on event-based revenue recognition or revenue accounting and reporting. 5. Technical proof: SD billing configuration lacks integration points for revenue contract creation. Insight: if billing flows are defined but revenue timing is unclear, the revenue model decision was skipped.
Why this happens, scenario analysis and root cause.
1. Finance transformation decisions are deferred until late in the program. 2. SD teams assume revenue logic will remain identical to ECC. 3. Leadership focuses on operational processes rather than accounting architecture. 4. RAR capabilities and regulatory implications are not evaluated during discovery. Revenue recognition is often treated as a finance detail rather than a system architecture decision.
Why this is a migration, exclusive failure.
1. ECC relied on classic SD revenue recognition tightly coupled to billing documents. 2. S/4HANA introduces new revenue recognition models that change financial integration. 3. Revenue accounting and reporting separates operational transactions from accounting logic. 4. Migration exposes the need to redesign revenue treatment across the entire order-to-cash process. This issue does not exist in ECC operations, but emerges when organizations adopt modern revenue recognition models.
Financial and customer impact.
1. Financial statements may misrepresent revenue timing and profitability. 2. Compliance risks appear for companies subject to IFRS 15 or ASC 606 regulations. 3. Delayed billing and contract processing affect revenue visibility. 4. Finance teams struggle to reconcile operational transactions with accounting reports. Incorrect revenue recognition architecture directly threatens financial compliance.
Governance and accountability, RACI model.
In ECC to S4 HANA programs, ownership follows a RACI model where authority and execution responsibilities are clearly separated across business and technical teams. 1. Accountable. Finance transformation lead the person responsible for defining the revenue recognition model and gets fired if financial reporting becomes non-compliant. 2. Responsible. SD functional lead designs billing processes that integrate with the chosen revenue recognition architecture. 3. Consulted. Solution architect validates that the revenue model fits overall system architecture. 4. Informed. Chief Financial Officer ensures the final approach meets regulatory and reporting expectations. Revenue recognition design is both an accounting and system architecture responsibility.
Ownership, who actually fixes it.
Resolving this requires selecting a clear revenue recognition architecture before design continues. 1. Finance transformation lead evaluates whether event-based revenue recognition or revenue accounting and reporting best fits the business model. 2. SD functional lead reviews billing processes to determine when revenue triggering events occur. 3. Solution architect designs the integration flow between SD billing and finance accounting objects. 4. Chief Financial Officer approves the final revenue recognition model for the transformation program.
Who gets blamed versus who owns it.
1. Blamed. Finance transformation lead leadership believes finance delayed key accounting decisions. 2. Blamed. SD functional lead perceived as designing billing processes incorrectly. 3. Actual owner, finance transformation lead and chief financial officer responsible for defining the enterprise revenue strategy. 4. Root cause, financial architecture decisions were postponed during discovery. Revenue recognition problems are rarely technical mistakes. They are delayed finance transformation decisions.
How this is actually fixed, the right way by a role.
1. Finance transformation lead evaluates regulatory requirements such as IFRS 15 and ASC 606 to select the correct revenue model. 2. SD functional lead maps order-to-cash events that trigger revenue recognition points. 3. Solution architect designs integration between SD billing documents and revenue contracts in the accounting layer. 4. Chief Financial Officer formally approves the revenue recognition framework for the transformation program.
What not to do, common wrong fixes.
1. Assuming the classic ECC revenue recognition model will continue unchanged. 2. Deferring revenue architecture decisions until system testing. 3. Allowing different regions to implement separate revenue models. 4. Designing billing processes without considering financial reporting requirements. Revenue recognition architecture must be defined before detailed SD design begins.
Follow-up 1. How do experienced architects choose between event-based revenue recognition and revenue accounting and reporting?
Answer: they analyze contract complexity, regulatory requirements, and integration needs across finance and sales. Event-based revenue recognition fits simpler operational scenarios, while revenue accounting and reporting supports complex contract structures and subscription models.
Follow-up 2. What analysis helps validate the revenue recognition decision early?
Answer: finance and architecture teams evaluate contract types, billing structures, and regulatory reporting requirements. They simulate revenue flows using sample contracts to confirm whether the selected model supports accurate accounting treatment.
Follow-up 3. Curveball. What happens if the revenue model is changed after system design is complete?
Answer: changing the revenue model late forces redesign of billing integration, financial postings, and contract management logic. This creates massive rework across SD and finance configurations and can delay the entire transformation timeline.
Exclusive pro tip.
Define the revenue recognition architecture before designing SD billing flows. Revenue accounting decisions influence how orders, billing documents, and financial postings interact across the entire system.
Scenario 10. Governance model for Fiori first operations undefined.
In the discover and prepare phase of ECC to S4 HANA migration, The organization adopts a Fiori-first user experience, but fails to define governance for how business operations will shift from SAP GUI transactions to Fiori applications. Without clear operational governance, users continue relying on legacy GUI transactions, while new Fiori apps introduce parallel process paths. This creates operational confusion, inconsistent user behavior, and fragmented process execution after go-live.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, medium user experience and process governance impact. 2. Phase, discover and prepare. 3. Frequency, common in organizations migrating from SAP GUI to Fiori. 4. Primary ownership, UX governance lead. 5. Supporting solution architect. 6. Business ownership, digital transformation head. 7. Relevant SAP note, not applicable process design gap. This is a project management or governance failure in defining new operational models, not an SAP software change. No specific note exists as it is about undefined Fiori-first governance during discovery. Reference SAP Note 2198647 for custom code adaptation context only.
Diagnostic dashboard, symptoms and evidence.
How lack of Fiori governance becomes visible during system adoption. 1. Symptom, business users continue executing transactions in SAP GUI even though equivalent Fiori apps exist. 2. Red flag, Fiori Launchpad roles are not aligned with operational job responsibilities. 3. Business impact, multiple operational pathways create inconsistent business processes. 4. Detection, compare SAP GUI transaction usage logs with Fiori app usage statistics. 5. Technical proof, system usage reports show low adoption rates for deployed Fiori apps. Insight, if Fiori apps exist but users still prefer SAP GUI, governance was never defined.
Why this happens, scenario analysis and root cause.
1. Organizations deploy Fiori apps without redefining operational workflows. 2. Security roles in Fiori catalogs are implemented without process governance. 3. Business users are not trained on new application-driven workflows. 4. Leadership treats Fiori as a UI upgrade instead of an operational transformation. Fiori adoption fails when governance focuses on technology instead of process transformation.
Why this is a migration, exclusive failure.
1. ECC operations were historically built around SAP GUI transactions. 2. S4 HANA introduces role-based applications and task-driven workflows. 3. Migration replaces transaction-centric operations with application-driven processes. 4. Failure occurs when organizations deploy Fiori apps but keep legacy operating habits. The challenge is not technology deployment but operational behavior change.
Financial and customer impact.
1. Operational inefficiencies reduce productivity gains expected from S4 HANA. 2. Support costs increase due to confusion between SAP GUI and Fiori workflows. 3. Training programs must be repeated due to inconsistent system usage. 4. Transformation ROI decreases because the modern user experience is not adopted. Deploying Fiori without governance prevents organizations from realizing digital transformation benefits.
Governance and accountability, RACI model.
In S4 HANA programs, ownership for user experience transformation must be clearly defined between business and technology teams. 1. Accountable, UX governance lead the person responsible for defining Fiori operating standards and gets fired if adoption fails across the organization. 2. Responsible, security and authorization lead configures Fiori roles, catalogs, and Launchpad access. 3. Consulted, solution architect ensures Fiori apps align with the overall system architecture. 4. Informed, digital transformation head monitors adoption and organizational readiness. User experience governance determines whether Fiori becomes the operational standard.
Ownership, who actually fixes it.
Fixing this requires defining how operational processes will run using Fiori applications. 1. UX governance lead defines which business activities must be executed through Fiori apps. 2. Security lead aligns Fiori catalogs and roles with job-based responsibilities. 3. Solution architect validates the technical architecture for Fiori Launchpad deployment. 4. Digital Transformation Head approves enterprise-wide adoption policies.
Who gets blamed versus who owns it?
1. Blamed. Solution architect leadership assumes technical design was incorrect. 2. Blamed. Security lead perceived as configuring roles incorrectly. 3. Actual owner. UX governance lead and digital transformation head responsible for defining operational governance. 4. Root cause. The organization deployed technology without defining operational standards. Fiori failures rarely come from configuration errors. They originate from missing governance.
How this is actually fixed, the right way by a role.
1. UX governance lead defines enterprise standards for which business tasks must run in Fiori apps. 2. Security lead configures role-based Fiori catalogs aligned with operational job functions. 3. Solution architect validates Launchpad architecture and integration with backend services. 4. Digital Transformation Head enforces adoption through training and governance policies.
What not to do, common wrong fixes.
1. Deploying Fiori apps without defining operational usage policies. 2. Allowing unrestricted access to both SAP GUI and Fiori processes. 3. Treating Fiori as a cosmetic interface upgrade. 4. Ignoring user adoption metrics after deployment. Fiori transformation succeeds only when governance drives behavioral change.
Follow-up 1. How do successful organizations enforce Fiori-first operations?
Answer: they define governance rules that mandate Fiori usage for specific operational tasks and restrict legacy GUI transactions where possible. Clear role-based access ensures employees naturally use the correct applications.
Follow-up 2. What metrics measure Fiori adoption success?
Answer: organizations track Launchpad usage statistics, application execution frequency, and reductions in SAP GUI transaction usage. These metrics show whether operational processes are shifting toward Fiori workflows.
Follow-up 3. Curveball. What happens if users resist Fiori adoption?
Answer: if governance allows unrestricted SAP GUI access, employees will continue using familiar transactions. Over time, the organization maintains two parallel operating models, reducing the efficiency gains expected from the S/4 HANA transformation.
Exclusive pro tip.
Define Fiori-first governance before deployment by mapping each operational role to specific applications. Without governance, Fiori becomes an optional interface instead of the new operational standard.
Scenario 11. Operational KPI model not realigned for real-time reporting.
In the discover and prepare phase of ECC to S/4 HANA migration, organizations migrate existing SD reporting structures without redesigning operational KPIs for real-time analytics. ECC systems relied heavily on LIS structures, batch reporting, and overnight aggregation. In S/4 HANA, embedded analytics and CDS-based reporting deliver operational insights instantly. When KPI models are not redesigned, business users continue using outdated reporting assumptions that conflict with real-time data behavior.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, medium reporting and decision support impact. 2. Phase, discover and prepare. 3. Frequency, common in organizations migrating from LIS-based reporting. 4. Primary ownership, analytics transformation lead. 5. Supporting SD functional lead. 6. Business ownership, sales operations director. 7. Relevant SAP note, not applicable analytics redesign gap. This is a reporting architecture and KPI governance failure, not an SAP software change. No specific note exists as it is about not redesigning KPIs for real-time analytics during discovery. Reference SAP Note 22673006 for SD analytics and LIS replacement context only.
Diagnostic dashboard, symptoms and evidence.
How legacy KPI definitions conflict with real-time reporting capabilities. 1. Symptom, business dashboards show different results compared to operational transactions. 2. Red flag, legacy LIS reports are recreated without redesigning KPI definitions. 3. Business impact, executives lose trust in analytics due to inconsistent metrics. 4. Detection, compare historical LIS KPI definitions with embedded analytics CDS views. 5. Technical proof, CDS-based reports calculate metrics directly from operational tables without batch aggregation. Insight: if real-time reports contradict legacy dashboards, KPI definitions were never redesigned.
Why this happens, scenario analysis and root cause.
1. Organizations migrate legacy reporting structures instead of redefining analytics strategy. 2. Business stakeholders assume KPI logic will behave the same as ECC aggregated reports. 3. Analytics teams recreate reports instead of redesigning metrics for real-time data models. 4. Discovery workshops focus on transactions rather than operational decision metrics. The root cause is treating analytics as reporting replication rather than strategic redesign.
Why this is a migration, exclusive failure.
1. ECC reporting relied on LIS structures and periodic batch calculations. 2. S4 HANA embedded analytics reads operational data directly using CDS views. 3. Real-time reporting removes the buffering logic that previously stabilized KPI calculations. 4. Migration exposes inconsistencies between legacy KPI assumptions and real-time operational data. This failure emerges when organizations move from aggregated reporting to real-time analytics.
Financial and customer impact.
1. Sales leadership receives conflicting performance metrics. 2. Operational decisions are delayed due to distrust in analytics. 3. Reporting reconciliation efforts increase operational overhead. 4. Strategic planning suffers due to inaccurate KPI interpretation. Incorrect KPI models undermine the decision-making value of embedded analytics.
Governance and accountability, RACI model.
In S4 HANA programs, analytics ownership must clearly define how operational metrics are calculated and interpreted. 1. Accountable analytics transformation lead the person responsible for KPI governance and gets fired if executives lose trust in reporting. 2. Responsible SD functional lead ensures operational transactions support accurate KPI calculation. 3. Consulted solution architect validates analytics architecture using CDS-based reporting. 4. Informed sales operations director relies on the KPI framework for business performance management. Analytics governance determines whether real-time reporting becomes a strategic asset.
Ownership, who actually fixes it.
Resolving this requires redesigning operational KPIs for embedded analytics. 1. Analytics transformation lead reviews legacy KPI definitions from LIS reporting. 2. SD functional lead validates how operational transactions populate analytics data models. 3. Solution architect designs embedded analytics architecture using CDS views. 4. Sales operations director approves the new KPI framework for executive dashboards.
Who gets blamed versus who owns it.
1. Blamed analytics lead executives believe reporting models were implemented incorrectly. 2. Blamed SD functional lead perceived as configuring transactional logic incorrectly. 3. Actual owner, analytics transformation lead and sales operations director responsible for KPI governance. 4. Root cause, legacy LIS reporting assumptions were never redesigned for real-time analytics. Analytics confusion is rarely technical. It originates from outdated KPI definitions.
How this is actually fixed, the right way by a role.
1. Analytics transformation lead reviews legacy LIS metrics and identifies KPIs that must be redesigned. 2. SD functional lead maps operational events such as order creation and billing to analytics calculations. 3. Solution architect implements CDS-based reporting models aligned with embedded analytics architecture. 4. Sales operations director validates KPI definitions for executive dashboards.
What not to do, common wrong fixes.
1. Recreating legacy LIS reports without redesigning KPI definitions. 2. Assuming batch aggregation logic behaves the same in real-time analytics. 3. Allowing multiple departments to define conflicting KPI formulas. 4. Ignoring governance for executive reporting metrics. Replicating legacy reports prevents organizations from realizing the value of embedded analytics.
Follow-up 1. Why do embedded analytics KPIs behave differently from LIS reports?
Answer: embedded analytics calculates metrics directly from operational tables using CDS views. LIS reports relied on periodic aggregation and buffering. When these assumptions change, KPI timing and values can differ significantly.
Follow-up 2. How do experienced architects redesign KPIs for real-time analytics?
Answer: they analyze operational event timing such as order creation, delivery posting, and billing completion. These events are mapped directly to analytics calculations, ensuring KPIs reflect real-time operational performance.
Follow-up 3. Curveball. What happens if organizations keep legacy KPI definitions?
Answer: executives receive inconsistent performance metrics that contradict operational transactions. Over time, leadership loses confidence in analytics, and the organization continues relying on manual reporting instead of real-time insights.
Exclusive pro tip.
Never migrate LIS reporting blindly. Redesign KPI definitions around real-time operational events and CDS analytics models to unlock the full value of S/4HANA embedded analytics.
Scenario 12. Support organization not trained on embedded analytics.
In the discover and prepare phase of ECC to S/4HANA migration, the operational support organization is not trained on embedded analytics architecture. ECC support teams were accustomed to troubleshooting LIS reports, BW extractors, and batch reporting jobs. In S/4HANA, operational reporting relies on CDS views, real-time analytics, and Fiori analytical apps. When support teams lack training in these technologies, they cannot diagnose reporting issues, causing prolonged downtime and incorrect business decisions.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, medium operational support capability impact. 2. Phase, discover and prepare. 3. Frequency, very common in organizations transitioning from BW or LIS reporting models. 4. Primary ownership, support operations lead. 5. Supporting analytics transformation lead. 6. Business ownership, IT operations director. 7. Relevant SAP note, not applicable process design gap. This is an organizational readiness and training failure, not an SAP software issue. The problem arises when support teams are not prepared to operate CDS-based analytics and Fiori reporting environments.
Diagnostic dashboard, symptoms and evidence.
How lack of embedded analytics knowledge appears in production support. 1. Symptom: support tickets escalate frequently because analysts cannot diagnose analytics issues. 2. Red flag: support teams rely on developers to troubleshoot CDS-based reports. 3. Business impact: operational dashboards remain unavailable during critical decision periods. 4. Detection: review incident resolution times for Fiori analytical applications. 5. Technical proof: support teams lack tools and knowledge to analyze CDS views or analytical queries. Insight: if every analytics issue requires developer intervention, the support team was never trained.
Why this happens, scenario analysis and root cause.
1. Organizations focus training budgets on implementation teams instead of operational support staff. 2. Support organizations assume reporting architecture remains similar to ECC. 3. Training plans focus on transactional processes rather than analytics platforms. 4. Analytics transformation teams fail to document operational troubleshooting procedures. The root cause is treating analytics as a development topic instead of an operational capability.
Why this is a migration, exclusive failure.
1. ECC support relied on batch reporting and BW extractors. 2. S/4HANA embedded analytics relies on CDS views and real-time calculations. 3. Operational reporting shifts from separate reporting systems to the transactional platform. 4. Migration exposes support teams to technologies they have never operated before. The issue emerges when reporting responsibility moves directly into the operational system.
Financial and customer impact.
1. Business leaders lose visibility into operational performance metrics. 2. Critical dashboards remain unavailable during decision cycles. 3. Support costs increase due to developer involvement in routine incidents. 4. Operational reporting reliability declines across departments. Embedded analytics becomes a liability when operational teams cannot support it.
Governance and accountability, RACI model.
Operational readiness requires clearly defined ownership between analytics teams and support organizations. 1. Accountable, support operations lead the person responsible for production support readiness and gets fired if analytics incidents disrupt business operations. 2. Responsible, analytics transformation lead provides technical training and documentation for embedded analytics. 3. Consulted, solution architect ensures analytics architecture is operationally supportable. 4. Informed, IT operations director oversees operational capability and support readiness. Analytics transformation succeeds only when operational teams are prepared to support it.
Ownership, who actually fixes it.
Resolving this requires preparing the support organization for embedded analytics operations. 1. Support operations lead defines operational training plans for analytics support. 2. Analytics transformation lead provides workshops covering CDS views and analytical apps. 3. Solution architect documents troubleshooting architecture for embedded analytics. 4. IT operations director validates operational readiness before go live.
Who gets blamed versus who owns it.
1. Blamed, analytics lead leadership assumes the analytics design is flawed. 2. Blamed, development team perceived as delivering unstable analytical applications. 3. Actual owner, support operations lead and IT operations director responsible for operational readiness. 4. Root cause, support teams were never trained on embedded analytics architecture. Analytics support failures usually originate from training gaps rather than technical issues.
How this is actually fixed, the right way by a role.
1. Support operations lead establishes training programs for embedded analytics operations. 2. Analytics transformation lead trains support teams on CDS views, analytical queries, and Fiori analytics apps. 3. Solution architect documents monitoring and troubleshooting procedures for analytics services. 4. IT operations director ensures operational readiness reviews before production deployment.
What not to do, common wrong fixes.
1. Assuming developers will support analytics issues indefinitely. 2. Ignoring operational training for analytics technologies. 3. Treating embedded analytics as purely a development component. 4. Deploying analytical applications without operational documentation. Without training, embedded analytics support quickly becomes unsustainable.
Follow-up 1. Why is embedded analytics difficult for traditional support teams?
Answer: embedded analytics introduces CDS views, analytical queries, and Fiori-based reporting applications. Traditional support teams were trained to troubleshoot batch reports and BW extractors, so the new technologies require different diagnostic skills.
Follow-up 2. How do mature organizations prepare support teams for analytics operations?
Answer: they implement operational training programs covering CDS view troubleshooting, analytical application monitoring, and query performance analysis. Documentation and runbooks are created to guide incident resolution.
Follow-up 3. Curveball. What happens if analytics support is outsourced without proper training?
Answer: outsourced support teams escalate nearly every analytics incident to developers or architects. This dramatically increases incident resolution times and creates operational risk for business reporting.
Exclusive pro tip.
Train production support teams on CDS views, analytical queries, and Fiori reporting tools before go live. Embedded analytics must be treated as an operational capability, not just an implementation deliverable.
Scenario 13. Month-end acceleration impact on SD and FI not assessed.
In the discover and prepare phase of ECC to S/4HANA migration, organizations aim to accelerate financial closing cycles using real-time financial integration. However, the operational impact of this acceleration on SD and FI integration is not evaluated. ECC systems often relied on delayed reconciliation and batch processes between SD billing and financial postings. In S/4HANA, universal journal architecture and real-time postings eliminate many buffering mechanisms, exposing process dependencies that were previously hidden.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high financial closing and revenue reporting impact. 2. phase, discover, and prepare. 3. Frequency, common in organizations targeting faster month-end close. 4. Primary ownership, finance transformation lead. 5. Supporting SD functional lead. 6. Business ownership, chief financial officer. 7. Relevant SAP note, not applicable process design gap. This is a financial process redesign failure where organizations accelerate financial closing cycles without redesigning SD and FI operational dependencies, not an SAP software change. No specific note exists as it is about undefined month-end governance during discovery. Reference SAP Note 2227014 for SD simplification context and SAP Note 2349298 for Universal Journal integration context only.
Diagnostic dashboard, symptoms and evidence.
How unassessed month-end acceleration impacts appear in SD and FI integration. 1. Symptom: finance teams demand faster closing cycles but operational billing processes remain unchanged. 2. Red flag: SD billing runs overlap with financial reconciliation activities. 3. Business impact: financial reports become inconsistent due to incomplete operational transactions. 4. Detection: compare billing completion times with financial closing schedules. 5. Technical proof: Universal Journal postings show timing mismatches between SD billing and FI reporting periods. Insight: if finance accelerates closing but SD processes remain unchanged, integration risks emerge.
Why this happens, scenario analysis and root cause.
1. Finance transformation teams prioritize faster financial reporting without analyzing operational dependencies. 2. SD teams assume billing timelines will remain unchanged after migration. 3. Project governance separates finance transformation initiatives from operational process design. 4. Discovery workshops focus on accounting architecture rather than operational integration timing. Month-end acceleration initiatives often overlook operational dependencies.
Why this is a migration, exclusive failure.
1. ECC systems relied on delayed reconciliation between SD and FI. 2. S4 HANA introduces real-time financial postings through the Universal Journal. 3. Operational transactions now immediately impact financial reporting. 4. Migration exposes timing conflicts between operational processes and financial closing cycles. Real-time financial integration reveals operational dependencies that were hidden in ECC.
Financial and customer impact.
1. Financial closing cycles experience unexpected reconciliation delays. 2. Revenue reporting becomes inconsistent across accounting periods. 3. Finance teams spend additional effort reconciling operational transactions. 4. Executive confidence in accelerated closing initiatives declines. Acceleration without operational redesign creates reconciliation chaos.
Governance and accountability, RACI model.
Financial transformation initiatives require coordinated ownership across operational and accounting teams. 1. Accountable: finance transformation lead the person responsible for defining accelerated financial closing strategy and gets fired if reconciliation failures disrupt financial reporting. 2. Responsible: SD functional lead aligns billing processes with financial closing timelines. 3. Consulted: solution architect validates integration architecture between SD billing and financial postings. 4. Informed: Chief Financial Officer monitors the impact of transformation initiatives on financial reporting. Month-end acceleration requires coordinated governance between finance and operations.
Ownership, who actually fixes it.
Resolving this requires aligning operational billing processes with financial closing objectives. 1. Finance transformation lead reviews financial closing timelines and reconciliation processes. 2. SD functional lead analyzes billing cycles and delivery completion patterns. 3. Solution architect designs integration controls between operational transactions and financial reporting. 4. Chief Financial Officer approves revised closing governance aligned with operational processes.
Who gets blamed versus who owns it.
1. Blamed: SD functional lead finance teams assume operational billing caused reporting delays. 2. Blamed, finance transformation team executives believe the closing strategy was unrealistic. 3. Actual owner, finance transformation lead and chief financial officer responsible for defining realistic closing strategy. 4. Root cause, financial acceleration initiatives were launched without operational process redesign. Financial transformation must account for operational realities.
How this is actually fixed, the right way by a role.
1. Finance transformation lead analyzes month-end closing dependencies across finance and operations. 2. SD functional lead redesigns billing schedules and delivery completion timing. 3. Solution architect validates real-time posting behavior between SD and financial accounting. 4. Chief financial officer approves revised financial closing governance aligned with operational flows.
What not to do, common wrong fixes.
1. Accelerating financial closing timelines without redesigning operational processes. 2. Assuming billing cycles will automatically align with financial reporting. 3. Separating finance transformation initiatives from operational process design. 4. Ignoring reconciliation dependencies between operational transactions and accounting reports. Month-end acceleration must be designed across finance and operations together.
Follow-up 1. Why does S/4HANA enable faster financial closing cycles?
Answer: S/4HANA introduces the Universal Journal architecture, which integrates financial and operational data in a single data model. This allows financial reports to be generated in near real time rather than waiting for batch reconciliation processes.
Follow-up 2. How do experienced architects align SD operations with financial closing?
Answer: they analyze billing cycles, delivery completion patterns, and revenue recognition timing. Operational processes are redesigned so financial reporting reflects completed business transactions rather than partially processed data.
Follow-up 3. Curveball. What happens if finance accelerates closing without operational redesign?
Answer: financial reports may be generated before all operational transactions are complete. This results in revenue mismatches, reconciliation effort, and loss of confidence in financial reporting accuracy.
Exclusive pro tip.
Before accelerating financial closing cycles, map every SD operational dependency including billing completion, delivery posting, and revenue recognition events. Financial speed must always match operational readiness.
Phase 1 Category 1 complete. Program and scope risks.
The first 13 scenarios revealed a critical truth about S/4HANA migrations. Most project failures do not begin with technology problems. They begin with strategic decisions made during discovery. When scope, governance, operational readiness, and financial transformation assumptions are incorrect, the program carries structural risk before a single configuration activity even begins.
Transition from program and scope risks to architecture risks.
The first category focused on program governance, scope clarity, and operational readiness. But even when scope is correct, migrations can still fail if core system architecture decisions are unclear. The next category shifts the discussion from strategy to technology, examining the architectural foundations that determine how the future S/4HANA system will actually operate.
Please check description or comment section of this video. I have given a lot of links for downloading 7 or 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked system design, most asked implementation project-related interview questions and answers, most asked support project-related interview questions and answers, required for your SAP functional modules interviews jobs like SAP MM consultant jobs, SAP FICO consultant jobs, SAP SD consultant jobs, SAP PP consultant jobs, SAP Ariba consultant jobs, SAP Extended Warehouse Management EWM consultant jobs, SAP Plant Maintenance PM consultant jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90%, of the people are failing to answer with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section. These questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people also for your interviews. You people can download all 7 or 8 PDFs in a single zip file from below given links.
Phase 1 Category 2 Architecture Risks.
Architecture decisions determine how the future S/4HANA system will actually operate. These decisions include logistics platforms, financial integration models, workflow engines, output frameworks, and cloud extensibility limits. When architecture choices are unclear or delayed during discovery, projects experience redesign cycles during realization and testing, often resulting in massive rework.
Architecture risks identified in Phase 1 Category 2.
The following architecture decisions must be finalized during discovery to prevent structural failures later in the program. 14. Embedded versus decentralized EWM deployment decision unclear. Relevant SAP note 28067070 EWM deployment options. 15. Transportation management integration architecture not defined. Relevant SAP note 22673317 LETRA to TM simplification. 16. Credit management architecture using FSCM unclear. Relevant SAP note 22705544 credit management to FSCM. 17. Output architecture using BRF plus strategy missing. Relevant SAP note 22288611 output management in S/4HANA. 18. Advanced available to promise adoption decision not defined. Relevant SAP note 23211191 advanced ATP versus classic ATP. 19. Settlement management adoption decision unclear for rebates replacement. Relevant SAP note 22673777 rebates to settlement management. 20. Advanced variant configuration adoption decision unclear. Relevant SAP note 2711932 advanced variant configuration. 21. Revenue accounting integration architecture not defined. Relevant SAP note 22673319 and SAP note 2225170 revenue recognition simplifications. 22. Flexible workflow architecture not defined. Relevant SAP note not applicable extensibility gap. Reference SAP note 2198647 for extensibility context only. 23. Data aging and archiving strategy not defined. Relevant SAP note 1616302 information lifecycle management policy. 24. Transportation zone redesign strategy unclear. Relevant SAP note 22673317 LETRA to TM simplification. 25. Public cloud extensibility limits not assessed. Relevant SAP note 297328 S/4HANA cloud extensibility. 26. Rise with SAP service level agreement impact on SD downtime not assessed. Relevant SAP note not applicable scope and project strategy. These architecture decisions shape the technical backbone of the future S/4HANA system.
Scenario 14. Embedded versus decentralized EWM decision unclear.
In the discover and prepare phase of ECC to S/4HANA migration, organizations fail to decide whether warehouse operations will run on embedded EWM inside the S/4HANA system or on a decentralized EWM system. This architectural decision determines system landscape complexity, warehouse execution capabilities, and integration architecture. When the decision is delayed, logistics process design cannot progress, and warehouse integration becomes a major redesign effort later in the project.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high logistics platform architecture impact. 2. Phase, discover and prepare. 3. Frequency, common in manufacturing, retail, and distribution industries. 4. Primary ownership, logistics solution architect. 5. Supporting warehouse operations lead. 6. Business ownership supply chain director. 7. Relevant SAP note, SAP note 28067070 EWM deployment options.
Diagnostic dashboard, symptoms and evidence.
How an unclear EWM deployment model appears during early architecture planning. 1. Symptom, warehouse process design workshops stall because system capabilities are undefined. 2. Red flag, project documents list both embedded and decentralized EWM as possible deployment models. 3. Business impact, warehouse automation investments cannot be aligned with the system architecture. 4. Detection, review architecture documents to verify whether the EWM deployment model is finalized. 5. Technical proof, integration architecture diagrams contain unresolved connections between S4 HANA and warehouse systems. Insight, if warehouse design depends on architecture decisions that are still open, the deployment model was never finalized.
Why this happens, scenario analysis and root cause.
1. Architecture teams delay the EWM decision while waiting for warehouse process requirements. 2. Business stakeholders underestimate how strongly warehouse architecture affects system design. 3. Organizations attempt to postpone infrastructure investment decisions until later phases. 4. Discovery workshops focus on functional requirements rather than system deployment strategy. The EWM deployment decision is often delayed because teams underestimate its architectural importance.
Why this is a migration, exclusive failure.
1. ECC warehouse management operated within the ERP system using classic WM. 2. S4 HANA introduces extended warehouse management with multiple deployment models. 3. Embedded EWM integrates tightly with S4 HANA processes while decentralized EWM runs as a separate system. 4. Migration forces organizations to decide which architecture will support future warehouse operations. The architecture decision did not exist in ECC, but becomes mandatory in S4 HANA transformations.
Financial and customer impact.
1. Warehouse automation investments may become incompatible with the final architecture. 2. Project timelines extend due to late architecture redesign. 3. Integration costs increase if decentralized EWM is selected late in the program. 4. Operational disruptions occur when warehouse systems are redesigned after deployment planning. Architecture indecision increases both implementation cost and operational risk.
Governance and accountability, RACI model.
Architecture decisions must be owned by roles responsible for long-term system design. 1. Accountable, logistics solution architect, the person responsible for defining warehouse system architecture, and gets fired if incorrect deployment decisions cause integration failures. 2. Responsible, warehouse operations lead provides operational requirements for warehouse execution. 3. Consulted, enterprise architect validates landscape complexity and integration implications. 4. Informed, supply chain director oversees warehouse transformation strategy. Architecture decisions must be finalized early to prevent large-scale redesign.
Ownership, who actually fixes it.
Resolving this requires selecting a definitive EWM deployment model during discovery. 1. Logistics solution architect evaluates embedded and decentralized EWM deployment models. 2. Warehouse operations lead provides warehouse process requirements including automation and throughput. 3. Enterprise architect analyzes landscape complexity and integration architecture. 4. Supply chain director approves the final warehouse platform strategy.
Who gets blamed versus who owns it.
1. Blamed, logistics architect executives assume architecture decisions were delayed. 2. Blamed, warehouse operations team perceived as not providing clear requirements. 3. Actual owner, logistics solution architect and enterprise architect responsible for defining deployment architecture. 4. Root cause, EWM deployment strategy was not finalized during discovery. Architecture indecision is often blamed on operations, but originates from governance gaps.
How this is actually fixed, the right way by a role.
1. Logistics solution architect evaluates warehouse complexity and automation requirements. 2. Warehouse operations lead provides throughput, automation, and labor management requirements. 3. Enterprise architect assesses infrastructure, integration architecture, and landscape scalability. 4. Supply chain director approves the warehouse deployment architecture before blueprint design begins.
What not to do, common wrong fixes.
1. Deferring the EWM deployment decision until realization. 2. Allowing each warehouse region to choose different deployment architectures. 3. Selecting deployment architecture without evaluating warehouse automation strategy. 4. Assuming embedded EWM will automatically meet all operational requirements. Deployment decisions must align with warehouse operational strategy.
Follow-up 1. When should organizations choose embedded EWM instead of decentralized EWM?
Answer: embedded EWM is typically chosen when warehouse operations are closely integrated with ERP processes, and the organization wants a simplified system landscape. It works well for moderate complexity warehouses where real-time integration with S4 HANA is beneficial.
Follow-up 2. When is decentralized EWM the better architectural choice?
Answer: decentralized EWM is suitable for highly automated warehouses or large distribution networks where warehouse operations require independence from ERP maintenance cycles. It allows greater scalability and operational resilience.
Follow-up 3. Curveball. What happens if the EWM deployment decision is delayed until realization?
Answer: process design, system integration, and infrastructure architecture must be redesigned simultaneously. This can delay warehouse implementation by months and significantly increase project cost.
Exclusive pro tip.
Always finalize the warehouse platform architecture before beginning detailed logistics process design. The choice between embedded and decentralized EWM determines integration models, infrastructure planning, and long-term warehouse scalability.
Scenario 15. Transportation Management Integration Architecture not defined.
In the discover and prepare phase of ECC to S4 HANA migration, the organization does not define how transportation processes will integrate with S4 HANA. Legacy ECC landscapes often relied on LETRA functionality embedded within ERP. S4 HANA deprecates this model and introduces integration with the Advanced Transportation Management Platform. When the integration architecture is not defined early, logistics execution design becomes fragmented, and transportation planning cannot be aligned with order-to-cash processes.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high logistics integration architecture impact. 2. Phase, discover and prepare. 3. Frequency, common in manufacturing and global distribution programs. 4. Primary ownership, logistics solution architect. 5. Supporting transportation planning lead. 6. Business ownership, global logistics director. 7. Relevant SAP note. SAP note 226717. LETRA to Transportation Management Simplification.
Diagnostic dashboard, symptoms and evidence.
How undefined transportation architecture appears during system design. 1. Symptom: logistics design workshops cannot define how shipments will be planned or optimized. 2. Red flag: architecture documents still reference LETRA functionality from ECC. 3. Business impact: transportation planning cannot be integrated with delivery creation or warehouse execution. 4. Detection: review architecture diagrams for integration flows between sales orders, deliveries, and transportation planning. 5. Technical proof: integration models between S4 HANA logistics and transportation platforms remain undefined. Insight: if shipment planning architecture is unclear, transportation strategy was never finalized.
Why this happens, scenario analysis and root cause.
1. Organizations assume legacy transportation functionality will continue unchanged. 2. Architecture teams postpone transportation platform decisions until realization. 3. Business stakeholders underestimate the operational complexity of transportation planning. 4. Discovery workshops focus on warehouse processes but ignore transportation architecture. Transportation architecture decisions are often delayed because they involve both logistics and integration complexity.
Why this is a migration, exclusive failure.
1. ECC supported transportation execution using the LETRA module. 2. S4 HANA replaces this model with advanced transportation management capabilities. 3. The new architecture introduces integrated freight planning and optimization functions. 4. Migration forces organizations to redesign transportation processes around a new platform. The transportation architecture decision becomes mandatory when migrating from LETRA.
Financial and customer impact.
1. Logistics costs increase due to inefficient freight planning. 2. Shipment scheduling conflicts delay deliveries to customers. 3. Integration redesign increases project cost and timeline. 4. Customer satisfaction declines when transportation execution becomes unstable. Transportation architecture directly influences supply chain efficiency.
Governance and accountability. RACI model.
Transportation architecture decisions must be owned by roles responsible for logistics platform design. 1. Accountable. Logistics solution architect, the person responsible for defining transportation platform architecture, and gets fired if integration failures disrupt logistics operations. 2. Responsible. Transportation planning lead provides operational requirements for shipment planning and freight optimization. 3. Consulted. Enterprise architect validates system landscape and integration architecture. 4. Informed. Global Logistics Director oversees transportation transformation strategy. Transportation integration decisions must be finalized before logistics design begins.
Ownership, who actually fixes it.
Resolving this requires defining the transportation platform and integration architecture early. 1. Logistics Solution Architect evaluates transportation management deployment models. 2. Transportation Planning Lead defines freight planning and carrier management requirements. 3. Enterprise Architect designs integration flows between sales, delivery, and transportation systems. 4. Global Logistics Director approves the final transportation architecture strategy.
Who gets blamed versus who owns it.
1. Blamed. Logistics architect leadership believes architecture decisions were delayed. 2. Blamed. Transportation planning team perceived as not providing operational requirements. 3. Actual owner. Logistics solution architect and enterprise architect responsible for defining transportation architecture. 4. Root cause. Transportation platform strategy was not finalized during discovery. Architecture indecision often originates from delayed platform strategy.
How this is actually fixed. The right way by a role.
1. Logistics solution architect evaluates the transportation planning capabilities required for the business. 2. Transportation planning lead defines shipment planning workflows and carrier management requirements. 3. Enterprise architect designs integration architecture between logistics execution and transportation planning. 4. Global Logistics Director approves the transportation platform deployment model.
What not to do. Common wrong fixes.
1. Assuming legacy transportation functionality will continue in S4 HANA. 2. Deferring transportation architecture decisions until system realization. 3. Separating transportation design from warehouse and delivery processes. 4. Ignoring integration complexity between logistics and transportation platforms. Transportation planning architecture must be aligned with logistics processes early in discovery.
Follow-up 1. Why does S4 HANA replace LETRA with transportation management?
Answer. Transportation management provides advanced freight planning, optimization, and carrier collaboration capabilities that exceed the functionality available in legacy LETRA systems.
Follow-up 2. How do architects evaluate whether transportation management is required?
Answer. They analyze shipment volume, freight planning complexity, carrier integration needs, and optimization requirements across the supply chain.
Follow-up 3. Curveball. What happens if transportation architecture is decided too late?
Answer. Logistics processes must be redesigned to integrate with the transportation platform. This can disrupt warehouse integration, delivery scheduling, and shipment planning simultaneously.
Exclusive pro tip.
Transportation planning architecture should be defined alongside warehouse and delivery design. The integration between order management, logistics execution, and freight optimization determines the efficiency of the entire supply chain.
Scenario 16. Credit management architecture using FSCM unclear.
In the discover and prepare phase of ECC to S4 HANA migration, organizations fail to define how credit management will operate in the future architecture. ECC environments commonly relied on classic SD credit management embedded within the ERP system. S/4HANA replaces this model with financial supply chain management credit management. If the transition to FSCM credit management is not planned early, order processing, risk evaluation, and financial exposure monitoring become inconsistent during system design.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high financial risk management architecture impact. 2. Phase, discover and prepare. 3. Frequency, very common in global sales and distribution programs. 4. Primary ownership, finance solution architect. 5. Supporting credit risk manager. 6. Business ownership, chief financial officer. 7. Relevant SAP note 2270544, credit management migration to FSCM.
Diagnostic dashboard, symptoms and evidence.
How unclear credit management architecture appears during early system design. 1. Symptom, sales order processing design does not include FSCM credit checks. 2. Red flag, project documentation still references classic SD credit management configuration. 3. Business impact, risk exposure monitoring becomes inconsistent across company codes. 4. Detection, review system architecture diagrams for FSCM credit management components. 5. Technical proof, integration between SD order processing and FSCM credit segments is not defined. Insight, if sales orders reference legacy credit checks, the FSCM architecture decision was never finalized.
Why this happens, scenario analysis and root cause.
1. Finance teams assume the existing credit management process will remain unchanged. 2. Architecture teams delay defining FSCM integration until later design phases. 3. Credit risk stakeholders are not involved early in the discovery workshops. 4. Organizations underestimate the architectural shift from classic credit management to FSCM. Credit architecture decisions are often delayed because they span both finance and sales processes.
Why this is a migration, exclusive failure.
1. ECC implemented credit checks directly inside SD configuration. 2. S/4HANA moves credit risk management to the FSCM platform. 3. Credit exposure calculations are centralized across financial processes. 4. Migration forces organizations to redesign how financial risk controls interact with sales operations. The architectural shift to FSCM makes credit management a cross-functional financial platform.
Financial and customer impact.
1. Incorrect credit exposure calculations increase financial risk. 2. Sales orders may be blocked incorrectly or released without proper checks. 3. Customer credit monitoring becomes fragmented across regions. 4. Revenue leakage or bad debt exposure increases due to inconsistent risk evaluation. Credit architecture directly protects revenue and financial stability.
Governance and accountability, RACI model.
Credit risk architecture must be governed jointly by finance and sales leadership. 1. Accountable, finance solution architect, the person responsible for defining FSCM credit architecture, and gets fired if risk exposure controls fail after go live. 2. Responsible, credit risk manager defines credit evaluation policies and exposure monitoring rules. 3. Consulted, SD functional lead ensures sales order processing integrates with credit checks. 4. Informed, Chief Financial Officer oversees enterprise credit risk governance. Credit architecture decisions must align finance risk controls with sales execution.
Ownership, who actually fixes it.
Resolving this requires defining FSCM credit management architecture during discovery. 1. Finance solution architect designs FSCM credit management architecture. 2. Credit risk manager defines credit policies and exposure monitoring processes. 3. SD functional lead integrates credit checks into order processing workflows. 4. Chief Financial Officer approves enterprise credit risk governance strategy.
Who gets blamed versus who owns it.
1. Blamed, finance architecture team executives believe credit controls were poorly designed. 2. Blamed, sales operations perceived as bypassing credit rules. 3. Actual owner, finance solution architect and chief financial officer responsible for enterprise credit risk architecture. 4. Root cause: FSCM credit architecture was never defined during discovery. Credit risk failures usually originate from delayed architectural decisions.
How this is actually fixed, the right way by a role.
1. Finance Solution Architect designs FSCM credit segments and exposure monitoring architecture. 2. Credit Risk Manager defines evaluation rules and credit limits for customers. 3. SD Functional Lead integrates credit checks into order management workflows. 4. Chief Financial Officer approves the Enterprise Credit Governance Framework.
What not to do, common wrong fixes.
1. Attempting to replicate classic ECC credit management configuration. 2. Deferring FSCM architecture decisions until realization. 3. Separating credit risk governance from sales order processing design. 4. Ignoring cross-company exposure monitoring requirements. Credit risk architecture must be defined before sales process design begins.
Follow-up 1. Why does S/4HANA require FSCM credit management instead of classic SD credit checks?
Answer: FSCM credit management centralizes credit risk evaluation across financial and operational processes. It allows exposure monitoring across multiple company codes and provides more advanced risk analysis capabilities.
Follow-up 2. What architectural decisions must be made for FSCM credit management?
Answer: architects must define credit segments, exposure calculation models, integration with sales order processing, and monitoring processes across financial and operational systems.
Follow-up 3. Curveball. What happens if organizations try to replicate ECC credit management behavior?
Answer: credit exposure monitoring becomes inconsistent, and sales order processing may bypass modern risk controls. This creates financial exposure and undermines enterprise credit governance.
Exclusive pro tip.
Treat credit management as a financial risk platform rather than a sales configuration topic. FSCM architecture must be designed with enterprise credit governance in mind.
Scenario 17. Output architecture using BRF plus not defined.
In the discover and prepare phase of ECC to S/4HANA migration, the organization fails to define how output management will operate in the new architecture. ECC systems relied heavily on NAST-based output processing for invoices, delivery notes, and order confirmations. S/4HANA replaces this framework with a BRF Plus-based output management architecture. When the strategy for BRF Plus output management is not defined early, document communication flows such as email, print, and EDI cannot be designed consistently across sales and distribution processes.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high communication and document output architecture impact. 2. Phase, discover and prepare. 3. Frequency, very common in large ECC conversions. 4. Primary ownership, enterprise architect. 5. Supporting SD billing lead. 6. Business ownership, order to cash process owner. 7. Relevant SAP note 2228611, output management in S/4HANA.
Diagnostic dashboard, symptoms and evidence.
How missing output architecture decisions appear during discovery and design. 1. Symptom, invoice and delivery output design still references legacy in a ST configuration. 2. Red flag, no architecture document defines BRF plus decision tables for output determination. 3. Business impact, customer invoices and order confirmations may fail to generate correctly. 4. Detection, review functional design documents for BRF plus output management decision tables. 5. Technical proof, integration between billing documents and BRF plus output framework is not defined. Insight, if output flows still reference in a ST, the BRF plus architecture decision was never finalized.
Why this happens, scenario analysis and root cause.
1. Teams assume existing ECC output configuration will migrate automatically. 2. Output management is treated as a minor configuration topic rather than an architecture change. 3. Discovery workshops focus on transaction flows instead of communication frameworks. 4. Organizations underestimate the design complexity of BRF plus decision tables. Output management redesign is often overlooked because it sits between functional and technical design.
Why this is a migration exclusive failure.
1. ECC relied on NAST tables to control output determination. 2. S/4HANA introduces BRF plus decision tables for output logic. 3. The architecture shifts output processing from configuration tables to rule-based frameworks. 4. Migration forces organizations to redesign document communication processes. The move from NAST to BRF plus fundamentally changes how output logic is defined.
Financial and customer impact.
1. Invoices fail to reach customers on time. 2. Delivery documents are not generated correctly for warehouse operations. 3. EDI integration with trading partners becomes unstable. 4. Customer service teams must manually resend documents. Output architecture failures directly impact customer communication and revenue cycles.
Governance and accountability, RACI model.
Output architecture must be governed jointly by enterprise architecture in order to cache leadership. 1. Accountable. Enterprise architect, the person responsible for defining the BRF plus output architecture, and gets fired if document communication fails after go live. 2. Responsible. SD billing lead defines invoice and billing output requirements. 3. Consulted. Integration architect validates email, EDI, and external communication flows. 4. Informed. Order-to-cash process owner oversees customer communication processes. Output architecture decisions must be finalized before billing process design is completed.
Ownership, who actually fixes it.
Resolving this requires designing BRF plus output architecture during the discovery phase. 1. Enterprise architect defines the BRF plus output management framework. 2. SD billing lead documents invoice, order confirmation, and delivery output requirements. 3. Integration architect designs communication channels including email and EDI. 4. Order-to-cash process owner validates customer communication workflows.
Who gets blamed versus who owns it.
1. Blamed. Billing team executives believe invoice configuration failed. 2. Blamed. Integration team perceived as misconfiguring communication channels. 3. Actual owner. Enterprise architect responsible for defining output management architecture. 4. Root cause. BRF plus output strategy was never defined during discovery. Most output failures originate from architecture gaps rather than billing configuration.
How this is actually fixed, the right way by a role.
1. Enterprise architect defines the BRF plus output management architecture and decision table structure. 2. SD billing lead maps output requirements for orders, deliveries, and invoices. 3. Integration architect designs document distribution channels including email and EDI. 4. Order-to-cash process owner approves the final communication strategy.
What not to do, common wrong fixes.
1. Attempting to replicate legacy in a ST configuration in S/4HANA. 2. Postponing output architecture design until system realization. 3. Separating billing design from communication architecture. 4. Ignoring external partner communication requirements. Output management must be designed as part of enterprise communication architecture.
Follow-up 1. Why did SAP replace NAST with BRF plus output management?
Answer: BRF plus provides rule-based output determination with flexible decision tables. This allows organizations to control document communication logic in a more scalable and maintainable framework.
Follow-up 2. What should architects define for output architecture?
Answer: they must define BRF plus decision tables, communication channels, document templates, and integration with external messaging platforms.
Follow-up 3. Curveball. What happens if organizations try to keep NAST-style logic?
Answer: output processing becomes unstable and difficult to maintain. Teams often create custom workarounds that increase technical debt and complicate future upgrades.
Exclusive pro tip.
Treat output management as an enterprise communication platform rather than a billing configuration. Designing BRF plus architecture early prevents document delivery failures after go live.
Scenario 18. Advanced ATP adoption decision not defined.
In the discover and prepare phase of ECC, the S/4HANA migration, the organization does not decide whether to adopt advanced available to promise capabilities. ECC systems relied on classic ATP logic for availability checks during order processing. S/4HANA introduces advanced ATP with new capabilities such as product allocation, backorder processing, and alternative-based confirmation. If the adoption decision is not made early, order fulfillment design becomes unstable because inventory availability logic cannot be finalized.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high order fulfillment architecture impact. 2. Phase, discover and prepare. 3. Frequency, very common in distribution and manufacturing programs. 4. Primary ownership, supply chain solution architect. 5. Supporting order fulfillment lead. 6. Business ownership, chief supply chain officer. 7. Relevant SAP note 2321191, advanced available to promise in S/4HANA.
Diagnostic dashboard, symptoms and evidence.
How missing advanced ATP decisions appear during solution design. 1. Symptom, order confirmation logic is unclear during sales order processing workshops. 2. Red flag, architecture documentation does not specify classic ATP or advanced ATP. 3. Business impact, inventory commitments become inconsistent across sales channels. 4. Detection, review system architecture documentation for advanced ATP activation and configuration decisions. 5. Technical proof, product allocation, backorder processing, and substitution strategies remain undefined. Insight, if order confirmation rules are unclear, the ATP architecture decision was never finalized.
Why this happens, scenario analysis and root cause.
1. Organizations assume classic ATP behavior will remain unchanged after migration. 2. Supply chain stakeholders are not involved early in architecture workshops. 3. Teams underestimate the operational impact of advanced ATP capabilities. 4. Discovery discussions focus on order entry rather than fulfillment optimization. ATP strategy is often delayed because it requires coordination between supply chain planning and order management.
Why this is a migration, exclusive failure.
1. ECC used classic ATP logic embedded in SD order processing. 2. S/4HANA introduces advanced ATP with a redesigned architecture for availability confirmation. 3. The new model supports allocation, substitution, and automated backorder processing. 4. Migration requires organizations to redefine how inventory commitments are managed. The shift from classic ATP to advanced ATP fundamentally changes order fulfillment logic.
Financial and customer impact.
1. Customer order confirmations become inconsistent. 2. Inventory allocation conflicts occur across multiple sales channels. 3. Backorder processing becomes manual and inefficient. 4. Revenue opportunities are lost due to incorrect availability confirmations. ATP architecture determines how reliably organizations promise delivery dates to customers.
Governance and accountability, RACI model.
ATP architecture decisions must be governed jointly by supply chain and order management leadership. 1. Accountable, supply chain solution architect, the person responsible for defining the ATP architecture and gets fired if order fulfillment logic fails after go live. 2. Responsible, order fulfillment lead defines order confirmation and inventory commitment rules. 3. Consulted, inventory planning lead validates supply allocation logic. 4. Informed, chief supply chain officer oversees enterprise fulfillment strategy. ATP decisions determine how inventory commitments are managed across the organization.
Ownership, who actually fixes it.
Resolving this requires defining ATP architecture before fulfillment design begins. 1. Supply chain solution architect evaluates advanced ATP capabilities for the organization. 2. Order fulfillment lead defines confirmation rules and delivery commitments. 3. Inventory planning lead aligns ATP logic with supply planning processes. 4. Chief Supply Chain Officer approves the final fulfillment architecture.
Who gets blamed versus who owns it.
1. Blamed. SD functional team executives believe order confirmation logic was poorly configured. 2. Blamed. Supply planning team perceived as mismanaging inventory allocation. 3. Actual owner, supply chain solution architect responsible for defining ATP architecture. 4. Root cause, advanced ATP adoption decision, was never finalized during discovery. Most fulfillment failures originate from missing ATP architecture decisions.
How this is actually fixed, the right way by a role.
1. Supply chain solution architect evaluates whether advanced ATP capabilities are required. 2. Order fulfillment lead defines confirmation rules and order allocation priorities. 3. Inventory planning lead aligns ATP logic with supply planning and stock allocation. 4. Chief Supply Chain Officer approves the final order fulfillment strategy.
What not to do, common wrong fixes.
1. Assuming classic ATP logic will continue unchanged. 2. Delaying ATP architecture decisions until realization phase. 3. Separating order fulfillment design from supply planning processes. 4. Ignoring product allocation and backorder processing capabilities. ATP architecture must be defined before order fulfillment configuration begins.
Follow-up 1. What advantages does advanced ATP provide over classic ATP?
Answer: advanced ATP introduces product allocation, automated backorder processing, substitution strategies, and advanced confirmation logic. These capabilities improve supply chain reliability and inventory utilization.
Follow-up 2. When should organizations adopt advanced ATP?
Answer: organizations with complex supply chains, high demand variability, or multi-channel sales operations benefit significantly from advanced ATP capabilities.
Follow-up 3. Curveball. What happens if advanced ATP is implemented without proper design?
Answer: inventory allocation, conflicts increase, and confirmation logic becomes unpredictable. Teams often disable advanced functionality, eliminating the benefits of the platform.
Exclusive pro tip.
Do not treat ATP as a simple configuration choice. Advanced ATP determines how supply commitments are managed across the entire supply chain.
Scenario 19. Settlement management adoption decision unclear.
In the discover and prepare phase of ECC to S/4HANA migration, the organization does not define how rebate and settlement processes will be handled in the new system. ECC relied on classic rebate agreements within sales and distribution. S/4HANA replaces this model with settlement management based on condition contracts. If the organization does not decide whether to adopt settlement management early, rebate processing architecture becomes unclear and financial settlement processes cannot be designed correctly.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high revenue settlement architecture impact. 2. Phase, discover and prepare. 3. Frequency, very common in consumer goods and distribution programs. 4. Primary ownership, revenue management solution architect. 5. Supporting pricing and rebates lead. 6. Business ownership, commercial finance director. 7. Relevant SAP note. SAP note 2267377. Settlement management and condition contract management simplification.
Diagnostic dashboard, symptoms and evidence.
How missing settlement architecture decisions appear during solution design. 1. Symptom: rebate process workshops cannot define how rebates will be calculated or settled. 2. Red flag: blueprint documentation still references legacy rebate agreements. 3. Business impact: rebate accruals and settlement calculations become inconsistent. 4. Detection: review pricing architecture documentation for condition contract management design. 5. Technical proof: integration between billing documents and settlement management processes is undefined. Insight: if rebate logic references ECC agreements, settlement management adoption was never decided.
Why this happens, scenario analysis and root cause.
1. Commercial teams assume existing rebate agreements will migrate automatically. 2. Pricing architecture discussions focus only on sales pricing rather than rebate settlements. 3. Organizations underestimate the operational impact of condition contract management. 4. Discovery workshops do not include commercial finance stakeholders. Settlement strategy is often delayed because it sits between pricing and financial accounting.
Why this is a migration, exclusive failure.
1. ECC used classic rebate agreements embedded in sales and distribution. 2. S/4HANA replaces rebate agreements with settlement management condition contracts. 3. The new model centralizes accrual calculations and financial settlements. 4. Migration requires organizations to redesign rebate management processes. The shift from rebate agreements to condition contracts fundamentally changes settlement architecture.
Financial and customer impact.
1. Incorrect rebate accruals distort margin analysis. 2. Settlement calculations become inconsistent across customers. 3. Financial reconciliation between SD and FI becomes unstable. 4. Commercial agreements with key customers become difficult to track. Settlement architecture directly influences revenue accuracy and financial reconciliation.
Governance and accountability. RACI model.
Settlement architecture decisions must be governed jointly by commercial finance and pricing leadership. 1. Accountable revenue management solution architect, the person responsible for defining settlement architecture and gets fired if rebate calculations fail after go live. 2. Responsible pricing and rebates lead defines rebate agreements and commercial settlement rules. 3. Consulted finance integration architect validates settlement postings to financial accounting. 4. Informed commercial finance director oversees revenue settlement governance. Settlement architecture decisions determine how commercial agreements are translated into financial postings.
Ownership. Who actually fixes it?
Resolving this requires defining settlement architecture during discovery. 1. Revenue management solution architect designs settlement management architecture. 2. Pricing and rebates lead documents rebate agreements and settlement logic. 3. Finance integration architect aligns settlement postings with financial accounting. 4. Commercial finance director approves the enterprise rebate management strategy.
Who gets blamed versus who owns it?
1. Blamed pricing team executives believe rebate calculations were configured incorrectly. 2. Blamed finance team perceived as mismanaging accrual reconciliation. 3. Actual owner revenue management solution architect responsible for defining settlement architecture. 4. Root cause settlement management adoption decision was never finalized during discovery. Most rebate failures originate from missing settlement architecture decisions.
How this is actually fixed. The right way by a role.
1. Revenue management solution architect evaluates settlement management capabilities for the organization. 2. Pricing and rebates lead defines rebate agreements and condition contract structures. 3. Finance integration architect aligns accrual postings with financial reporting requirements. 4. Commercial finance director approves the enterprise rebate settlement model.
What not to do. Common wrong fixes.
1. Attempting to replicate ECC rebate agreements in S4 HANA. 2. Deferring settlement architecture decisions until realization phase. 3. Separating rebate management design from financial settlement processes. 4. Ignoring the impact of settlement management on margin reporting. Settlement management architecture must be defined before pricing and billing design begins.
Follow-up 1. What advantages does settlement management provide over ECC rebate agreements?
Answer: settlement management centralizes rebate calculations using condition contracts and provides better integration with financial accounting and analytics.
Follow-up 2. When should organizations adopt settlement management?
Answer: organizations with complex rebate programs, promotional agreements, or large distribution networks benefit from condition contract management.
Follow-up 3. Curveball. What happens if organizations attempt to maintain legacy rebate logic?
Answer: rebate calculations become inconsistent and financial reconciliation becomes difficult. Custom workarounds increase technical debt and complicate future upgrades.
Exclusive pro tip.
Treat settlement management as a commercial revenue platform rather than a pricing configuration topic. Designing condition contract architecture early ensures accurate rebate settlements.
Scenario 20. Advanced variant configuration adoption decision unclear.
In the discover and prepare phase of ECC to S4 HANA migration, the organization does not define whether product configuration will continue using the classic variant configuration model or move to advanced variant configuration. ECC systems commonly use the classic configuration engine integrated with pricing and bill of materials logic. S4 HANA introduces advanced variant configuration, which operates on a redesigned architecture optimized for HANA performance. If the adoption decision is not defined early, product configuration architecture becomes unstable in manufacturing, pricing, and sales configuration logic cannot be finalized.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high product configuration architecture impact. 2. Phase, discover and prepare. 3. Frequency, common in manufacturing and engineer-to-order programs. 4. Primary ownership, manufacturing solution architect. 5. Supporting product configuration lead. 6. Business ownership, product engineering director. 7. Relevant SAP note. SAP note 2711932. Advanced variant configuration in S4 HANA.
Diagnostic dashboard, symptoms and evidence.
How unclear variant configuration architecture appears during solution design. 1. Symptom, product configuration workshops cannot define the configuration engine that will be used. 2. Red flag, design documents reference both classic configuration and advanced variant configuration without a decision. 3. Business impact, sales order configuration logic becomes inconsistent and manufacturing dependencies cannot be finalized. 4. Detection, review product configuration architecture documentation for advanced variant configuration adoption decisions. 5. Technical proof, dependency models and configuration rules are not aligned with the chosen configuration engine. Insight, if configuration models cannot be finalized, the configuration architecture decision was never made.
Why this happens, scenario analysis and root cause.
1. Organizations assume classic variant configuration will continue unchanged after migration. 2. Engineering teams are not involved early in system architecture discussions. 3. Teams underestimate the impact of configuration engine changes on manufacturing processes. 4. Discovery workshops focus on sales order configuration but ignore product engineering dependencies. Variant configuration architecture decisions require collaboration between sales, engineering, and manufacturing.
Why this is a migration, exclusive failure.
1. ECC used the classic variant configuration engine embedded within the ERP platform. 2. S4 HANA introduces advanced variant configuration optimized for HANA processing. 3. The new model changes dependency processing and configuration runtime architecture. 4. Migration requires organizations to decide whether to remain on classic configuration or adopt the new architecture. The introduction of advanced variant configuration forces organizations to rethink configuration architecture.
Financial and customer impact.
1. Incorrect product configuration leads to manufacturing errors. 2. Sales orders may generate invalid product combinations. 3. Engineering change management becomes difficult to manage. 4. Customer orders for configurable products may be delayed or rejected. Configuration architecture directly affects product accuracy and customer order fulfillment.
Governance and accountability, RACI model.
Variant configuration architecture must be governed jointly by engineering and manufacturing leadership. 1. Accountable, manufacturing solution architect, the person responsible for defining configuration architecture and gets fired if product configuration fails after go live. 2. Responsible, product configuration lead defines configuration models and dependency rules. 3. Consulted, engineering systems architect validates integration with engineering design systems. 4. Informed, product engineering director oversees enterprise product configuration strategy. Configuration architecture determines how configurable products are defined and sold.
Ownership, who actually fixes it.
Resolving this requires defining configuration architecture during discovery. 1. Manufacturing solution architect evaluates advanced variant configuration adoption. 2. Product configuration lead designs configuration models and dependency structures. 3. Engineering systems architect validates integration with engineering data systems. 4. Product engineering director approves the enterprise configuration strategy.
Who gets blamed versus who owns it.
1. Blamed, sales configuration team executives believe configuration models were implemented incorrectly. 2. Blamed, engineering team perceived as providing inconsistent configuration rules. 3. Actual owner, manufacturing solution architect responsible for defining variant configuration architecture. 4. Root cause, Advanced Variant Configuration Adoption Decision was never finalized during discovery. Configuration failures typically originate from architecture decisions, rather than configuration errors.
How this is actually fixed, the right way by a role.
1. Manufacturing Solution Architect evaluates whether advanced variant configuration should be adopted. 2. Product Configuration Lead defines configuration models and dependency structures. 3. Engineering Systems Architect aligns configuration rules with engineering product models. 4. Product Engineering Director approves the enterprise configuration architecture.
What not to do, common wrong fixes.
1. Assuming classic variant configuration will automatically work after migration. 2. Delaying configuration architecture decisions until realization. 3. Separating product configuration design from engineering product structures. 4. Ignoring configuration performance requirements in HANA environments. Configuration architecture must be finalized before manufacturing and sales configuration design begins.
Follow-up 1. What advantages does advanced variant configuration provide?
Answer: Advanced variant configuration improves configuration runtime performance, simplifies dependency models, and enables more scalable configuration logic for complex products.
Follow-up 2. When should organizations adopt advanced variant configuration?
Answer: Organizations with complex configurable products, large dependency models, or performance issues with classic configuration benefit significantly from adopting the new configuration engine.
Follow-up 3. Curveball. What happens if advanced variant configuration is adopted without proper preparation?
Answer: Configuration models may break during migration, and dependency logic may not behave as expected. This often forces teams to rebuild configuration models under tight project timelines.
Exclusive pro tip.
Variant configuration is not only a sales feature. It connects engineering, manufacturing, pricing, and logistics. Decide the configuration engine early to prevent product design instability.
Scenario 21. Revenue accounting integration architecture not defined.
In the discover and prepare phase of ECC to S/4HANA migration, the organization does not define how revenue recognition will integrate with sales processes. ECC systems often relied on classic SD revenue recognition logic or financial accounting adjustments. S/4HANA introduces revenue accounting and reporting as the central platform for managing complex revenue contracts and performance obligations. If the integration architecture between sales and distribution and revenue accounting is not defined early, revenue recognition processes cannot be designed correctly, and financial reporting becomes unstable.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, very high financial reporting and revenue recognition architecture impact. 2. Phase, discover and prepare. 3. Frequency, increasingly common in subscription software and project-based businesses. 4. Primary ownership, finance solution architect. 5. Supporting revenue accounting lead. 6. Business ownership, corporate controller. 7. Relevant SAP note. SAP note 22673119 and SAP note 2225170. Revenue accounting and reporting simplifications.
Diagnostic dashboard, symptoms and evidence.
How missing revenue accounting architecture decisions appear during discovery. 1. Symptom: revenue recognition workshops cannot define how sales contracts map to revenue accounting objects. 2. Red flag: architecture documentation references classic SD revenue recognition logic. 3. Business impact: revenue postings cannot be reconciled correctly with financial reporting. 4. Detection: review architecture diagrams for integration flows between sales documents and revenue accounting contracts. 5. Technical proof: performance obligation derivation logic and contract identification rules remain undefined. Insight: if revenue recognition logic cannot be defined, the revenue accounting architecture decision was never finalized.
Why this happens, scenario analysis and root cause.
1. Finance teams assume existing revenue recognition processes will remain unchanged after migration. 2. Architecture discussions focus on billing processes rather than revenue recognition requirements. 3. Organizations underestimate the complexity of revenue accounting contract management. 4. Discovery workshops exclude revenue accounting specialists. Revenue recognition architecture requires coordination between finance governance and order management.
Why this is a migration, exclusive failure.
1. ECC allowed revenue recognition logic embedded within SD processes. 2. S4 HANA introduces revenue accounting and reporting as a separate financial platform. 3. Revenue recognition is now driven by contracts and performance obligations. 4. Migration requires organizations to redesign how sales transactions trigger revenue events. The shift to revenue accounting introduces a new financial architecture for revenue recognition.
Financial and customer impact.
1. Revenue postings become inconsistent across financial reporting periods. 2. Contract-based revenue cannot be reconciled with sales transactions. 3. Financial closing cycles become longer due to manual adjustments. 4. Audit compliance risks increase due to inaccurate revenue reporting. Revenue recognition architecture directly impacts financial compliance and reporting accuracy.
Governance and accountability, RACI model.
Revenue recognition architecture must be governed jointly by finance leadership and enterprise architecture. 1. Accountable, finance solution architect, the person responsible for defining revenue accounting architecture and gets fired if revenue recognition fails after go live. 2. Responsible, revenue accounting lead defines contract identification and performance obligation logic. 3. Consulted, SD billing lead validates integration between billing and revenue recognition processes. 4. Informed, corporate controller oversees enterprise revenue governance and financial compliance. Revenue architecture determines how financial reporting reflects sales transactions.
Ownership, who actually fixes it.
Resolving this requires defining revenue accounting architecture during discovery. 1. Finance solution architect designs revenue accounting integration architecture. 2. Revenue accounting lead defines contract identification and revenue recognition rules. 3. SD billing lead aligns billing events with revenue accounting triggers. 4. Corporate controller approves the enterprise revenue governance framework.
Who gets blamed versus who owns it.
1. Blamed billing team executives believe billing configuration created incorrect revenue postings. 2. Blamed finance reporting team perceived as mismanaging revenue reconciliation. 3. Actual owner, finance solution architect responsible for defining revenue accounting architecture. 4. Root cause, revenue accounting integration architecture was never defined during discovery. Most revenue recognition failures originate from missing architecture decisions.
How this is actually fixed, the right way by a role.
1. Finance solution architect defines the revenue accounting integration architecture. 2. Revenue accounting lead designs contract identification and performance obligation rules. 3. SD billing lead maps billing events to revenue recognition triggers. 4. Corporate controller approves the final revenue governance model.
What not to do, common wrong fixes.
1. Attempting to replicate classic SD revenue recognition logic. 2. Deferring revenue accounting architecture decisions until realization. 3. Separating revenue recognition design from sales contract structures. 4. Ignoring financial reporting and audit compliance requirements. Revenue recognition architecture must be defined before billing design begins.
Follow-up 1. Why does S4 HANA introduce revenue accounting and reporting?
Answer: revenue accounting supports modern revenue recognition standards such as IFRS 15 and ASC 606. It manages contracts, performance obligations, and revenue allocation with improved compliance and transparency.
Follow-up 2. When should organizations implement revenue accounting?
Answer: organizations with subscription services, long-term contracts, bundled products, or complex revenue allocation models benefit significantly from revenue accounting capabilities.
Follow-up 3. Curveball. What happens if revenue accounting is activated without proper design?
Answer: revenue contracts may be created incorrectly, and revenue postings become inconsistent across financial periods. This can cause severe financial reporting errors and audit issues.
Exclusive pro tip.
Treat revenue recognition as a financial architecture topic rather than a billing configuration. Designing revenue accounting integration early prevents financial reporting instability after go live.
Scenario 22. Flexible workflow architecture not defined.
In the discover and prepare phase of ECC to S/4HANA migration, the organization does not define how approval workflows will operate in the new system. ECC systems commonly relied on classic release strategies and custom workflow developments for approvals in areas such as credit release, billing blocks, and pricing changes. S/4HANA introduces flexible workflow, which is designed to replace many traditional approval mechanisms. If the workflow architecture is not defined early, approval processes become inconsistent and governance controls cannot be properly designed.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, medium approval governance architecture impact. 2. Phase, discover and prepare. 3. Frequency, very common in complex approval environments. 4. Primary ownership, enterprise architect. 5. Supporting workflow design lead. 6. Business ownership, governance and compliance director. 7. Relevant SAP note, not applicable extensibility gap. This is a workflow governance design failure rather than an SAP software change. No specific note exists as it is about not defining approval architecture during discovery. Reference SAP Note 2198647 for custom code adaptation and extensibility context only.
Diagnostic dashboard, symptoms and evidence.
How missing workflow architecture decisions appear during solution design. 1. Symptom, approval processes for pricing, billing blocks, or credit release cannot be defined. 2. Red flag, design documents still reference classic release strategies from ECC. 3. Business impact, approvals become inconsistent and governance controls weaken. 4. Detection, review architecture documentation for flexible workflow design and approval rule definitions. 5. Technical proof, workflow triggers, approval hierarchies and escalation paths remain undefined. Insight, if approval processes cannot be mapped, the flexible workflow architecture was never finalized.
Why this happens, scenario analysis and root cause.
1. Organizations assume classic release strategies will continue unchanged. 2. Governance teams are not involved early in system design workshops. 3. Workflow architecture is treated as a technical topic rather than a governance framework. 4. Teams underestimate the operational impact of flexible approval rules. Approval governance often fails because workflow architecture is not addressed during discovery.
Why this is a migration, exclusive failure.
1. ECC relied on release strategies and custom workflow logic. 2. S/4HANA introduces flexible workflow to manage approval processes using rule-based configuration. 3. The new model centralizes approval governance and improves transparency. 4. Migration forces organizations to redesign approval processes around the new framework. Flexible workflow introduces a new governance architecture for approvals.
Financial and customer impact.
1. Pricing approvals may be bypassed or delayed. 2. Credit releases become inconsistent across sales teams. 3. Billing approvals slow down order-to-cash cycles. 4. Governance and compliance risks increase. Approval workflow failures undermine operational governance and financial controls.
Governance and accountability, RACI model.
Workflow architecture must be governed jointly by enterprise architecture and compliance leadership. 1. Accountable. Enterprise architect, the person responsible for defining workflow architecture, and gets fired if approval governance fails after go live. 2. Responsible. Workflow design lead defines approval rules, escalation paths, and workflow triggers. 3. Consulted. SD functional lead validates workflow integration with order-to-cash processes. 4. Informed. Governance and compliance director oversees approval governance policies. Workflow architecture determines how operational approvals are enforced across the enterprise.
Ownership, who actually fixes it.
Resolving this requires defining workflow architecture during discovery. 1. Enterprise architect designs the flexible workflow architecture. 2. Workflow design lead defines approval hierarchies and rule conditions. 3. SD functional lead integrates workflow triggers with sales processes. 4. Governance and compliance director approves the final approval governance framework.
Who gets blamed versus who owns it?
1. Blamed. SD functional team executives believe approval logic was configured incorrectly. 2. Blamed. IT workflow team perceived as misconfiguring workflow automation. 3. Actual owner, enterprise architect responsible for defining workflow architecture. 4. Root cause, flexible workflow architecture was never defined during discovery. Most approval failures originate from missing governance architecture.
How this is actually fixed, the right way by a role.
1. Enterprise architect defines the flexible workflow architecture and governance model. 2. Workflow design lead creates approval rule structures and escalation paths. 3. SD functional lead integrates workflow triggers with sales processes. 4. Governance and compliance director approves the final approval governance design.
What not to do, common wrong fixes.
1. Attempting to replicate classic release strategies exactly. 2. Deferring workflow architecture decisions until realization. 3. Separating approval design from governance policy discussions. 4. Ignoring escalation rules and approval delegation structures. Workflow architecture must be defined before operational process design is finalized.
Follow-up 1. What advantages does flexible workflow provide?
Answer: flexible workflow allows organizations to define approval rules dynamically using business conditions rather than rigid release strategies. This improves governance flexibility and transparency.
Follow-up 2. Which processes typically use flexible workflow in S/4HANA?
Answer: common examples include sales order approvals, billing blocks, purchase approvals, and financial document approvals.
Follow-up 3. Curveball. What happens if organizations ignore flexible workflow capabilities?
Answer: they often rebuild legacy approval logic using custom developments, which increases technical complexity and reduces the benefits of modern workflow automation.
Exclusive pro tip.
Treat workflow architecture as a governance platform rather than a technical configuration. Designing flexible workflow early ensures that approval controls scale across the enterprise.
Scenario 23. Data aging and archiving strategy not defined.
In the discover and prepare phase of ECC to S/4HANA migration, the organization does not define a strategy for data aging and archiving. ECC systems often accumulated large volumes of historical SD documents such as sales orders, deliveries, and billing records. S/4HANA introduces advanced data aging and information lifecycle management capabilities that require clear governance decisions. If a strategy is not defined early, system performance, storage costs, and reporting accuracy can become difficult to manage after migration.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, medium data lifecycle and performance architecture impact. 2. Phase, discover and prepare. 3. Frequency, common in large enterprises with high transaction volumes. 4. Primary ownership, data architecture lead. 5. Supporting basis performance lead. 6. Business ownership, data governance director. 7. Relevant SAP note. SAP note 1616302. Information lifecycle management and data aging policy.
Diagnostic dashboard, symptoms and evidence.
How missing data aging and archiving strategies appear during migration planning. 1. Symptom: data migration scope includes excessive volumes of historical SD documents. 2. Red flag: no documented data lifecycle policy exists for operational and historical records. 3. Business impact: system performance declines due to unnecessary historical data loads. 4. Detection: review migration scope documents for archiving and data aging policies. 5. Technical proof: HANA storage projections increase dramatically due to historical document migration. Insight: if historical documents are migrated without filtering, the data lifecycle strategy was never defined.
Why this happens, scenario analysis and root cause.
1. Organizations assume all ECC historical data must be migrated into S/4HANA. 2. Data governance teams are not involved early in migration planning. 3. Project teams focus on system conversion rather than data lifecycle optimization. 4. Historical data volumes are underestimated during system sizing exercises. Data lifecycle governance is often overlooked during early migration planning.
Why this is a migration exclusive failure.
1. ECC environments tolerated large volumes of historical data using traditional database architectures. 2. S/4HANA introduces in-memory storage where excessive historical data increases infrastructure cost. 3. Data aging allows older records to remain accessible while reducing operational database load. 4. Migration requires organizations to redesign how historical data is stored and accessed. S/4HANA forces organizations to rethink the life cycle of operational data.
Financial and customer impact.
1. Infrastructure costs increase due to unnecessary storage requirements. 2. System performance declines when operational tables grow excessively large. 3. Analytics and reporting queries become slower due to large historical datasets. 4. Data governance risks increase when retention policies are unclear. Data lifecycle architecture directly impacts system performance and infrastructure cost.
Governance and accountability, RACI model.
Data lifecycle architecture must be governed jointly by data governance and system architecture leadership. 1. Accountable data architecture lead the person responsible for defining data lifecycle strategy and gets fired if system performance collapses due to excessive data volumes. 2. Responsible basis performance lead analyzes system sizing and storage impact. 3. Consulted SD functional lead identifies operational data that must remain accessible. 4. Informed data governance director oversees enterprise data retention policies. Data lifecycle governance determines how operational and historical data are managed.
Ownership, who actually fixes it.
Resolving this requires defining data aging and archiving strategies during discovery. 1. Data architecture lead designs the enterprise data lifecycle strategy. 2. Basis performance lead evaluates HANA storage impact for historical data. 3. SD functional lead identifies operational documents required for reporting and compliance. 4. Data governance director approves the final data retention and archiving policy.
Who gets blamed versus who owns it.
1. Blamed basis team executives believe infrastructure sizing was incorrect. 2. Blamed data migration team perceived as loading unnecessary historical data. 3. Actual owner data architecture lead responsible for defining data lifecycle architecture. 4. Root cause, data aging and archiving strategy was never defined during discovery. Performance issues caused by excessive data volumes usually originate from missing lifecycle strategy.
How this is actually fixed, the right way by a role.
1. Data architecture lead defines data aging and archiving policies for operational and historical data. 2. Basis performance lead analyzes system sizing impact and storage projections. 3. SD functional lead determines which documents must remain available for operational reporting. 4. Data governance director approves the enterprise data lifecycle policy.
What not to do, common wrong fixes.
1. Migrating all ECC historical data without evaluation. 2. Deferring data lifecycle decisions until after migration. 3. Ignoring data retention regulations and compliance requirements. 4. Treating archiving as a technical activity rather than a governance decision. Data lifecycle architecture must be defined before data migration scope is finalized.
Follow-up 1. What is the purpose of data aging in S/4HANA?
Answer: data aging allows older transactional records to remain accessible while reducing the load on operational tables. This improves system performance and reduces infrastructure costs.
Follow-up 2. How should organizations decide which data to archive?
Answer: they should analyze operational reporting needs, legal retention policies, and system performance requirements before defining retention periods for different document types.
Follow-up 3. Curveball. What happens if organizations ignore data aging capabilities?
Answer: system storage costs increase rapidly and operational tables grow excessively large. Over time, reporting performance and system stability degrade.
Exclusive pro tip.
Treat data lifecycle design as part of system architecture rather than a post-migration cleanup task. A clear archiving strategy protects system performance and reduces infrastructure cost.
Scenario 24. Transportation Zone Redesign Strategy Unclear.
In the discover and prepare phase of ECC to S/4HANA migration, the organization does not define how transportation zones will be redesigned for the new logistics architecture. ECC systems often relied on transportation zones configured within the legacy LETRA framework for route determination and shipment planning. When organizations migrate to S/4HANA and adopt modern logistics platforms, transportation zones often need to be restructured. If this redesigned strategy is not defined early, route determination logic becomes inconsistent, and transportation planning processes cannot be finalized.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, medium logistics network design impact. 2. Phase, discover and prepare. 3. Frequency, common in global distribution and manufacturing organizations. 4. Primary ownership, logistics solution architect. 5. Supporting transportation planning lead. 6. Business ownership, global logistics director. 7. Relevant SAP note. SAP note 2267317. Logistics execution simplification and transportation management transition.
Diagnostic dashboard, symptoms and evidence.
How transportation zone redesign gaps appear during architecture planning. 1. Symptom, route determination logic cannot be finalized during logistics workshops. 2. Red flag, legacy ECC transportation zones are copied directly without evaluation. 3. Business impact, shipment planning and freight calculation become inconsistent. 4. Detection, review route determination design for updated transportation zone definitions. 5. Technical proof, transportation zones do not align with modern logistics network structures. Insight, if route determination logic cannot be validated, transportation zone design was never redefined.
Why this happens, scenario analysis and root cause.
1. Organizations assume legacy transportation zones will remain valid after migration. 2. Logistics teams focus on warehouse design rather than transportation network structure. 3. Discovery workshops do not include transportation planning specialists. 4. Teams underestimate the impact of transportation zone changes on route determination. Transportation zone strategy often fails because logistics architecture discussions focus only on warehouse processes.
Why this is a migration, exclusive failure.
1. ECC transportation zones were designed around the legacy logistics execution model. 2. S/4HANA introduces new logistics architectures that integrate warehouse and transportation platforms. 3. Transportation zones must align with updated route determination logic. 4. Migration exposes inconsistencies between legacy zone structures and modern logistics networks. Transportation zone redesign becomes necessary when logistics architecture evolves.
Financial and customer impact.
1. Incorrect route determination increases transportation costs. 2. Shipment scheduling becomes unreliable. 3. Delivery lead times become inconsistent across regions. 4. Customer satisfaction declines due to delivery delays. Transportation network design directly impacts logistics cost and delivery reliability.
Governance and accountability, RACI model.
Transportation zone architecture must be governed jointly by logistics architecture and transportation planning leadership. 1. Accountable, logistics solution architect, the person responsible for transportation network architecture and gets fired if route determination fails after go live. 2. Responsible, transportation planning lead defines route planning and shipment optimization rules. 3. Consulted, supply chain network design lead validates transportation zone alignment with distribution networks. 4. Informed, global logistics director oversees enterprise transportation strategy. Transportation zone design determines how logistics networks operate across regions.
Ownership, who actually fixes it.
Resolving this requires redesigning transportation zones during discovery. 1. Logistics solution architect defines the transportation zone architecture. 2. Transportation planning lead maps shipment planning requirements to zone structures. 3. Supply chain network design lead aligns zones with distribution networks. 4. Global Logistics Director approves the enterprise transportation network strategy.
Who gets blamed versus who owns it.
1. Blamed, logistics operations team executives believe route planning was configured incorrectly. 2. Blamed, transportation planning team perceived as mismanaging shipment design. 3. Actual owner, logistics solution architect responsible for defining transportation zone architecture. 4. Root cause, transportation zone redesign strategy was never defined during discovery. Route determination failures typically originate from missing network architecture decisions.
How this is actually fixed, the right way by a role.
1. Logistics solution architect redesigns transportation zones aligned with logistics network strategy. 2. Transportation planning lead defines route determination logic using updated zone structures. 3. Supply chain network design lead validates zone alignment with distribution and carrier networks. 4. Global logistics director approves the enterprise transportation architecture.
What not to do, common wrong fixes.
1. Copying ECC transportation zones without redesign. 2. Deferring route determination design until realization. 3. Separating transportation planning from network design decisions. 4. Ignoring the impact of logistics platform integration. Transportation zone architecture must be defined before route determination configuration begins.
Follow-up 1. Why must transportation zones be redesigned during S4 HANA migration?
Answer: transportation zones must align with updated logistics architectures and route determination logic. Legacy ECC zones often reflect outdated distribution structures.
Follow-up 2. What factors influence transportation zone design?
Answer: key factors include distribution center locations, carrier networks, shipping regions, and transportation planning optimization requirements.
Follow-up 3. Curveball. What happens if transportation zones remain unchanged?
Answer: route determination becomes inaccurate, and shipment planning may not reflect the real logistics network. This increases transportation cost and reduces delivery reliability.
Exclusive pro tip.
Treat transportation zones as part of supply chain network design rather than a simple configuration object. Redesigning them early ensures route determination logic remains stable after migration.
Scenario 25. Public cloud extensibility limits not assessed.
In the discover and prepare phase of ECC to S4HANA migration, the organization does not evaluate the extensibility limitations of the public cloud deployment model. ECC environments typically relied on extensive custom developments, user exits, and enhancements across sales and distribution processes. S4HANA Public Cloud introduces strict clean core principles that restrict traditional customization approaches. If extensibility limits are not assessed early, critical SD processes may depend on enhancements that cannot be implemented in the cloud environment.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, very high platform architecture and extensibility impact. 2. Phase, discover and prepare. 3. Frequency, increasingly common in cloud transformation programs. 4. Primary ownership, enterprise architect. 5. Supporting extensibility architecture lead. 6. Business ownership, chief information officer. 7. Relevant SAP note. SAP note 2973248. S4HANA Cloud Extensibility Framework.
Diagnostic dashboard, symptoms and evidence.
How unassessed extensibility limits appear during system architecture planning. 1. Symptom: business processes rely heavily on legacy user exits and custom enhancements. 2. Red flag: architecture documents assume custom ABAP development will be allowed in the cloud environment. 3. Business impact: critical SD processes cannot be implemented due to platform restrictions. 4. Detection: review custom code inventory and enhancement dependencies during discovery. 5. Technical proof: custom logic requires modification of core ERP objects that are restricted in the cloud environment. Insight: if custom enhancements drive critical processes, extensibility constraints must be evaluated before cloud adoption.
Why this happens, scenario analysis and root cause.
1. Organizations assume that all ECC customizations can be replicated in the cloud. 2. Architecture discussions focus on infrastructure rather than extensibility models. 3. Teams underestimate the impact of clean core principles. 4. Discovery workshops do not analyze custom code dependencies in detail. Cloud transformation fails when extensibility constraints are ignored.
Why this is a migration, exclusive failure.
1. ECC allowed extensive modification of core ERP logic using enhancements and user exits. 2. S/4HANA Public Cloud enforces clean core principles with restricted modification capabilities. 3. Custom developments must follow in app extensibility or side-by-side extension models. 4. Migration requires organizations to redesign how custom business logic is implemented. Cloud architecture fundamentally changes how customization is implemented.
Financial and customer impact.
1. Critical business processes may require redesign due to extensibility limitations. 2. Unexpected development costs arise when extensions must be rebuilt using new frameworks. 3. Project timelines extend as custom code is re-engineered. 4. Operational processes may temporarily lose functionality after migration. Extensibility architecture decisions directly influence project cost and system capability.
Governance and accountability, RACI model.
Extensibility architecture must be governed jointly by enterprise architecture and platform governance leadership. 1. Accountable. Enterprise architect, the person responsible for defining extensibility architecture, and gets fired if critical functionality cannot be implemented after go live. 2. Responsible. Extensibility architecture lead evaluates extension models and custom development options. 3. Consulted. SD functional lead identifies business processes requiring extensions. 4. Informed. Chief Information Officer oversees enterprise platform governance. Extensibility architecture determines how custom functionality is implemented in cloud environments.
Ownership, who actually fixes it.
Resolving this requires evaluating extensibility options during discovery. 1. Enterprise architect defines the extensibility architecture for the cloud platform. 2. Extensibility architecture lead evaluates in-app extensions and side-by-side extension models. 3. SD functional lead identifies business logic that requires customization. 4. Chief Information Officer approves the enterprise extensibility strategy.
Who gets blamed versus who owns it.
1. Blamed. Development team executives believe custom functionality was implemented incorrectly. 2. Blamed. Functional teams perceived as designing processes that require excessive customization. 3. Actual owner. Enterprise architect responsible for defining extensibility architecture. 4. Root cause. Public cloud extensibility limits were not assessed during discovery. Extensibility failures originate from platform architecture decisions rather than development errors.
How this is actually fixed, the right way by a role.
1. Enterprise architect evaluates extensibility constraints of the cloud platform. 2. Extensibility architecture lead defines extension patterns for custom logic. 3. SD functional lead identifies business processes requiring extensions. 4. Chief Information Officer approves the enterprise extensibility governance model.
What not to do, common wrong fixes.
1. Assuming ECC-style custom development will be supported in the cloud. 2. Ignoring clean core principles during solution design. 3. Delaying extensibility decisions until development phases. 4. Underestimating the complexity of rebuilding custom enhancements. Extensibility architecture must be defined before selecting the deployment model.
Follow-up 1. What are the primary extensibility models in S/4HANA Public Cloud?
Answer: S/4HANA Public Cloud supports in-app extensibility for lightweight customizations and side-by-side extensions on the SAP Business Technology Platform for advanced logic.
Follow-up 2. Why is the clean core principle important in S/4HANA?
Answer: clean core ensures that standard SAP functionality remains unchanged, allowing faster upgrades and reducing long-term maintenance complexity.
Follow-up 3. Curveball. What happens if organizations ignore extensibility constraints?
Answer: critical custom functionality may become impossible to implement in the selected deployment model, forcing expensive redesign or migration delays.
Exclusive pro tip.
Always analyze custom code dependencies before choosing the S/4HANA deployment model. Extensibility limitations can fundamentally change how business processes must be implemented.
Scenario 26. Rise with SAP service level agreements impact on SD downtime.
In the discover and prepare phase of ECC to S/4HANA migration, organizations adopt the RISE with SAP operating model without fully evaluating how SAP managed infrastructure and service level agreements impact system availability. ECC environments often allowed companies to control maintenance windows, upgrade schedules, and operational downtime. Under RISE with SAP, many infrastructure operations are managed by SAP according to predefined service agreements. If this operational model is not evaluated early, critical SD processes such as order entry, delivery processing, and billing may face downtime during business-critical periods.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high operational governance and availability impact. 2. Phase, discover and prepare. 3. Frequency, increasingly common in cloud transformation programs. 4. Primary ownership, enterprise architect. 5. Supporting basis operations lead. 6. Business ownership, chief information officer. 7. Relevant SAP note, not applicable scope and project strategy. This is an operational governance and service management failure, not an SAP software change. No specific SAP note exists as it is about evaluating service-level agreements and operational downtime policies during discovery.
Diagnostic dashboard, symptoms and evidence.
How operational downtime governance gaps appear in RISE with SAP programs. 1. Symptom, business teams discover that maintenance windows are scheduled during operational hours. 2. Red flag, architecture documents focus on infrastructure but ignore service-level agreement terms. 3. Business impact, order processing or billing activities stop during scheduled maintenance windows. 4. Detection, review RISE with SAP service agreements for downtime scheduling policies. 5. Technical proof, maintenance windows conflict with peak order entry or month-end billing periods. Insight, infrastructure may be modernized, but operational control shifts significantly under managed cloud services.
Why this happens, scenario analysis and root cause.
1. Organizations focus heavily on infrastructure modernization rather than operational governance. 2. Architecture discussions do not include detailed review of service-level agreements. 3. Business teams assume operational control remains similar to ECC environments. 4. Discovery workshops prioritize technology adoption instead of operational availability requirements. Operational governance often becomes an afterthought during cloud adoption discussions.
Why this is a migration, exclusive failure.
1. ECC environments allowed organizations to control maintenance windows and infrastructure upgrades. 2. RISE with SAP introduces managed infrastructure where operational schedules follow predefined agreements. 3. Downtime policies may conflict with critical business transaction windows. 4. Migration introduces a new operating model that changes operational control over system availability. Cloud operating models fundamentally change how system downtime is governed.
Financial and customer impact.
1. Order entry interruptions directly impact revenue generation. 2. Billing delays disrupt financial closing timelines. 3. Delivery processing pauses affect customer fulfillment commitments. 4. Operational downtime damages customer confidence during peak sales periods. Operational downtime planning directly affects revenue and customer satisfaction.
Governance and accountability, RACI model.
Operational governance in managed cloud environments must be clearly defined across architecture and operations leadership. 1. Accountable, enterprise architect, the person responsible for evaluating the operational architecture and gets fired if business-critical processes fail due to service-level agreement downtime. 2. Responsible, basis operations lead reviews service-level agreements and operational scheduling constraints. 3. Consulted, SD functional lead identifies business-critical transaction windows that must remain available. 4. Informed, chief information officer oversees enterprise operational governance. Operational architecture must align with real business transaction patterns.
Ownership, who actually fixes it.
Resolving this requires aligning operational service agreements with business transaction cycles. 1. Enterprise architect evaluates the operational governance model of RISE with SAP. 2. Basis operations lead reviews service level agreements and maintenance window policies. 3. SD functional lead identifies peak transaction periods that must remain uninterrupted. 4. Chief Information Officer approves operational availability governance.
Who gets blamed versus who owns it?
1. Blamed basis operations team executives believe system downtime is caused by operational mismanagement. 2. Blamed infrastructure provider perceived as scheduling maintenance during business hours. 3. Actual owner enterprise architect responsible for evaluating operational service models during discovery. 4. Root cause service level agreement impacts on business operations were never evaluated. Operational downtime issues usually originate from architecture governance gaps rather than technical failures.
How this is actually fixed, the right way by a role.
1. Enterprise architect evaluates the managed service operating model before platform adoption. 2. Basis operations lead negotiates maintenance window policies aligned with business needs. 3. SD functional lead documents business critical transaction cycles. 4. Chief Information Officer approves the operational governance framework.
What not to do, common wrong fixes.
1. Assuming operational control remains identical to ECC environments. 2. Ignoring service-level agreement details during architecture planning. 3. Deferring operational governance decisions until go live. 4. Allowing maintenance windows to conflict with business-critical transaction cycles. Operational governance must be defined before adopting managed cloud infrastructure.
Follow-up 1. Why do service-level agreements matter in S4 HANA cloud programs?
Answer: service-level agreements define system availability, maintenance windows, and operational responsibilities. These directly influence when business processes can run.
Follow-up 2. Which SD processes are most sensitive to downtime?
Answer: order entry, delivery processing, billing, and month-end financial postings are highly sensitive to system availability.
Follow-up 3. Curveball. What happens if downtime occurs during peak order periods?
Answer: revenue generation stops immediately because order processing and billing cannot occur. This creates operational chaos and damages customer relationships.
Exclusive pro tip.
Always evaluate managed cloud operating models before finalizing architecture decisions. Infrastructure modernization without operational governance alignment can create hidden availability risks.
Phase 1 Category 2 Wrap-up. Architecture decisions define system survivability.
The architecture risks we just explored reveal a critical truth about S4 HANA migrations. These failures are not caused by configuration mistakes or testing defects. They originate from architectural decisions that were never made or were made incorrectly during the discover and prepare phase. Decisions about EWM deployment, transportation management integration, credit management architecture, output frameworks, extensibility models, and cloud operating structures determine whether the future system will be stable, scalable, and maintainable. If these decisions are delayed or misunderstood, the entire migration inherits structural weaknesses that surface much later during design, testing, or production operations.
Phase 1 Wrap-up. Discover and prepare is where most migrations are already won or lost.
Phase 1 incidents demonstrate that the most dangerous failures in an S4 HANA program occur before the system is even built. Scope definition gaps, integration blindness, incorrect volume assumptions, missing seasonality analysis, undefined global template governance, and incomplete architecture decisions create hidden structural risks. These issues do not appear immediately. Instead, they emerge later as performance failures, integration breakdowns, or operational instability. Successful S4 HANA programs treat the discover and prepare phase as architectural engineering rather than project kickoff administration.
Transition from architecture planning to system design reality.
Phase 1 focused on defining scope, integration boundaries, operational models, and system architecture. Those decisions determine whether the future system is structurally sound, but the explore phase introduces a completely different challenge. This is where organizations confront the technical reality of S4 HANA simplifications. Legacy ECC assumptions about tables, document structures, pricing models, analytics, and integration behavior begin to break down. The next set of incidents reveals how deeply S/4HANA changes the underlying data and process architecture.
Please check description or comment section of this video. I have given a lot of links for downloading 7 or 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked system design, most asked implementation project-related interview questions and answers, most asked support project-related interview questions and answers, required for your SAP functional modules interviews jobs like SAP MM consultant jobs, SAP FICO consultant jobs, SAP SD consultant jobs, SAP PP consultant jobs, SAP Ariba consultant jobs, SAP Extended Warehouse Management EWM consultant jobs, SAP Plant Maintenance PM consultant jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section, these questions and answers will be helpful for freshers, 2 to 3 years experienced people and 5 or above years experienced people also for your interviews. You people can download all 7 or 8 PDFs in a single zip file from below given links.
Phase 2, Explore Phase, where simplifications break legacy assumptions.
Once scope and architecture are defined, the program enters the Explore phase. This is where the most fundamental transformation of SAP occurs. S/4HANA introduces deep simplifications across data models, pricing structures, logistics objects, finance integration, and analytics frameworks. Many legacy ECC assumptions about tables, document structures, reporting models, and integration logic no longer hold true. Organizations that treat S/4HANA as a simple system upgrade quickly discover that the underlying data architecture has changed dramatically.
Phase 2 categories, Explore Phase risk domains.
The Explore phase introduces 3 major categories of design risks where ECC assumptions frequently collide with S/4HANA simplifications. Category 1, Simplification Item and Data Model Risks. Category 2, Master Data and Customer Vendor Integration Design Risks. Category 3, Process Design Risks and Behavioral Delta between ECC and S/4HANA. These categories represent the areas where most design workshops underestimate the depth of S/4HANA transformation.
Phase 2 Category 1, Simplification Item and Data Model Risks.
The first category focuses on one of the most underestimated aspects of S/4HANA migration, the simplification of core data models. Tables that existed for decades in ECC have been replaced, consolidated, or removed. Pricing structures changed. Logistics documents changed. Analytics moved from aggregated statistics to real-time CDS models. Compatibility views often hide these changes temporarily, which creates a dangerous illusion that legacy logic still works. In reality, these data model shifts affect pricing, reporting, credit management, logistics execution, finance integration, and revenue recognition.
Category 1 Incident List, Simplification Item and Data Model Risks.
27. KONV replaced by PRCD_elements not assessed. Relevant SAP Note, SAP Note 2267308, Pricing Data Model Simplification. 28. SD Custom Reports reading obsolete tables. Relevant SAP Note, SAP Note 2227014, SD Simplification List. 29. VBFA Logic Assumptions Invalid. Relevant SAP Note, SAP Note 2198647, Custom Code Adaptation. 30. LIS Statistics Structures Removed Impact Not Assessed. Relevant SAP Note, SAP Note 2267306, SD Analytics and LIS Replacement. 31. SD Credit Tables Obsolete Usage. Relevant SAP Note, SAP Note 2270544, Credit Management Simplification. 32. Compatibility Views Masking Logic Issues. Relevant SAP Note, SAP Note 2198647, S4 HANA Compatibility Views. 33. MATDOC Impact on SD Analytics. Relevant SAP Note, SAP Note 2206980, MATDOC Data Model. 34. Output Model Redesign Underestimated. Relevant SAP Note, SAP Note 2228611, Output Management and BRF Plus Strategy. 35. Rebates Replaced by Settlement Management Design Gaps. Relevant SAP Note, SAP Note 2267377, Condition Contract Management. 36. Credit Management Redesign Gaps with FSCM. Relevant SAP Note, SAP Note 2267311, FSCM Credit Management. 37. Foreign Trade Replaced by International Trade Classification Gaps. Relevant SAP Note, SAP Note 2267310, Foreign Trade Deprecation. 38. CS Service Order Replaced by S4 HANA Service Object Migration Gaps. Relevant SAP Note, SAP Note 2267331, CS to S4 HANA Service. 39. Commodity Pricing Engine Data Model Simplification. Relevant SAP Note, SAP Note 2226411 and SAP Note 2267308, Commodity Pricing Engine and Pricing Simplifications. 40. Retail Power Lists Obsolete Replacement Strategy Missing. Relevant SAP Note, SAP Note 2267208, Retail Specific Simplifications. 41. Retail Bonus by Obsolete Migration Gap. Relevant SAP Note, SAP Note 2386001, Omnichannel Promotion Pricing. 42. Revenue Accounting Contract Identification Redesign Gaps. Relevant SAP Note, SAP Note 2267319, and SAP Note 2225170, Revenue Recognition. 43. Performance Obligation Derivation Logic Incorrect. Relevant SAP Note, SAP Note 2267319, and SAP Note 2225170, Revenue Recognition. 44. SD to Revenue Accounting Interface Redesign Gaps. Relevant SAP Note, SAP Note 2267319, and SAP Note 2225170, Revenue Recognition. 45. Open Revenue Contract Migration Strategy Missing. Relevant SAP Note, SAP Note 2267319, and SAP Note 2225170, Revenue Recognition. 46. Advanced Variant Configuration Dependency Incompatibility. Relevant SAP Note, SAP Note 2711932, Advanced Variant Configuration. 47. IPC Decommissioning Impact Not Assessed. Relevant SAP Note, SAP Note 2318509, IPC Deprecation. 48. Class Type Inconsistencies in Configuration. Relevant SAP Note, SAP Note 2711932, Advanced Variant Configuration. 49. Flexible Workflow Replacing Classic Approval Strategies. Relevant SAP Note, Not Applicable Extensibility Gap. This is a process redesign requirement due to workflow modernization, not an SAP software change. Reference SAP Note 2198647 for custom code adaptation context only. 50. Scale-based type behavior change in pricing. Relevant SAP Note, SAP Note 2267308, Pricing Data Model. 51. Pricing Rounding and Currency Decimal Precision Differences. Relevant SAP Note, SAP Note 2267308, Pricing Data Model. 52. HANA Numeric Precision Causing Pricing Variances. Relevant SAP Note, SAP Note 1912445, ABAP Code for HANA. 53. Number Buffering Behavior Change on HANA. Relevant SAP Note, SAP Note 1912445, ABAP Code for HANA. 54. Data Aging Impact on SD Document Visibility. Relevant SAP Note, SAP Note 1616302, Information Lifecycle Management Policy. 55. Archive Object Redesign Impact Not Assessed. Relevant SAP Note, SAP Note 1616302, Information Lifecycle Management Policy. 56. Transportation Zone Master Redesign Affecting Route Determination. Relevant SAP Note, SAP Note 2267317, Logistics Execution and Transportation Management Transition. 57. Universal Journal Impact on SD Revenue Postings Not Designed. Relevant SAP Note 2349298, Universal Journal ACDOCA. 58. Predictive Analytics Integration for SD Forecasting Gaps. Relevant SAP Note 25333694, Predictive Analytics Integration.
Scenario 27. KONV replaced by PRCD_elements not assessed.
In the explore phase of ECC to S4HANA migration, organizations fail to recognize that the classic pricing condition table KONV has been replaced by the new pricing data model based on table PRCD_elements. Many custom programs, reports, and pricing enhancements built in ECC directly read KONV for condition values, discounts, taxes, and surcharges. In S4HANA, pricing conditions are stored differently, and the old table access logic no longer behaves the same. If this simplification is not assessed during design, custom code and reporting logic begin to fail during realization and testing.
Scenario classification and relevant SAP note, if applicable.
1. Complexity High Core Pricing Data Model Impact. 2. Phase Explore. 3. Frequency extremely common in ECC systems with custom pricing logic. 4. Primary ownership SD pricing lead. 5. Supporting ABAP custom code remediation lead. 6. Business ownership global order to cash process owner. 7. Relevant SAP Note 2267308, Pricing Data Model Simplification.
Diagnostic dashboard, symptoms and evidence.
How pricing data model simplification issues appear during design and testing. 1. Symptom, custom reports return incorrect pricing values or fail during execution. 2. Red flag, custom code directly selects data from KONV instead of pricing APIs. 3. Business impact, billing accuracy and pricing analytics become unreliable. 4. Detection, run custom code scans to identify select statements reading KONV. 5. Technical proof, pricing data now resides in PRCD_elements rather than legacy condition storage structures. Insight, compatibility views may hide the issue initially, but direct KONV access eventually breaks.
Why this happens, scenario analysis and root cause.
1. ECC custom reports frequently relied on direct table reads for pricing conditions. 2. Pricing enhancements and analytical reports often bypass standard pricing APIs. 3. Teams assume compatibility views fully replicate ECC table structures. 4. Discovery workshops underestimate how deeply pricing data structures changed. Legacy reporting patterns often expose pricing simplification risks.
Why this is a migration, exclusive failure.
1. ECC pricing conditions were stored primarily in the KONV table. 2. S4HANA introduces a new pricing persistence model centered on PRCD_elements. 3. Compatibility views temporarily simulate legacy structures but do not guarantee correct logic. 4. Migration exposes custom code dependencies on obsolete data models. Pricing simplification is one of the most impactful S4HANA data model changes.
Financial and customer impact.
1. Incorrect pricing calculations affect revenue accuracy. 2. Billing documents may contain incorrect condition values. 3. Sales reporting becomes inconsistent across regions. 4. Pricing disputes with customers increase due to inconsistent condition interpretation. Pricing data model failures directly affect revenue integrity.
Governance and accountability, RACI model.
Pricing architecture redesign must be governed jointly by functional pricing leadership and technical remediation teams. 1. Accountable, SD pricing lead the person responsible for pricing architecture and gets fired if pricing calculations fail after migration. 2. Responsible, ABAP custom code remediation lead identifies and remediates code reading obsolete pricing tables. 3. Consulted, solution architect validates pricing redesign alignment with S4HANA simplification principles. 4. Informed, global order to cash process owner oversees pricing governance across regions. Pricing architecture changes must be owned functionally and technically.
Ownership, who actually fixes it.
Resolving this requires redesigning how pricing data is accessed and reported. 1. SD pricing lead redesigns pricing reporting logic aligned with the new pricing model. 2. ABAP custom code remediation lead replaces direct KONV reads with supported APIs or CDS views. 3. Solution architect validates pricing architecture alignment with S4 HANA simplification strategy. 4. Global order to cash process owner approves the revised pricing governance model.
Who gets blamed versus who owns it?
1. Blamed. Development team executives assume custom code was poorly written. 2. Blamed. Pricing configuration team perceived as misconfiguring pricing conditions. 3. Actual owner. SD pricing lead responsible for redesigning pricing architecture during explore phase. 4. Root cause. Pricing data model simplification was not evaluated during design. Pricing failures typically originate from missed simplification analysis.
How this is actually fixed, the right way by a role.
1. SD pricing lead analyzes pricing data model simplification impacts. 2. ABAP custom code remediation lead replaces direct table access with supported data models. 3. Solution architect ensures compatibility views are not relied upon for long-term reporting logic. 4. Global order to cash process owner approves redesigned pricing analytics standards.
What not to do, common wrong fixes.
1. Continuing to rely on compatibility views for pricing reports. 2. Copying ECC reporting logic without evaluating data model simplification. 3. Ignoring direct table reads in custom programs. 4. Delaying pricing data model redesign until realization. Compatibility views are temporary bridges, not long-term architecture.
Follow-up 1. Why did SAP replace KONV with PRCD_elements?
Answer: SAP redesigned the pricing persistence model to improve performance, simplify data structures, and support advanced pricing scenarios in S4 HANA.
Follow-up 2. What is the biggest technical risk when KONV is still used?
Answer: custom programs that read KONV directly may return incorrect results or fail, because the underlying pricing logic is now stored differently.
Follow-up 3. Curveball. If compatibility views exist, why not just keep using them?
Answer: compatibility views simulate legacy tables, but do not guarantee correct logic or long-term stability. Relying on them increases upgrade risks and performance issues.
Exclusive pro tip.
During explore phase, run automated code scans to identify every direct reference to KONV. Pricing simplification should be treated as a mandatory architecture redesign rather than a simple table replacement.
Scenario 28. SD Custom reports reading obsolete tables.
In the explore phase of ECC to S4 HANA migration, organizations discover that many legacy SD reports and custom programs read data directly from obsolete or simplified tables. ECC reporting logic frequently access tables such as VBAK, VBAP, VBRK, VBRP, or KONV with assumptions about document structures and relationships. In S4 HANA, several of these structures are simplified or replaced, and new data models such as CDS views are introduced for reporting. If this simplification is not assessed during design, custom reports produce incorrect results or fail during testing.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high custom code and reporting architecture impact. 2. Phase, explore. 3. Frequency, extremely common in mature ECC landscapes with heavy custom reporting. 4. Primary ownership, ABAP custom code remediation lead. 5. Supporting SD reporting lead. 6. Business ownership, sales operations director. 7. Relevant SAP note, SAP note 2227014, SD simplification list.
Diagnostic dashboard, symptoms and evidence.
How obsolete table dependencies appear during system design and testing. 1. Symptom: legacy reports return incomplete or inconsistent sales document information. 2. Red flag: custom programs contain direct select statements reading simplified tables. 3. Business impact: operational reporting for orders, deliveries, and billing becomes unreliable. 4. Detection: run ABAP test cockpit scans to detect obsolete table access. 5. Technical proof: simplification list identifies replaced or deprecated tables referenced by custom code. Insight: Most ECC reporting logic assumed stable table structures that changed in S/4HANA.
Why this happens, scenario analysis and root cause.
1. ECC development standards encouraged direct table reads for performance. 2. Reporting tools were often built outside standard SAP APIs. 3. Teams assume compatibility views fully preserve legacy table behavior. 4. Simplification list reviews are sometimes skipped during design workshops. Custom reporting logic often exposes hidden dependencies on simplified tables.
Why this is a migration, exclusive failure.
1. ECC reporting models relied heavily on stable physical table structures. 2. S/4HANA replaces several physical tables with simplified or virtualized models. 3. CDS views are introduced as the preferred reporting layer. 4. Migration exposes dependencies on obsolete database structures. The reporting architecture shift from tables to CDS views is one of the biggest S/4HANA changes.
Financial and customer impact.
1. Operational reporting becomes inconsistent across regions. 2. Sales forecasting and pipeline analysis may become inaccurate. 3. Management dashboards display incomplete sales data. 4. Decision-making slows due to unreliable analytics. Broken reporting reduces trust in system-generated business insights.
Governance and accountability, RACI model.
Custom reporting remediation requires collaboration between functional reporting owners and technical development teams. 1. Accountable, ABAP custom code remediation lead the person responsible for adapting legacy code and gets fired if reporting failures occur after migration. 2. Responsible, SD reporting lead identifies business-critical reports and validates output accuracy. 3. Consulted, solution architect validates redesign alignment with S/4HANA reporting architecture. 4. Informed, sales operations director oversees reporting governance and business usage. Reporting modernization must be treated as part of system architecture transformation.
Ownership, who actually fixes it.
Resolving this requires redesigning reporting architecture around supported data models. 1. ABAP custom code remediation lead analyzes custom code dependencies on obsolete tables. 2. SD reporting lead identifies high-priority reports used by business operations. 3. Solution architect defines reporting standards based on CDS views. 4. Sales operations director approves reporting governance changes.
Who gets blamed versus who owns it.
1. Blamed, development team executives assume the reports were poorly coded. 2. Blamed, business analysts perceived as requesting incorrect reporting logic. 3. Actual owner, ABAP custom code remediation lead responsible for adapting reporting architecture during explore phase. 4. Root cause, simplification impacts on reporting tables were not evaluated early. Most reporting failures originate from missed simplification analysis rather than coding mistakes.
How this is actually fixed, the right way by a role.
1. ABAP custom code remediation lead scans codebase for obsolete table references. 2. SD reporting lead validates the business logic of legacy reports. 3. Solution architect defines CDS-based reporting architecture. 4. Sales operations director approves redesigned reporting dashboards.
What not to do, common wrong fixes.
1. Assuming compatibility views fully replicate ECC table logic. 2. Migrating custom reports without redesigning the data model. 3. Ignoring simplification list documentation. 4. Delaying reporting remediation until realization phase. Compatibility views are transitional tools, not permanent reporting solutions.
Follow-up 1. Why are CDS views recommended for reporting in S/4HANA?
Answer: CDS views provide optimized data models, semantic layers, and integration with analytics tools such as embedded analytics and SAP Analytics Cloud.
Follow-up 2. What is the biggest risk of keeping legacy reports unchanged?
Answer: reports may return incomplete or inconsistent results because underlying tables behave differently in S/4HANA.
Follow-up 3. Curveball. Why do many migrations miss reporting simplification impacts?
Answer: design workshops often focus on transactional processes, while underestimating how heavily reporting logic depends on underlying data structures.
Exclusive pro tip.
During the Explore phase inventory, every Z report, and classify them by table dependencies. Any report reading simplified tables should be redesigned using CDS-based reporting architecture.
Scenario 29. VBFA logic assumptions invalid.
In the explore phase of ECC to S/4HANA migration, organizations assume that document flow logic stored in table VBFA behaves exactly the same as in ECC. Many custom programs, workflow triggers, and reporting tools rely on VBFA to determine relationships between sales orders, deliveries, invoices, and subsequent logistics documents. In S/4HANA, document processing optimizations and simplified data models change how document relationships are stored and retrieved. If these assumptions are not reassessed during design, document flow analysis and downstream integrations may produce inconsistent results.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, medium document flow logic and integration impact. 2. Phase, explore. 3. Frequency, common in systems with custom workflow or document tracking logic. 4. Primary ownership, solution architect. 5. Supporting ABAP custom code remediation lead. 6. Business ownership, order to cash process owner. 7. Relevant SAP note 2198-647, custom code adaptation.
Diagnostic dashboard, symptoms and evidence.
How document flow assumptions begin to fail during S/4HANA migration testing. 1. Symptom, custom workflows fail to identify correct document relationships. 2. Red flag, custom code directly queries VBFA to derive order to delivery or billing relationships. 3. Business impact, order tracking, and logistics monitoring reports become inconsistent. 4. Detection. Identify programs reading VBFA to determine document lineage. 5. Technical proof. Document relationships retrieved from VBFA do not match expected ECC patterns. Insight. Document flow logic often depends on assumptions embedded in legacy programs.
Why this happens, scenario analysis and root cause.
1. ECC developers frequently used VBFA as a universal source for document relationships. 2. Workflow triggers and reporting logic were often hard-coded around VBFA reads. 3. Teams assume document flow tables behave identically after migration. 4. Simplification documentation related to document relationships is overlooked during design. Document flow logic frequently hides deep dependencies on legacy database structures.
Why this is a migration, exclusive failure.
1. ECC document processing relied on well-known table relationships such as VBFA. 2. S/4HANA optimizes document processing and introduces new data access patterns. 3. Compatibility layers may not fully preserve historical assumptions used in custom logic. 4. Migration exposes custom code that assumed static document flow structures. Document flow simplifications often affect workflow and integration logic.
Financial and customer impact.
1. Order tracking systems display incomplete or incorrect document relationships. 2. Logistics monitoring dashboards lose accuracy. 3. Customer service teams struggle to trace order history. 4. Operational reporting becomes inconsistent across regions. Reliable document flow visibility is critical for customer service and logistics operations.
Governance and accountability, RACI model.
Document flow logic redesign requires coordination between architecture leadership and technical remediation teams. 1. Accountable. Solution architect, the person responsible for system architecture validation, and gets fired if document flow logic breaks business operations after migration. 2. Responsible. ABAP custom code remediation lead analyzes and remediates programs relying on legacy document flow tables. 3. Consulted. SD functional lead validates correct business document relationships. 4. Informed. Order to cash process owner oversees operational process continuity. Document flow architecture must be validated early during system design.
Ownership, who actually fixes it.
Resolving this requires redesigning document relationship logic in custom applications. 1. Solution architect reviews document flow architecture in S/4HANA. 2. ABAP custom code remediation lead identifies programs reading VBFA directly. 3. SD functional lead validates document relationships across order, delivery, and billing processes. 4. Order-to-cash process owner approves revised process monitoring logic.
Who gets blamed versus who owns it?
1. Blamed, development team executives assume the programs were incorrectly coded. 2. Blamed, SD functional team perceived as misconfiguring document relationships. 3. Actual owner, solution architect responsible for validating data model simplification impacts. 4. Root cause, document flow assumptions from ECC were not re-evaluated during explore phase. Architecture validation failures often appear as technical defects later.
How this is actually fixed, the right way by a role.
1. Solution architect reviews document relationship logic defined by S4 HANA simplification guidance. 2. ABAP custom code remediation lead replaces VBFA dependent logic with supported APIs or CDS views. 3. SD functional lead validates end-to-end document flow scenarios. 4. Order-to-cash process owner approves redesigned monitoring and reporting mechanisms.
What not to do, common wrong fixes.
1. Assuming VBFA behaves identically to ECC. 2. Leaving custom code dependent on legacy document flow tables. 3. Ignoring document flow logic during design workshops. 4. Postponing document flow validation until integration testing. Document flow logic must be validated during design, not during testing.
Follow-up 1. Why do many custom programs rely on VBFA?
Answer: VBFA historically provided a convenient way to determine document relationships between sales, logistics, and billing documents.
Follow-up 2. What is the biggest risk of relying on legacy document flow tables?
Answer: programs may return incomplete or inconsistent document relationships because the underlying processing logic changed in S4 HANA.
Follow-up 3. Curveball. Why do many migrations miss document flow simplification risks?
Answer: design workshops typically focus on configuration and transactions, while overlooking embedded logic inside custom programs.
Exclusive pro tip.
During the Explore phase inventory, all programs reading VBFA. Any logic determining document relationships should be validated against S4 HANA document processing behavior.
Scenario 30. LIS statistic structures removed impact not assessed.
In the Explore phase of ECC to S4 HANA migration, organizations fail to recognize that the classic logistics information system statistic structures used in ECC for SD analytics have been removed. Many operational dashboards, management reports, and custom analytics relied on LIS tables such as S001, S002, and related structures. S4 HANA replaces this reporting architecture with embedded analytics built on CDS views and real-time data models. If LIS removal is not evaluated during design, legacy reports and business analytics begin to fail during realization and testing.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high reporting architecture and analytics transformation impact. 2. Phase, explore. 3. Frequency, extremely common in systems with custom SD analytics. 4. Primary ownership, analytics architecture lead. 5. Supporting SD reporting lead. 6. Business ownership, sales analytics director. 7. Relevant SAP note 2267306, SD analytics and LIS replacement.
Diagnostic dashboard, symptoms and evidence.
How LIS removal begins to affect analytics during migration testing. 1. Symptom: sales analytics reports return empty results or outdated data. 2. Red flag: custom dashboards depend on LIS statistics structures such as S001 and S002. 3. Business impact: sales performance reporting becomes inconsistent across regions. 4. Detection: inventory custom reports referencing LIS structures. 5. Technical proof: LIS update mechanisms do not exist in S4 HANA. Insight: S4 HANA replaces aggregated LIS reporting with real-time analytics.
Why this happens, scenario analysis and root cause.
1. ECC reporting heavily depended on LIS aggregated statistics structures. 2. Many companies created custom reports based on LIS update mechanisms. 3. Teams assume reporting tables remain unchanged after migration. 4. Embedded analytics transformation is underestimated during design workshops. Legacy reporting habits often hide dependencies on LIS structures.
Why this is a migration exclusive failure.
1. ECC relied on aggregated LIS tables for logistics reporting. 2. S/4HANA eliminates LIS updates and replaces them with real-time analytics. 3. Embedded analytics uses CDS views and the HANA database for reporting. 4. Migration exposes legacy reports that rely on obsolete LIS data structures. The shift from aggregated statistics to real-time analytics is a major S/4HANA transformation.
Financial and customer impact.
1. Sales reporting becomes unreliable during early migration stages. 2. Management dashboards lose visibility into order and billing performance. 3. Business users lose trust in system-generated analytics. 4. Operational decisions are delayed due to missing real-time insights. Analytics reliability is essential for operational decision-making.
Governance and accountability, RACI model.
Analytics modernization must be governed jointly by reporting leadership and enterprise architecture teams. 1. Accountable. Analytics architecture lead the person responsible for analytics transformation and gets fired if reporting architecture fails after migration. 2. Responsible. SD reporting lead identifies business-critical analytics affected by LIS removal. 3. Consulted. Solution architect validates analytics architecture aligned with S/4HANA embedded analytics strategy. 4. Informed. Sales analytics director oversees business reporting governance. Analytics transformation is a core component of S/4HANA design.
Ownership, who actually fixes it.
Resolving this requires redesigning SD reporting architecture around embedded analytics. 1. Analytics architecture lead defines the embedded analytics framework. 2. SD reporting lead identifies reports previously based on LIS statistics. 3. Solution architect validates CDS-based analytics models. 4. Sales analytics director approves redesigned reporting governance.
Who gets blamed versus who owns it.
1. Blamed. Development team executives assume the reports were poorly implemented. 2. Blamed. Business intelligence team perceived as delivering incomplete analytics. 3. Actual owner. Analytics architecture lead responsible for redesigning reporting architecture. 4. Root cause. LIS removal impact was not assessed during explore phase. Analytics failures often originate from missed simplification analysis.
How this is actually fixed, the right way by a role.
1. Analytics architecture lead defines CDS-based reporting models. 2. SD reporting lead identifies business reports dependent on LIS statistics. 3. Solution architect validates embedded analytics architecture. 4. Sales analytics director approves redesigned dashboards.
What not to do, common wrong fixes.
1. Attempting to replicate LIS structures using custom tables. 2. Migrating reports without redesigning analytics architecture. 3. Ignoring embedded analytics capabilities of S/4HANA. 4. Postponing analytics redesign until after go live. Analytics redesign must happen during explore phase.
Follow-up 1. Why did SAP remove LIS in S/4HANA?
Answer: S/4HANA replaces aggregated statistics tables with real-time analytics powered by the HANA database and CDS views.
Follow-up 2. What is the biggest advantage of embedded analytics?
Answer: embedded analytics eliminates data latency by providing real-time operational reporting directly from transactional data.
Follow-up 3. Curveball. Why do many organizations underestimate LIS removal?
Answer: because LIS was deeply embedded in operational reporting for decades, and many companies forget how many reports depend on those statistics structures.
Exclusive pro tip.
During the explore phase, perform a complete inventory of LIS-dependent reports. Every LIS-based report should be redesigned using CDS views and embedded analytics architecture.
Scenario 31. SD credit tables obsolete usage.
In the explore phase of ECC to S/4HANA migration, organizations continue relying on legacy SD credit management tables such as KNKK, S066, and S067 to evaluate customer credit exposure. In S/4HANA, Classic SD credit management has been replaced by SAP Financial Supply Chain Management Credit Management. Credit exposure and credit control logic are now stored in different structures and governed by new business partner-based master data. If this redesign is not assessed during design, custom reports, integrations, and operational processes relying on legacy credit tables produce incorrect results.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high credit risk management and financial integration impact. 2. Phase, explore. 3. Frequency, very common in ECC systems using classic SD credit management. 4. Primary ownership, credit management lead. 5. Supporting SD functional lead. 6. Business ownership, accounts receivable director. 7. Relevant SAP note. SAP note 2270544. Credit management simplification.
Diagnostic dashboard, symptoms and evidence.
How legacy credit management dependencies appear during system design and testing. 1. Symptom, credit exposure reports display incorrect balances or missing values. 2. Red flag, custom reports directly read tables KNKK or S066 for credit exposure. 3. Business impact, sales orders may bypass credit checks or block incorrectly. 4. Detection, scan custom programs referencing classic SD credit tables. 5. Technical proof, credit exposure in S4 HANA is managed through FSCM structures and business partner integration. Insight, S4 HANA moves credit management from SD tables into an integrated financial risk management framework.
Why this happens, scenario analysis and root cause.
1. ECC credit management was embedded directly within the SD module. 2. Custom reports frequently relied on legacy credit exposure tables. 3. Teams assume credit control structures remain identical after migration. 4. Design workshops underestimate the impact of migrating to FSCM credit management. Credit management simplification is both a functional and technical redesign.
Why this is a migration, exclusive failure.
1. ECC supported classic SD credit management embedded within sales processing. 2. S4 HANA replaces classic credit management with FSCM credit management. 3. Credit exposure data structures and risk evaluation logic change significantly. 4. Migration exposes custom reports that rely on obsolete credit tables. Credit management modernization is one of the most significant SD and FI integration changes.
Financial and customer impact.
1. Incorrect credit exposure calculations increase financial risk. 2. Sales orders may be blocked unnecessarily, delaying revenue. 3. Credit risk reporting becomes inconsistent across regions. 4. Customer relationships suffer due to unpredictable order blocking. Accurate credit exposure calculation is critical for balancing revenue growth and financial risk.
Governance and accountability, RACI model.
Credit management redesign requires close coordination between finance leadership and SD functional teams. 1. Accountable, credit management lead the person responsible for credit risk governance and gets fired if credit exposure calculations fail after migration. 2. Responsible, SD functional lead validates sales order credit check behavior under the new credit management model. 3. Consulted, solution architect validates integration architecture between SD and FSCM credit management. 4. Informed, accounts receivable director oversees financial risk management governance. Credit management redesign sits at the intersection of finance and sales operations.
Ownership, who actually fixes it.
Resolving this requires migrating classic credit logic to the FSCM credit management framework. 1. Credit management lead defines the FSCM credit management operating model. 2. SD functional lead redesigns credit check logic within sales order processing. 3. Solution architect validates integration between business partner master data and credit management. 4. Accounts receivable director approves enterprise credit governance.
Who gets blamed versus who owns it.
1. Blamed, finance team executives assume credit policies were implemented incorrectly. 2. Blamed, SD configuration team perceived as misconfiguring credit checks. 3. Actual owner, credit management lead responsible for redesigning credit architecture. 4. Root cause, migration to FSCM credit management was not assessed during explore phase. Credit management failures often originate from incomplete finance and SD integration design.
How this is actually fixed, the right way by a role.
1. Credit management lead defines the new credit exposure model using FSCM. 2. SD functional lead validates credit checks during order processing scenarios. 3. Solution architect ensures correct integration between business partner master data and credit segments. 4. Accounts receivable director approves revised enterprise credit governance.
What not to do, common wrong fixes.
1. Continuing to rely on legacy SD credit tables. 2. Migrating credit reports without redesigning the credit exposure model. 3. Ignoring integration between business partner master data and credit segments. 4. Delaying credit management redesign until testing phases. Credit risk governance must be redesigned during explore phase.
Follow-up 1. Why did SAP replace classic SD credit management?
Answer: S4 HANA centralizes credit risk management within the FSCM framework to support integrated financial risk evaluation across multiple business processes.
Follow-up 2. What is the biggest architectural change in credit management?
Answer: credit exposure is now calculated using FSCM structures linked to business partner master data rather than classic SD credit tables.
Follow-up 3. Curveball. Why do many companies underestimate credit management redesign?
Answer: because credit checks appear to function normally in early testing, hiding deeper architectural changes in exposure calculation and financial risk evaluation.
Exclusive pro tip.
During the explore phase inventory, every custom report referencing legacy credit tables. Any credit exposure logic must be redesigned around the FSCM credit management architecture.
Scenario 32. Compatibility views masking logic issues.
In the explore phase of ECC to S4 HANA migration, organizations rely on compatibility views that simulate legacy table structures from ECC. These views are designed to provide temporary backward compatibility for existing programs during migration. However, compatibility views do not fully replicate the original business logic or performance characteristics of the legacy tables. When custom programs continue to depend on compatibility views instead of redesigned data models, hidden logic problems and performance issues eventually surface during realization or production operations.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high data model and custom code adaptation impact. 2. Phase explore. 3. Frequency, very common in systems with extensive custom development. 4. Primary ownership, ABAP custom code remediation lead. 5. Supporting solution architect. 6. Business ownership, enterprise applications director. 7. Relevant SAP note. SAP note 2-198647. Custom code adaptation and compatibility views.
Diagnostic dashboard, symptoms and evidence.
How compatibility views create hidden logic problems during migration. 1. Symptom: custom reports run successfully but return inconsistent results. 2. Red flag: programs depend heavily on compatibility views representing legacy tables. 3. Business impact: business users receive inconsistent operational reports. 4. Detection: identify custom code referencing compatibility view structures instead of redesigned models. 5. Technical proof: performance degradation appears when compatibility views translate queries into new data structures. Insight: compatibility views create an illusion of stability while hiding deeper architectural changes.
Why this happens, scenario analysis and root cause.
1. Compatibility views are introduced to ease migration from ECC to S4 HANA. 2. Development teams assume compatibility views permanently preserve legacy behavior. 3. Custom programs are migrated without redesigning underlying logic. 4. Simplification analysis during design workshops is incomplete. Compatibility views are designed as temporary bridges, not long-term architectural solutions.
Why this is a migration, exclusive failure.
1. ECC systems relied on direct access to physical database tables. 2. S4 HANA introduces compatibility views to simulate legacy structures. 3. These views translate queries into new simplified data models. 4. Migration exposes logic that depends on outdated table assumptions. Compatibility views delay problems but do not eliminate them.
Financial and customer impact.
1. Operational reports deliver inconsistent results across departments. 2. Performance issues increase system response times for business reports. 3. Incorrect analytics affect management decision-making. 4. Business trust in system data gradually declines. Hidden data model inconsistencies eventually surface as operational reporting failures.
Governance and accountability. RACI model.
Compatibility view dependency must be addressed during custom code remediation planning. 1. Accountable. ABAP custom code remediation lead the person responsible for adapting legacy programs and gets fired if compatibility view dependencies break the system after migration. 2. Responsible. Solution architect validates data model redesign aligned with S4 HANA simplification principles. 3. Consulted. SD functional lead confirms that redesigned logic produces correct business results. 4. Informed. Enterprise Applications Director oversees application architecture governance. Compatibility views should be treated as temporary migration aids rather than permanent architecture.
Ownership. Who actually fixes it?
Resolving this requires replacing compatibility view dependencies with supported data models. 1. ABAP custom code remediation lead identifies programs using compatibility views. 2. Solution architect defines redesigned data access patterns using CDS views or APIs. 3. SD functional lead validates business logic results after redesign. 4. Enterprise Applications Director approves remediation priorities.
Who gets blamed versus who owns it?
1. Blamed. Development team executives assume performance problems are coding errors. 2. Blamed. Infrastructure team perceived as providing insufficient system resources. 3. Actual owner. ABAP custom code remediation lead responsible for eliminating compatibility view dependencies. 4. Root cause. Simplification analysis did not evaluate compatibility view risks. Compatibility view misuse is a common hidden cause of post-migration instability.
How this is actually fixed. The right way by a role.
1. ABAP custom code remediation lead scans programs for compatibility view usage. 2. Solution architect defines redesigned access using CDS-based data models. 3. SD functional lead validates correct business results after redesign. 4. Enterprise Applications Director approves remediation roadmap.
What not to do. Common wrong fixes.
1. Treating compatibility views as permanent replacements for legacy tables. 2. Ignoring performance issues caused by translated queries. 3. Migrating programs without redesigning data access logic. 4. Deferring compatibility remediation until after go live. Compatibility views are migration bridges, not architectural foundations.
Follow-up 1. Why did SAP introduce compatibility views in S4 HANA?
Answer. Compatibility views were introduced to help legacy ECC programs run temporarily, while organizations redesign custom code for the new data model.
Follow-up 2. What is the biggest risk of relying on compatibility views?
Answer. They hide deeper data model changes and can cause performance issues or incorrect business results when used long-term.
Follow-up 3. Curveball. Why do compatibility view problems often appear only after go live?
Answer. Because compatibility views initially allow programs to run normally, but high production workloads expose performance and logic issues.
Exclusive pro tip.
During Explore phase, treat compatibility views as temporary technical bridges. Every program using them should be scheduled for redesign before realization.
Scenario 33. MATDOC impact on SD analytics.
In the Explore phase of ECC to S4 HANA migration, organizations fail to recognize that the traditional inventory and material document structures used in ECC have been replaced by the MATDOC data model. In ECC, logistics analytics and reporting often relied on tables such as MKPF and MSEG. S4 HANA consolidates these structures into the MATDOC table to simplify inventory management and improve performance. If the impact of MATDOC on SD analytics and logistics reporting is not assessed during design, Reports that depend on legacy document tables produce incorrect results or fail during realization.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high logistics data model and analytics impact. 2. Phase, explore. 3. Frequency, common in systems with custom logistics and inventory reporting. 4. Primary ownership, logistics data architecture lead. 5. Supporting SD reporting lead. 6. Business ownership, supply chain analytics director. 7. Relevant SAP note. SAP note 22069880. EMA TDOC data model simplification.
Diagnostic dashboard, symptoms and evidence.
How EMA TDOC data model changes affect reporting and analytics during migration testing. 1. Symptom, logistics and inventory reports return inconsistent material movement information. 2. Red flag, custom reports read legacy tables such as MKPF or MSEG for inventory movements. 3. Business impact, supply chain analytics display incorrect stock movement data. 4. Detection, identify custom code referencing legacy inventory document tables. 5. Technical proof, inventory transactions are now persisted in the EMA TDOC table rather than traditional document structures. Insight, S4 HANA simplifies inventory data structures, but requires analytics redesign.
Why this happens, scenario analysis and root cause.
1. ECC reporting logic relied heavily on MKPF and MSEG document tables. 2. Custom logistics analytics often bypass standard APIs and read physical tables. 3. Design workshops underestimate the impact of the EMA TDOC simplification. 4. Teams assume compatibility views completely preserve legacy reporting logic. Legacy reporting patterns frequently hide dependencies on obsolete inventory tables.
Why this is a migration, exclusive failure.
1. ECC inventory management stored document information across multiple tables. 2. S4 HANA consolidates inventory documents into the EMA TDOC structure. 3. Legacy analytics built on older table structures cannot interpret the simplified model correctly. 4. Migration exposes reporting dependencies that rely on obsolete document tables. EMA TDOC consolidation changes how logistics analytics retrieve movement data.
Financial and customer impact.
1. Inventory movement reports become inaccurate during early migration stages. 2. Supply chain analytics lose visibility into stock flows. 3. Management decisions based on logistics reporting become unreliable. 4. Operational teams struggle to track material movements accurately. Accurate logistics analytics are critical for supply chain visibility.
Governance and accountability, RACI model.
Inventory analytics redesign requires coordination between logistics architecture and reporting teams. 1. Accountable. Logistics data architecture lead the person responsible for inventory data model redesign and gets fired if logistics analytics fail after migration. 2. Responsible. SD reporting lead identifies reports that rely on legacy inventory tables. 3. Consulted. Solution architect validates analytics architecture aligned with the EMA TDOC data model. 4. Informed. Supply chain analytics director oversees reporting governance for logistics operations. Inventory data model changes must be reflected across reporting architecture.
Ownership, who actually fixes it.
Resolving this requires redesigning analytics around the EMA TDOC inventory model. 1. Logistics data architecture lead defines inventory analytics based on EMA TDOC. 2. SD reporting lead identifies reports dependent on legacy logistics tables. 3. Solution architect validates redesigned analytics architecture. 4. Supply chain analytics director approves updated reporting standards.
Who gets blamed versus who owns it.
1. Blamed. Development team executives assume reports were implemented incorrectly. 2. Blamed. Supply chain analytics team perceived as producing inaccurate reports. 3. Actual owner, logistics data architecture lead responsible for redesigning analytics around the EMA TDOC model. 4. Root cause, EMA TDOC simplification impact was not assessed during explore phase. Analytics failures frequently originate from overlooked data model transformations.
How this is actually fixed. the right way by a role.
1. Logistics Data Architecture Lead defines inventory analytics aligned with EMA TDOC. 2. SD Reporting Lead replaces legacy inventory reports with CDS-based analytics. 3. Solution Architect validates analytics architecture for logistics reporting. 4. Supply Chain Analytics Director approves redesigned dashboards.
What not to do, common wrong fixes.
1. Continuing to rely on legacy inventory document tables. 2. Migrating logistics reports without redesigning analytics models. 3. Ignoring EMA TDOC simplification documentation. 4. Postponing analytics redesign until realization phase. Inventory data model redesign must occur during explore phase.
Follow-up 1. Why did SAP introduce EMA TDOC?
Answer: EMA TDOC consolidates multiple inventory tables into a single simplified structure, improving performance and reducing data redundancy.
Follow-up 2. What is the biggest reporting risk with EMA TDOC?
Answer: legacy reports that read older inventory tables may produce incorrect or incomplete analytics.
Follow-up 3. Curveball. Why do many companies overlook EMA TDOC during migration?
Answer: because the simplification primarily affects logistics tables that many teams assume remain stable across SAP releases.
Exclusive pro tip.
During Explore Phase inventory, every custom report reading inventory document tables. Any report dependent on MKPF or MSEG should be redesigned around the EMA TDOC-based analytics architecture.
Scenario 34. Output model redesign underestimated.
In the Explore phase of ECC to S4HANA migration, organizations underestimate the architectural shift from the classic ENA ST-based output framework to the BRF Plus-based output management model. Many ECC implementations rely on condition records, custom print programs, and message determination logic tightly coupled to ENA ST tables. In S4HANA, output management moves toward a BRF Plus rule-based framework integrated with Adobe Forms and flexible configuration. If this redesign is ignored during design workshops, output processes such as order confirmations, delivery notes, invoices, and partner communications fail during testing or immediately after go live.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high communication architecture and document output impact. 2. Phase, explore. 3. Frequency, very common in systems with heavy output customization. 4. Primary ownership, SD output architecture lead. 5. Supporting ABAP forms and output development lead. 6. Business ownership, customer communication and billing operations head. 7. Relevant SAP note. SAP note 22286111. Output management in S4HANA.
Diagnostic dashboard, symptoms and evidence.
How output management architecture issues surface during migration testing. 1. Symptom, sales order confirmations or invoices fail to generate automatically. 2. Red flag, existing output configuration depends on ENA ST message determination. 3. Business impact, customers stop receiving order confirmations, invoices, or shipping notifications. 4. Detection. Identify output procedures still configured using legacy message determination logic. 5. Technical proof. BRF Plus decision tables are missing or incorrectly configured for output determination. Insight. Output failures are often architecture redesign problems rather than simple configuration errors.
Why this happens, scenario analysis and root cause.
1. ECC implementations rely heavily on ENA ST message determination tables. 2. Migration teams assume legacy output configuration will automatically continue to work. 3. Design workshops underestimate the architectural shift to BRF Plus decision frameworks. 4. Organizations postpone output redesign until testing phases. Output architecture changes require deliberate redesign rather than technical migration.
Why this is a migration, exclusive failure.
1. ECC output architecture relied on ENA ST tables and message determination logic. 2. S4HANA introduces BRF Plus-based output management architecture. 3. The new framework separates decision logic, form generation, and communication channels. 4. Migration exposes dependencies between legacy output configuration and obsolete architecture. Output architecture redesign is a core S/4HANA transformation requirement.
Financial and customer impact.
1. Customers fail to receive invoices or order confirmations. 2. Billing cycles are delayed due to missing document outputs. 3. Customer service teams receive spikes in manual inquiries. 4. Regulatory documentation such as shipping documents may fail to generate. Output failures quickly escalate into customer service and revenue recognition problems.
Governance and accountability, RACI model.
Output architecture redesign must be governed during the explore phase. 1. Accountable SD output architecture lead the person responsible for output management redesign and gets fired if customer communications fail after go live. 2. Responsible ABAP forms and output development lead redesigns print programs and Adobe Forms integration. 3. Consulted solution architect validates architecture alignment with S/4HANA output management framework. 4. Informed customer communication and billing operations head ensures business continuity of customer documents. Output architecture should be treated as a business-critical communication platform.
Ownership, who actually fixes it.
Resolving this requires redesigning output management architecture using BRF+. 1. SD output architecture lead defines the new output determination model using BRF+ decision tables. 2. ABAP forms and output development lead redesigns output forms using Adobe Forms or supported technologies. 3. Solution architect validates communication architecture across email, print, and EDI channels. 4. Customer communication and billing operations head confirms document delivery requirements.
Who gets blamed versus who owns it.
1. Blamed development team executives assume output forms were implemented incorrectly. 2. Blamed infrastructure team perceived as causing system communication failures. 3. Actual owner SD output architecture lead responsible for redesigning output architecture aligned with S/4HANA. 4. Root cause output management redesign was underestimated during explore phase. Output failures are often architectural problems disguised as configuration issues.
How this is actually fixed, the right way by a role.
1. SD output architecture lead maps existing in a ST-based outputs to BRF+ decision logic. 2. ABAP forms and output development lead rebuilds forms using Adobe Forms framework. 3. Solution architect validates end-to-end output architecture across business scenarios. 4. Customer communication and billing operations head verifies document delivery across channels.
What not to do, common wrong fixes.
1. Assuming legacy in a ST configuration will automatically work in S/4HANA. 2. Migrating print programs without redesigning output determination logic. 3. Ignoring BRF+ framework during design workshops. 4. Delaying output architecture redesign until realization phase. Output redesign must happen early because it affects nearly every customer document.
Follow-up 1. Why did SAP replace the classic NAST output framework?
Answer: the NAST-based framework was rigid and difficult to extend across modern communication channels. BRF+-based output management provides a rule-driven decision engine that separates business logic from document generation. This allows organizations to support email, print, EDI, and digital communication more flexibly.
Follow-up 2. Why do many projects underestimate output management redesign?
Answer: because output management appears to be a configuration topic rather than an architecture change. In reality, the shift from NAST to BRF+ changes the entire decision logic and form generation framework. Projects often discover this only during testing when documents stop generating.
Follow-up 3. Curveball. What happens if organizations keep NAST output temporarily?
Answer: some S/4HANA deployments allow limited compatibility modes for output management. However, relying on them creates long-term technical debt and limits adoption of modern communication frameworks. Eventually, organizations must migrate to BRF+ to remain compatible with future S/4HANA releases.
Exclusive pro tip.
During the explore phase inventory, every output type used in ECC such as order confirmations, deliveries, invoices, and EDI messages. Build a mapping matrix from NAST configuration to BRF plus decision tables before realization begins. This prevents last-minute output failures during testing.
Scenario 35. Rebates to settlement management design gaps.
In the explore phase of ECC to S/4HANA migration, organizations fail to properly redesign legacy rebate processing into the new condition contract settlement management framework. In ECC, rebates were handled through rebate agreements tightly coupled to pricing condition records and settlement transactions. S/4HANA replaces this architecture with condition contracts and settlement management. If this transition is not carefully designed during Explore phase workshops, rebate accruals, settlements, and financial postings become inconsistent or fail entirely during testing or after go-live.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, very high revenue and settlement architecture impact. 2. Phase, explore. 3. Frequency, common in consumer goods, retail, and distribution industries. 4. Primary ownership, SD pricing and settlement architecture lead. 5. Supporting FI revenue accounting lead. 6. Business ownership, commercial finance director. 7. Relevant SAP note. SAP note 2267377. Condition contract settlement management.
Diagnostic dashboard, symptoms and evidence.
How settlement management design gaps appear during migration testing. 1. Symptom, rebate accruals are missing or incorrectly posted during billing. 2. Red flag, legacy rebate agreements are migrated without mapping to condition contracts. 3. Business impact, revenue adjustments and customer rebates are calculated incorrectly. 4. Detection, identify rebate agreements that were not redesigned as condition contracts. 5. Technical proof, settlement runs fail due to missing contract structures or incorrect settlement schema. Insight, rebate failures directly impact revenue accuracy and financial reconciliation.
Why this happens, scenario analysis and root cause.
1. ECC rebate processing relied on pricing conditions and rebate agreement tables. 2. Migration teams underestimate the architectural shift to settlement management. 3. Design workshops focus on pricing conditions but ignore settlement structures. 4. Finance and SD teams do not jointly redesign accrual and settlement flows. Settlement management introduces a fundamentally different rebate architecture.
Why this is a migration, exclusive failure.
1. ECC rebate agreements were embedded within pricing condition logic. 2. S/4HANA introduces condition contracts to separate commercial agreements from pricing. 3. Settlement management automates accruals and settlements using contract structures. 4. Migration exposes legacy rebate logic that cannot operate in the new architecture. Rebate processing is no longer a pricing add-on but a contract-driven settlement engine.
Financial and customer impact.
1. Incorrect rebate accruals distort financial statements. 2. Customer settlements are delayed or miscalculated. 3. Finance teams struggle to reconcile revenue adjustments. 4. Sales partners lose trust due to incorrect rebate settlements. Settlement errors directly affect partner relationships and revenue recognition.
Governance and accountability, RACI model.
Settlement management redesign must involve both commercial and financial architecture teams. 1. Accountable, SD pricing and settlement architecture lead the person responsible for rebate architecture redesign and gets fired if settlement processes fail after migration. 2. Responsible, FI revenue accounting lead validates accrual and financial posting structures. 3. Consulted, solution architect ensures settlement management integrates correctly with pricing and billing. 4. Informed, commercial finance director monitors financial accuracy of rebate settlements. Settlement management architecture directly connects sales pricing with financial revenue reporting.
Ownership, who actually fixes it.
Resolving this requires redesigning rebate agreements as condition contracts. 1. SD pricing and settlement architecture lead maps rebate agreements to condition contracts. 2. FI revenue accounting lead defines accrual and settlement posting structures. 3. Solution architect validates integration between pricing, billing, and settlement management. 4. Commercial finance director approves settlement governance and reporting controls.
Who gets blamed versus who owns it.
1. Blamed, SD pricing team executives assume pricing conditions were configured incorrectly. 2. Blamed, finance team perceived as producing incorrect revenue adjustments. 3. Actual owner, SD pricing and settlement architecture lead responsible for redesigning rebate architecture. 4. Root cause, settlement management transformation was not designed during explore phase. Rebate failures are usually architectural design issues rather than pricing configuration mistakes.
How this is actually fixed, the right way by a role.
1. SD pricing and settlement architecture lead redesigns rebate agreements as condition contracts. 2. FI revenue accounting lead defines accrual posting logic aligned with settlement cycles. 3. Solution architect validates integration between settlement management and billing. 4. Commercial finance director approves settlement governance and reconciliation processes.
What not to do, common wrong fixes.
1. Migrating legacy rebate agreements without redesigning settlement architecture. 2. Treating settlement management as a simple pricing configuration topic. 3. Ignoring financial posting logic during rebate redesign. 4. Postponing settlement architecture design until realization phase. Settlement management must be architected early because it directly affects revenue recognition.
Follow-up 1. Why did SAP replace ECC rebate agreements with settlement management?
Answer: ECC rebate agreements were tightly coupled to pricing conditions and were difficult to manage for complex partner settlements. Settlement management introduces condition contracts that separate commercial agreements from pricing execution. This allows more flexible accruals, settlements, and partner collaboration models.
Follow-up 2. Why do many migrations fail in settlement management design?
Answer: because teams treat rebates as a simple pricing configuration rather than a financial settlement architecture. Settlement management affects accrual postings, financial reconciliation, and partner contract structures. Without redesigning these flows early, projects discover major issues during testing.
Follow-up 3. Curveball. What happens if companies postpone settlement management redesign?
Answer: projects may temporarily migrate legacy rebate logic, but settlement runs will eventually fail or produce incorrect accruals. Finance reconciliation becomes extremely difficult and revenue reporting becomes unreliable. Fixing settlement architecture after go-live becomes significantly more expensive.
Exclusive pro tip.
During explore phase, build a full rebate architecture map. Identify every rebate agreement, settlement process, and accrual rule in ECC and redesign them as condition contracts with settlement schemas. This prevents major revenue reconciliation issues during go-live.
Scenario 36. Credit management redesign gaps, FSCM.
In the explore phase of ECC to S4 HANA migration, organizations fail to redesign their credit management processes for the new financial supply chain management credit framework. ECC credit management relied on classic credit control areas and SD tables for exposure tracking. S4 HANA replaces this architecture with FSCM credit management, which centralizes credit exposure calculation, risk classes, and credit segments. If this transition is not designed early, order processing, credit checks, and exposure calculations fail or behave inconsistently during testing and post-go-live.
Scenario classification and relevant SAP note, if applicable.
1. Complexity very high. Financial risk and order processing impact. 2. Phase explore. 3. Frequency very common in large enterprise migrations. 4. Primary ownership credit management architecture lead. 5. Supporting SD order management lead. 6. Business ownership corporate credit risk director. 7. Relevant SAP note 2267311 FSCM credit management simplification.
Diagnostic dashboard, symptoms and evidence.
How credit management redesign failures appear during migration testing. 1. Symptom: sales orders are blocked unexpectedly or bypass credit checks. 2. Red flag: classic credit control areas are migrated without mapping to credit segments. 3. Business impact: high-risk customers receive shipments or legitimate customers are blocked from ordering. 4. Detection: review credit exposure calculation logic in FSCM credit master configuration. 5. Technical proof: exposure values differ between ECC and S4 HANA because exposure now aggregates across multiple documents. Insight: credit management redesign errors directly affect revenue protection and order fulfillment.
Why this happens, scenario analysis and root cause.
1. ECC credit management relied on SD-specific tables and credit control areas. 2. Migration teams assume classic credit structures will behave the same in S4 HANA. 3. Credit exposure calculation change due to integration with FSCM. 4. Finance and SD teams often redesign credit rules independently without joint workshops. Credit management is not a technical migration task. It requires redesign of financial risk governance.
Why this is a migration, exclusive failure.
1. ECC used SD-based credit checks tied to credit control areas. 2. S4 HANA introduces FSCM credit management as the new architecture. 3. Credit exposure now aggregates across multiple financial and logistical documents. 4. Migration exposes gaps between legacy SD credit logic and the new FSCM credit framework. FSCM transforms credit management from a sales configuration into a financial risk platform.
Financial and customer impact.
1. Incorrect credit exposure calculations allow high-risk orders to proceed. 2. Legitimate customers may experience order blocks and shipment delays. 3. Financial risk monitoring becomes inconsistent across regions. 4. Revenue protection mechanisms fail during high transaction volumes. Credit management failures expose organizations to direct financial risk.
Governance and accountability, RACI model.
Credit architecture redesign must involve both finance and order management governance teams. 1. Accountable credit management architecture lead. The person responsible for credit risk architecture and gets fired if exposure calculations fail after migration. 2. Responsible SD order management lead. Ensures sales order processing integrates correctly with credit checks. 3. Consulted solution architect. Validates integration between SD processes and FSCM credit framework. 4. Informed corporate credit risk director. Oversees financial exposure governance across the enterprise. Credit management architecture directly protects enterprise revenue and financial exposure.
Ownership, who actually fixes it.
Resolving this requires redesigning credit structures using the FSCM architecture. 1. Credit management architecture lead maps legacy credit control areas to FSCM credit segments. 2. SD order management lead validates order processing scenarios using FSCM credit checks. 3. Solution architect reviews integration between credit exposure calculations and SD billing flows. 4. Corporate credit risk director approves enterprise credit governance rules.
Who gets blamed versus who owns it.
1. Blamed SD configuration team. Executives assume incorrect credit check configuration. 2. Blamed finance team. Perceived as providing incorrect exposure calculations. 3. Actual owner credit management architecture lead. Responsible for FSCM credit architecture redesign. 4. Root cause credit governance was not redesigned during the explore phase. Credit failures are usually architecture and governance problems rather than configuration errors.
How this is actually fixed, the right way by a role.
1. Credit management architecture lead redesigns credit segments and exposure calculation logic. 2. SD order management lead validates sales order scenarios with updated credit checks. 3. Solution architect verifies integration between credit exposure and financial postings. 4. Corporate credit risk director approves final credit governance policies.
What not to do, common wrong fixes.
1. Migrating classic credit control areas without redesigning exposure calculations. 2. Treating credit management as an SD configuration topic only. 3. Ignoring integration between credit exposure and financial postings. 4. Deferring credit governance redesign until testing phases. Credit management architecture must be redesigned early because it controls financial exposure.
Follow-up 1. Why did SAP move credit management to FSCM in S4 HANA?
Answer: the classic ECC credit management model was tightly coupled to SD processes and had limited risk analytics capabilities. FSCM credit management centralizes exposure calculation, integrates financial documents, and enables advanced risk management. This architecture allows organizations to manage credit risk across multiple business units more effectively.
Follow-up 2. Why do credit problems appear only during integration testing?
Answer: credit exposure calculations depend on interactions between sales orders, deliveries, billing, and financial postings. These interactions are rarely tested during early configuration stages. As a result, incorrect exposure calculations become visible only during end-to-end integration scenarios.
Follow-up 3, Curveball. What happens if organizations delay FSCM credit redesign until after go live?
Answer: postponing credit architecture redesign creates serious financial risk. Incorrect exposure calculations may allow high-value orders from risky customers or block legitimate orders from trusted partners. Correcting credit governance after go-live often requires major redesign of financial and sales processes.
Exclusive pro tip.
During Explore phase, run a full credit exposure simulation comparing ECC and FSCM calculations. Validate credit checks across orders, deliveries, billing, and financial documents. This ensures the new credit architecture protects revenue while avoiding unnecessary order blocks.
Please check description or comments section of this video. I have given a lot of links for downloading 7 or 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked system design, most asked implementation project-related interview questions and answers, most asked support project-related interview questions and answers, required for your SAP functional modules interviews jobs like SAP consultant jobs, SAP FICO consultant jobs, SAP SD consultant jobs, SAP PP consultant jobs, SAP Ariba consultant jobs, SAP Extended Warehouse Management EWM consultant jobs, SAP Plant Maintenance PM consultant jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section, these questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people also for your interviews. You people can download all 7 or 8 PDFs in a single zip file from below given links.
Scenario 37. Foreign trade to international trade classification gaps.
In the Explore phase of ECC to S4 HANA migration, organizations fail to redesign their foreign trade compliance processes for the new international trade framework. ECC used the foreign trade component with tables and configuration tied to SD and MM processes. S4 HANA removes this component and replaces it with the international trade solution integrated with business partner master data and classification structures. If this redesign is ignored, export controls, commodity classifications, and compliance checks fail during testing or production operations.
Scenario classification and relevant SAP note, if applicable.
1. Complexity high, regulatory compliance and global trade impact. 2. Phase Explore. 3. Frequency very common in global manufacturing and export-driven organizations. 4. Primary ownership global trade compliance architecture lead. 5. Supporting SD international sales process lead. 6. Business ownership global trade compliance director. 7. Relevant SAP note. SAP note 2267310. Foreign trade deprecation and international trade replacement.
Diagnostic dashboard, symptoms and evidence.
How foreign trade redesign gaps appear during migration testing. 1. Symptom: export control checks fail or do not trigger during order processing. 2. Red flag: legacy foreign trade configuration objects remain active in migration scope. 3. Business impact: export compliance violations or shipment delays during international transactions. 4. Detection, identify foreign trade configuration and tables still referenced in SD processes. 5. Technical proof, missing international trade classification data in material master and business partner records. Insight, international trade compliance failures expose organizations to regulatory and legal risk.
Why this happens, scenario analysis and root cause.
1. ECC foreign trade configuration was deeply embedded in SD and logistics processes. 2. Migration teams assume compliance functionality will behave the same in S4 HANA. 3. Design workshops underestimate the impact of removing the foreign trade component. 4. Trade compliance teams are often not included in early system design discussions. Trade compliance redesign requires coordination between logistics, legal, and compliance teams.
Why this is a migration, exclusive failure.
1. ECC relied on the foreign trade component for compliance and classification. 2. S4 HANA removes the legacy foreign trade module entirely. 3. The new international trade framework introduces different master data and compliance structures. 4. Migration exposes dependencies between SD export processes and obsolete compliance configuration. Trade compliance architecture must be redesigned to align with the new S4 HANA International Trade Framework.
Financial and customer impact.
1. Export shipments may be blocked due to missing compliance checks. 2. Regulatory penalties may arise from incorrect commodity classification. 3. International sales transactions experience unexpected shipment delays. 4. Trade compliance audits reveal incomplete documentation or classification errors. Trade compliance failures create both financial penalties and operational disruption.
Governance and accountability, RACI model.
Trade compliance redesign must be governed jointly by logistics and legal compliance leadership. 1. Accountable Global Trade Compliance Architecture Lead. The person responsible for export compliance architecture and gets fired if regulatory failures occur after migration. 2. Responsible SD International Sales Process Lead. Ensures export sales processes integrate correctly with compliance checks. 3. Consulted Solution Architect. Validates the integration of compliance architecture with logistics and SD order processing. 4. Informed Global Trade Compliance Director. Oversees regulatory compliance governance across international operations. Trade compliance architecture protects organizations from regulatory violations and export risks.
Ownership, who actually fixes it.
Resolving this requires redesigning compliance processes using the International Trade Framework. 1. Global Trade Compliance Architecture Lead redesigns classification and export control structures. 2. SD International Sales Process Lead validates export order scenarios with compliance checks. 3. Solution Architect reviews integration between compliance rules and SD order processing. 4. Global Trade Compliance Director approves enterprise compliance governance.
Who gets blamed versus who owns it.
1. Blamed Logistics Configuration Team. Executives assume incorrect export control configuration. 2. Blamed Compliance Department. Perceived as failing to provide regulatory requirements. 3. Actual owner Global Trade Compliance Architecture Lead. Responsible for redesigning international trade compliance architecture. 4. Root cause trade compliance architecture was not redesigned during explore phase. Compliance failures are typically governance and architecture issues rather than simple configuration mistakes.
How this is actually fixed, the right way by a role.
1. Global Trade Compliance Architecture Lead redesigns commodity classification and export control rules. 2. SD International Sales Process Lead validates export sales flows using new compliance structures. 3. Solution Architect ensures compliance checks integrate correctly with order processing. 4. Global Trade Compliance Director approves enterprise compliance governance policies.
What not to do, common wrong fixes.
1. Migrating legacy foreign trade configuration without redesign. 2. Ignoring international trade compliance during system design workshops. 3. Treating compliance as a purely legal topic rather than a system architecture issue. 4. Postponing trade compliance redesign until realization or testing phases. Trade compliance architecture must be validated early to avoid regulatory risk.
Follow-up 1. Why did SAP remove the foreign trade component in S/4HANA?
Answer: the legacy foreign trade module was limited in scalability and integration with modern compliance frameworks. SAP replaced it with the International Trade Solution that integrates more effectively with master data and global compliance rules. This allows organizations to manage export controls, classification, and compliance processes more consistently.
Follow-up 2. Why do trade compliance issues often appear late in migration projects?
Answer: trade compliance processes are often managed by legal or regulatory teams who are not deeply involved in technical design workshops. As a result, design decisions are made without considering export control and classification requirements. Problems become visible only when international shipments are tested.
Follow-up 3. Curveball. What happens if organizations ignore compliance redesign during migration?
Answer: ignoring compliance redesign exposes organizations to serious regulatory risk. Export shipments may be blocked or incorrectly released without proper screening. Regulatory audits can lead to penalties, shipment delays, and reputational damage in global markets.
Exclusive pro tip.
During Explore phase, perform a full trade compliance inventory. Identify commodity classifications, export control rules, and legal reporting requirements currently implemented in ECC. Redesign these controls using the International Trade Framework before system realization begins.
Scenario 38. CS service order to S/4HANA service object migration gaps.
In the Explore phase of ECC to S/4HANA migration, organizations fail to redesign customer service order processing for the new S/4HANA service management architecture. ECC relied on the classic CS service order framework tightly integrated with SD billing and logistics processes. S/4HANA introduces a redesigned service object model that integrates service contracts, service orders, and service confirmations into a modern service management framework. If this transition is not properly designed during the Explore phase, service orders, billing integration, and service reporting fail, or behave inconsistently during testing or production.
Scenario classification and relevant SAP note, if applicable.
1. Complexity high, service management and billing integration impact. 2. Phase Explore. 3. Frequency common in manufacturing, utilities, and field service organizations. 4. Primary ownership service management architecture lead. 5. Supporting SD billing integration lead. 6. Business ownership field service operations director. 7. Relevant SAP note. SAP note 22673331. CS to S/4HANA service simplification.
Diagnostic dashboard, symptoms and evidence.
How service management redesign gaps appear during migration testing. 1. Symptom: service orders fail to generate billing documents correctly. 2. Red flag: legacy CS service objects are migrated without redesigning service structures. 3. Business impact: field service teams cannot complete service confirmations or billing cycles. 4. Detection: identify legacy CS service order structures still referenced in SD billing flows. 5. Technical proof: missing integration between service objects and S/4HANA service management components. Insight: service management failures disrupt both operational service delivery and revenue generation.
Why this happens, scenario analysis and root cause.
1. ECC service management relied on legacy CS modules tightly coupled with SD billing. 2. Migration teams assume existing service order structures will function the same in S/4HANA. 3. Design workshops underestimate the architectural shift to the S/4HANA service model. 4. Service operations teams are often not deeply involved in system architecture decisions. Service management redesign requires coordination between field service operations and SD billing teams.
Why this is a migration exclusive failure.
1. ECC customer service relied on the CS module and traditional service orders. 2. S/4HANA introduces a new service management architecture and object model. 3. Service confirmations, contracts, and billing integration behave differently. 4. Migration exposes dependencies between legacy CS orders and SD billing processes. Service management redesign ensures continuity of field service revenue streams.
Financial and customer impact.
1. Service orders cannot generate billing documents correctly. 2. Field technicians experience delays in service confirmation processes. 3. Customer service contracts and warranty services become difficult to track. 4. Revenue from service activities may be delayed or incorrectly recognized. Service management disruptions directly affect customer satisfaction and service revenue.
Governance and accountability, RACI model.
Service management redesign must involve both field service operations and billing architecture teams. 1. Accountable service management architecture lead. The person responsible for service process architecture and gets fired if service order processing fails after migration. 2. Responsible SD billing integration lead. Ensures service orders integrate correctly with billing processes. 3. Consulted solution architect. Validates service management integration across logistics and finance. 4. Informed field service operations director. Oversees operational service delivery and customer satisfaction. Service architecture ensures operational continuity for field service organizations.
Ownership, who actually fixes it.
Resolving this requires redesigning service order architecture using the S/4HANA service framework. 1. Service management architecture lead redesigns service objects and order structures. 2. SD billing integration lead validates service billing integration scenarios. 3. Solution architect reviews service architecture alignment with logistics and finance. 4. Field service operations director approves operational service workflows.
Who gets blamed versus who owns it.
1. Blamed SD billing team. Executives assume billing configuration errors cause service failures. 2. Blamed service operations team. Perceived as failing to execute service processes correctly. 3. Actual owner service management architecture lead. Responsible for redesigning service management architecture. 4. Root cause service process architecture was not redesigned during the explore phase. Service failures usually originate from architectural redesign gaps rather than operational mistakes.
How this is actually fixed, the right way by a role.
1. Service management architecture lead redesigns service objects and service order lifecycle. 2. SD billing integration lead validates billing flows generated from service confirmations. 3. Solution architect ensures integration between service management and financial posting processes. 4. Field service operations director approves updated service workflows.
What not to do, common wrong fixes.
1. Migrating legacy CS service orders without redesigning service architecture. 2. Treating service management as a minor logistics configuration topic. 3. Ignoring integration between service confirmations and billing. 4. Deferring service process redesign until realization phase. Service architecture must be redesigned early to protect service revenue streams.
Follow-up 1. Why did SAP redesign the customer service module in S/4HANA?
Answer: the legacy ECC customer service module was tightly coupled to logistics and billing processes and lacked flexibility for modern service operations. S/4HANA introduces a redesigned service management architecture with better integration to service contracts, confirmations, and analytics. This enables organizations to manage field service operations more efficiently.
Follow-up 2. Why do service management issues appear late in migration projects?
Answer: service operations involve multiple interconnected processes including order creation, technician confirmations, billing, and contract management. These interactions are rarely tested during early configuration phases. As a result, service architecture problems become visible only during integration testing or pilot deployments.
Follow-up 3. Curveball. What happens if organizations ignore service architecture redesign?
Answer: service operations may appear functional initially, but revenue recognition and billing integration quickly break down. Field technicians may complete service tasks that cannot be billed correctly. Fixing service architecture after go-live usually requires major redesign of operational processes.
Exclusive pro tip.
During Explore phase, run end-to-end service lifecycle simulations including service order creation, technician confirmation, billing generation, and financial posting. This ensures the new service architecture supports operational field service workflows before system realization.
Scenario 39. Commodity Pricing Engine Data Model Simplification.
In the explore phase of ECC to S/4HANA migration, organizations underestimate the architectural changes introduced by the Commodity Pricing Engine Data Model. ECC commodity pricing implementations often relied on tightly coupled pricing procedures, condition records, and external market data integration. S/4HANA introduces a redesigned commodity pricing engine architecture that integrates with the simplified pricing data model and financial settlement structures. If these changes are not properly evaluated during design workshops, commodity pricing calculations, hedge settlements, and contract pricing behave incorrectly during testing or production.
Scenario classification and relevant SAP note, if applicable.
1. Complexity very high. Commodity trading and pricing architecture impact. 2. Phase explore. 3. Frequency common in energy, metals, agriculture, and commodity trading organizations. 4. Primary ownership commodity pricing architecture lead. 5. Supporting SD pricing lead. 6. Business ownership commodity trading risk director. 7. Relevant SAP note. SAP note 2226411. Commodity pricing engine simplification. And SAP note 2267308. Pricing data model simplification.
Diagnostic dashboard, symptoms and evidence.
How commodity pricing architecture issues appear during migration testing. 1. Symptom: commodity price calculations produce unexpected results during sales order creation. 2. Red flag: legacy commodity pricing logic depends on outdated pricing structures or tables. 3. Business impact: trading margins become inconsistent due to incorrect pricing calculations. 4. Detection: review commodity pricing procedures and external market data integration logic. 5. Technical proof: commodity pricing calculations fail due to missing CPE configuration or incorrect data model integration. Insight: commodity pricing failures directly affect trading profitability and financial settlement accuracy.
Why this happens, scenario analysis and root cause.
1. ECC commodity pricing implementations were heavily customized for market pricing feeds. 2. Migration teams assume legacy pricing logic will function the same in S/4HANA. 3. Design workshops focus on standard pricing without evaluating commodity trading scenarios. 4. Commodity trading teams are often not involved in system architecture discussions. Commodity pricing requires specialized architecture aligned with financial risk management.
Why this is a migration, exclusive failure.
1. ECC pricing relied on complex custom logic integrated with commodity market feeds. 2. S/4HANA introduces a redesigned commodity pricing engine integrated with the simplified pricing model. 3. The new architecture separates commodity pricing calculations from standard SD pricing procedures. 4. Migration exposes dependencies between legacy pricing logic and obsolete pricing data structures. Commodity pricing architecture must align with both trading operations and financial settlement processes.
Financial and customer impact.
1. Incorrect commodity pricing calculations distort trading margins. 2. Commodity contract settlements become inconsistent with market price indices. 3. Financial risk exposure increases due to inaccurate pricing models. 4. Customer contracts linked to commodity pricing formulas may produce incorrect invoice values. Commodity pricing accuracy is critical for protecting trading profitability.
Governance and accountability, RACI model.
Commodity pricing redesign must involve both trading risk teams and pricing architecture leadership. 1. Accountable commodity pricing architecture lead. The person responsible for commodity pricing architecture and gets fired if pricing calculations fail after migration. 2. Responsible SD pricing lead. Ensures pricing procedures integrate correctly with the commodity pricing engine. 3. Consulted solution architect. Validates integration between commodity pricing logic and financial settlement processes. 4. Informed commodity trading risk director. Oversees financial exposure related to commodity price fluctuations. Commodity pricing architecture protects trading margins and financial risk exposure.
Ownership, who actually fixes it.
Resolving this requires redesigning commodity pricing architecture using the commodity pricing engine. 1. Commodity pricing architecture lead redesigns commodity pricing formulas using CPE. 2. SD pricing lead validates integration between standard pricing and commodity pricing procedures. 3. Solution architect reviews integration between pricing calculations and financial settlement processes. 4. Commodity trading risk director approves trading risk governance rules.
Who gets blamed versus who owns it?
1. Blamed pricing configuration team. Executives assume incorrect condition record configuration. 2. Blamed trading desk operations. Perceived as entering incorrect pricing parameters. 3. Actual owner commodity pricing architecture lead. Responsible for redesigning commodity pricing architecture. 4. Root cause commodity pricing architecture was not evaluated during explore phase. Commodity pricing failures usually originate from architectural design gaps rather than operational errors.
How this is actually fixed, the right way by a role.
1. Commodity pricing architecture lead redesigns pricing formulas using the commodity pricing engine. 2. SD pricing lead validates pricing scenarios involving commodity-based contracts. 3. Solution architect ensures integration between pricing calculations and financial settlement processes. 4. Commodity trading risk director approves pricing governance and risk control policies.
What not to do, common wrong fixes.
1. Migrating legacy commodity pricing logic without redesigning pricing architecture. 2. Treating commodity pricing as a simple pricing procedure configuration. 3. Ignoring integration between pricing calculations and financial risk management. 4. Deferring commodity pricing redesign until testing phases. Commodity pricing architecture must be validated early because it directly affects trading margins.
Follow-up 1. Why did SAP introduce the commodity pricing engine in S4 HANA?
Answer: commodity trading requires complex pricing formulas linked to external market indices and contract conditions. The commodity pricing engine provides a dedicated framework to manage these calculations separately from standard SD pricing. This improves scalability and integration with financial risk management.
Follow-up 2. Why are commodity pricing issues difficult to detect early?
Answer: commodity pricing scenarios depend on market price feeds, contract terms, and settlement calculations that are not always simulated during early configuration testing. As a result, pricing issues often appear only when real trading scenarios are executed. This makes early architecture validation essential.
Follow-up 3. Curveball. What happens if commodity pricing architecture is not redesigned during migration?
Answer: trading margins may fluctuate unpredictably because pricing formulas do not match real market pricing logic. Incorrect settlements can distort financial reporting and risk exposure calculations. Correcting commodity pricing architecture after go live often requires major redesign of trading workflows.
Exclusive pro tip.
During explore phase, simulate commodity pricing scenarios using real market data and contract pricing formulas. Validate price calculations across sales orders, settlements, and financial postings. This ensures the commodity pricing engine architecture behaves correctly before realization.
Scenario 40. Retail power lists obsolete, replacement strategy missing.
In the explore phase of ECC to S4 HANA migration, organizations fail to assess the impact of retail power lists becoming obsolete. In ECC retail environments, power lists were used to simplify order creation by allowing users to quickly create orders using predefined assortments of materials. S4 HANA removes the power list functionality and expects organizations to use alternative approaches such as product hierarchies, product catalogs, or custom order templates. If this replacement strategy is not defined during design workshops, retail order entry processes become inefficient or unusable after migration.
Scenario classification and relevant SAP note, if applicable.
1. Complexity medium. Retail order entry process impact. 2. Phase explore. 3. Frequency common in SAP retail implementations. 4. Primary ownership retail sales process architecture lead. 5. Supporting SD order management lead. 6. Business ownership retail merchandising operations director. 7. Relevant SAP note 22672008, retail-specific simplifications.
Diagnostic dashboard, symptoms and evidence.
How the removal of power lists appears during migration testing. 1. Symptom: retail order entry screens become slower or require manual product selection. 2. Red flag: business users rely heavily on power lists for daily order entry activities. 3. Business impact: retail sales teams struggle to create orders efficiently. 4. Detection: identify transactions and processes that reference power lists in ECC. 5. Technical proof: power list-related transactions are no longer available in S4 HANA. Insight: retail order efficiency often depends on structured product selection tools.
Why this happens, scenario analysis and root cause.
1. ECC retail environments relied heavily on power lists to speed up order creation. 2. Migration teams assume alternative product selection methods will automatically replace this functionality. 3. Design workshops focus on system simplifications but ignore operational usability. 4. Retail operations teams are often not deeply involved in system design discussions. Operational efficiency tools are frequently overlooked during system redesign.
Why this is a migration, exclusive failure.
1. ECC retail included power lists as a specialized ordering tool. 2. S4 HANA removes power lists as part of retail simplification. 3. Organizations must replace them using product catalogs or custom ordering frameworks. 4. Migration exposes dependencies between retail order workflows and obsolete power list functionality. Retail simplifications often require process redesign rather than technical conversion.
Financial and customer impact.
1. Retail order creation becomes slower and more error-prone. 2. Sales teams spend additional time searching for products during order entry. 3. Incorrect product selections increase order correction workload. 4. Customer orders may be delayed during high-volume retail periods. Retail order entry efficiency directly affects store replenishment and revenue flow.
Governance and accountability, RACI model.
Retail process redesign must include usability improvements for order entry teams. 1. Accountable retail sales process architecture lead. The person responsible for retail order architecture and gets fired if retail order entry becomes inefficient after migration. 2. Responsible SD order management lead. Ensures order entry processes integrate correctly with product catalogs. 3. Consulted solution architect. Validates the replacement architecture for power list functionality. 4. Informed retail merchandising operations director. Oversees operational order creation workflows. Retail order entry tools must support high-volume operational efficiency.
Ownership, who actually fixes it.
Resolving this requires designing a replacement for power list-based ordering. 1. Retail sales process architecture lead defines the replacement ordering framework. 2. SD order management lead configures product catalogs or templates for order entry. 3. Solution architect ensures the solution integrates with retail master data structures. 4. Retail Merchandising Operations Director approves the redesigned ordering process.
Who gets blamed versus who owns it.
1. Blamed order management team. Executives assume operational inefficiencies are user-related. 2. Blamed IT development team. Perceived as failing to provide adequate system functionality. 3. Actual owner retail sales process architecture lead. Responsible for redesigning the order entry framework. 4. Root cause power list replacement strategy was not defined during explore phase. Retail usability failures usually originate from missing process redesign decisions.
How this is actually fixed, the right way by a role.
1. Retail sales process architecture lead designs product selection frameworks to replace power lists. 2. SD order management lead configures product catalogs or predefined order templates. 3. Solution architect ensures integration with retail master data and order processing. 4. Retail merchandising operations director validates usability with business users.
What not to do, common wrong fixes.
1. Ignoring power list usage during system design workshops. 2. Assuming users will manually search products after migration. 3. Treating retail order entry tools as minor usability features. 4. Deferring replacement design until after user acceptance testing. Retail ordering efficiency must be preserved to maintain operational productivity.
Follow-up 1. Why were power lists removed in S/4HANA?
Answer: power lists were part of older retail functionality that did not align well with modern product catalog frameworks. S/4HANA encourages the use of flexible product hierarchies and catalog-driven ordering. This approach supports more scalable and integrated retail sales processes.
Follow-up 2. Why do retail usability issues appear late in migration projects?
Answer: retail usability problems often appear only during user testing because early project phases focus on technical architecture. Operational teams who rely on tools such as power lists may not participate in early design workshops. As a result, usability issues are discovered only when business users begin executing real workflows.
Follow-up 3. Curveball. What happens if organizations do not replace power lists properly?
Answer: retail order entry teams may experience a significant drop in productivity. Sales representatives spend more time searching for products and correcting order mistakes. This operational inefficiency can slow store replenishment and negatively impact revenue performance.
Exclusive pro tip.
During Explore phase, analyze how retail users actually create orders in ECC. If power lists are heavily used, design replacement ordering tools using product catalogs, templates, or Fiori-based order assistance. This ensures retail operations remain efficient after migration.
Scenario 41. Retail bonus by obsolete migration gap.
In the Explore phase of ECC to S/4HANA migration, organizations fail to assess the removal of the retail bonus buy functionality. In ECC retail environments, bonus buy promotions allowed retailers to create complex promotional pricing scenarios such as buy one, get one free or bundle discounts. S/4HANA removes the bonus buy functionality and replaces it with omnichannel promotion pricing. If organizations do not redesign their promotional pricing strategy during migration, promotional campaigns fail or produce incorrect pricing results during order processing.
Scenario classification and relevant SAP note, if applicable.
1. Complexity high. Retail promotion and pricing strategy impact. 2. Phase Explore. 3. Frequency common in retail and consumer goods industries. 4. Primary ownership retail promotion architecture lead. 5. Supporting SD pricing lead. 6. Business ownership retail marketing campaign director. 7. Relevant SAP note 2386001 omnichannel promotion pricing.
Diagnostic dashboard, symptoms and evidence.
How bonus buy removal issues appear during migration testing. 1. Symptom: promotional pricing scenarios fail to trigger during order creation. 2. Red flag: legacy bonus buy promotion rules are migrated without redesign. 3. Business impact: marketing campaigns produce incorrect pricing discounts or fail entirely. 4. Detection: review promotional pricing scenarios previously implemented using bonus buy. 5. Technical proof: missing omnichannel promotion pricing configuration for promotional rules. Insight: promotional pricing architecture directly affects retail campaign success.
Why this happens, scenario analysis and root cause.
1. ECC retail implementations relied heavily on bonus buy promotional pricing. 2. Migration teams assume promotional pricing can continue using traditional pricing conditions. 3. Design workshops underestimate the architectural shift to omnichannel promotion pricing. 4. Marketing teams are often not included in early system architecture discussions. Promotional pricing redesign must involve both technical and marketing stakeholders.
Why this is a migration, exclusive failure.
1. ECC retail provided bonus buy functionality for complex promotional pricing. 2. S/4HANA removes this feature as part of retail simplification. 3. Promotional pricing must now be implemented using omnichannel promotion pricing. 4. Migration exposes dependencies between marketing campaigns and obsolete pricing features. Retail promotional pricing must be redesigned to align with the S/4HANA promotion framework.
Financial and customer impact.
1. Retail promotional campaigns fail or generate incorrect discounts. 2. Customers receive incorrect promotional pricing during checkout. 3. Marketing campaign effectiveness declines due to system limitations. 4. Revenue forecasting becomes inaccurate during promotional periods. Promotional pricing failures directly affect marketing ROI and customer experience.
Governance and accountability, RACI model.
Retail promotion architecture must be jointly governed by pricing and marketing leadership. 1. Accountable retail promotion architecture lead. The person responsible for promotional pricing architecture and gets fired if retail campaigns fail after migration. 2. Responsible SD pricing lead. Ensures promotional pricing integrates correctly with the pricing engine. 3. Consulted solution architect. Validates integration between promotional pricing and order processing. 4. Informed retail marketing campaign director. Oversees marketing campaign execution and promotional strategy. Retail promotional architecture must align system capabilities with marketing campaign design.
Ownership, who actually fixes it.
Resolving this requires redesigning promotional pricing using the omnichannel promotion pricing framework. 1. Retail promotion architecture lead redesigns promotional pricing rules using omnichannel promotion pricing. 2. SD pricing lead validates integration between promotional pricing and standard pricing procedures. 3. Solution architect reviews integration with order processing and retail channels. 4. Retail marketing campaign director approves promotional campaign rules.
Who gets blamed versus who owns it.
1. Blamed pricing configuration team. Executives assume incorrect discount configuration. 2. Blamed marketing department. Perceived as designing incorrect promotional campaigns. 3. Actual owner retail promotion architecture lead. Responsible for redesigning promotional pricing architecture. 4. Root cause bonus buy replacement strategy was not defined during explore phase. Retail promotional failures often originate from missing architecture decisions.
How this is actually fixed, the right way by a role.
1. Retail promotion architecture lead redesigns promotional campaigns using the omnichannel promotion pricing framework. 2. SD pricing lead validates pricing integration across promotional scenarios. 3. Solution architect ensures pricing architecture integrates with retail channels and order processing. 4. Retail marketing campaign director verifies campaign behavior during testing.
What not to do, common wrong fixes.
1. Migrating bonus by promotions without redesigning promotion architecture. 2. Treating promotional pricing as simple discount condition configuration. 3. Ignoring marketing workflows during system design workshops. 4. Deferring promotional pricing redesign until user acceptance testing. Retail promotions require architecture planning rather than simple pricing configuration.
Follow-up 1. Why did SAP replace bonus buy with omnichannel promotion pricing?
Answer: bonus buy was designed primarily for traditional retail systems and had limitations for modern omnichannel commerce. Omnichannel promotion pricing allows organizations to manage promotions consistently across physical stores, e-commerce platforms, and digital channels. This provides greater flexibility for complex promotional strategies.
Follow-up 2. Why do promotional pricing issues often appear during user testing?
Answer: promotional pricing logic typically involves complex combinations of product bundles, quantity rules, and campaign conditions. These scenarios are rarely tested during early system configuration phases. As a result, marketing teams often discover issues only when executing real campaign simulations.
Follow-up 3. Curveball. What happens if promotional pricing architecture is not redesigned?
Answer: retail campaigns may generate inconsistent discounts across different sales channels. Customers may see different promotional prices online and in stores, which damages trust and campaign effectiveness. Fixing promotional pricing architecture after go live often requires redesigning pricing frameworks and campaign processes.
Exclusive pro tip.
During explore phase, analyze every promotional pricing scenario used in ECC marketing campaigns. Map these scenarios to omnichannel promotion pricing structures and validate them through simulation before realization begins. This ensures marketing campaigns function correctly after migration.
Scenario 42. Revenue accounting contract identification redesign gaps.
In the explore phase of ECC to S/4HANA migration, organizations fail to redesign how revenue contracts are identified when adopting revenue accounting and reporting. ECC revenue recognition often relied on SD billing events and FI postings without formal contract identification logic. S/4HANA introduces revenue accounting and reporting, where revenue contracts must be derived from sales orders, billing documents, or service contracts using defined identification rules. If this identification logic is not designed early, revenue contracts are created incorrectly or not created at all during transaction processing.
Scenario classification and relevant SAP note, if applicable.
1. Complexity very high. Revenue recognition architecture impact. 2. Phase explore. 3. Frequency common in subscription services and long-term contract businesses. 4. Primary ownership revenue accounting architecture lead. 5. Supporting SD billing architecture lead. 6. Business ownership corporate revenue recognition director. 7. Relevant SAP note. SAP note 22673119 and SAP note 2225170. Revenue accounting and reporting simplifications.
Diagnostic dashboard, symptoms and evidence.
How contract identification problems appear during RAR testing. 1. Symptom: revenue contracts are missing or incorrectly created during order or billing processing. 2. Red flag: no defined contract identification rules exist for sales transactions. 3. Business impact: revenue recognition schedules are incomplete or inaccurate. 4. Detection: review configuration of contract identification rules in revenue accounting. 5. Technical proof: revenue accounting logs show failed contract creation events during transaction processing. Insight: contract identification is the foundation of accurate revenue recognition.
Why this happens, scenario analysis and root cause.
1. ECC revenue recognition relied on billing events rather than contract structures. 2. Migration teams assume SD billing automatically generates revenue contracts. 3. Design workshops focus on revenue posting but ignore contract identification logic. 4. Finance and SD teams often redesign revenue processes independently. Revenue recognition architecture requires coordination between finance and sales processes.
Why this is a migration, exclusive failure.
1. ECC revenue recognition was event-driven through billing and FI postings. 2. S/4HANA revenue accounting requires formal revenue contract structures. 3. Contracts must be identified and grouped from sales transactions. 4. Migration exposes gaps between legacy billing logic and contract-based revenue recognition. Revenue contract identification drives the entire RAR revenue recognition process.
Financial and customer impact.
1. Revenue recognition schedules become incomplete or inaccurate. 2. Financial reporting does not align with accounting standards such as IFRS 15. 3. Revenue postings become inconsistent across billing periods. 4. Finance teams struggle to reconcile revenue between SD and accounting systems. Revenue recognition failures create major financial reporting risks.
Governance and accountability, RACI model.
Revenue contract architecture must be governed jointly by finance and sales leadership. 1. Accountable revenue accounting architecture lead. The person responsible for RAR architecture and gets fired if revenue contracts fail after migration. 2. Responsible SD billing architecture lead. Ensures billing transactions generate correct contract identification signals. 3. Consulted solution architect. Validates integration between SD transactions and RAR contract creation. 4. Informed corporate revenue recognition director. Oversees financial reporting compliance. Revenue contract identification is the foundation of IFRS-compliant revenue recognition.
Ownership, who actually fixes it.
Resolving this requires defining contract identification logic for all revenue-generating transactions. 1. Revenue accounting architecture lead defines contract identification rules. 2. SD billing architecture lead maps sales and billing transactions to revenue contracts. 3. Solution architect validates integration between SD processes and RAR. 4. Corporate revenue recognition director approves revenue recognition governance.
Who gets blamed versus who owns it.
1. Blamed billing configuration team. Executives assume billing configuration errors caused revenue issues. 2. Blamed finance accounting team, perceived as producing incorrect financial reports. 3. Actual owner, revenue accounting architecture lead, responsible for contract identification architecture. 4. Root cause, revenue contract identification was not designed during explore phase. Revenue recognition issues usually originate from missing contract identification logic.
How this is actually fixed, the right way by a role.
1. Revenue accounting architecture lead defines contract identification rules for sales transactions. 2. SD billing architecture lead ensures billing triggers correct revenue contract creation. 3. Solution architect validates end-to-end integration between SD billing and RAR. 4. Corporate revenue recognition director validates compliance with accounting standards.
What not to do, common wrong fixes.
1. Assuming SD billing automatically generates correct revenue contracts. 2. Ignoring contract identification during revenue accounting design. 3. Treating revenue recognition as a purely financial configuration topic. 4. Deferring RAR contract design until realization or testing phases. RAR architecture must be designed early to ensure financial reporting compliance.
Follow-up 1. Why does revenue accounting require contract identification?
Answer: revenue accounting is based on the concept of revenue contracts rather than individual billing events. Contracts group together related sales transactions and define how revenue is recognized over time. Without correct contract identification, the entire revenue recognition framework cannot function properly.
Follow-up 2. Why do many projects overlook contract identification design?
Answer: many migration teams focus heavily on billing configuration and financial postings. However, revenue accounting requires an entirely new contract-based architecture. If contract identification rules are not defined early, revenue recognition logic becomes inconsistent during integration testing.
Follow-up 3. Curveball. What happens if revenue contracts are created incorrectly?
Answer: incorrect contract identification leads to incorrect revenue schedules and financial reporting discrepancies. Revenue may be recognized too early or too late relative to accounting standards. Correcting these errors after go live often requires manual financial adjustments and system redesign.
Exclusive pro tip.
During explore phase, simulate contract identification for every revenue-generating scenario, including subscriptions, service contracts, and milestone billing. Validate how transactions group into revenue contracts before realization begins. This prevents major revenue recognition errors during financial close.
Scenario 43. Performance obligation derivation logic incorrect.
In the explore phase of ECC to S4 HANA migration, organizations fail to correctly design the logic that derives performance obligations for revenue accounting and reporting. Under modern revenue recognition standards such as IFRS 15, revenue must be allocated to specific performance obligations within a contract. S4 HANA revenue accounting requires explicit rules to derive these obligations from sales orders, billing items, or service deliverables. If these rules are not properly designed, revenue allocations become incorrect and financial reporting becomes inconsistent.
Scenario classification and relevant SAP note, if applicable.
1. Complexity very high. Revenue recognition and financial reporting impact. 2. Phase explore. 3. Frequency common in subscription software licensing and service contract businesses. 4. Primary ownership revenue accounting architecture lead. 5. Supporting SD pricing and billing lead. 6. Business ownership financial reporting compliance director. 7. Relevant SAP note. SAP note 22673119 and SAP note 2225170. Revenue accounting and reporting simplifications.
Diagnostic dashboard, symptoms and evidence.
How incorrect performance obligation derivation appears during RAR testing. 1. Symptom: revenue contracts contain incorrect or missing performance obligations. 2. Red flag: no defined derivation rules linking sales items to performance obligations. 3. Business impact: revenue schedules are distributed incorrectly across contract obligations. 4. Detection: review RAR configuration for performance obligation derivation rules. 5. Technical proof: revenue contract logs show incorrect mapping between sales items and obligations. Insight: Incorrect performance obligation logic directly distorts revenue recognition schedules.
Why this happens, scenario analysis and root cause.
1. ECC revenue recognition did not explicitly manage performance obligations. 2. Migration teams assume billing items automatically represent revenue obligations. 3. Design workshops focus on revenue postings rather than contract structure design. 4. Finance and SD teams often define obligations without shared governance. Performance obligation derivation requires collaboration between finance, pricing, and sales process teams.
Why this is a migration, exclusive failure.
1. ECC systems recognized revenue primarily through billing events. 2. S4 HANA revenue accounting introduces contract-based revenue allocation. 3. Each contract must identify distinct performance obligations. 4. Migration exposes gaps between legacy billing structures and contract-based revenue models. Performance obligations define how revenue is allocated across contractual deliverables.
Financial and customer impact.
1. Revenue recognition schedules become inaccurate or inconsistent. 2. Financial statements may not comply with IFRS 15 or ASC 606 requirements. 3. Audit findings increase due to incorrect allocation of contract revenue. 4. Finance teams struggle to reconcile revenue between operational and accounting systems. Revenue allocation errors directly affect financial reporting accuracy.
Governance and accountability, RACI model.
Performance obligation architecture must be governed jointly by finance and sales leadership. 1. Accountable revenue accounting architecture lead. The person responsible for RAR obligation architecture and gets fired if revenue allocation fails after migration. 2. Responsible SD pricing and billing lead. Ensures sales items map correctly to performance obligations. 3. Consulted solution architect. Validates integration between SD transactions and revenue contract structures. 4. Informed financial reporting compliance director. Oversees accounting standard compliance. Correct performance obligation derivation ensures compliance with modern revenue accounting standards.
Ownership, who actually fixes it.
Resolving this requires defining performance obligation derivation rules for all contract scenarios. 1. Revenue accounting architecture lead defines obligation derivation logic. 2. SD pricing and billing lead maps sales items to revenue obligations. 3. Solution architect validates integration between sales transactions and RAR. 4. Financial reporting compliance director approves accounting compliance rules.
Who gets blamed versus who owns it.
1. Blamed billing configuration team. Executives assume incorrect billing setup caused revenue allocation errors. 2. Blamed finance accounting team. Perceived as generating incorrect financial reports. 3. Actual owner revenue accounting architecture lead. Responsible for performance obligation derivation logic. 4. Root cause performance obligation architecture was not designed during explore phase. Revenue allocation errors usually originate from missing contract structure design.
How this is actually fixed, the right way by a role.
1. Revenue accounting architecture lead defines performance obligation derivation rules. 2. SD pricing and billing lead ensures sales order items correctly map to obligations. 3. Solution architect validates integration between SD processes and RAR contract structures. 4. Financial reporting compliance director validates accounting standard compliance.
What not to do, common wrong fixes.
1. Assuming billing items automatically represent performance obligations. 2. Ignoring obligation derivation logic during RAR design workshops. 3. Treating revenue allocation as a purely accounting configuration. 4. Deferring obligation design until realization or testing phases. Performance obligation logic must be designed early to ensure revenue compliance.
Follow-up 1. What is a performance obligation in revenue accounting?
Answer: a performance obligation represents a distinct promise to deliver goods or services to a customer within a contract. Revenue must be recognized when that obligation is fulfilled rather than simply when billing occurs. S4 HANA Revenue Accounting uses these obligations to determine how revenue is distributed across contract deliverables.
Follow-up 2. Why do projects struggle with performance obligation design?
Answer: many organizations historically relied on billing events for revenue recognition and never modeled contract deliverables formally. When implementing RAR, they must identify and map obligations explicitly. This requires collaboration between finance, sales operations, and pricing teams.
Follow-up 3, curveball. What happens if performance obligations are derived incorrectly?
Answer: revenue may be recognized in the wrong accounting periods or allocated incorrectly across contract deliverables. This can lead to audit findings and financial reporting discrepancies. Correcting these issues after go-live often requires manual revenue adjustments and system redesign.
Exclusive pro tip.
During Explore phase, perform a contract structure workshop involving finance, sales, and pricing teams. Identify every deliverable that constitutes a performance obligation and validate its revenue recognition schedule. This ensures RAR configuration aligns with accounting standards before realization begins.
Scenario 44, SD to RAR interface redesign gaps.
In the Explore phase of ECC to S/4HANA migration, organizations fail to redesign the interface between sales and distribution transactions and revenue accounting and reporting. In ECC environments, revenue recognition was usually triggered directly from billing documents through FI postings. S/4HANA introduces a dedicated integration layer where SD sales orders, billing documents, and service transactions generate revenue accounting events. If this SD to RAR integration architecture is not properly designed, revenue contracts are created incorrectly or financial postings fail during transaction processing.
Scenario classification and relevant SAP note, if applicable.
1. Complexity very high, cross-module revenue architecture impact. 2. Phase Explore. 3. Frequency common in organizations implementing revenue accounting and reporting. 4. Primary ownership revenue accounting architecture lead. 5. Supporting SD billing integration lead. 6. Business ownership corporate revenue recognition director. 7. Relevant SAP note. SAP note 22673119 and SAP note 2225170. Revenue accounting and reporting simplifications.
Diagnostic dashboard, symptoms and evidence.
How SD and RAR interface gaps appear during integration testing. 1. Symptom: revenue contracts fail to generate after sales order or billing transactions. 2. Red flag: integration configuration between SD events and RAR is missing or incomplete. 3. Business impact: revenue recognition schedules cannot be generated for customer transactions. 4. Detection: validate event mapping configuration between SD billing and RAR integration layer. 5. Technical proof: integration logs show failed revenue event creation during sales transaction processing. Insight: if billing documents post successfully but revenue contracts are missing, the SD to RAR interface is broken.
Why this happens, scenario analysis and root cause.
1. ECC revenue recognition was driven directly by billing events without an intermediate revenue contract layer. 2. Migration teams underestimate the architectural changes introduced by revenue accounting and reporting. 3. Design workshops focus on RAR configuration but ignore SD transaction integration. 4. Sales and finance teams often design their processes independently. RAR architecture requires tight integration between SD operational transactions and financial revenue models.
Why this is a migration, exclusive failure.
1. ECC revenue recognition logic was embedded directly within billing and FI postings. 2. S/4HANA introduces a new revenue contract architecture through revenue accounting and reporting. 3. Sales transactions must generate revenue events that feed the RAR engine. 4. Migration exposes missing integration logic between operational sales processing and revenue accounting. RAR depends on event-based integration between operational transactions and financial recognition models.
Financial and customer impact.
1. Revenue contracts fail to generate for customer transactions. 2. Financial reporting becomes incomplete or inconsistent. 3. Revenue schedules cannot be reconciled between sales transactions and accounting systems. 4. Audit risks increase due to inconsistent revenue recognition processes. Broken SD and RAR integration creates financial reporting inconsistencies.
Governance and accountability, RACI model.
Revenue integration architecture requires joint governance between finance and sales system design teams. 1. Accountable revenue accounting architecture lead. The person responsible for RAR integration architecture and gets fired if revenue recognition fails after migration. 2. Responsible SD billing integration lead. Ensures SD billing events correctly trigger revenue accounting events. 3. Consulted solution architect. Validates architecture between SD operational processes and revenue accounting engine. 4. Informed corporate revenue recognition director. Oversees financial compliance and reporting accuracy. RAR integration failures usually originate from poor cross-module architecture decisions.
Ownership, who actually fixes it.
Resolving this requires designing a complete event-based integration architecture between SD and revenue accounting. 1. Revenue accounting architecture lead defines revenue event integration architecture. 2. SD billing integration lead maps billing and sales events to RAR contract creation. 3. Solution architect validates cross-module integration architecture. 4. Corporate revenue recognition director approves revenue reporting governance.
Who gets blamed versus who owns it.
1. Blamed SD billing team. Executives assume billing configuration errors caused revenue failures. 2. Blamed finance accounting team. Perceived as producing incorrect financial reports. 3. Actual owner revenue accounting architecture lead. Responsible for SD to RAR integration architecture. 4. Root cause integration architecture between sales transactions and RAR engine was never designed. Revenue integration failures almost always originate from architectural design gaps.
How this is actually fixed, the right way by a role.
1. Revenue accounting architecture lead defines revenue event creation architecture. 2. SD billing integration lead maps SD billing and sales transactions to revenue accounting events. 3. Solution architect validates integration between SD operational flows and RAR engine. 4. Corporate revenue recognition director validates accounting compliance and revenue reporting alignment.
What not to do, common wrong fixes.
1. Assuming billing postings automatically generate revenue recognition. 2. Ignoring SD integration during RAR design workshops. 3. Treating revenue recognition architecture as a purely finance-driven configuration. 4. Deferring integration design until realization or testing phases. Revenue accounting requires early cross-module architecture design.
Follow-up 1. Why is SD integration critical for revenue accounting?
Answer: revenue accounting and reporting depends on operational sales transactions to generate revenue events. These events trigger contract creation and revenue allocation within the accounting engine. Without properly designed SD integration, the revenue recognition process cannot function correctly.
Follow-up 2. Why do projects often overlook SD and RAR integration design?
Answer: many organizations assume revenue recognition is purely a financial configuration topic. However, the process actually begins with operational sales transactions. If the SD event architecture is not designed early, revenue accounting cannot correctly process customer transactions.
Follow-up 3. Curveball. What happens if SD and RAR integration fails after go live?
Answer: revenue contracts may fail to generate for new transactions, even though billing and delivery processes continue working. Finance teams must manually adjust revenue recognition schedules and financial postings. Fixing the architecture post-go-live is extremely complex and disruptive.
Exclusive pro tip.
During Explore phase, perform an integration simulation where sales orders, deliveries, and billing documents generate revenue events in the RAR engine. Validate the entire chain from operational transaction to revenue recognition schedule before realization begins.
Scenario 45. Open revenue contract migration strategy missing.
In the Explore phase of ECC to S4 HANA migration, organizations fail to define how open revenue contracts or partially fulfilled customer agreements will migrate into revenue accounting and reporting. ECC revenue recognition often stored progress in billing, and FI postings without a formal contract structure. S/4HANA requires revenue contracts to exist in the revenue accounting engine, with defined obligations and revenue schedules. Without a clear migration strategy for open contracts, financial balances and revenue schedules cannot be reconstructed correctly in the new system.
Scenario classification and relevant SAP note, if applicable.
1. Complexity very high. Financial migration and revenue compliance risk. 2. Phase explore. 3. Frequency common in subscription, project billing, and long-term contract businesses. 4. Primary ownership revenue accounting architecture lead. 5. Supporting data migration lead. 6. Business ownership financial reporting compliance director. 7. Relevant SAP note. SAP note 22673119 and SAP note 2225170. Revenue accounting and reporting simplifications.
Diagnostic dashboard, symptoms and evidence.
How missing revenue contract migration strategies appear during testing and financial reconciliation. 1. Symptom: open revenue balances in ECC cannot be reconciled after migration. 2. Red flag: no documented strategy exists for converting open revenue contracts into RAR. 3. Business impact: revenue schedules and financial balances become inconsistent after go live. 4. Detection: compare ECC open revenue balances with RAR contract balances during mock migration tests. 5. Technical proof: migration logs show missing or partially created revenue contracts in the RAR engine. Insight: open revenue contracts must be migrated with their obligations and schedules intact.
Why this happens, scenario analysis and root cause.
1. ECC revenue balances were stored across billing documents and FI postings rather than contract structures. 2. Migration teams underestimate the complexity of reconstructing revenue schedules. 3. Finance teams assume historical balances can be recreated automatically after migration. 4. Revenue migration planning is often deferred until late realization phases. Revenue migration requires reconstructing contract structures from legacy financial data.
Why this is a migration, exclusive failure.
1. ECC systems did not maintain formal revenue contract structures. 2. S/4HANA revenue accounting requires explicit contract and obligation models. 3. Open revenue balances must be reconstructed into new contract records. 4. Migration exposes structural gaps between legacy revenue data and modern contract-based accounting. RAR migration requires transforming historical billing data into structured revenue contracts.
Financial and customer impact.
1. Revenue balances cannot be reconciled during financial close after migration. 2. Financial statements may contain inaccurate revenue schedules. 3. Audit risks increase due to incomplete contract reconstruction. 4. Finance teams must manually adjust revenue balances after go live. Revenue migration errors directly impact financial reporting credibility.
Governance and accountability, RACI model.
Revenue contract migration requires strong governance across finance, migration, and architecture teams. 1. Accountable revenue accounting architecture lead. The person responsible for revenue migration architecture and gets fired if financial balances cannot be reconciled after migration. 2. Responsible data migration lead. Designs and executes revenue contract migration processes. 3. Consulted solution architect. Validates architecture between legacy revenue data and RAR contract models. 4. Informed financial reporting compliance director. Oversees revenue compliance and audit readiness. Revenue migration architecture must preserve financial integrity across systems.
Ownership, who actually fixes it.
Resolving this requires designing a structured migration approach for open revenue contracts. 1. Revenue accounting architecture lead defines the migration architecture for open revenue contracts. 2. Data migration lead reconstructs revenue schedules from ECC billing and FI history. 3. Solution architect validates alignment between migrated contracts and RAR structures. 4. Financial reporting compliance director approves final revenue reconciliation strategy.
Who gets blamed versus who owns it.
1. Blamed data migration team. Executives assume migration scripts failed to move revenue balances. 2. Blamed finance accounting team. perceived as producing inconsistent financial reports. 3. Actual owner, revenue accounting architecture lead, responsible for defining revenue contract migration architecture. 4. Root cause, open revenue contract migration strategy was never designed during explore phase. Revenue migration failures almost always originate from missing architectural planning.
How this is actually fixed, the right way by a role.
1. Revenue accounting architecture lead defines contract reconstruction logic for open revenue balances. 2. Data migration lead extracts ECC billing and FI data to rebuild contract schedules. 3. Solution architect validates structural integrity of migrated contracts within RAR. 4. Financial reporting compliance director verifies financial reconciliation before cutover.
What not to do, common wrong fixes.
1. Ignoring open revenue contracts during migration planning. 2. Assuming revenue balances can be recreated automatically in RAR. 3. Migrating billing history without reconstructing contract structures. 4. Deferring revenue reconciliation planning until cutover phases. Revenue contracts must be reconstructed with full financial context during migration.
Follow-up 1. Why is migrating open revenue contracts difficult?
Answer: open revenue contracts represent partially fulfilled customer obligations with remaining revenue schedules. ECC systems often track this information across billing documents and FI postings rather than structured contracts. Migration requires reconstructing these contracts with accurate obligations and revenue schedules.
Follow-up 2. What is the safest migration strategy for open revenue balances?
Answer: many organizations create reconstructed revenue contracts in RAR using extracted ECC billing and financial data. These reconstructed contracts include remaining obligations and revenue schedules. Mock migrations are then used to validate financial reconciliation before production cutover.
Follow-up 3. Curveball. What happens if open revenue balances are not migrated correctly?
Answer: financial statements after go live may contain missing or incorrect revenue balances. Finance teams may need to manually reconstruct revenue schedules and post adjusting entries. This often leads to audit concerns and significant post-go-live remediation work.
Exclusive pro tip.
Always perform a financial reconciliation simulation for open revenue balances during mock migration cycles. Reconstruct revenue contracts using historical billing and FI data, and validate that revenue schedules match legacy system balances before final cutover.
Scenario 46. Advanced Variant Configuration Dependency Incompatibility.
In the explore phase of ECC to S4 HANA migration, organizations discover that their existing variant configuration models contain dependencies that are incompatible with advanced variant configuration. ECC variant configuration relied heavily on classic dependency syntax and configuration tables that behave differently in S4 HANA. When these dependencies are not validated during design, product configuration logic fails, leading to incorrect pricing, invalid product combinations, or order entry errors.
Scenario classification and relevant SAP note, if applicable.
1. Complexity high. Product configuration and sales order processing impact. 2. Phase explore. 3. Frequency common in manufacturing, automotive, and industrial equipment industries. 4. Primary ownership variant configuration architecture lead. 5. Supporting SD product configuration lead. 6. Business ownership product engineering director. 7. Relevant SAP note. SAP note 2711932. Advanced variant configuration simplifications.
Diagnostic dashboard, symptoms and evidence.
How configuration dependency incompatibilities appear during testing. 1. Symptom: product configuration fails during sales order creation. 2. Red flag: legacy dependency syntax used in configuration models without validation for advanced variant configuration. 3. Business impact: customers cannot configure valid product combinations during order entry. 4. Detection: run configuration simulation tests in the S4 HANA sandbox environment. 5. Technical proof: configuration engine logs show dependency evaluation errors. Insight: Configuration dependency errors often surface only when complex product options are selected.
Why this happens, scenario analysis and root cause.
1. ECC variant configuration dependencies were designed for legacy configuration engines. 2. Migration teams assume configuration models will behave identically in advanced variant configuration. 3. Dependency syntax and object relationships change in the S4 HANA configuration engine. 4. Configuration testing often focuses on simple scenarios rather than complex option combinations. Variant configuration dependencies must be revalidated when migrating to advanced variant configuration.
Why this is a migration, exclusive failure.
1. ECC configuration engines allowed legacy dependency structures. 2. S4 HANA Advanced Variant Configuration introduces a redesigned configuration engine. 3. Dependency evaluation logic behaves differently in the new engine. 4. Migration exposes incompatibilities between legacy dependency models and modern configuration logic. Configuration engines are fundamentally redesigned in advanced variant configuration.
Financial and customer impact.
1. Customers cannot create valid product configurations during order entry. 2. Sales orders contain incorrect product variants or pricing results. 3. Manufacturing instructions may be generated incorrectly for configured products. 4. Revenue loss occurs when configured products cannot be sold accurately. Configuration failures directly affect product sales and manufacturing accuracy.
Governance and accountability, RACI model.
Product configuration architecture must be governed jointly by engineering and SAP configuration teams. 1. Accountable variant configuration architecture lead. The person responsible for configuration architecture and gets fired if product configuration fails after migration. 2. Responsible SD product configuration lead. Validates dependency compatibility in advanced variant configuration. 3. Consulted solution architect. Reviews configuration architecture across product models and sales processes. 4. Informed product engineering director. Oversees product configuration governance. Configuration architecture must be validated before product models are migrated.
Ownership, who actually fixes it.
Resolving this requires redesigning incompatible configuration dependencies. 1. Variant configuration architecture lead analyzes dependency compatibility. 2. SD product configuration lead updates configuration rules and dependency syntax. 3. Solution architect validates cross-module integration between configuration and pricing. 4. Product engineering director approves updated configuration logic.
Who gets blamed versus who owns it.
1. Blamed product configuration team. Executives assume configuration data was migrated incorrectly. 2. Blamed sales operations team. Perceived as entering invalid product configurations. 3. Actual owner variant configuration architecture lead. Responsible for dependency compatibility design. 4. Root cause legacy configuration dependencies were not validated during explore phase. Configuration errors usually originate from dependency architecture mismatches.
How this is actually fixed, the right way by a role.
1. Variant configuration architecture lead performs dependency compatibility analysis. 2. SD product configuration lead rewrites incompatible dependency logic. 3. Solution architect validates integration between configuration, pricing, and manufacturing processes. 4. Product engineering director approves redesigned configuration rules.
What not to do, common wrong fixes.
1. Assuming ECC configuration models will work unchanged in advanced variant configuration. 2. Testing only simple configuration scenarios during validation. 3. Ignoring dependency compatibility during migration planning. 4. Deferring configuration validation until integration testing. Configuration models must be validated before production product catalogs are migrated.
Follow-up 1. Why does advanced variant configuration behave differently from ECC configuration?
Answer: Advanced variant configuration introduces a redesigned configuration engine with improved performance and modeling capabilities. However, legacy, dependency syntax, and evaluation logic may behave differently. Organizations must review and validate all configuration dependencies during migration.
Follow-up 2. What is the safest approach to validating configuration dependencies?
Answer: organizations typically simulate configuration scenarios in sandbox environments using real product models. Complex option combinations should be tested along with pricing and manufacturing integrations. This ensures configuration logic behaves correctly before production migration.
Follow-up 3, Curveball. What happens if configuration dependencies fail after go live?
Answer: sales teams may be unable to configure products correctly during order entry. Incorrect product combinations may also generate manufacturing errors or pricing discrepancies. Fixing configuration logic after go live can disrupt both sales and production processes.
Exclusive pro tip.
Before migrating product configuration models, run dependency compatibility checks and simulate complex product combinations in advanced variant configuration. Validate pricing, manufacturing, and logistics outcomes to ensure configuration logic behaves correctly in the new engine.
Please check description or comment section of this video. I have given a lot of links for downloading 7 or 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked system design, most asked implementation project-related interview questions and answers, most asked support project-related interview questions and answers, required for your SAP functional modules interviews jobs like SAP MM consultant jobs, SAP FICO consultant jobs, SAP SD consultant jobs, SAP PP consultant jobs, SAP Ariba consultant jobs, SAP Extended Warehouse Management EWM consultant jobs, SAP Plant Maintenance PM consultant jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section, these questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people also for your interviews. You people can download all 7 or 8 PDFs in a single zip file from below given links.
Scenario 47. IPC decommissioning impact not assessed.
In the explore phase of ECC to S/4HANA migration, organizations fail to evaluate the impact of internet pricing and configurator decommissioning. Many ECC landscapes used IPC for pricing calculations in e-commerce platforms, CRM systems, and external configuration tools. S/4HANA replaces IPC with the S/4HANA pricing engine and new integration APIs. If this architectural shift is not assessed during design, external applications cannot perform pricing simulations correctly, resulting in incorrect quotations, order pricing mismatches, or failed integrations.
Scenario classification and relevant SAP note, if applicable.
1. Complexity high, pricing integration and e-commerce architecture impact. 2. Phase explore. 3. Frequency common in organizations with CRM, e-commerce, or CPQ integrations. 4. Primary ownership pricing architecture lead. 5. Supporting integration architecture lead. 6. Business ownership digital commerce director. 7. Relevant SAP note. SAP note 23185009. Internet pricing and configurator deprecation.
Diagnostic dashboard, symptoms and evidence.
How IPC decommissioning gaps appear during integration testing. 1. Symptom, e-commerce, or CRM systems cannot calculate pricing during quotation simulations. 2. Red flag external applications still reference IPC pricing endpoints. 3. Business impact customers receive incorrect product prices during online ordering. 4. Detection, review integration architecture for dependencies on IPC pricing services. 5. Technical proof, Integration logs show failed pricing calls from external systems. Insight: if external systems cannot simulate pricing correctly, IPC dependencies were not replaced.
Why this happens, scenario analysis and root cause.
1. ECC landscapes relied on IPC to provide pricing calculations to external applications. 2. Migration teams assume pricing logic will behave the same after system conversion. 3. External integrations using IPC are often poorly documented in legacy architectures. 4. Pricing architecture workshops focus on internal billing rather than external integrations. Pricing engines often power multiple external systems beyond core order processing.
Why this is a migration, exclusive failure.
1. ECC environments supported IPC as an external pricing engine. 2. S/4HANA replaces IPC with the internal S/4HANA pricing engine. 3. External applications must integrate through new APIs or pricing services. 4. Migration exposes hidden dependencies on legacy IPC architecture. Pricing architecture must be redesigned when IPC is removed.
Financial and customer impact.
1. Customers receive incorrect prices during online order simulations. 2. Quotations generated by CRM or e-commerce platforms do not match SAP billing. 3. Revenue leakage occurs when incorrect discounts or pricing conditions are applied. 4. Sales teams lose credibility when system pricing becomes inconsistent. Pricing consistency across systems is essential for customer trust and revenue protection.
Governance and accountability, RACI model.
Pricing architecture changes must be governed across integration and sales platform teams. 1. Accountable pricing architecture lead. The person responsible for pricing architecture and gets fired if pricing integrations fail after migration. 2. Responsible integration architecture lead. Designs new APIs and services replacing IPC integrations. 3. Consulted solution architect. Validates architecture between SAP pricing engine and external systems. 4. Informed digital commerce director. Oversees e-commerce pricing accuracy. Pricing architecture failures often originate from undocumented legacy integrations.
Ownership, who actually fixes it.
Resolving this requires redesigning pricing integration architecture. 1. Pricing architecture lead defines new pricing service architecture for S/4HANA. 2. Integration architecture lead replaces IPC endpoints with supported APIs. 3. Solution architect validates cross-system pricing consistency. 4. Digital Commerce Director approves updated e-commerce pricing flows.
Who gets blamed versus who owns it.
1. Blamed e-commerce platform team. Executives assume website pricing logic is broken. 2. Blamed sales operations team. Perceived as maintaining incorrect pricing conditions. 3. Actual owner pricing architecture lead. Responsible for IPC decommissioning strategy. 4. Root cause, legacy IPC dependencies were not identified during explore phase. Pricing integration issues almost always originate from architectural oversight.
How this is actually fixed, the right way by a role.
1. Pricing architecture lead designs replacement pricing architecture for S/4HANA. 2. Integration architecture lead rebuilds external pricing integrations using supported APIs. 3. Solution architect validates consistency between internal billing and external price simulations. 4. Digital Commerce Director validates e-commerce pricing accuracy across customer journeys.
What not to do, common wrong fixes.
1. Ignoring legacy IPC integrations during migration planning. 2. Assuming external systems can reuse ECC pricing interfaces. 3. Testing pricing only within SAP order entry scenarios. 4. Deferring e-commerce pricing validation until user acceptance testing. Pricing architecture must be validated across all systems that generate customer prices.
Follow-up 1. Why was IPC widely used in ECC environments?
Answer: Internet pricing and configurator allowed external applications such as e-commerce websites and CRM systems to simulate SAP pricing logic without creating real orders. This enabled online quotations and pricing simulations. Many legacy systems depend heavily on this architecture.
Follow-up 2. How should organizations replace IPC integrations?
Answer: organizations typically redesign integrations using S/4HANA pricing APIs or specialized pricing services. External systems must connect through supported interfaces rather than the legacy IPC engine. This ensures pricing simulations remain consistent with SAP billing logic.
Follow-up 3, Curveball. What happens if IPC dependencies are discovered after go live?
Answer: external systems may suddenly fail to calculate product pricing during customer interactions. E-commerce platforms might display incorrect prices or fail to generate quotations. Emergency integration redesign becomes necessary while business operations continue running.
Exclusive pro tip.
During architecture discovery, map every external system that performs pricing simulations, including e-commerce platforms, CRM systems, and CPQ tools. Validate that all IPC dependencies are replaced with supported S/4HANA pricing APIs before integration testing begins.
Scenario 48. Class type inconsistencies in configuration.
In the explore phase of ECC to S/4HANA migration, organizations discover inconsistencies in class type assignments used within variant configuration models. ECC systems often allowed flexible or loosely governed usage of class types across materials, characteristics, and configuration objects. S/4HANA Advanced Variant Configuration introduces stricter structure and dependency validation. When class type usage is inconsistent across product models, configuration logic fails, resulting in incorrect product selections, invalid dependencies, or configuration runtime errors during order entry.
Scenario classification and relevant SAP note, if applicable.
1. Complexity high, product configuration and order entry impact. 2. Phase explore. 3. Frequency common in manufacturing and complex product industries. 4. Primary ownership variant configuration architecture lead. 5. Supporting master data governance lead. 6. Business ownership product engineering director. 7. Relevant SAP note. SAP note 2711932. Advanced variant configuration simplifications.
Diagnostic dashboard, symptoms and evidence.
How class type inconsistencies appear during configuration testing. 1. Symptom: configuration runtime errors appear when selecting product options during sales order entry. 2. Red flag: product models use different class types for similar configuration objects. 3. Business impact: sales teams cannot configure valid product combinations for customers. 4. Detection: analyze class type usage across materials, characteristics, and configuration objects. 5. Technical proof: configuration engine logs show dependency evaluation failures linked to class type mismatches. Insight: configuration errors often originate from inconsistent class structures rather than dependency syntax.
Why this happens, scenario analysis and root cause.
1. ECC environments allow decentralized product model governance. 2. Different product teams created configuration models using inconsistent class structures. 3. Migration teams assume legacy class assignments will behave identically in advanced variant configuration. 4. Configuration design documentation is often incomplete in legacy environments. Configuration architecture must be standardized before migrating product models.
Why this is a migration, exclusive failure.
1. ECC configuration engines tolerated flexible class type structures. 2. S/4HANA Advanced Variant Configuration enforces stricter dependency validation. 3. Class types must align consistently across configuration objects. 4. Migration exposes structural inconsistencies within product configuration models. Configuration architecture must be normalized when migrating to advanced variant configuration.
Financial and customer impact.
1. Sales teams cannot configure products correctly during customer order entry. 2. Incorrect product combinations lead to manufacturing or fulfillment errors. 3. Quotation processes slow down due to configuration validation failures. 4. Revenue opportunities may be lost when configured products cannot be sold. Configuration model inconsistencies directly affect sales and production accuracy.
Governance and accountability, RACI model.
Configuration master data governance must align product engineering and SAP configuration architecture. 1. Accountable Variant Configuration Architecture Lead. The person responsible for configuration model architecture and gets fired if product configuration fails after migration. 2. Responsible Master Data Governance Lead. Ensures class type consistency across product models. 3. Consulted Solution Architect. Validates cross-module impact between configuration, pricing, and manufacturing. 4. Informed Product Engineering Director. Oversees product configuration governance. Configuration architecture failures often originate from poor master data governance.
Ownership, who actually fixes it.
Resolving this requires standardizing configuration class structures. 1. Variant Configuration Architecture Lead analyzes class type architecture across product models. 2. Master Data Governance Lead standardizes class type assignments and characteristic usage. 3. Solution Architect validates integration between configuration, pricing, and logistics processes. 4. Product Engineering Director approves standardized configuration governance rules.
Who gets blamed versus who owns it.
1. Blamed Product Configuration Team. Executives assume configuration rules were incorrectly migrated. 2. Blamed Sales Operations Team. Perceived as selecting invalid configuration options. 3. Actual Owner Variant Configuration Architecture Lead. Responsible for configuration class architecture design. 4. Root cause class type governance was inconsistent across legacy product models. Configuration architecture inconsistencies usually originate from fragmented master data governance.
How this is actually fixed, the right way by a role.
1. Variant Configuration Architecture Lead performs class type architecture review. 2. Master Data Governance Lead standardizes class structures and characteristic assignments. 3. Solution Architect validates integration between configuration models and downstream processes. 4. Product Engineering Director approves updated configuration governance framework.
What not to do, common wrong fixes.
1. Assuming legacy class type assignments will behave correctly in advanced variant configuration. 2. Testing only basic configuration scenarios during migration validation. 3. Ignoring master data governance for configuration objects. 4. Deferring configuration structure validation until late testing phases. Configuration structures must be standardized before product models are migrated.
Follow-up 1. Why are class types critical in variant configuration?
Answer: class types determine how characteristics and configuration objects are structured within product models. They define relationships between materials, configuration dependencies, and product features. If class types are inconsistent across models, the configuration engine cannot correctly evaluate product options.
Follow-up 2. How should organizations validate configuration class structures?
Answer: configuration architects typically analyze all class types and characteristic assignments across product models. They standardize structures and validate dependencies in sandbox environments. This ensures configuration logic behaves consistently before migrating production models.
Follow-up 3. Curveball. What happens if class inconsistencies remain after go live?
Answer: sales order configuration may fail or generate invalid product combinations. Manufacturing instructions may also become inconsistent with customer orders. Fixing configuration class structures after go live often requires reworking product models and master data.
Exclusive pro tip.
Before migrating configuration models, perform a class structure audit across all configurable products. Standardize class types and characteristic assignments to ensure compatibility with advanced variant configuration and avoid configuration runtime errors after go live.
Scenario 49. Flexible workflow replacing classic approval strategies.
In the explore phase of ECC to S4 HANA migration, organizations fail to redesign approval processes that previously relied on classic release strategies or custom workflow logic. ECC systems often used user exits, custom programs, or traditional workflow frameworks to control approvals for pricing overrides, credit blocks, or billing releases. S4 HANA introduces flexible workflow as the modern framework for approval processes. If this architectural shift is not planned during design, approval processes break, resulting in blocked transactions, unauthorized approvals, or Inconsistent governance across sales processes.
Scenario classification and relevant SAP note, if applicable.
1. Complexity high. Approval governance and process automation impact. 2. Phase explore. 3. Frequency common in organizations with complex approval processes. 4. Primary ownership workflow architecture lead. 5. Supporting SD process design lead. 6. Business ownership sales governance director. 7. Relevant SAP note not applicable extensibility gap. This is a workflow architecture redesign requirement, not an SAP software change. Reference SAP Note 2198647 for custom code adaptation context only.
Diagnostic dashboard, symptoms and evidence.
How approval workflow redesign gaps appear during process testing. 1. Symptom, sales orders, pricing changes, or billing documents remain blocked without triggering approvals. 2. Red flag legacy approval strategies still referenced in configuration or custom code. 3. Business impact sales transactions stall because approvals cannot be completed. 4. Detection. Review workflow configuration for migration from classic release strategies to flexible workflow. 5. Technical proof. Workflow logs show missing approval triggers for sales transactions. Insight. Approval failures usually originate from missing workflow architecture redesign.
Why this happens, scenario analysis and root cause.
1. ECC approval processes relied heavily on custom exits and classic workflow logic. 2. Migration teams assume legacy approval configurations will continue working in S4 HANA. 3. Workflow architecture discussions are often deferred until realization phases. 4. Business stakeholders may not fully understand the shift toward flexible workflow governance. Approval governance must be redesigned when moving to the flexible workflow framework.
Why this is a migration, exclusive failure.
1. ECC supported multiple legacy workflow frameworks and release strategies. 2. S4 HANA standardizes approval automation through flexible workflow. 3. Legacy user exits and custom workflow triggers may no longer function correctly. 4. Migration exposes approval logic embedded in custom code or legacy configurations. Flexible workflow introduces a modern approval architecture replacing legacy mechanisms.
Financial and customer impact.
1. Sales orders remain blocked because approvals cannot be triggered. 2. Pricing exceptions may bypass governance controls. 3. Billing documents cannot be released due to missing approval processes. 4. Operational delays occur as manual approvals replace automated governance. Broken approval processes disrupt operational control across sales transactions.
Governance and accountability, RACI model.
Approval architecture must align workflow governance with operational sales processes. 1. Accountable workflow architecture lead. The person responsible for approval workflow architecture and gets fired if approval processes fail after migration. 2. Responsible SD process design lead. Defines business approval scenarios and triggers. 3. Consulted solution architect. Validates integration between workflow automation and transaction processing. 4. Informed sales governance director. Oversees compliance with approval policies. Workflow governance failures usually originate from missing architectural redesign.
Ownership, who actually fixes it.
Resolving this requires redesigning approval processes using flexible workflow. 1. Workflow architecture lead designs approval architecture using flexible workflow. 2. SD process design lead defines approval triggers for pricing, credit, and billing scenarios. 3. Solution architect validates integration between workflows and transaction processing. 4. Sales governance director approves updated approval governance rules.
Who gets blamed versus who owns it.
1. Blamed SD functional team. Executives assume incorrect configuration caused approval failures. 2. Blamed workflow support team. Perceived as failing to maintain approval processes. 3. Actual owner workflow architecture lead. Responsible for redesigning approval architecture. 4. Root cause legacy approval frameworks were not replaced with flexible workflow. Approval process failures typically originate from outdated workflow architecture.
How this is actually fixed, the right way by a role.
1. Workflow architecture lead designs approval processes using flexible workflow framework. 2. SD process design lead maps approval triggers for sales orders, pricing, and billing events. 3. Solution architect validates workflow integration across transactional processes. 4. Sales governance director approves governance policies for automated approvals.
What not to do, common wrong fixes.
1. Attempting to reuse legacy release strategies without redesign. 2. Embedding approval logic directly within custom code. 3. Testing workflows only during late user acceptance testing. 4. Ignoring governance requirements for approval automation. Approval automation must be redesigned using the flexible workflow framework.
Follow-up 1. What is flexible workflow in S4 HANA?
Answer: Flexible workflow is the modern approval framework introduced in S4 HANA to manage approval processes across business transactions. It allows organizations to define rules, approval chains, and conditions without heavy custom development. This provides greater flexibility and transparency compared to classic workflow mechanisms.
Follow-up 2. Why do approval processes often fail after migration?
Answer: Many legacy approval mechanisms relied on custom exits, user status checks, or classic workflow triggers. When migrating to S4 HANA, these mechanisms may no longer work correctly. Without redesigning approval architecture using flexible workflow, transaction approvals may fail or become inconsistent.
Follow-up 3. Curveball. What happens if approval processes break after go live?
Answer: Sales transactions may become blocked because approvals cannot be completed automatically. Alternatively, pricing or credit exceptions may bypass governance controls entirely. Fixing approval architecture after go live often requires urgent workflow redesign and operational disruption.
Exclusive pro tip.
During Explore phase, conduct a complete approval governance workshop, mapping every approval scenario across pricing, credit, billing, and order management. Design these approvals directly within the flexible workflow framework, rather than attempting to replicate legacy release strategies.
Scenario 50. Scale-based type behavior change in pricing.
In the Explore phase of ECC to S4 HANA migration, organizations fail to reassess how pricing scales behave under the new pricing data model. ECC pricing scales often relied on quantity, value, or weight thresholds defined in condition records stored in the KONV table. S4 HANA replaces KONV with the PRCD_elements data model and introduces subtle behavioral differences in scale-based type evaluation. If these differences are not analyzed during design, pricing calculations may produce incorrect discounts, surcharges, or tiered pricing results during order processing.
Scenario classification and relevant SAP note, if applicable.
1. Complexity high, pricing calculation and revenue impact. 2. Phase Explore. 3. Frequency common in organizations using tiered pricing or volume discounts. 4. Primary ownership pricing architecture lead. 5. Supporting SD pricing configuration lead. 6. Business ownership commercial pricing director. 7. Relevant SAP note 2267308, pricing data model simplification.
Diagnostic dashboard, symptoms and evidence.
How pricing scale-based type issues appear during order pricing tests. 1. Symptom, discounts or surcharges calculated differently compared to ECC pricing results. 2. Red flag pricing scale-based types were migrated without validation against S4 HANA pricing logic. 3. Business impact, customers receive incorrect pricing for bulk orders or tiered discounts. 4. Detection. Compare ECC and S4 HANA pricing simulations for identical sales orders. 5. Technical proof. Pricing trace logs show different scale thresholds being applied in calculations. Insight. Pricing scale behavior differences are often subtle, but can significantly affect revenue.
Why this happens, scenario analysis and root cause.
1. ECC pricing scales were built around legacy KONV data structures. 2. Migration teams assume pricing behavior will remain identical in the new pricing model. 3. Scale-based type evaluation logic changes slightly with the PRCD_element structure. 4. Pricing design workshops often focus on condition types rather than scale evaluation logic. Scale-based types must be validated during pricing model redesign.
Why this is a migration, exclusive failure.
1. ECC pricing logic was tightly coupled with the KONV condition record structure. 2. S/4HANA introduces a redesigned pricing data model using PRCD_elements. 3. Scale evaluation behavior may produce different results in complex pricing scenarios. 4. Migration exposes pricing logic assumptions embedded in legacy condition records. Pricing scale evaluation must be tested thoroughly when adopting the new pricing data model.
Financial and customer impact.
1. Customers may receive incorrect volume discounts or pricing adjustments. 2. Revenue leakage occurs when pricing tiers apply incorrectly. 3. Commercial agreements may be violated due to pricing inconsistencies. 4. Sales teams lose confidence in automated pricing calculations. Even small pricing calculation changes can create major financial discrepancies.
Governance and accountability, RACI model.
Pricing architecture must be governed jointly by commercial and SAP pricing teams. 1. Accountable pricing architecture lead. The person responsible for pricing architecture and gets fired if pricing calculations become incorrect after migration. 2. Responsible SD pricing configuration lead. Validates scale-based type logic across pricing procedures. 3. Consulted solution architect. Reviews pricing model architecture across sales scenarios. 4. Informed commercial pricing director. Oversees pricing governance and revenue protection. Pricing architecture errors often originate from overlooked scale calculation logic.
Ownership, who actually fixes it.
Resolving this requires validating pricing scales under the new pricing model. 1. Pricing architecture lead analyzes pricing model differences between ECC and S/4HANA. 2. SD pricing configuration lead reviews scale-based type configuration across condition types. 3. Solution architect validates pricing behavior across order and billing scenarios. 4. Commercial pricing director approves pricing model adjustments.
Who gets blamed versus who owns it.
1. Blamed sales operations team. Executives assume incorrect pricing conditions were maintained. 2. Blamed SD configuration team. Perceived as misconfiguring pricing procedures. 3. Actual owner pricing architecture lead. Responsible for pricing model validation. 4. Root cause pricing scale behavior differences were not analyzed during explore phase. Pricing discrepancies often originate from subtle differences in scale evaluation logic.
How this is actually fixed, the right way by a role.
1. Pricing architecture lead compares ECC and S/4HANA pricing simulation results. 2. SD pricing configuration lead validates scale-based types for all pricing conditions. 3. Solution architect reviews pricing model architecture for consistency across sales processes. 4. Commercial pricing director approves corrected pricing logic.
What not to do, common wrong fixes.
1. Assuming pricing scale behavior remains identical after migration. 2. Testing pricing only for simple order scenarios. 3. Ignoring pricing trace logs during validation testing. 4. Deferring pricing comparison tests until user acceptance testing. Pricing models must be validated through comprehensive simulation testing.
Follow-up 1. What is a scale-based type in SAP pricing?
Answer: a scale-based type defines how pricing scales are evaluated based on quantities, values, or other thresholds. It determines when discounts or surcharges apply as order volumes increase. Correct scale configuration is essential for tiered pricing agreements.
Follow-up 2. Why do pricing scales behave differently after migration?
Answer: S/4HANA introduces a new pricing data model using the PRCD_elements table instead of KONV. While pricing logic remains conceptually similar, evaluation behavior can differ in complex scale scenarios. These differences must be validated through pricing simulations.
Follow-up 3. Curveball. What happens if pricing scale errors reach production?
Answer: customers may receive incorrect discounts or incorrect pricing tiers during order entry. This can lead to financial losses or disputes over commercial agreements. Correcting pricing models after go live often requires extensive pricing condition adjustments.
Exclusive pro tip.
Always run ECC versus S/4HANA pricing simulations for high volume and tiered pricing scenarios. Compare scale behavior across identical orders to identify subtle pricing differences before production deployment.
Scenario 51. Pricing, rounding, and currency decimal precision differences.
In the explore phase of ECC to S/4HANA migration, organizations do not account for changes in pricing, rounding logic, and currency decimal precision handling. ECC used specific rounding rules and decimal places based on classic condition tables. In S/4HANA, the new pricing data model and HANA numeric precision introduce subtle differences in how amounts are rounded and stored, leading to discrepancies in pricing calculations, billing totals, and margin reports.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high pricing accuracy, and revenue impact. 2. Phase, explore. 3. Frequency, very common in multi-currency and high-volume environments. 4. Primary ownership, SD pricing lead. 5. Supporting ABAP custom code remediation lead. 6. Business ownership, global order-to-cash process owner. 7. Relevant SAP note 2267308, pricing data model simplification.
Diagnostic dashboard, symptoms and evidence.
How rounding and decimal precision differences appear during testing and production. 1. Symptom, pricing totals or condition values differ slightly between ECC and S/4HANA for the same sales order. 2. Red flag, custom reports or billing programs show rounding variances after migration. 3. Business impact, margin reports become inconsistent and billing disputes increase. 4. Detection, runs side-by-side comparison of pricing procedures and condition records. 5. Technical proof, HANA numeric precision and new rounding logic in PRCD_elements produce different results. Insight, if small decimal differences appear only after migration, rounding logic was not realigned.
Why this happens, scenario analysis and root cause.
1. ECC rounding rules were tied to classic condition table behavior. 2. Teams assume the same decimal precision and rounding will apply in S/4HANA. 3. Discovery does not include side-by-side testing of currency and rounding scenarios. 4. Custom code and reports rely on hard-coded rounding assumptions from ECC. Pricing rounding is a hidden assumption that changes with the new data model.
Why this is a migration, exclusive failure.
1. ECC used fixed decimal handling in KONV table. 2. S/4HANA introduces HANA numeric precision and new rounding in PRCD_elements. 3. Compatibility views do not fully replicate legacy rounding behavior. 4. The issue only surfaces when real pricing calculations run in the new system. This is not an ECC configuration issue. It is a migration-specific data model change.
Financial and customer impact.
1. Small rounding differences accumulate into significant revenue variances. 2. Billing totals no longer match expected values, causing disputes. 3. Margin reporting becomes unreliable for decision-making. 4. Compliance risks in regulated industries with strict decimal requirements. Pricing precision failures directly affect revenue accuracy and trust.
Governance and accountability, RACI model.
In ECC to S/4HANA programs, ownership follows a RACI model where authority and execution are clearly separated across functional and technical work streams. 1. Accountable, SD pricing lead, the person who owns pricing accuracy and gets fired if rounding variances cause revenue discrepancies. 2. Responsible, ABAP custom code remediation lead, adjusts code for new rounding logic. 3. Consulted, solution architect validates alignment with S/4HANA pricing model. 4. Informed, global order to cash process owner monitors financial reporting integrity. Pricing accuracy accountability prevents revenue leakage.
Ownership, who actually fixes it.
Resolving this requires testing and realignment of rounding logic. 1. SD pricing lead reviews all currency and rounding settings in pricing procedures. 2. ABAP custom code remediation lead updates custom code to use new HANA rounding rules. 3. Solution architect validates changes against S/4HANA pricing simplification. 4. Global order to cash process owner approves revised rounding standards.
Who gets blamed versus who owns it.
1. Blamed, SD pricing lead business assumes pricing configuration is incorrect. 2. Blamed, ABAP team perceived as not updating custom code properly. 3. Actual owner, SD pricing lead and ABAP custom code remediation lead responsible for joint rounding realignment. 4. Root cause, rounding, and decimal changes were not evaluated during design. Rounding variances are governance gaps, not simple configuration errors.
How this is actually fixed, the right way by a role.
1. SD Pricing Lead tests all currency combinations and rounding scenarios in S/4HANA. 2. ABAP Custom Code Remediation Lead replaces legacy rounding logic with HANA-compliant methods. 3. Solution Architect ensures changes align with PRCD_elements data model. 4. Global Order-to-Cash Process Owner validates financial accuracy before sign-off.
What not to do, common wrong fixes.
1. Assuming ECC rounding rules will automatically work in S/4HANA. 2. Relying on compatibility views for decimal precision. 3. Delaying rounding validation until after go live. 4. Ignoring small decimal differences as insignificant. Tiny rounding differences can create large financial discrepancies over time.
Follow-up 1. Why does pricing rounding change in S/4HANA?
Answer: S/4HANA uses HANA's native numeric precision and a new pricing data model that handles rounding differently for performance and accuracy. ECC relied on classic table logic that is no longer used. This change affects how amounts are stored and calculated in real time.
Follow-up 2. How do senior pricing leads validate rounding accuracy?
Answer: Senior pricing leads run side-by-side tests with identical sales orders in ECC and S/4HANA. They compare condition values and totals across multiple currencies and decimal places. This validation is done before design freeze to catch discrepancies early.
Follow-up 3. Curveball. What if we ignore small decimal differences and fix them manually later?
Answer: Ignoring small differences seems harmless at first, but accumulates into significant revenue variances over high-volume periods. It also triggers compliance issues in audited financial reports. Manual fixes become unsustainable and erode trust in the new system.
Exclusive pro tip.
During Explore, create a pricing rounding test script with 10+ currencies and extreme decimal scenarios. Treat rounding and precision as a mandatory validation gate. Small differences become big problems at scale.
Scenario 52. HANA numeric precision causing pricing variances.
In the Explore phase of ECC to S/4HANA migration, organizations do not account for changes in numeric precision handling when moving from ECC to HANA. ECC used fixed decimal places and classic rounding logic in pricing calculations. In S/4HANA, HANA's native numeric precision and the new pricing data model introduce subtle differences in how decimal values are stored and calculated, causing variances in condition amounts, totals, and margin reports.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high pricing accuracy, and revenue impact. 2. Phase Explore. 3. Frequency, common in multi-currency and high-volume environments. 4. Primary ownership, SD pricing lead. 5. Supporting ABAP custom code remediation lead. 6. Business ownership, global order-to-cash process owner. 7. Relevant SAP note 1912445, ABAP code for HANA.
Diagnostic dashboard, symptoms and evidence.
How HANA numeric precision issues appear during testing and production. 1. Symptom: condition values or totals differ slightly between ECC and S/4HANA for the same sales order. 2. Red flag: custom reports show rounding or decimal variances after migration. 3. Business impact: margin reports become unreliable and billing disputes increase. 4. Detection: run side-by-side pricing simulations with multiple currencies and decimal places. 5. Technical proof: HANA stores and calculates numeric values with higher internal precision than ECC. Insight: if small decimal differences appear only after migration, numeric precision was not realigned.
Why this happens, scenario analysis and root cause.
1. ECC pricing relied on fixed decimal handling in classic tables. 2. Teams assume the same precision and rounding rules apply in S/4HANA. 3. Discovery does not include detailed currency and decimal testing. 4. Custom code contains hard-coded assumptions about numeric behavior. Numeric precision is a hidden technical assumption that changes with HANA.
Why this is a migration, exclusive failure.
1. ECC used database-specific decimal handling that masked precision issues. 2. S/4HANA and HANA introduced new internal numeric precision rules. 3. The pricing data model change in PRCD_elements amplifies these differences. 4. The issue only surfaces when real pricing calculations run in the new system. This is not an ECC configuration issue. It is a migration-specific HANA behavior change.
Financial and customer impact.
1. Small precision differences accumulate into significant revenue variances over time. 2. Billing totals no longer match expected values, causing disputes with customers. 3. Margin reporting becomes unreliable for executive decisions. 4. Compliance risks in industries with strict decimal or rounding requirements. Numeric precision failures directly affect revenue accuracy and trust.
Governance and accountability, RACI model.
In ECC to S/4HANA programs, ownership follows a RACI model where authority and execution are clearly separated across functional and technical work streams. 1. Accountable, SD pricing lead the person who owns pricing accuracy and gets fired if numeric precision variances cause revenue discrepancies. 2. Responsible, ABAP custom code remediation lead adjusts code for HANA numeric precision rules. 3. Consulted, solution architect validates alignment with S/4HANA pricing model. 4. Informed, global order to cash process owner monitors financial reporting integrity. Pricing accuracy accountability prevents revenue leakage.
Ownership, who actually fixes it.
Resolving this requires testing and realignment of numeric precision logic. 1. SD pricing lead reviews all currency and decimal scenarios and pricing procedures. 2. ABAP custom code remediation lead updates custom code to handle HANA precision correctly. 3. Solution architect validates changes against the new pricing data model. 4. Global order to cash process owner approves revised precision standards.
Who gets blamed versus who owns it.
1. Blamed, SD pricing lead business assumes pricing configuration is incorrect. 2. Blamed, ABAP team perceived as not updating custom code properly. 3. Actual owner, SD pricing lead and ABAP custom code remediation lead responsible for joint precision realignment. 4. Root cause, HANA numeric precision change was not evaluated during design. Precision variances are governance gaps, not simple configuration errors.
How this is actually fixed, the right way by a role.
1. SD pricing lead creates test cases covering multiple currencies and extreme decimal values. 2. ABAP custom code remediation lead updates code to use HANA-compliant numeric handling. 3. Solution architect validates results against PRCD_elements data model. 4. Global order to cash process owner approves the revised pricing standards.
What not to do, common wrong fixes.
1. Assuming ECC decimal handling will automatically work in S/4HANA. 2. Relying on compatibility views for numeric precision. 3. Delaying precision validation until after go live. 4. Ignoring small decimal differences as insignificant. Tiny precision differences can create large financial discrepancies over time.
Follow-up 1. Why does numeric precision change in S/4HANA?
Answer: S/4HANA uses HANA's native numeric types with higher internal precision for performance and accuracy. ECC relied on database-specific decimal handling that is no longer used. This change affects how amounts are stored and calculated in real time.
Follow-up 2. How do senior pricing leads validate precision accuracy?
Answer: senior pricing leads run side-by-side tests with identical sales orders in ECC and S/4HANA. They compare condition values and totals across multiple currencies and decimal places. This validation is done before design freeze to catch discrepancies early.
Follow-up 3. Curveball. What if we ignore small decimal differences and fix them manually later?
Answer: ignoring small differences seems harmless at first, but accumulates into significant revenue variances over high-volume periods. It also triggers compliance issues in audited financial reports. Manual fixes become unsustainable and erode trust in the new system.
Exclusive pro tip.
During Explore, create a pricing precision test script with 10+ currencies and extreme decimal scenarios. Treat numeric precision as a mandatory validation gate. Small differences become big problems at scale.
Scenario 53. Number buffering behavior change on HANA.
In the explore phase of ECC to S/4HANA migration, organizations do not account for the change in number range buffering behavior when moving to HANA. In ECC, number range buffering was heavily used for performance in high-volume SD documents such as sales orders and invoices. In S/4HANA, the default buffering logic is different, leading to gaps in number ranges, duplicate numbers, or performance degradation if not adjusted during design.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, medium number range and performance impact. 2. Phase, explore. 3. Frequency, common in high-volume SD environments. 4. Primary ownership, SD functional lead. 5. Supporting basis lead. 6. Business ownership, global order-to-cash process owner. 7. Relevant SAP note 1912445 ABAP code for HANA.
Diagnostic dashboard, symptoms and evidence.
How number buffering changes appear during testing and production. 1. Symptom, duplicate document numbers or gaps appear in sales orders and invoices. 2. Red flag, number range buffering settings from ECC are carried over without adjustment. 3. Business impact, compliance issues in legal reporting and customer invoice sequencing. 4. Detection, monitor number range usage via transaction SNRO during load testing. 5. Technical proof, HANA default buffering differs from ECC, causing unexpected number allocation. Insight, if number ranges look fine in low volume but fail under load, buffering was not realigned.
Why this happens, scenario analysis and root cause.
1. ECC relied on aggressive number range buffering for performance. 2. Teams assume the same buffering settings will work in S/4HANA. 3. Discovery does not include HANA-specific number range behavior review. 4. Basis and functional teams do not jointly validate buffering impact on SD documents. Number buffering is a hidden technical assumption that changes with HANA.
Why this is a migration, exclusive failure.
1. ECC allowed custom buffering settings without HANA constraints. 2. S/4HANA introduces different default buffering logic for performance reasons. 3. Migration tools do not automatically adjust number range settings. 4. The failure only surfaces when high-volume SD processing begins in the new system. This is not an ECC configuration issue. It is a migration-specific HANA behavior change.
Financial and customer impact.
1. Duplicate invoice numbers cause compliance and audit problems. 2. Gaps in sales order numbers disrupt legal reporting. 3. Manual corrections increase operational costs. 4. Customer confusion from inconsistent document sequencing. Number range issues create compliance and trust risks in SD.
Governance and accountability, RACI model.
In ECC to S/4HANA programs, ownership follows a RACI model where authority and execution are clearly separated across functional and technical work streams. 1. Accountable, SD functional lead, the person who owns number range strategy and gets fired if document sequencing fails after migration. 2. Responsible, basis lead adjusts buffering settings and validates HANA behavior. 3. Consulted, solution architect ensures alignment with S/4HANA simplification principles. 4. Informed, global order-to-cash process owner monitors legal and reporting compliance. Number range governance must be jointly owned to avoid compliance failures.
Ownership, who actually fixes it.
Resolving this requires joint adjustment of number range buffering. 1. SD functional lead reviews all SD number ranges used in sales and billing. 2. Basis lead reconfigures buffering settings for HANA compatibility. 3. Solution architect validates the new settings against S/4HANA guidelines. 4. Global order-to-cash process owner approves the updated number range strategy.
Who gets blamed versus who owns it.
1. Blamed, SD functional lead business assumes pricing or order configuration is broken. 2. Blamed, basis lead seen as not tuning the system properly for HANA. 3. Actual owner, SD functional lead and basis lead responsible for joint number range redesign. 4. Root cause, number buffering behavior change was not evaluated during design. Number range failures are governance gaps, not technical errors.
How this is actually fixed, the right way by a role.
1. SD Functional Lead identifies all active number ranges used in SD documents. 2. Basis Lead reconfigures buffering settings according to HANA best practices. 3. Solution Architect tests the new settings under peak load conditions. 4. Global Order-to-Cash Process Owner signs off on the updated number range configuration.
What not to do, common wrong fixes.
1. Keeping ECC buffering settings unchanged in S/4HANA. 2. Assuming HANA will automatically handle number range performance. 3. Delaying number range review until after conversion. 4. Ignoring gaps and duplicates during testing. Number range issues cannot be fixed after go live without major rework.
Follow-up 1. Why does number buffering behave differently in S4HANA?
Answer: S/4HANA uses HANA's in-memory architecture, which changes how number ranges are buffered for performance and consistency. The default behavior is more conservative than ECC to prevent gaps and duplicates. This requires explicit reconfiguration during migration.
Follow-up 2. How do senior teams validate number range settings?
Answer: senior teams extract active number ranges from SNRO, simulate peak loads, and compare results between ECC and S/4HANA. They involve both functional and basis experts in the review. This joint validation prevents surprises during high-volume periods.
Follow-up 3. Curveball. What if we ignore buffering changes and fix duplicates later?
Answer: ignoring the changes often leads to massive duplicate numbers during peak seasons, triggering compliance violations and manual corrections. It creates audit issues and erodes trust in document sequencing. Early reconfiguration is far cheaper than post-go-live cleanup.
Exclusive pro tip.
Always review number ranges in SNRO during Explore and test them under peak load. Treat number buffering as a critical migration task, not a minor configuration item.
Scenario 54. Data aging impact on SD document visibility.
In the Explore phase of ECC to S/4HANA migration, organizations do not account for the impact of data aging and archiving strategies on SD document visibility. In S/4HANA, Information Lifecycle Management moves older sales orders, deliveries, and billing documents to archive storage. When data aging rules are not defined early, business users lose access to historical documents in standard transactions and reports, creating operational and compliance issues.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, medium data visibility and compliance impact. 2. Phase, explore. 3. Frequency, common in long-running systems with large SD history. 4. Primary ownership, data governance lead. 5. Supporting SD functional lead. 6. Business ownership, global order-to-cash process owner. 7. Relevant SAP note 1616302, ILM policy.
Diagnostic dashboard, symptoms and evidence.
How data aging issues appear during testing and production. 1. Symptom: historical sales orders or billing documents disappear from standard transactions and reports. 2. Red flag: data aging rules are activated without defining SD document retention periods. 3. Business impact: auditors and customer service teams cannot access required historical data. 4. Detection: review ILM rules in transaction, ILM_config and test document visibility after aging runs. 5. Technical proof: archived documents are moved to secondary storage and no longer appear in standard CDS views. Insight: if old documents are missing after migration, data aging was not planned properly.
Why this happens, scenario analysis and root cause.
1. Discovery focuses on current data without considering long-term archiving needs. 2. Teams assume all SD documents will remain visible forever in S/4HANA. 3. Data governance is treated as a basis task instead of a business requirement. 4. Retention policies from ECC are not reviewed against S/4HANA ILM capabilities. Data aging is a new S/4HANA concept that requires proactive planning.
Why this is a migration, exclusive failure.
1. ECC kept all documents in active tables indefinitely. 2. S/4HANA introduces mandatory data aging and ILM for HANA performance. 3. Migration loads historical data that triggers aging rules automatically. 4. The issue only surfaces when archived documents become inaccessible. This is not an ECC visibility issue. It is a migration-specific data lifecycle change.
Financial and customer impact.
1. Audit delays and penalties due to missing historical documents. 2. Customer service cannot resolve old disputes or inquiries. 3. Manual data restoration increases operational costs. 4. Compliance risks in regulated industries requiring long-term record retention. Data aging failures create compliance and service risks.
Governance and accountability, RACI model.
In ECC to S4 HANA programs, ownership follows a RACI model where authority and execution are clearly separated across functional and technical work streams. 1. Accountable, data governance lead the person who owns data aging strategy and gets fired if historical SD documents become inaccessible. 2. Responsible, SD functional lead defines retention periods for sales and billing documents. 3. Consulted, basis lead configures ILM rules and archive objects. 4. Informed, global order to cash process owner ensures business access requirements are met. Data visibility accountability prevents compliance failures.
Ownership, who actually fixes it.
Resolving this requires defining data aging rules and retention policies. 1. Data governance lead establishes overall ILM policy and retention periods. 2. SD functional lead defines business rules for sales orders, deliveries, and billing documents. 3. Basis lead configures archive objects and aging runs in S4 HANA. 4. Global order to cash process owner validates that required documents remain accessible.
Who gets blamed versus who owns it.
1. Blamed data governance lead executives see it as poor data strategy. 2. Blamed SD functional lead perceived as not protecting business document access. 3. Actual owner data governance lead and SD functional lead responsible for joint retention policy design. 4. Root cause data aging impact was not evaluated during discovery. Document visibility failures are governance gaps, not technical errors.
How this is actually fixed, the right way by a role.
1. Data governance lead defines retention periods based on legal and business requirements. 2. SD functional lead maps SD document types to appropriate archive objects. 3. Basis lead configures ILM rules and tests aging runs in a sandbox. 4. Global order to cash process owner approves the final data aging strategy.
What not to do, common wrong fixes.
1. Activating data aging without defining SD retention periods. 2. Assuming all historical documents will remain visible forever. 3. Delaying ILM configuration until after go live. 4. Ignoring legal retention requirements for sales and billing documents. Data aging must be planned early. Late fixes are expensive and risky.
Follow-up 1. Why does data aging affect SD document visibility?
Answer: S4 HANA automatically moves older documents to archive storage to keep the HANA database fast and lean. Without proper retention rules, business users lose access to historical sales orders and invoices in standard transactions. This change is new to S4 HANA and requires explicit planning.
Follow-up 2. How do senior teams define proper data aging rules?
Answer: senior teams combine legal retention requirements with business access needs. They map SD document types to archive objects and test visibility after aging runs. This joint functional and basis review ensures documents remain accessible when needed.
Follow-up 3. Curveball. What if we turn off data aging completely to keep everything visible?
Answer: turning off data aging keeps all documents visible, but causes severe HANA performance degradation and higher infrastructure costs over time. It also violates clean core principles and makes future upgrades more complex. Proper aging with clear retention rules is the only sustainable approach.
Exclusive pro tip.
Define data aging rules in the explore phase using legal retention periods and business access needs. Test document visibility after aging runs. Never assume all SD history will remain visible forever.
Scenario 55. Archive object redesign impact not assessed.
In the explore phase of ECC to S4 HANA migration, organizations do not evaluate how archive objects for SD documents such as sales orders, deliveries, and billing documents need to be redesigned under S/4HANA Information Lifecycle Management. Legacy ECC archive objects and retention rules are carried over without adjustment, causing documents to be archived too early or become inaccessible in standard transactions and reports after go-live.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, medium data visibility and compliance impact. 2. Phase, explore. 3. Frequency, common in systems with large historical SD data. 4. Primary ownership, data governance lead. 5. Supporting SD functional lead. 6. Business ownership, global order-to-cash process owner. 7. Relevant SAP note 1616302, ILM policy.
Diagnostic dashboard, symptoms and evidence.
How archive object redesign issues appear during testing and production. 1. Symptom, historical SD documents disappear from standard Fiori apps and reports after archiving runs. 2. Red flag ECC archive objects are used without redesign or testing in S/4HANA. 3. Business impact, auditors and customer service teams cannot access required historical records. 4. Detection. Run ILM simulation and check document visibility in VA03, VF03, and CDS views. 5. Technical proof. Archived documents are moved to secondary storage without proper access paths in S/4HANA. Insight. If old documents become inaccessible after archiving, archive objects were not redesigned.
Why this happens, scenario analysis and root cause.
1. Discovery treats archiving as a basis task without involving SD business requirements. 2. Teams assume ECC archive objects will work unchanged in S/4HANA. 3. Retention periods and access rules are not reviewed against new ILM capabilities. 4. Project scope excludes detailed archive object redesign to save time. Archive objects require business-driven redesign in S/4HANA.
Why this is a migration, exclusive failure.
1. ECC allowed simple archive objects with minimal redesign. 2. S/4HANA introduces mandatory ILM and new archive object structures. 3. Migration loads full historical data that triggers automatic archiving. 4. The failure appears only when archived documents become inaccessible in the new system. This is not an ECC archiving issue. It is a migration-specific ILM redesign requirement.
Financial and customer impact.
1. Audit delays and penalties due to missing historical records. 2. Customer service cannot resolve old disputes or inquiries. 3. Manual data restoration increases operational costs. 4. Compliance risks in regulated industries requiring long-term document retention. Archive redesign failures create compliance and service risks.
Governance and accountability, RACI model.
In ECC to S/4HANA programs, ownership follows a RACI model where authority and execution are clearly separated across functional and technical work streams. 1. Accountable, data governance lead the person who owns archive strategy and gets fired if historical SD documents become inaccessible. 2. Responsible, SD functional lead defines retention and access rules for sales and billing documents. 3. Consulted, basis lead configures ILM archive objects and aging runs. 4. Informed, global order-to-cash process owner ensures business access requirements are met. Archive visibility accountability prevents compliance failures.
Ownership, who actually fixes it.
Resolving this requires redesign of archive objects and retention rules. 1. Data governance lead defines overall ILM policy and retention periods. 2. SD functional lead maps SD document types to new archive objects. 3. Basis lead configures and tests ILM rules in a sandbox. 4. Global order-to-cash process owner validates that required documents remain accessible.
Who gets blamed versus who owns it.
1. Blamed data governance lead executives see it as poor data strategy. 2. Blamed SD functional lead perceived as not protecting business document access. 3. Actual owner data governance lead and SD functional lead responsible for joint archive object redesign. 4. Root cause archive object impact was not assessed during Explore. Document visibility failures are governance gaps, not technical errors.
How this is actually fixed, the right way by a role.
1. Data governance lead defines retention periods based on legal and business needs. 2. SD functional lead maps sales orders, deliveries, and billing documents to new archive objects. 3. Basis lead configures ILM rules and tests document visibility after aging. 4. Global order-to-cash process owner approves the final archive strategy.
What not to do, common wrong fixes.
1. Using ECC archive objects without redesign in S4 HANA. 2. Activating ILM without business retention rules. 3. Delaying archive object assessment until after go live. 4. Assuming all historical documents will remain visible forever. Archive objects must be redesigned early. Late fixes are expensive and risky.
Follow-up 1. Why does archive object redesign matter in S4 HANA?
Answer: S4 HANA uses a completely new information lifecycle management framework that requires redesigned archive objects for SD documents. Legacy ECC objects do not map directly and can cause documents to become inaccessible. Proper redesign ensures both performance and compliance.
Follow-up 2. How do senior teams define archive retention rules?
Answer: senior teams combine legal retention requirements with business access needs for SD documents. They map document types to new archive objects and test visibility after aging runs. This joint functional and basis review ensures documents remain accessible when required.
Follow-up 3. Curveball. What if we turn off archiving completely to keep everything visible?
Answer: turning off archiving keeps documents visible, but causes severe HANA performance degradation and higher infrastructure costs over time. It also violates clean core principles and makes future upgrades more complex. Proper archiving with redesigned objects is the only sustainable approach.
Exclusive pro tip.
Define archive object redesign rules in the explore phase using legal retention periods and business access needs. Test document visibility after aging runs. Never assume all SD history will remain visible forever.
Scenario 56. Transportation zone master redesign, affecting route determination.
In the explore phase of ECC to S4 HANA migration, organizations do not assess the redesign of transportation zone master data and its impact on route determination. ECC used transportation zones in a specific way for route and shipment planning. In S4 HANA, the transportation management logic and zone handling have changed, causing route determination to behave differently and leading to incorrect shipping routes, delivery delays, and increased freight costs if not realigned during design.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, medium logistics and route determination impact. 2. Phase, explore. 3. Frequency, common in companies using transportation management. 4. Primary ownership, SD functional lead. 5. Supporting TM consultant. 6. Business ownership, logistics operations head. 7. Relevant SAP note 2267317, LE-TRA to TM.
Diagnostic dashboard, symptoms and evidence.
How transportation zone redesign issues appear during testing and production. 1. Symptom: routes determined in S4 HANA differ from ECC, leading to wrong shipping points or carriers. 2. Red flag: transportation zone master data is migrated without redesign or validation. 3. Business impact: delivery delays, higher freight costs, and customer complaints. 4. Detection: compare route determination results in VA01 and VT01N between ECC and S4 HANA. 5. Technical proof: transportation zones are now handled differently in the new TM integration. Insight: if routes look correct in ECC but wrong in S4 HANA, zone master redesign was missed.
Why this happens, scenario analysis and root cause.
1. Discovery treats transportation zones as simple master data without considering TM changes. 2. Teams assume ECC zone configuration will work unchanged in S4 HANA. 3. TM and SD teams are not aligned early on route determination logic. 4. Project scope excludes detailed transportation master redesign. Transportation zones require redesign when moving from LETRA to embedded TM.
Why this is a migration, exclusive failure.
1. ECC used LETRA transportation zones with simple route determination. 2. S4 HANA introduces new TM integration and zone handling logic. 3. Migration tools do not automatically adjust transportation master data. 4. The failure only surfaces when route determination is executed in the new system. This is not an ECC configuration issue. It is a migration-specific transportation redesign requirement.
Financial and customer impact.
1. Higher freight costs due to incorrect carrier or route selection. 2. Delivery delays leading to penalties and lost customer trust. 3. Increased manual intervention in logistics planning. 4. Compliance risks in international shipments requiring accurate zone data. Transportation zone failures directly increase logistics costs and affect customer satisfaction.
Governance and accountability, RACI model.
In ECC to S4 HANA programs, ownership follows a RACI model where authority and execution are clearly separated across functional and technical work streams. 1. Accountable. SD functional lead, the person who owns route determination strategy and gets fired if transportation issues disrupt deliveries. 2. Responsible. TM consultant redesigns transportation zones and route determination logic. 3. Consulted. Solution architect ensures alignment with S4 HANA TM integration. 4. Informed. Logistics operations head validates business impact on shipments. Transportation zone accountability prevents delivery and cost failures.
Ownership, who actually fixes it.
Resolving this requires redesign of transportation zones and route determination. 1. SD functional lead reviews all transportation zones used in route determination. 2. TM consultant redesigns zones and mapping for S4 HANA TM integration. 3. Solution architect validates the new configuration against simplification list. 4. Logistics operations head approves the updated route determination strategy.
Who gets blamed versus who owns it.
1. Blamed. SD functional lead business assumes route configuration is incorrect. 2. Blamed. TM team perceived as not updating transportation master data. 3. Actual owner. SD functional lead and TM consultant responsible for joint transportation zone redesign. 4. Root cause. Transportation zone impact was not assessed during Explore. Transportation issues are governance gaps, not simple master data errors.
How this is actually fixed, the right way by a role.
1. SD functional lead extracts all active transportation zones and route determination settings. 2. TM consultant redesigns zones and mapping according to S4 HANA TM logic. 3. Solution architect tests route determination in VA01 and VT01N. 4. Logistics operations head validates business impact and signs off.
What not to do, common wrong fixes.
1. Migrating transportation zones without redesign. 2. Assuming ECC route determination will work unchanged. 3. Delaying zone validation until after go live. 4. Ignoring TM integration changes in zone master data. Transportation zone redesign must be done early. Late fixes cause delivery disruptions.
Follow-up 1. Why does transportation zone handling change in S4 HANA?
Answer. S4 HANA integrates transportation management more tightly with core SD processes and uses a new zone and route determination logic. ECC LETRA zones no longer map directly. This change improves accuracy, but requires explicit redesign during migration.
Follow-up 2. How do senior teams validate transportation zone redesign?
Answer. Senior teams extract zones from ECC tables, redesign them in S4 HANA TM, and run side-by-side route determination tests in VA01. They involve logistics operations for business validation. This ensures routes remain correct after migration.
Follow-up 3. Curveball. What if we keep ECC transportation zones and fix routes later?
Answer. Keeping ECC zones seems quick, but leads to incorrect carrier selection and delivery delays during peak seasons. It creates compliance issues in international shipments and increases freight costs. Early redesign is far cheaper than post-go-live corrections.
Exclusive pro tip.
Extract transportation zones early and test route determination in both ECC and S4 HANA side-by-side. Treat zone redesign as a mandatory logistics task. Incorrect routes directly increase costs and delay deliveries.
Scenario 57. Universal Journal, ACDOCA. Impact on SD revenue postings not designed.
In the explore phase of ECC to S/4HANA migration, organizations do not assess how the Universal Journal Table ACDOCA changes the way SD revenue postings are recorded and reconciled. In ECC, revenue was posted through separate SD and FI documents with batch reconciliation. In S/4HANA, all revenue postings flow directly into ACDOCA in real time. When this impact is not designed early, margin analysis, profitability reporting, and financial reconciliation become inconsistent or require manual corrections.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high revenue recognition, and FI integration impact. 2. Phase, explore. 3. Frequency, common in companies using revenue recognition. 4. Primary ownership, SD functional lead. 5. Supporting FI or CO consultant. 6. Business ownership, global order-to-cash process owner. 7. Relevant SAP note 2349298, Universal Journal ACDOCA.
Diagnostic dashboard, symptoms and evidence.
How ACDOCA impact issues appear during testing and production. 1. Symptom, margin reports or profitability analysis show different revenue figures than ECC. 2. Red flag revenue postings are still designed using classic SDFI interface logic. 3. Business impact, margin analysis becomes unreliable and financial close is delayed. 4. Detection. Compare ACDOCA entries with ECC revenue tables for the same sales order. 5. Technical proof. Revenue now flows directly into ACDOCA instead of separate SD and FI documents. Insight. If revenue numbers differ between SD and FI after migration, ACDOCA impact was not designed.
Why this happens, scenario analysis and root cause.
1. Discovery treats revenue postings as a simple copy from ECC without considering Universal Journal. 2. SD and FI teams work in silos without joint redesign workshops. 3. Teams assume classic SDF/I interface logic will continue to work. 4. Project scope excludes detailed ACDOCA impact analysis for revenue flows. Universal Journal requires joint SD and FI redesign. Ignoring it creates reconciliation gaps.
Why this is a migration, exclusive failure.
1. ECC used separate SD and FI documents with batch reconciliation. 2. S/4HANA introduces the Universal Journal where revenue is posted in real time to ACDOCA. 3. Migration tools do not automatically redesign revenue posting logic. 4. The failure only surfaces when real-time postings and reporting begin in the new system. This is not an ECC revenue issue. It is a migration-specific Universal Journal redesign requirement.
Financial and customer impact.
1. Inaccurate margin analysis leads to wrong pricing and discount decisions. 2. Financial close is delayed due to reconciliation issues. 3. Revenue recognition errors affect statutory reporting. 4. Customer trust is damaged when billing and reporting no longer align. ACDOCA failures directly affect revenue accuracy and financial integrity.
Governance and accountability, RACI model.
In ECC to S/4HANA programs, ownership follows a RACI model where authority and execution are clearly separated across functional and technical work streams. 1. Accountable. SD functional lead, the person who owns revenue posting design and gets fired if financial reconciliation fails after migration. 2. Responsible. FI or CO consultant redesigns ACDOCA postings for SD revenue. 3. Consulted. Solution architect ensures alignment with Universal Journal principles. 4. Informed. Global order to cash process owner monitors revenue reporting accuracy. Revenue posting accountability prevents financial close delays.
Ownership, who actually fixes it.
Resolving this requires joint redesign of revenue posting logic. 1. SD functional lead maps legacy revenue flows to ACDOCA postings. 2. FI or CO consultant redesigns accounting document generation for real-time integration. 3. Solution architect validates the new design against Universal Journal rules. 4. Global order to cash process owner approves the revised revenue recognition model.
Who gets blamed versus who owns it.
1. Blamed. SD functional lead business assumes pricing or billing configuration is wrong. 2. Blamed FI or CO team perceived as not updating accounting logic properly. 3. Actual owner SD functional lead and FI or CO consultant responsible for joint ACDOC redesign. 4. Root cause universal journal impact was not assessed during Explore. Revenue reconciliation failures are governance gaps, not technical errors.
How this is actually fixed, the right way by a role.
1. SD functional lead maps all SD revenue scenarios to ACDOC align items. 2. FI or CO consultant configures real-time posting rules in the Universal Journal. 3. Solution architect tests end-to-end revenue flow from sales order to financial report. 4. Global order-to-cash process owner validates margin and profitability reporting.
What not to do, common wrong fixes.
1. Assuming ECC revenue posting logic will work unchanged. 2. Relying on classic SDFI interface without ACDOC redesign. 3. Delaying universal journal testing until after go live. 4. Ignoring real-time posting differences in margin analysis. Universal journal requires early redesign. Late fixes cause financial close failures.
Follow-up 1. Why does Universal Journal change SD revenue postings?
Answer: S4 HANA records all revenue directly in the single ACDOC table in real time instead of separate SD and FI documents. This eliminates batch reconciliation, but requires new posting logic. The change improves accuracy and speed, but demands redesign.
Follow-up 2. How do senior teams validate ACDOC revenue flows?
Answer: senior teams run end-to-end tests from sales order creation to financial reporting. They compare ACDOC entries with ECC revenue tables for the same transactions. This validation ensures margin and profitability reports are accurate before go live.
Follow-up 3. Curveball. What if we keep classic SDFI interface and fix ACDOC later?
Answer: keeping the classic interface seems faster initially, but creates permanent reconciliation gaps and delayed financial close. It also increases manual effort and audit risk. Early redesign is the only way to achieve real-time revenue accuracy.
Exclusive pro tip.
During Explore, map every SD revenue scenario to ACDOC align items and test real-time postings. Treat Universal Journal as a mandatory redesign, not an optional FI topic.
Scenario 58. Predictive Analytics PI. Integration for SD forecasting gaps.
In the Explore phase of ECC to S4 HANA migration, organizations do not assess how predictive analytics integration should be redesigned for SD forecasting. ECC relied on batch statistical models or external tools for demand and sales forecasting. In S4 HANA, predictive analytics integrated directly into core processes delivers real-time forecasts. When this integration is not designed early, forecasting accuracy drops and planning decisions become unreliable after go live.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, medium forecasting and planning impact. 2. Phase, explore. 3. Frequency, common in companies using demand planning. 4. Primary ownership, analytics transformation lead. 5. Supporting SD functional lead. 6. Business ownership, sales operations director. 7. Relevant SAP note 2533694 PI integration.
Diagnostic dashboard, symptoms and evidence.
How PI integration gaps appear during testing and production. 1. Symptom, forecast values in S4 HANA differ significantly from ECC or external tools. 2. Red flag, predictive models are not configured or integrated with SD master data. 3. Business impact, inaccurate demand planning leads to stockouts or excess inventory. 4. Detection, compare forecast results between ECC statistical models and S4 HANA PI scenarios. 5. Technical proof, PI models are not consuming real-time SD data from CDS views. Insight, if forecasts look correct in ECC but fail in S4 HANA, PI integration was not designed.
Why this happens, scenario analysis and root cause.
1. Discovery treats forecasting as a copy of ECC batch models without considering real-time PI. 2. Analytics and SD teams work in silos without joint design sessions. 3. Teams assume external forecasting tools will continue to work unchanged. 4. Project scope excludes detailed PI integration planning to save time. Predictive analytics requires proactive integration design in S/4HANA.
Why this is a migration, exclusive failure.
1. ECC used batch statistical models or external tools with nightly runs. 2. S/4HANA embeds predictive analytics directly into core processes for real-time forecasts. 3. Migration tools do not automatically integrate PI with SD master data. 4. The failure only surfaces when real-time forecasting is required in the new system. This is not an ECC forecasting issue. It is a migration-specific PI integration requirement.
Financial and customer impact.
1. Inaccurate forecasts lead to excess inventory or stockouts. 2. Higher carrying costs and lost sales opportunities. 3. Increased manual planning effort and expediting costs. 4. Customer dissatisfaction from unreliable delivery commitments. Forecasting failures directly affect inventory costs and customer service.
Governance and accountability, RACI model.
In ECC to S/4HANA programs, ownership follows a RACI model where authority and execution are clearly separated across functional and technical work streams. 1. Accountable analytics transformation lead the person who owns predictive forecasting strategy and gets fired if inaccurate forecasts cause inventory or service failures. 2. Responsible SD functional lead maps SD master data to PI models. 3. Consulted solution architect ensures PI integration aligns with S/4HANA core processes. 4. Informed sales operations director validates forecast accuracy for business planning. Forecasting accountability prevents costly planning errors.
Ownership, who actually fixes it.
Resolving this requires designing PI integration with SD processes. 1. Analytics transformation lead defines predictive models for SD forecasting. 2. SD functional lead maps master data and transactional flows to PI scenarios. 3. Solution architect validates integration with embedded analytics. 4. Sales operations director approves the new forecasting accuracy standards.
Who gets blamed versus who owns it.
1. Blamed analytics transformation lead executives see it as failed forecasting capability. 2. Blamed SD functional lead perceived as not providing correct master data. 3. Actual owner analytics transformation lead and SD functional lead responsible for joint PI redesign. 4. Root cause predictive analytics integration was not assessed during Explore. Forecasting failures are governance gaps, not technical errors.
How this is actually fixed, the right way by a role.
1. Analytics transformation lead configures PI models using S/4HANA embedded analytics. 2. SD functional lead maps sales history and master data to predictive scenarios. 3. Solution architect tests real-time forecast accuracy against historical results. 4. Sales operations director validates business outcomes and signs off.
What not to do, common wrong fixes.
1. Assuming ECC statistical models will work unchanged in S/4HANA. 2. Relying on external forecasting tools without PI integration. 3. Delaying predictive model design until after go live. 4. Ignoring real-time data requirements for forecasting accuracy. Predictive analytics must be designed early. Late integration reduces its value.
Follow-up 1. Why does predictive analytics integration change in S/4HANA?
Answer: S/4HANA embeds predictive models directly into core processes using real-time data from CDS views. ECC relied on batch statistical models or external tools. This change enables instant forecasts, but requires explicit integration design during migration.
Follow-up 2. How do senior teams validate PI forecasting accuracy?
Answer: senior teams compare PI forecast results with historical actuals using side-by-side testing. They involve sales operations for business validation and adjust models iteratively. This ensures forecasts are reliable before go live.
Follow-up 3. Curveball. What if we keep using the old external forecasting tool after migration?
Answer: continuing with the old external tool seems safe, but creates data silos and misses real-time insights from S/4HANA. It also increases integration maintenance costs and reduces forecast accuracy over time. Native PI integration is the only way to achieve full value.
Exclusive pro tip.
During Explore, Run a proof of concept with Pi using your actual SD historical data. Treat predictive forecasting as a core design element, not an optional add-on.
Phase 2 Category 1 Wrap-Up, Simplification and Data Model Risks.
These first 32 incidents in Phase 2 Category 1 reveal a critical truth about S/4HANA migrations. The biggest risk during Explore is not configuration, but misunderstanding how deeply SAP simplified the SD data model. Tables disappeared, pricing structures changed, and entire functional capabilities such as rebates and revenue recognition were redesigned. If these simplifications are not fully understood during design, every downstream phase, realization, testing, and cutover becomes exponentially more complex.
Transition from data model changes to master data architecture.
But understanding simplification items is only half the challenge. Once the technical model changes are clear, the next risk emerges: master data redesign. S/4HANA fundamentally restructures how customer, partner, credit, and geographic data are governed. If business partner architecture and credit management structures are not redesigned early, the entire order-to-cash process becomes unstable.
Please check description or comment section of this video. I have given a lot of links for downloading 7 or 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked system design, most asked implementation project-related interview questions and answers, most asked support project-related interview questions and answers, required for your SAP functional modules interviews jobs like SAP consultant jobs, SAP FICO consultant jobs, SAP SD consultant jobs, SAP PP consultant jobs, SAP Ariba consultant jobs, SAP Extended Warehouse Management EWM consultant jobs, SAP Plant Maintenance PM consultant jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem-solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section. These questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people also for your interviews. You people can download all 7 or 8 PDFs in a single zip file from below given links.
Phase 2 Category 2 Master Data and CVI Design Risks.
The second category in Phase 2 focuses on master data transformation and customer vendor integration. S/4HANA replaces classic customer master structures with the business partner model and introduces new credit management architecture through financial supply chain management. These changes affect customer roles, partner determination, credit exposure calculations, and even tax and geographic master data. Poor design in this area can disrupt sales processing across the entire enterprise.
Master Data and CVI Design Risk Incidents.
59. Missing business partner role mapping. Relevant SAP Note 2265093 Business Partner Approach. 60. Business partner mandatory fields not designed. Relevant SAP Note 2265093 Business Partner Approach. 61. Customer hierarchy business partner impact not designed. Relevant SAP Note 2265093 Business Partner Approach. 62. Number range strategy conflicts between business partner and customer. Relevant SAP Note 2265093 Business Partner Approach. 63. Partner determination redesign gaps. Relevant SAP Note 2265093 Business Partner Approach. 64. Credit segment design incomplete. Relevant SAP Note 2270544 Credit management simplification. 65. Credit horizon logic redesign gaps. Relevant SAP Note, SAP Note 2270544, Credit Management Simplification. 66. Static versus Dynamic Credit Check Behavior Change. Relevant SAP Note, SAP Note 2270544, Credit Management Simplification. 67. Documented versus Undocumented Exposure Mismatch. Relevant SAP Note, SAP Note 2270544, Credit Management Simplification. 68. Credit Master Replication Timing Issues. Relevant SAP Note, SAP Note 2270544, Credit Management Simplification. 69. Tax Jurisdiction Redesign Incomplete. Relevant SAP Note, SAP Note 2267310, Foreign Trade Simplification. 70. Geographic Master Harmonization Gaps. Relevant SAP Note, SAP Note 2267310, Foreign Trade Simplification.
Scenario 59. Missing business partner role mapping.
In the explore phase of ECC to S/4HANA migration, organizations fail to properly design business partner role mapping between legacy customer master records and the new business partner architecture. ECC stored customer information in separate customer master tables, but S/4HANA consolidates customer and vendor identities under a single business partner object. If business partner roles such as customer, contact person, and financial roles are not clearly mapped during design, sales transactions, partner determination, and credit checks begin to fail or behave inconsistently after migration.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high master data and transaction integrity risk. 2. Phase, explore. 3. Frequency, extremely common in customer-vendor integration migrations. 4. Primary ownership, master data architecture lead. 5. Supporting SD functional lead. 6. Business ownership, global customer master data owner. 7. Relevant SAP Note, SAP Note 2265093, business partner approach.
Diagnostic dashboard, symptoms and evidence.
How missing business partner role mapping appears during testing and early system usage. 1. Symptom, sales orders failed during creation because required partner roles are missing. 2. Red flag, customer master records exist but business partner roles are incomplete. 3. Business impact, order processing stops due to missing partner assignments. 4. Detection, execute customer-vendor integration consistency checks during migration preparation. 5. Technical proof, business partner records exist but required roles such as FLCU00 or FLCU01 are not assigned. Insight, if business partner exists but sales transactions fail, role mapping was not designed correctly.
Why this happens, scenario analysis and root cause.
1. Teams assume ECC customer master structures will map automatically to business partner roles. 2. Customer-vendor integration preparation is treated as a technical task rather than a design activity. 3. Role assignments such as sales area roles are not defined during blueprint. 4. Legacy customer master inconsistencies are not cleaned before business partner conversion. Business partner migration fails when master data architecture is treated as a technical conversion instead of a design exercise.
Why this is a migration, exclusive failure.
1. ECC allowed separate customer and vendor master objects. 2. S/4HANA consolidates identities under a single business partner architecture. 3. Sales, finance, and logistics roles must now exist under the same master object. 4. Missing roles only become visible when SD transactions attempt to use the business partner. This is not a configuration mistake. It is a fundamental master data architecture change.
Financial and customer impact.
1. Sales orders cannot be created for customers with incomplete business partner roles. 2. Credit management integration fails due to missing financial roles. 3. Customer onboarding becomes inconsistent across regions. 4. Support teams spend excessive effort manually correcting business partner records. Business partner role failures stop order-to-cash transactions at the source.
Governance and accountability, RACI model.
In ECC to S/4HANA programs, ownership follows a RACI model where authority and execution are clearly separated across functional and technical work streams. 1. Accountable, master data architecture lead the person who owns business partner design and gets fired if customer master migration fails across the enterprise. 2. Responsible, SD functional lead defines required business partner roles for sales transactions. 3. Consulted, solution architect ensures business partner architecture aligns with S/4HANA design principles. 4. Informed, global customer master data owner oversees master data governance and quality. Business partner governance must be owned centrally to prevent transaction failures.
Ownership, who actually fixes it.
Resolving this issue requires redesigning business partner roles and validating master data conversion. 1. Master data architecture lead defines a global business partner role model. 2. SD functional lead identifies sales area roles required for order processing. 3. Solution architect validates role architecture against S/4HANA master data design. 4. Global customer master data owner enforces governance across all regions.
Who gets blamed versus who owns it.
1. Blamed, SD functional team business believes order processing configuration is incorrect. 2. Blamed, data migration team perceived as not converting customer records correctly. 3. Actual owner, master data architecture lead and SD functional lead responsible for business partner role design. 4. Root cause, business partner architecture was never fully designed during Explore. Transaction failures are symptoms of poor master data architecture decisions.
How this is actually fixed, the right way by a role.
1. Master data architecture lead defines a standardized business partner role model. 2. SD functional lead maps required partner roles for each sales process. 3. Solution architect validates business partner structure against S/4HANA simplification guidelines. 4. Global customer master data owner enforces governance during migration and onboarding.
What not to do, common wrong fixes.
1. Assuming ECC customer master records will automatically convert correctly. 2. Treating customer vendor integration as a purely technical migration task. 3. Ignoring business partner role testing during Explore phase. 4. Allowing each region to define its own business partner role structure. Business partner architecture must be standardized before migration begins.
Follow-up 1. Why is business partner mandatory in S/4HANA?
Answer: S/4HANA unifies customer and vendor master data into a single business partner architecture to simplify identity management across finance, logistics, and sales. This allows one entity to represent multiple business relationships. However, it also requires careful design of business partner roles before migration.
Follow-up 2. How do experienced architects design business partner roles?
Answer: senior architects begin by mapping existing ECC customer and vendor roles and consolidating them into a unified business partner model. They then define which roles are required for finance, sales, logistics, and contact relationships. This structure is validated with customer-vendor integration tools before data migration begins.
Follow-up 3. Curveball. What happens if we migrate customers first and design roles later?
Answer: migrating customers without a defined business partner role structure creates inconsistent master data across the system. Transactions start failing because required roles are missing or incomplete. Correcting thousands of business partner records after go live becomes extremely expensive and time-consuming.
Exclusive pro tip.
Before customer-vendor integration migration begins, build a business partner role matrix that maps every ECC customer function to its S/4HANA role equivalent. Treat business partner architecture as a master data blueprint decision, not a technical conversion task.
Scenario 60. Business partner mandatory fields not designed.
In the Explore phase of ECC to S/4HANA migration, organizations fail to define mandatory business partner fields required for customer creation and maintenance. ECC customer master records allowed flexibility in field usage across regions and business units. In S/4HANA, the business partner model enforces structured data governance through mandatory fields. If these mandatory attributes are not clearly designed during blueprint, customer creation fails, onboarding processes slow down, and master data quality deteriorates across the enterprise.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high master data governance risk. 2. Phase, Explore. 3. Frequency, extremely common in global template programs. 4. Primary ownership, master data governance lead. 5. Supporting SD functional lead. 6. Business ownership global customer master data owner. 7. Relevant SAP note 22655093 business partner approach.
Diagnostic dashboard, symptoms and evidence.
How missing mandatory business partner fields appear during testing and customer onboarding. 1. Symptom customer creation fails due to missing required business partner fields. 2. Red flag different regions populate different fields with no global standard. 3. Business impact customer onboarding slows down and manual corrections increase. 4. Detection review business partner field status configuration across account groups. 5. Technical proof. Mandatory field validation errors appear during business partner creation transactions. Insight. If customer creation fails with validation errors, mandatory field governance was not designed.
Why this happens, scenario analysis and root cause.
1. Organizations migrate ECC customer structures without redesigning mandatory attributes. 2. Business stakeholders are not involved in defining master data standards. 3. Regional teams use different fields for the same business meaning. 4. Field status settings are configured late during realization instead of during explore. Mandatory field governance is a design activity that must be completed before migration.
Why this is a migration, exclusive failure.
1. ECC allowed decentralized customer master structures across regions. 2. S/4HANA consolidates customer and vendor identities under business partner. 3. Business partner architecture enforces consistent master data governance. 4. Missing mandatory fields become visible when customer onboarding begins. What was flexible in ECC becomes structured governance in S/4HANA.
Financial and customer impact.
1. Customer onboarding delays disrupt sales operations. 2. Sales orders fail when required master data attributes are missing. 3. Manual corrections increase operational costs. 4. Inconsistent customer records degrade reporting accuracy. Poor master data governance creates operational friction across the enterprise.
Governance and accountability, RACI model.
In ECC to S/4HANA programs, ownership follows a RACI model where authority and execution are clearly separated across functional and technical work streams. 1. Accountable. Master data governance lead the person who owns business partner field governance and gets fired if customer onboarding fails across the enterprise. 2. Responsible. SD functional lead defines which master data attributes are required for order processing. 3. Consulted. Solution architect ensures business partner field governance aligns with S/4HANA architecture. 4. Informed. Global customer master data owner monitors enterprise master data quality. Master data governance must be centrally owned to prevent operational failures.
Ownership, who actually fixes it.
Resolving this issue requires designing mandatory business partner attributes and enforcing governance. 1. Master data governance lead defines a global mandatory field standard for business partner. 2. SD functional lead identifies which attributes are required for order-to-cash processing. 3. Solution architect validates field status configuration against S/4HANA design standards. 4. Global customer, master data owner, enforces master data governance across regions.
Who gets blamed versus who owns it.
1. Blamed. SD functional team business believes configuration errors cause customer creation failures. 2. Blamed. Data migration team perceived as loading incomplete customer data. 3. Actual owner, master data governance lead and SD functional lead responsible for defining mandatory attributes. 4. Root cause, business partner field governance was not defined during explore. Customer onboarding failures are usually governance problems, not technical ones.
How this is actually fixed, the right way by a role.
1. Master data governance lead defines mandatory business partner attributes for global operations. 2. SD functional lead validates which fields are required for sales transactions. 3. Solution architect reviews field status configuration against S/4HANA standards. 4. Global customer master data owner enforces governance during onboarding and migration.
What not to do, common wrong fixes.
1. Allowing each region to define its own mandatory fields. 2. Treating field governance as a configuration task instead of a design decision. 3. Ignoring master data standards during migration preparation. 4. Deferring field governance until after go live. Mandatory field governance must be defined before master data migration begins.
Follow-up 1. Why are mandatory business partner fields critical in S/4HANA?
Answer: mandatory business partner fields ensure that customer records contain all attributes required for finance, sales, and logistics processes. Without standardized fields, transactions fail or produce inconsistent reporting. Designing mandatory attributes early prevents operational disruptions later.
Follow-up 2. How do experienced architects design business partner field governance?
Answer: senior architects work with business stakeholders to define a global master data standard. They map required attributes for sales, finance, and compliance processes. This structure is then enforced through field status configuration before data migration begins.
Follow-up 3. Curveball. What happens if we relax mandatory fields to avoid onboarding delays?
Answer: relaxing mandatory fields solves short-term onboarding issues but creates inconsistent master data across the enterprise. Over time, reporting, compliance, and credit management processes begin to fail. Cleaning master data after go live becomes significantly more expensive.
Exclusive pro tip.
Design a global business partner field governance matrix during Explore that defines mandatory attributes for finance, sales, compliance, and logistics processes. Treat master data governance as an architectural decision, not just a configuration step.
Scenario 61. Customer hierarchy business partner impact not designed.
In the Explore phase of ECC to S/4HANA migration, organizations fail to redesign customer hierarchy structures for the business partner model. In ECC, customer hierarchies were maintained directly in customer master tables and used extensively for pricing, reporting, and credit exposure management. In S/4HANA, customer relationships are represented through business partner relationships and hierarchy structures. If this redesign is not completed during blueprint, pricing hierarchies break, reporting becomes inconsistent, and credit exposure aggregation across parent customers fails.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high hierarchy and pricing governance risk. 2. Phase, explore. 3. Frequency, common in enterprises using customer hierarchy-based pricing. 4. Primary ownership, master data architecture lead. 5. Supporting SD pricing lead. 6. Business ownership, global sales operations owner. 7. Relevant SAP note 22655093, business partner approach.
Diagnostic dashboard, symptoms and evidence.
How hierarchy redesign issues appear during testing and sales operations. 1. Symptom: pricing conditions based on customer hierarchy fail during order processing. 2. Red flag: parent and child relationships are missing in business partner structures. 3. Business impact: discount agreements and hierarchy pricing logic no longer apply correctly. 4. Detection: review migrated business partner relationship structures against ECC hierarchy data. 5. Technical proof: hierarchy nodes exist in legacy data but are not represented in business partner relationships. Insight: if hierarchy pricing fails after migration, the business partner hierarchy model was not redesigned.
Why this happens, scenario analysis and root cause.
1. Teams migrate customer master data without redesigning hierarchy relationships. 2. Customer hierarchy design is treated as a data migration problem instead of a master data architecture decision. 3. Pricing and reporting teams are not involved in hierarchy modeling discussions. 4. Legacy hierarchy inconsistencies are not cleaned before conversion. Customer hierarchy redesign requires both functional and master data governance alignment.
Why this is a migration, exclusive failure.
1. ECC stored hierarchy relationships directly in customer master tables. 2. S/4HANA represents customer relationships using business partner relationship modeling. 3. Hierarchy structures must be rebuilt using the business partner architecture. 4. Legacy hierarchy logic cannot simply be migrated without redesign. What was table-driven in ECC becomes relationship-driven in S/4HANA.
Financial and customer impact.
1. Hierarchy-based pricing discounts fail during sales order processing. 2. Revenue reporting by parent customer becomes inconsistent. 3. Credit exposure across corporate hierarchies cannot be calculated correctly. 4. Sales organizations lose visibility into consolidated customer structures. Hierarchy failures disrupt pricing logic and enterprise sales visibility.
Governance and accountability, RACI model.
In ECC to S/4HANA programs, ownership follows a RACI model where authority and execution are clearly separated across functional and technical work streams. 1. Accountable. Master data architecture lead the person who owns business partner hierarchy architecture and gets fired if hierarchy structures fail across the enterprise. 2. Responsible. SD pricing lead defines hierarchy requirements for pricing and discount agreements. 3. Consulted. Solution architect ensures business partner hierarchy design aligns with S/4HANA architecture. 4. Informed. Global sales operations owner oversees hierarchy governance across regions. Customer hierarchy architecture must be governed centrally to support enterprise pricing.
Ownership, who actually fixes it.
Resolving this issue requires redesigning hierarchy relationships within the business partner architecture. 1. Master data architecture lead defines a global business partner hierarchy model. 2. SD pricing lead validates hierarchy structures required for pricing conditions. 3. Solution architect reviews hierarchy architecture against S/4HANA master data design. 4. Global sales operations owner approves hierarchy governance standards.
Who gets blamed versus who owns it.
1. Blamed. SD pricing team business assumes pricing configuration errors. 2. Blamed. Data migration team believed to have migrated hierarchy data incorrectly. 3. Actual owner, master data architecture lead and SD pricing lead responsible for hierarchy redesign. 4. Root cause, customer hierarchy architecture was not redesigned during Explore. Hierarchy pricing failures are architecture issues rather than configuration mistakes.
How this is actually fixed, the right way by a role.
1. Master data architecture lead designs a business partner relationship model for hierarchy structures. 2. SD pricing lead maps hierarchy levels required for pricing agreements. 3. Solution architect validates hierarchy structures against S/4HANA master data architecture. 4. Global sales operations owner enforces hierarchy governance across regions.
What not to do, common wrong fixes.
1. Migrating legacy hierarchy tables without redesigning relationships. 2. Allowing each region to create its own hierarchy structure. 3. Ignoring hierarchy testing during explore and testing phases. 4. Treating hierarchy problems as simple pricing configuration issues. Hierarchy architecture must be designed before data migration begins.
Follow-up 1. Why are customer hierarchies important in enterprise sales?
Answer: customer hierarchies allow organizations to manage pricing, reporting, and credit exposure across large corporate structures. Many global customers operate with multiple subsidiaries that require consolidated pricing agreements. Without hierarchy modeling, enterprise sales management becomes fragmented.
Follow-up 2. How do experienced architects redesign hierarchies for business partner?
Answer: senior architects first analyze legacy hierarchy structures used for pricing and reporting. They then model equivalent relationships using business partner relationship frameworks. This redesigned structure is validated with pricing and credit management scenarios before migration begins.
Follow-up 3. Curveball. What happens if hierarchy redesign is delayed until after go live?
Answer: delaying hierarchy redesign causes immediate operational problems because pricing and credit aggregation rely on parent-customer relationships. Fixing hierarchy structures after go live requires massive master data corrections and reconfiguration of pricing agreements. The effort often becomes far more expensive than designing it properly during Explore.
Exclusive pro tip.
Before migration begins, create a customer hierarchy architecture blueprint that maps legacy ECC hierarchy nodes to business partner relationship models. Validate hierarchy structures using pricing and credit scenarios to ensure the design supports enterprise sales governance.
Scenario 62. Number range strategy conflicts between business partner and customer.
In the Explore phase of ECC to S/4HANA migration, organizations do not design a consistent number range strategy between business partner and legacy customer numbers. ECC allowed customer numbers to be managed independently through account groups. In S/4HANA, customer-vendor integration requires business partner and customer records to be synchronized. If number range strategies are not aligned during design, migration failures occur, customer records duplicate, and master data governance becomes inconsistent across the enterprise.
Scenario classification and relevant SAP note, if applicable.
1. Complexity, high master data synchronization risk. 2. Phase, explore. 3. Frequency, very common in customer-vendor integration migrations. 4. Primary ownership, master data architecture lead. 5. Supporting data migration lead. 6. Business ownership, global customer master data owner. 7. Relevant SAP note, SAP note 2265093, business partner approach.
Diagnostic dashboard, symptoms and evidence.
How number range conflicts appear during migration and master data operations. 1. Symptom, customer records fail to synchronize during customer-vendor integration migration. 2. Red flag, business partner numbers and customer numbers do not match expected patterns. 3. Business impact, duplicate customer identities appear in the system. 4. Detection, review business partner and customer number range configuration before migration. 5. Technical proof, CVI synchronization reports show number mapping conflicts. Insight, if customer numbers change unexpectedly after migration, number range strategy was not designed correctly.
Why this happens, scenario analysis and root cause.
1. Legacy ECC customer numbering schemes are migrated without redesign. 2. Business partner number ranges are configured independently from customer numbers. 3. Customer-vendor integration mapping rules are not validated during Explore. 4. Global master data governance does not define a unified numbering policy. Numbering conflicts emerge when business partner architecture is not treated as a master data design decision.
Why this is a migration, exclusive failure.
1. ECC managed customer numbers independently through account groups. 2. S/4HANA requires business partner and customer objects to be synchronized. 3. Customer-vendor integration enforces consistent identity mapping. 4. Number range conflicts only appear when migration synchronization runs. Identity management becomes centralized in S/4HANA and exposes legacy numbering inconsistencies.
Financial and customer impact.
1. Duplicate customer records disrupt order processing and reporting. 2. Customer identities become fragmented across finance and sales modules. 3. Manual reconciliation of master data increases operational costs. 4. Customer trust decreases when account structures become inconsistent. Numbering inconsistencies break the single customer identity principle of S/4HANA.
Governance and accountability, RACI model.
In ECC to S/4HANA programs, ownership follows a RACI model where authority and execution are clearly separated across functional and technical work streams. 1. Accountable, master data architecture lead the person who owns business partner identity design and gets fired if numbering conflicts break customer synchronization. 2. Responsible, data migration lead implements number range mapping during customer-vendor integration migration. 3. Consulted, solution architect validates numbering architecture against S/4HANA identity design principles. 4. Informed, global customer master data owner monitors enterprise master data identity governance. Customer identity governance must be centrally owned to prevent duplication.
Ownership, who actually fixes it.
Resolving this issue requires designing a unified numbering strategy across business partner and customer objects. 1. Master data architecture lead defines a unified identity numbering policy. 2. Data migration lead configures number range synchronization rules for customer-vendor integration. 3. Solution architect validates numbering architecture against S/4HANA master data principles. 4. Global customer master data owner enforces enterprise identity governance.
Who gets blamed versus who owns it.
1. Blamed, data migration team business believes migration scripts created duplicate customers. 2. Blamed, SD functional team believed to have configured account groups incorrectly. 3. Actual owner, master data architecture lead and data migration lead responsible for identity design and synchronization. 4. Root cause, number range strategy was never defined during Explore. Identity conflicts are architecture issues. rather than simple migration errors.
How this is actually fixed, the right way by a role.
1. Master Data Architecture Lead defines a global numbering strategy for business partner and customer objects. 2. Data Migration Lead configures customer-vendor integration mapping rules. 3. Solution Architect validates numbering architecture against S4 HANA identity management principles. 4. Global Customer Master Data Owner enforces identity governance across regions.
What not to do, common wrong fixes.
1. Migrating ECC number ranges without redesigning identity architecture. 2. Allowing business partner and customer numbers to diverge across regions. 3. Ignoring identity mapping validation during customer-vendor integration testing. 4. Treating numbering conflicts as simple migration errors. Customer identity must be designed as a global architecture decision.
Follow-up 1. Why is number range synchronization critical in S4 HANA?
Answer: S4 HANA uses business partner as the central identity object across finance, sales, and logistics. If customer numbers and business partner numbers are not aligned, systems cannot maintain a consistent customer identity. This creates duplicate records and reporting inconsistencies.
Follow-up 2. How do experienced architects design numbering strategies?
Answer: Senior architects analyze existing ECC number ranges and determine whether internal or external numbering should be used. They then design a unified business partner numbering architecture that supports customer-vendor integration synchronization. This design is validated before migration begins.
Follow-up 3. Curveball. What happens if business partner numbers differ from customer numbers?
Answer: When business partner numbers differ from customer numbers, the system maintains multiple identifiers for the same entity. This causes confusion across modules and makes reporting inconsistent. Fixing identity mismatches after go live requires massive master data reconciliation.
Exclusive pro tip.
Design a unified business partner identity strategy before customer-vendor integration migration begins. Align business partner and customer number ranges so that a single identifier represents each customer across the entire enterprise.
Scenario 63. Partner determination redesign gaps.
In the explore phase of ECC to S4 HANA migration, organizations do not redesign partner determination logic to align with the business partner architecture. In ECC, partner functions such as sold to party, shipped to party, payer, and bill to party were maintained directly in the customer master and partner determination procedures. In S4 HANA, these relationships are managed through business partner roles and relationships. If partner determination is not redesigned during blueprint, sales orders fail to assign correct partners, billing relationships break, and credit exposure cannot be evaluated properly.
Scenario classification and relevant SAP note, if applicable.
1. Complexity high, sales transaction integrity risk. 2. Phase explore. 3. Frequency very common in global S4 HANA conversions. 4. Primary ownership SD functional lead. 5. Supporting master data architecture lead. 6. Business ownership global order to cash process owner. 7. Relevant SAP note 22655093 business partner approach.
Diagnostic dashboard, symptoms and evidence.
How partner determination failures appear during testing and order processing. 1. Symptom: sales orders fail to populate required partner functions automatically. 2. Red flag: partner functions exist in ECC but are missing from business partner role relationships. 3. Business impact: incorrect billing partners or delivery partners are assigned. 4. Detection: review partner determination procedures against business partner relationship design. 5. Technical proof: business partner records exist but required partner functions cannot be derived. Insight: if partner functions fail during order creation, business partner relationships were not designed properly.
Why this happens, scenario analysis and root cause.
1. ECC partner determination logic is migrated without redesign. 2. Teams assume business partner automatically inherits partner roles. 3. Master data relationships between business partners are not modeled during blueprint. 4. Functional teams focus on configuration and ignore master data relationship design. Partner determination redesign requires both master data architecture and SD configuration alignment.
Why this is a migration, exclusive failure.
1. ECC stored partner functions directly in customer master records. 2. S/4HANA represents partner relationships through business partner architecture. 3. Partner determination now relies on business partner relationship modeling. 4. Legacy partner logic cannot function correctly without redesign. What was customer master driven in ECC becomes relationship driven in S/4HANA.
Financial and customer impact.
1. Billing documents are issued to incorrect payer entities. 2. Delivery partners are assigned incorrectly, causing logistics failures. 3. Credit exposure is evaluated against the wrong customer relationship. 4. Customer experience deteriorates due to incorrect document routing. Partner determination failures disrupt the entire order-to-cash process.
Governance and accountability, RACI model.
In ECC to S/4HANA programs, ownership follows a RACI model where authority and execution are clearly separated across functional and technical work streams. 1. Accountable, SD functional lead. The person who owns partner determination design and gets fired if sales documents assign incorrect partners across the enterprise. 2. Responsible, master data architecture lead. Designs business partner relationship structures required for partner determination. 3. Consulted, solution architect. Validates alignment between business partner architecture and SD process design. 4. Informed, global order-to-cash process owner. Oversees partner governance across regions. Partner determination must be jointly owned by functional design and master data architecture.
Ownership, who actually fixes it.
Resolving this issue requires redesigning partner determination logic within the business partner model. 1. SD functional lead redesigns partner determination procedures for sales documents. 2. Master data architecture lead models business partner relationships required for partner functions. 3. Solution architect validates end-to-end partner assignment across order-to-cash flows. 4. Global order-to-cash process owner approves partner governance standards.
Who gets blamed versus who owns it.
1. Blamed SD configuration team. Business assumes partner procedures were configured incorrectly. 2. Blamed data migration team. Believed to have migrated customer data incorrectly. 3. Actual owner SD functional lead and master data architecture lead. Responsible for partner relationship redesign. 4. Root cause, partner determination architecture was not redesigned during Explore. Partner determination failures usually originate from missing business partner relationships.
How this is actually fixed, the right way by a role.
1. SD functional lead redesigns partner determination procedures aligned with S/4HANA processes. 2. Master data architecture lead defines business partner relationships supporting partner roles. 3. Solution architect validates partner assignment across sales, delivery, billing, and credit processes. 4. Global order-to-cash process owner enforces partner governance policies globally.
What not to do, common wrong fixes.
1. Migrating ECC partner procedures without redesign. 2. Ignoring business partner relationship modeling. 3. Allowing regions to define inconsistent partner roles. 4. Treating partner determination failures as simple configuration errors. Partner determination must be redesigned alongside business partner architecture.
Follow-up 1. Why does partner determination break during S/4HANA migration?
Answer: partner determination in ECC relied heavily on customer master data structures. S/4HANA introduces business partner relationships as the foundation for partner roles. Without redesigning these relationships, the system cannot correctly derive sold to, shipped to, or payer roles during transaction processing.
Follow-up 2. How do experienced architects redesign partner determination?
Answer: senior architects start by mapping existing ECC partner functions and identifying how those relationships translate into business partner roles. They then redesign partner determination procedures in SD while simultaneously modeling business partner relationships to support those procedures.
Follow-up 3. Curveball. What happens if partner determination is corrected only after go live?
Answer: correcting partner determination after go live often requires modifying thousands of business partner relationships and reconfiguring partner procedures. This disrupts billing, delivery, and credit processes simultaneously. Fixing it during Explore is dramatically safer and cheaper.
Exclusive pro tip.
Create a partner relationship blueprint before migration that maps every ECC partner function to a business partner relationship. Validate the design with full order to cash transaction testing to ensure partner roles resolve correctly.
Scenario 64. Credit segment design incomplete.
In the Explore phase of ECC to S/4HANA migration, organizations fail to redesign credit management architecture using credit segments in financial supply chain management. In ECC, credit control areas governed credit exposure across company codes. In S/4HANA, the FSCM credit management framework replaces this model with credit segments and new exposure calculations. If credit segments are not properly designed during blueprint, credit checks fail, credit exposure is calculated incorrectly, and order processing becomes inconsistent across the enterprise.
Scenario classification and relevant SAP note, if applicable.
1. Complexity high, financial risk and order processing impact. 2. Phase Explore. 3. Frequency extremely common in S/4HANA migrations replacing classic credit management. 4. Primary ownership credit management lead. 5. Supporting SD functional lead. 6. Business ownership global credit risk director. 7. Relevant SAP note 2270544 credit management simplification.
Diagnostic dashboard, symptoms and evidence.
How incomplete credit segment design appears during testing and order processing. 1. Symptom, sales orders are blocked incorrectly due to unexpected credit check results. 2. Red flag, customers exist in FSCM Credit Master but credit segments are missing or incomplete. 3. Business impact, legitimate orders are blocked or risky customers bypass credit checks. 4. Detection, review credit segment configuration in FSCM Credit Management Setup. 5. Technical proof, credit exposure reports show missing or incorrect credit segment assignments. Insight, if credit checks behave differently from ECC, the credit segment architecture was not designed correctly.
Why this happens, scenario analysis and root cause.
1. Organizations migrate classic credit control areas without redesigning credit segments. 2. Functional teams assume credit management configuration will remain unchanged. 3. Business credit policies are not mapped to the new FSCM architecture. 4. Global credit governance is not aligned with S/4HANA credit segmentation design. Credit management redesign requires both financial governance and system architecture alignment.
Why this is a migration, exclusive failure.
1. ECC credit management use credit control areas to group company codes. 2. S/4HANA FSCM introduces credit segments with new exposure calculation logic. 3. Credit checks are now integrated with financial supply chain management. 4. Legacy credit structures cannot simply be migrated without redesign. Credit control areas in ECC evolve into credit segment architecture in S/4HANA.
Financial and customer impact.
1. Orders for reliable customers are blocked due to incorrect credit checks. 2. Risky customers may bypass credit limits due to missing credit segments. 3. Cash flow planning becomes unreliable due to incorrect credit exposure reporting. 4. Sales teams lose confidence in automated credit management controls. Incorrect credit segmentation exposes the organization to both financial risk and lost revenue.
Governance and accountability, RACI model.
In ECC to S/4HANA programs, ownership follows a RACI model where authority and execution are clearly separated across functional and technical work streams. 1. Accountable credit management lead. The person who owns credit segment design and gets fired if credit checks fail across the enterprise. 2. Responsible SD functional lead. Ensures credit checks are correctly integrated with order processing. 3. Consulted solution architect. Validates credit management architecture with an S/4HANA design. 4. Informed global credit risk director. Oversees enterprise credit governance policies. Credit governance must align financial policy with system architecture.
Ownership, who actually fixes it.
Resolving this issue requires redesigning credit management architecture using credit segments. 1. Credit management lead defines enterprise credit segmentation policy. 2. SD functional lead ensures credit checks align with order processing flows. 3. Solution architect validates integration between FSCM credit management and SD. 4. Global credit risk director approves the credit governance framework.
Who gets blamed versus who owns it?
1. Blamed SD functional team. Sales believes order blocking is caused by incorrect configuration. 2. Blamed finance team. Perceived to have defined overly restrictive credit rules. 3. Actual owner credit management lead and solution architect. Responsible for credit architecture redesign. 4. Root cause credit segments were never properly designed during Explore. Credit failures usually originate from architecture design gaps rather than operational mistakes.
How this is actually fixed, the right way by a role.
1. Credit management lead defines credit segments aligned with enterprise credit policy. 2. SD functional lead integrates credit checks into order processing procedures. 3. Solution architect validates credit architecture across finance and sales modules. 4. Global credit risk director approves enterprise credit governance standards.
What not to do, common wrong fixes.
1. Migrating classic credit control areas without redesign. 2. Allowing inconsistent credit segments across company codes. 3. Treating credit check failures as simple configuration problems. 4. Ignoring FSCM architecture during credit management design. Credit management redesign must align with the new S4 HANA FSCM architecture.
Follow-up 1. Why does S4 HANA replace credit control areas with credit segments?
Answer: S4 HANA integrates credit management into financial supply chain management to provide more flexible and granular risk control. Credit segments allow organizations to evaluate exposure across multiple business dimensions. This architecture improves enterprise risk visibility compared to ECC credit control areas.
Follow-up 2. How do experienced architects design credit segment structures?
Answer: Senior architects begin by analyzing how credit control areas were used in ECC across company codes and regions. They then design credit segments that reflect real credit risk exposure structures. This design is validated through order processing and credit exposure testing before go live.
Follow-up 3. Curveball. What happens if credit segments are designed after migration?
Answer: Designing credit segments after migration causes credit exposure inconsistencies and widespread order blocking. Customers may suddenly exceed limits because exposure is recalculated under the new architecture. Correcting credit structures after go live requires major reconfiguration and business disruption.
Exclusive pro tip.
Before migration begins, build a credit architecture blueprint that maps ECC credit control areas to S4 HANA credit segments. Validate the design with real customer exposure scenarios to ensure credit checks behave correctly after migration.
Scenario 65. Credit horizon logic redesign gaps.
In the Explore phase of ECC to S4 HANA migration, organizations fail to redesign credit horizon logic when transitioning to FSCM credit management. In ECC, credit checks used simple horizon parameters tied to delivery dates and open orders. In S4 HANA, credit exposure calculations are integrated with FSCM and financial documents through enhanced horizon logic. If the credit horizon configuration is not redesigned during blueprint, exposure calculations become inaccurate and credit decisions block legitimate sales orders or allow risky transactions.
Scenario classification and relevant SAP note, if applicable.
1. Complexity high, credit risk and exposure calculation impact. 2. Phase Explore. 3. Frequency common in organizations migrating classic credit management. 4. Primary ownership credit management lead. 5. Supporting SD functional lead. 6. Business ownership global credit risk director. 7. Relevant SAP note 2270544 credit management simplification.
Diagnostic dashboard, symptoms and evidence.
How credit horizon configuration issues appear during order processing and credit checks. 1. Symptom: sales orders are blocked unexpectedly despite sufficient customer credit limits. 2. Red flag credit exposure reports include future deliveries incorrectly. 3. Business impact: legitimate orders are delayed due to incorrect credit exposure evaluation. 4. Detection: compare ECC credit horizon parameters with FSCM credit check configuration. 5. Technical proof: exposure calculation logs show incorrect horizon inclusion of open documents. Insight: if exposure calculations include unexpected documents, credit horizon logic was not redesigned.
Why this happens, scenario analysis and root cause.
1. Organizations migrate ECC credit horizon settings without redesigning exposure calculation logic. 2. Functional teams assume the same credit check behavior will apply in S/4HANA. 3. FSCM credit management architecture introduces new exposure calculation models. 4. Business credit policies are not translated into the new configuration framework. Credit horizon redesign must align financial risk policies with the new FSCM architecture.
Why this is a migration, exclusive failure.
1. ECC credit checks evaluated exposure using simple document horizon parameters. 2. S/4HANA FSCM integrates exposure calculation with financial supply chain management. 3. Credit horizon logic becomes more dynamic and configurable. 4. Legacy horizon assumptions cannot be migrated directly. Exposure calculation in S/4HANA becomes a financial architecture decision rather than a simple parameter.
Financial and customer impact.
1. Orders for reliable customers are blocked due to incorrect credit exposure evaluation. 2. Credit risk monitoring becomes unreliable across company codes. 3. Sales teams lose confidence in automated credit control decisions. 4. Revenue opportunities are delayed or lost due to incorrect blocking. Incorrect credit horizon logic disrupts the balance between risk control and revenue growth.
Governance and accountability, RACI model.
In ECC to S/4HANA programs, ownership follows a RACI model where authority and execution are clearly separated across functional and technical work streams. 1. Accountable credit management lead: the person who owns credit horizon policy and gets fired if exposure calculations block legitimate orders across the enterprise. 2. Responsible SD functional lead: ensures credit checks integrate correctly with sales order processing. 3. Consulted solution architect: validates FSCM credit architecture and exposure logic. 4. Informed global credit risk director: oversees enterprise credit governance policies. Credit exposure governance must align financial risk policy with system configuration.
Ownership, who actually fixes it.
Resolving this issue requires redesigning exposure calculation rules in FSCM credit management. 1. Credit management lead defines enterprise credit horizon policy. 2. SD functional lead validates credit check integration with order processing. 3. Solution architect reviews exposure calculation logic in FSCM configuration. 4. Global credit risk director approves credit risk governance standards.
Who gets blamed versus who owns it.
1. Blamed SD functional team: sales believes order blocking is caused by configuration errors. 2. Blamed finance team: believed to have set overly restrictive credit rules. 3. Actual owner credit management lead and solution architect: responsible for exposure architecture redesign. 4. Root cause credit horizon logic was not redesigned during Explore. Credit blocking issues often originate from architectural design gaps rather than operational errors.
How this is actually fixed, the right way by a role.
1. Credit management lead redesigns exposure calculation policies aligned with enterprise credit strategy. 2. SD functional lead ensures credit checks behave correctly during order processing. 3. Solution architect validates FSCM credit management configuration. 4. Global credit risk director approves enterprise credit governance standards.
What not to do, common wrong fixes.
1. Migrating ECC credit horizon parameters without redesign. 2. Assuming credit exposure calculations will behave the same in S/4HANA. 3. Ignoring FSCM architecture when configuring credit checks. 4. Treating exposure issues as simple SD configuration problems. Credit horizon logic must be designed alongside the new credit management architecture.
Follow-up 1. Why does credit horizon logic change in S/4HANA?
Answer: S/4HANA integrates credit management with financial supply chain management, which introduces more flexible exposure calculation models. Horizon parameters now interact with financial documents and risk monitoring structures. This architecture provides more accurate credit control, but requires careful redesign during migration.
Follow-up 2. How do experienced architects design credit horizon structures?
Answer: senior architects begin by analyzing how ECC credit checks evaluated open orders and deliveries. They then translate those policies into FSCM exposure calculation rules. The new configuration is validated through order simulations to confirm that credit checks behave as expected.
Follow-up 3. Curveball. What happens if exposure calculations are corrected after go-live?
Answer: correcting exposure logic after go-live disrupts order processing because thousands of existing sales documents must be re-evaluated. Customers may suddenly exceed limits or have orders blocked unexpectedly. Designing credit horizon logic during Explore avoids large operational disruptions.
Exclusive pro tip.
Build credit exposure test scenarios during Explore that simulate real customer order pipelines across multiple horizon periods. Validate that exposure calculations behave exactly as intended before migration begins.
Scenario 66. Static versus dynamic credit check behavior change.
In the Explore phase of ECC to S/4HANA migration, organizations fail to understand behavioral differences between static and dynamic credit checks when moving to FSCM credit management. In ECC, credit checks relied on simpler static and dynamic parameters based on open orders and deliveries. In S/4HANA, FSCM credit checks integrate additional exposure elements including financial documents and enhanced risk evaluation logic. If the differences between static and dynamic checks are not validated during design, credit blocks behave unpredictably and sales operations experience significant disruption.
Scenario classification and relevant SAP note, if applicable.
1. Complexity high, credit control behavior risk. 2. Phase Explore. 3. Frequency very common when migrating from classic credit management. 4. Primary ownership credit management lead. 5. Supporting SD functional lead. 6. Business ownership global credit risk director. 7. Relevant SAP note 2270544, credit management simplification.
Diagnostic dashboard, symptoms and evidence.
How static and dynamic credit behavior changes appear during testing and order entry. 1. Symptom: orders that pass credit checks in ECC are blocked in S/4HANA. 2. Red flag: credit exposure calculations include unexpected document categories. 3. Business impact: sales teams experience unpredictable order blocking. 4. Detection: compare static and dynamic credit check configuration between ECC and FSCM. 5. Technical proof: credit exposure logs show different document inclusion logic. Insight: if credit checks behave inconsistently compared to ECC, the static and dynamic check logic was not validated.
Why this happens, scenario analysis and root cause.
1. Functional teams assume ECC static and dynamic checks will behave the same in S/4HANA. 2. FSCM credit management introduces expanded exposure calculation rules. 3. Testing scenarios do not simulate real customer credit exposure pipelines. 4. Credit policy changes are not aligned with new system capabilities. Static and dynamic credit checks must be revalidated against the FSCM exposure architecture.
Why this is a migration, exclusive failure.
1. ECC credit checks evaluated exposure using a simpler document structure. 2. S/4HANA FSCM introduces enhanced exposure calculation logic. 3. Financial documents, deliveries, and open orders interact differently in exposure calculations. 4. Legacy assumptions about credit behavior no longer hold true. Credit checks in S/4HANA become part of a broader financial risk architecture.
Financial and customer impact.
1. Reliable customers may have orders blocked unnecessarily. 2. Risk exposure monitoring becomes inconsistent across regions. 3. Sales operations experience delays in order processing. 4. Revenue opportunities are lost due to excessive credit blocking. Incorrect credit check behavior disrupts the balance between risk management and sales growth.
Governance and accountability, RACI model.
In ECC to S/4HANA programs, Ownership follows a RACI model where authority and execution are clearly separated across functional and technical work streams. 1. Accountable credit management lead. The person who owns credit check architecture and gets fired if order blocking behavior disrupts enterprise sales operations. 2. Responsible SD functional lead. Ensures credit checks integrate correctly into order processing. 3. Consulted solution architect. Validates FSCM exposure logic and risk calculation architecture. 4. Informed global credit risk director. Oversees enterprise credit governance policies. Credit governance requires alignment between financial risk policy and system behavior.
Ownership, who actually fixes it.
Resolving this issue requires validating credit exposure logic and redesigning check parameters. 1. Credit management lead redesigns static and dynamic credit check policies. 2. SD functional lead validates credit checks during order lifecycle scenarios. 3. Solution architect ensures exposure calculations align with FSCM architecture. 4. Global credit risk director approves enterprise credit risk governance.
Who gets blamed versus who owns it.
1. Blamed SD functional team. Sales assumes configuration errors caused incorrect credit blocking. 2. Blamed finance team. Believed to have changed credit policies incorrectly. 3. Actual owner, credit management lead and solution architect. Responsible for exposure architecture validation. 4. Root cause, static and dynamic credit check behavior was not validated during Explore. Credit blocking issues typically originate from misunderstood exposure logic.
How this is actually fixed, the right way by a role.
1. Credit management lead redesigns credit check policies aligned with FSCM capabilities. 2. SD functional lead validates order lifecycle credit checks using realistic scenarios. 3. Solution architect verifies exposure calculation logic in FSCM configuration. 4. Global credit risk director approves final enterprise credit policy design.
What not to do, common wrong fixes.
1. Assuming ECC static and dynamic credit checks will behave identically in S4 HANA. 2. Ignoring FSCM exposure calculation changes during testing. 3. Treating credit blocking issues as simple SD configuration problems. 4. Allowing credit check rules to evolve after go live. Credit exposure logic must be validated before migration to prevent operational disruptions.
Follow-up 1. What is the difference between static and dynamic credit checks?
Answer: static credit checks evaluate total exposure against a credit limit at a given moment. Dynamic credit checks incorporate a horizon period that evaluates future commitments such as open deliveries or planned billing. In S4 HANA, exposure calculations also integrate financial documents through FSCM.
Follow-up 2. How do experienced architects validate credit check behavior?
Answer: architects simulate real customer order pipelines including open orders, deliveries, billing documents, and financial exposure. These scenarios are executed in both ECC and S4 HANA environments to compare credit decisions. Differences are analyzed, and configuration is adjusted accordingly.
Follow-up 3. Curveball. What happens if credit checks become too strict after migration?
Answer: excessive credit blocking frustrates sales teams and disrupts order fulfillment. Customers with good payment history may suddenly face blocked orders due to new exposure calculations. Adjusting credit policies after go live becomes operationally disruptive and politically sensitive.
Exclusive pro tip.
During Explore, run parallel credit check simulations using real customer order histories. Compare ECC and S4 HANA credit decisions to identify behavioral differences early and redesign credit policies before migration begins.
Scenario 67. Documented versus undocumented exposure mismatch.
In the Explore phase of ECC to S4 HANA migration, organizations do not redesign how documented and undocumented credit exposure is calculated in FSCM credit management. In ECC, credit exposure primarily relied on open sales documents such as orders, deliveries, and billing. In S4 HANA, FSCM expands exposure calculation to include documented financial exposure such as open receivables and accounting postings. If this distinction is not understood during blueprint, Exposure calculations become inconsistent and credit checks behave unpredictably across the enterprise.
Scenario classification and relevant SAP note, if applicable.
1. Complexity high, credit exposure calculation risk. 2. Phase explore. 3. Frequency common when transitioning from classic credit management to FSCM. 4. Primary ownership credit management lead. 5. Supporting finance integration lead. 6. Business ownership global credit risk director. 7. Relevant SAP note 2270544, credit management simplification.
Diagnostic dashboard, symptoms and evidence.
How documented and undocumented exposure mismatches appear during testing and credit evaluation. 1. Symptom credit exposure reports show significantly higher values than expected. 2. Red flag exposure calculations include financial postings not previously considered in ECC. 3. Business impact orders are blocked despite customers appearing within credit limits in legacy systems. 4. Detection. Compare ECC exposure reports with FSCM exposure calculations. 5. Technical proof. FSCM exposure categories include accounting documents alongside sales documents. Insight. If exposure suddenly increases after migration, documented and undocumented exposure categories were not aligned.
Why this happens, scenario analysis and root cause.
1. Organizations assume exposure calculations will behave the same as ECC. 2. FSCM integrates financial accounting exposure with sales document exposure. 3. Exposure category configuration is not reviewed during design workshops. 4. Finance and sales teams are not aligned on exposure calculation logic. Credit exposure architecture must align finance and sales perspectives on customer risk.
Why this is a migration, exclusive failure.
1. ECC calculated exposure primarily from open sales documents. 2. S4 HANA FSCM integrates exposure from financial accounting and sales documents. 3. Exposure categories become more comprehensive in the new architecture. 4. Legacy exposure assumptions no longer match the new risk calculation model. Exposure calculation evolves from document-based evaluation to enterprise risk visibility.
Financial and customer impact.
1. Customers appear to exceed credit limits due to new exposure calculations. 2. Sales teams face unexpected credit blocks for routine transactions. 3. Financial risk reporting becomes inconsistent across regions. 4. Customer relationships suffer due to unexpected credit restrictions. Incorrect exposure alignment disrupts both credit control and sales continuity.
Governance and accountability, RACI model.
In ECC to S4 HANA programs, ownership follows a RACI model where authority and execution are clearly separated across functional and technical work streams. 1. Accountable credit management lead. The person who owns credit exposure architecture and gets fired if exposure calculations disrupt enterprise credit control. 2. Responsible finance integration lead ensures financial documents are correctly integrated into exposure calculations. 3. Consulted solution architect validates exposure calculation design across finance and sales modules. 4. Informed global credit risk director oversees enterprise credit governance. Credit exposure design must unify financial accounting and sales document visibility.
Ownership, who actually fixes it.
Resolving this issue requires redesigning exposure categories within FSCM credit management. 1. Credit management lead defines exposure categories aligned with enterprise risk policy. 2. Finance integration lead ensures accounting documents integrate correctly into exposure calculations. 3. Solution architect validates FSCM exposure configuration. 4. Global credit risk director approves enterprise credit exposure governance.
Who gets blamed versus who owns it.
1. Blamed finance team. Sales assumes accounting exposure calculations caused excessive credit blocking. 2. Blamed SD functional team. Believed to have configured credit checks incorrectly. 3. Actual owner credit management lead and finance integration lead. Responsible for exposure category design. 4. Root cause documented and undocumented exposure categories were not aligned during Explore. Exposure mismatches. often originate from cross-module architecture gaps.
How this is actually fixed, the right way by a role.
1. Credit Management Lead redesigns exposure categories for FSCM Credit Management. 2. Finance Integration Lead validates financial document integration with exposure calculations. 3. Solution Architect reviews cross-module exposure architecture. 4. Global Credit Risk Director approves the enterprise exposure governance model.
What not to do, common wrong fixes.
1. Assuming ECC exposure logic will behave the same in S4 HANA. 2. Ignoring financial document exposure during credit configuration. 3. Treating exposure discrepancies as simple configuration issues. 4. Allowing exposure policies to evolve after go live. Exposure governance must be designed during Explore to prevent credit chaos.
Follow-up 1. What is the difference between documented and undocumented exposure?
Answer: documented exposure refers to financial postings, such as open receivables recorded in accounting. Undocumented exposure includes operational documents such as sales orders and deliveries that have not yet posted to finance. FSCM Credit Management evaluates both categories to provide a more complete credit risk picture.
Follow-up 2. How do experienced architects align exposure categories?
Answer: architects analyze how exposure was calculated in ECC and compare it with the expanded exposure model in FSCM. They then design exposure categories that reflect both financial risk and operational commitments. This configuration is validated using real customer transaction histories.
Follow-up 3. Curveball. What happens if exposure calculations are adjusted after go live?
Answer: changing exposure categories after go live can dramatically alter credit limits and customer risk profiles overnight. Customers who previously had available credit may suddenly exceed limits. This creates operational confusion and damages trust between finance and sales teams.
Exclusive pro tip.
Before migration begins, simulate credit exposure calculations using real customer transaction data. Validate that FSCM exposure categories reflect actual business risk policies and align with both finance and sales perspectives.
Scenario 68. Credit master replication timing issues.
In the Explore phase of ECC to S4 HANA migration, organizations fail to design proper synchronization timing between business partner master data and FSCM credit master records. In S4 HANA, credit management data is maintained within the FSCM framework and must be synchronized with business partner objects. If replication timing and synchronization rules are not designed during blueprint, credit master data becomes inconsistent, and sales orders may fail credit checks due to missing or outdated credit information.
Scenario classification and relevant SAP note, if applicable.
1. Complexity high, master data synchronization risk. 2. Phase Explore. 3. Frequency common when integrating FSCM credit management with business partner. 4. Primary ownership credit management lead. 5. Supporting master data architecture lead. 6. Business ownership global credit risk director. 7. Relevant SAP note 2270544 credit management simplification.
Diagnostic dashboard, symptoms and evidence.
How credit master replication timing problems appear during order processing and master data maintenance. 1. Symptom: sales orders fail credit checks even though customer credit limits appear correct. 2. Red flag: business partner records exist but corresponding credit master records are missing. 3. Business impact: orders are blocked or delayed due to incomplete credit data. 4. Detection: monitor synchronization jobs between business partner and FSCM credit master. 5. Technical proof: credit master tables show outdated or missing entries compared to business partner data. Insight: if credit limits appear correct in master data but orders still fail credit checks, replication timing was not designed correctly.
Why this happens, scenario analysis and root cause.
1. Organizations assume credit master records automatically synchronize with business partner data. 2. Replication jobs between master data objects are not defined during blueprint. 3. Credit management architecture is designed without considering master data timing dependencies. 4. Integration testing does not simulate realistic master data update sequences. Credit master synchronization requires both technical integration design and operational governance.
Why this is a migration, exclusive failure.
1. ECC maintain credit master data directly within customer master structures. 2. S/4HANA separates business partner and FSCM credit management architecture. 3. Credit master records must synchronize across multiple components. 4. Timing dependencies between these objects create new synchronization risks. Master data synchronization becomes more complex as S/4HANA separates functional responsibilities.
Financial and customer impact.
1. Orders are blocked due to missing or outdated credit master data. 2. Sales teams cannot reliably determine customer credit availability. 3. Credit exposure reporting becomes inconsistent across systems. 4. Customer satisfaction decreases due to unnecessary order delays. Credit master inconsistencies disrupt both financial risk control and sales continuity.
Governance and accountability, RACI model.
In ECC to S/4HANA programs, ownership follows a RACI model where authority and execution are clearly separated across functional and technical work streams. 1. Accountable credit management lead. The person who owns credit master governance and gets fired if credit data inconsistencies disrupt order processing. 2. Responsible master data architecture lead. Designs synchronization architecture between business partner and credit master data. 3. Consulted solution architect. Validates cross-module master data integration. 4. Informed global credit risk director. Oversees enterprise credit governance policies. Master data synchronization governance must align technical architecture with financial risk control.
Ownership, who actually fixes it.
Resolving this issue requires designing synchronization processes between business partner and credit master data. 1. Credit management lead defines governance for credit master maintenance. 2. Master data architecture lead designs synchronization jobs and timing rules. 3. Solution architect validates integration between business partner and FSCM credit management. 4. Global credit risk director approves enterprise credit master governance standards.
Who gets blamed versus who owns it.
1. Blamed SD functional team. Sales assumes credit blocking is caused by order processing configuration. 2. Blamed finance team. Believed to have defined incorrect credit limits. 3. Actual owner credit management lead and master data architecture lead. Responsible for synchronization architecture. 4. Root cause credit master replication timing was not designed during Explore. Credit data inconsistencies typically originate from integration architecture gaps.
How this is actually fixed, the right way by a role.
1. Credit management lead defines enterprise credit master governance policies. 2. Master data architecture lead designs synchronization timing between business partner and credit master records. 3. Solution architect validates cross-module data replication architecture. 4. Global credit risk director approves enterprise credit governance design.
What not to do, common wrong fixes.
1. Assuming credit master records automatically synchronize with business partner data. 2. Ignoring replication timing dependencies during design. 3. Treating credit master inconsistencies as simple configuration errors. 4. Allowing synchronization logic to evolve after go live. Master data synchronization must be designed before migration to avoid operational disruption.
Follow-up 1. Why does credit master synchronization become more complex in S/4HANA?
Answer: S/4HANA separates business partner master data from FSCM credit management structures. This modular architecture improves flexibility, but introduces synchronization dependencies between components. Without proper replication design, credit data may become inconsistent across modules.
Follow-up 2. How do experienced architects design credit master synchronization?
Answer: architects identify all systems and modules that interact with credit master data. They then define synchronization timing, replication jobs, and validation checks to ensure data consistency. This architecture is tested using realistic master data update scenarios.
Follow-up 3. Curveball. What happens if credit master data becomes inconsistent after go live?
Answer: inconsistent credit master data causes unpredictable credit checks that frustrate both sales teams and customers. Orders may be blocked even when customers have valid credit limits. Correcting these issues often requires emergency synchronization fixes across multiple systems.
Exclusive pro tip.
Design credit master synchronization architecture during Explore by mapping every business partner update event to corresponding credit master updates. Validate this design with realistic master data maintenance scenarios before migration begins.
Scenario 69. Tax jurisdiction redesign incomplete.
In the Explore phase of ECC to S/4HANA migration, organizations fail to redesign tax jurisdiction structures when moving to the new international trade and compliance framework. ECC tax determination often relied on legacy jurisdiction codes and country-specific logic embedded in customer and plant master data. In S/4HANA, tax determination integrates more tightly with international trade classification and address-based determination. If jurisdiction logic is not redesigned during blueprint, tax calculation errors appear across order, delivery, and billing processes.
Scenario classification and relevant SAP note, if applicable.
1. Complexity high, tax determination and compliance risk. 2. Phase Explore. 3. Frequency common in multinational deployments and complex localization environments. 4. Primary ownership tax configuration lead. 5. Supporting SD functional lead. 6. Business ownership global tax director. 7. Relevant SAP note 2267310 foreign trade simplification.
Diagnostic dashboard, symptoms and evidence.
How tax jurisdiction redesign issues appear during order processing and billing. 1. Symptom, sales orders calculate incorrect tax values compared to ECC. 2. Red flag, jurisdiction codes in customer or plant master records do not align with new address-based determination. 3. Business impact, incorrect tax calculations lead to compliance risks and financial adjustments. 4. Detection, compare tax determination results for identical transactions in ECC and S/4HANA. 5. Technical proof, jurisdiction tables contain inconsistent or outdated regional mappings. Insight, if tax values change unexpectedly after migration, jurisdiction redesign was not completed.
Why this happens, scenario analysis and root cause.
1. Organizations assume existing ECC jurisdiction codes will work unchanged in S/4HANA. 2. International trade simplification introduces new master data dependencies. 3. Tax workshops focus only on configuration rather than master data redesign. 4. Regional localization teams are not involved during blueprint. Tax determination accuracy depends on jurisdiction master data design.
Why this is a migration, exclusive failure.
1. ECC relied heavily on static jurisdiction codes embedded in master data. 2. S/4HANA integrates tax logic with address and international trade data. 3. Legacy jurisdiction codes may not match the new determination model. 4. Migration exposes inconsistencies between geographic master data and tax logic. Tax architecture evolves from static jurisdiction codes to integrated geographic determination.
Financial and customer impact.
1. Incorrect tax calculations lead to financial reporting discrepancies. 2. Regulatory compliance risks increase due to inaccurate tax reporting. 3. Customers receive invoices with incorrect tax amounts. 4. Manual tax corrections increase operational workload. Tax determination failures create both financial and regulatory exposure.
Governance and accountability, RACI model.
In ECC to S/4HANA programs, ownership follows a RACI model where authority and execution are clearly separated across functional and technical work streams. 1. Accountable tax configuration lead. The person who owns tax determination architecture and gets fired if incorrect tax calculations create compliance exposure. 2. Responsible SD functional lead ensures tax determination integrates correctly with order-to-cash processes. 3. Consulted solution architect validates tax design across logistics and finance integration. 4. Informed global tax director oversees enterprise tax governance and regulatory compliance. Tax architecture must align legal compliance requirements with system configuration.
Ownership, who actually fixes it.
Resolving this issue requires redesigning jurisdiction master data and validating tax determination logic. 1. Tax configuration lead redesigns jurisdiction structure aligned with international trade rules. 2. SD functional lead validates tax determination during order and billing processing. 3. Solution architect reviews tax architecture across logistics and finance modules. 4. Global tax director approves the final tax governance framework.
Who gets blamed versus who owns it?
1. Blamed finance team. Sales assumes accounting created incorrect tax logic. 2. Blamed SD functional team. Believed to have configured tax determination incorrectly. 3. Actual owner tax configuration lead and solution architect, responsible for jurisdiction redesign. 4. Root cause jurisdiction master data redesign was skipped during Explore. Tax errors typically originate from master data design gaps, rather than simple configuration mistakes.
How this is actually fixed, the right way by a role.
1. Tax configuration lead redesigns jurisdiction structures aligned with international trade rules. 2. SD functional lead validates tax determination across order, delivery, and billing processes. 3. Solution architect reviews integration between tax configuration and logistics data. 4. Global tax director signs off on final jurisdiction governance.
What not to do, common wrong fixes.
1. Assuming ECC jurisdiction codes will work unchanged in S4 HANA. 2. Ignoring geographic master data dependencies in tax determination. 3. Delaying jurisdiction redesign until after go live. 4. Treating tax discrepancies as minor rounding issues. Tax architecture must be validated before migration to prevent regulatory exposure.
Follow-up 1. Why does tax determination change in S4 HANA?
Answer: S4 HANA integrates tax determination more closely with address and international trade data structures. This architecture improves compliance, but introduces new dependencies between geographic master data and tax rules. Without redesigning jurisdiction structures, legacy assumptions no longer hold.
Follow-up 2. How do experienced architects validate tax redesign?
Answer: architects simulate tax determination across multiple geographic scenarios using real transaction data. They test order creation, delivery processing, and billing to verify tax consistency. This testing ensures that jurisdiction logic works correctly across the entire order-to-cash cycle.
Follow-up 3. Curveball. What happens if tax errors appear after go live?
Answer: post-go-live tax errors create immediate compliance risks because invoices may contain incorrect tax amounts. Regulatory authorities may require corrections and penalties for inaccurate reporting. Fixing jurisdiction logic after migration often requires large-scale master data corrections.
Exclusive pro tip.
Before design freeze, run tax determination simulations for at least 10 cross-region transactions. Validate jurisdiction codes, address data, and pricing conditions together to ensure tax accuracy across the entire order-to-cash lifecycle.
Scenario 70. Geo-master harmonization gaps.
In the Explore phase of ECC to S4 HANA migration, organizations fail to harmonize geographic master data such as country codes, region codes, postal logic, and location attributes across customer, vendor, and plant records. ECC environments often contain inconsistent geographic data accumulated over many years of decentralized maintenance. S4 HANA relies heavily on accurate geographic master data for tax determination, logistics routing, compliance checks, and international trade processes. If geographic master data is not harmonized during design, order processing, tax determination, and compliance validations produce inconsistent results.
Scenario classification and relevant SAP note, if applicable.
1. Complexity high, geographic master data governance risk. 2. Phase explore. 3. Frequency very common in global deployments and merged landscapes. 4. Primary ownership master data governance lead. 5. Supporting SD functional lead. 6. Business ownership global data governance director. 7. Relevant SAP note 2267310, foreign trade simplification.
Diagnostic dashboard, symptoms and evidence.
How geographic master inconsistencies appear during order processing and compliance checks. 1. Symptom: tax determination or compliance checks fail for specific geographic regions. 2. Red flag customer and plant master records use inconsistent region or postal structures. 3. Business impact, incorrect routing, tax calculation errors, and compliance validation failures. 4. Detection. Run master data profiling to identify inconsistent country, region, and postal combinations. 5. Technical proof. Address master tables contain duplicate or incompatible geographic codes. Insight. If identical transactions behave differently across regions, geographic master data is inconsistent.
Why this happens, scenario analysis and root cause.
1. ECC landscapes accumulated geographic data inconsistencies over many years. 2. Organizations maintain regional address standards differently across business units. 3. Migration workshops focus on configuration rather than master data governance. 4. Data cleansing initiatives underestimate geographic data complexity. Geographic master data quality depends on strong data governance rather than system configuration.
Why this is a migration, exclusive failure.
1. ECC tolerated geographic inconsistencies across customer and vendor records. 2. S4 HANA integrates geographic master data with compliance and logistics processes. 3. Address and region fields influence tax, export compliance, and logistics determination. 4. Migration exposes geographic inconsistencies previously hidden in decentralized systems. Geographic harmonization becomes critical because S4 HANA uses location data across multiple modules.
Financial and customer impact.
1. Incorrect tax determination due to geographic mismatches. 2. Export compliance checks fail for incorrectly classified locations. 3. Delivery routing errors increase logistics costs. 4. Customer invoices contain incorrect geographic tax or jurisdiction data. Geographic data quality directly influences compliance, logistics accuracy, and financial reporting.
Governance and accountability, RACI model.
In ECC to S4 HANA programs, ownership follows a RACI model where authority and execution are clearly separated across functional and technical work streams. 1. Accountable master data governance lead. The person who owns geographic data standards and gets fired if inconsistent master data disrupts enterprise operations. 2. Responsible SD functional lead. Validates geographic data usage in order to cache processes. 3. Consulted solution architect. Ensures geographic master data integrates correctly with compliance and logistics architecture. 4. Informed global data governance director. Oversees enterprise data quality standards. Geographic master data governance must align enterprise data standards with operational processes.
Ownership, who actually fixes it.
Resolving this issue requires a structured geographic data harmonization initiative. 1. Master data governance lead defines standardized geographic master data structures. 2. SD functional lead validates geographic fields used in order processing and logistics. 3. Solution architect reviews integration of geographic master data with tax and compliance logic. 4. Global data governance director approves enterprise geographic data standards.
Who gets blamed versus who owns it.
1. Blamed SD functional team. Logistics teams assume configuration errors caused routing problems. 2. Blame tax team. Incorrect jurisdiction calculations are often attributed to tax configuration. 3. Actual owner, master data governance lead and solution architect, responsible for geographic master harmonization. 4. Root cause, geographic master data governance was not enforced during Explore. Geographic inconsistencies usually originate from poor master data governance rather than configuration mistakes.
How this is actually fixed, the right way by a role.
1. Master data governance lead launches geographic master data harmonization programs. 2. SD functional lead validates geographic data usage in order to cache scenarios. 3. Solution architect reviews compliance and logistics dependencies on geographic data. 4. Global data governance director signs off on enterprise geographic data standards.
What not to do, common wrong fixes.
1. Assuming geographic inconsistencies will not impact system behavior. 2. Ignoring address data standardization during migration preparation. 3. Treating geographic data quality as a purely technical issue. 4. Allowing regional teams to maintain independent geographic standards. Without geographic harmonization, compliance, logistics, and tax calculations become unreliable.
Follow-up 1. Why does geographic data become more critical in S/4HANA?
Answer: S/4HANA integrates geographic master data with logistics routing, tax determination, and international trade compliance. This integration increases the operational impact of inconsistent address or region data. Accurate geographic structures become essential for enterprise-wide process reliability.
Follow-up 2. How do experienced architects harmonize geographic master data?
Answer: architects perform data profiling across customer, vendor, and plant records to identify inconsistencies. They then standardize country codes, region structures, and postal logic according to enterprise governance policies. This harmonization is validated through logistics and tax scenario simulations.
Follow-up 3. Curveball. What happens if geographic harmonization is skipped?
Answer: skipping geographic harmonization leads to unpredictable logistics routing, incorrect tax calculations, and compliance validation failures. These issues often surface after go-live when real operational volumes expose inconsistencies. Correcting geographic data after migration requires large-scale master data cleanup.
Exclusive pro tip.
Before design freeze, run geographic data profiling across all customer, vendor, and plant records. Standardize region structures, postal formats, and country codes to ensure logistics routing, tax determination, and compliance validation behave consistently across the enterprise.
Phase 2 Category 2 Wrap-up. Master data and CVI design risks.
The previous scenarios exposed one of the most underestimated risks in S/4HANA migrations: master data architecture. Business partner conversion, credit management integration, and geographic harmonization fundamentally change how customer data is structured across the enterprise. If these foundations are not redesigned during the explore phase, the entire order-to-cash process becomes unstable. However, master data is only part of the challenge. Even when data structures are correct, process behavior itself often changes dramatically in S/4HANA.
Transition from master data design to process behavior.
Once master data structures are stabilized, the next layer of risk appears in process execution itself. Many organizations assume their ECC processes will behave exactly the same in S/4HANA. In reality, several core order-to-cash processes behave differently due to simplifications, embedded analytics, and redesigned logistics integrations. These behavioral changes are subtle but extremely dangerous when ignored.
Please check description or comment section of this video. I have given a lot of links for downloading 7 or 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked system design, most asked implementation project-related interview questions and answers, most asked support project-related interview questions and answers, required for your SAP functional modules interviews jobs like SAP MM consultant jobs, SAP FICO consultant jobs, SAP SD consultant jobs, SAP PP consultant jobs, SAP Ariba consultant jobs, SAP Extended Warehouse Management EWM consultant jobs, SAP Plant Maintenance PM consultant jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem-solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section. These questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people also for your interviews. You people can download all 7 or 8 PDFs in a single zip file from below given links.
Phase 2 Category 3 Process design risks, behavioral delta.
Process design risks appear when organizations replicate ECC process assumptions without validating how S/4HANA actually executes those processes. Pricing engines behave differently. ATP logic evolves into advanced ATP, and logistics integrations introduce new routing and compliance behavior. These changes create what architects call behavioral delta between ECC and S/4HANA. If this delta is not analyzed during Explore, the system may technically work, but operational behavior will diverge from business expectations.
Category 3 incident list, process design risks, behavioral delta.
The following incidents represent the most common process behavior changes organizations overlook during the Explore phase. 71. Pricing redesign assumptions incorrect. Relevant SAP note 2267308, pricing data model. 72. ATP behavior not understood. Relevant SAP note 2321191, advanced ATP simplifications. 73. Delivery split logic not revalidated. Relevant SAP note, not applicable process design gap. This is a process redesign failure where delivery determination logic was not revalidated during S/4HANA migration. Reference SAP note 2227014 for SD simplification context only. 74. Intercompany redesign gaps. Relevant SAP note 2503673, advanced intercompany. 75. Advanced returns design incomplete. Relevant SAP note 2267324, advanced returns management. 76. Third-party processing redesign gaps. Relevant SAP note not applicable process design gap. This is a business process redesign failure, not an SAP software change. These incidents represent the behavioral delta between ECC processes and S/4HANA execution logic. 77. Free goods redesign gaps. Relevant SAP note not applicable process design gap. This is a process design oversight during blueprint. 78. Billing block workflow redesign incomplete. Relevant SAP note not applicable process design gap. Workflow governance was not redesigned for S/4HANA process architecture. 79. Down payment clearing logic redesign incomplete. Relevant SAP note 2333948, down payments in S/4HANA. 80. Route determination recalculation not validated. Relevant SAP note 2267317, LETRA to TM simplification. 81. Export control and embargo logic redesign incomplete. Relevant SAP note 2267310, international trade. 82. Intrastat default value redesign gaps. Relevant SAP note 2267310, intrastat simplification. These incidents represent the behavioral delta between ECC processes and S/4HANA execution logic.
Scenario 71. Pricing redesign assumptions incorrect.
In the Explore phase of ECC to S/4HANA migration, organizations assume that their existing ECC pricing architecture will behave the same way in the S/4HANA pricing engine. However, S/4HANA introduces a redesigned pricing data model, enhanced performance logic on HANA, and different runtime evaluation behaviors. If pricing architecture and assumptions are not validated during design, organizations experience unexpected price calculations, condition behavior differences, and margin discrepancies during order processing and billing.
Scenario classification and relevant SAP note, if applicable.
1. Complexity high, core pricing engine behavior risk. 2. Phase Explore. 3. Frequency extremely common in complex pricing environments. 4. Primary ownership SD pricing lead. 5. Supporting solution architect. 6. Business ownership global pricing strategy director. 7. Relevant SAP note 2267308, pricing data model simplification.
Diagnostic dashboard, symptoms and evidence.
How incorrect pricing assumptions appear during testing and operational transactions. 1. Symptom, sales orders produce pricing results that differ from ECC expectations. 2. Red flag condition determination sequence behaves differently after migration. 3. Business impact margins fluctuate and financial reporting becomes inconsistent. 4. Detection runs side-by-side pricing simulations between ECC and S/4HANA. 5. Technical proof. Pricing results differ due to new runtime evaluation logic in the pricing engine. Insight. If identical pricing procedures produce different results after migration, pricing assumptions were not redesigned.
Why this happens, scenario analysis and root cause.
1. Organizations replicate ECC pricing configuration without reviewing behavioral differences. 2. Design workshops focus on configuration replication rather than pricing architecture. 3. Teams underestimate the impact of the new pricing data model on runtime evaluation. 4. Pricing simulation and regression testing are delayed until late project stages. Pricing behavior must be validated through simulation rather than assumed during migration.
Why this is a migration, exclusive failure.
1. ECC pricing relied on legacy table structures and classic database behavior. 2. S/4HANA pricing logic operates on a redesigned data model optimized for HANA. 3. Condition evaluation and runtime calculation logic may produce subtle behavioral differences. 4. These changes only appear when pricing procedures execute in the new system. Pricing architecture evolves in S/4HANA to support real-time analytics and high-performance calculations.
Financial and customer impact.
1. Incorrect pricing calculations reduce profit margins. 2. Customer invoices contain unexpected price differences. 3. Revenue forecasting becomes unreliable due to inconsistent pricing. 4. Sales teams lose trust in pricing accuracy. Pricing errors directly affect revenue accuracy and customer confidence.
Governance and accountability, RACI model.
In ECC to S/4HANA programs, ownership follows a RACI model where authority and execution are clearly separated across functional and technical work streams. 1. Accountable SD pricing lead. The person who owns pricing architecture and gets fired if incorrect pricing behavior damages enterprise revenue. 2. Responsible solution architect. Validates pricing architecture against S/4HANA design principles. 3. Consulted. Finance integration lead. Ensures pricing results align with financial reporting expectations. 4. Informed global pricing strategy director. Oversees enterprise pricing governance. Pricing governance must align system configuration with enterprise pricing strategy.
Ownership, who actually fixes it.
Resolving this issue requires validating pricing architecture and running controlled simulations. 1. SD pricing lead reviews pricing procedures and condition evaluation sequences. 2. Solution architect validates alignment with the S/4HANA pricing data model. 3. Finance integration lead compares pricing results with financial reporting expectations. 4. Global pricing strategy director approves revised pricing governance.
Who gets blamed versus who owns it.
1. Blamed SD functional team. Sales assumes pricing configuration errors caused the issue. 2. Blamed finance team. Pricing differences are often interpreted as accounting discrepancies. 3. Actual owner, SD pricing lead and solution architect. Responsible for pricing architecture validation. 4. Root cause pricing assumptions were replicated from ECC without behavioral validation. Pricing discrepancies usually originate from architectural assumptions rather than configuration mistakes.
How this is actually fixed, the right way by a role.
1. SD pricing lead runs comprehensive pricing simulation scenarios. 2. Solution architect reviews pricing architecture against S/4HANA design principles. 3. Finance integration lead validates pricing output against margin expectations. 4. Global pricing strategy director signs off on the redesigned pricing model.
What not to do, common wrong fixes.
1. Assuming ECC pricing behavior will remain unchanged in S/4HANA. 2. Delaying pricing validation until user acceptance testing. 3. Ignoring small pricing differences during simulation. 4. Treating pricing discrepancies as temporary migration issues. Pricing architecture must be validated early in Explore to avoid revenue disruption.
Follow-up 1. Why does pricing behavior change in S/4HANA?
Answer: S/4HANA introduces a redesigned pricing data model optimized for the HANA database. This architecture improves performance and analytical capabilities, but may change how conditions are evaluated at runtime. Organizations must validate pricing behavior through simulation rather than assuming identical results.
Follow-up 2. How do experienced pricing leads validate pricing architecture?
Answer: they build controlled pricing test scenarios covering different condition combinations, currencies, and customer segments. These simulations are executed in both ECC and S/4HANA environments to identify behavioral differences early. The results guide pricing procedure redesign before development begins.
Follow-up 3. Curveball. What happens if pricing differences are discovered after go live?
Answer: pricing discrepancies discovered after go live often require emergency configuration corrections and large-scale billing adjustments. This creates financial reconciliation challenges and damages business confidence in the new system. Correcting pricing architecture late in the program is extremely disruptive.
Exclusive pro tip.
Before design freeze, execute full pricing regression simulations across key product categories, customer segments, and currencies. Pricing architecture should be validated as a financial control system rather than treated as a simple configuration exercise.
Scenario 72. ABAP behavior not understood.
In the explore phase of ECC to S/4HANA migration, organizations underestimate how advanced available to promise, known as ABAP, fundamentally changes availability checking behavior. ECC relied on classic ATP logic focused on simple availability checks during order entry. S/4HANA introduces advanced capabilities such as backorder processing, supply allocation, and product substitution. If the new behavior is not understood during design, availability checks behave differently than expected, leading to unexpected order confirmations or delivery shortages.
Scenario classification and relevant SAP note, if applicable.
1. Complexity high, supply chain availability architecture risk. 2. Phase explore. 3. Frequency very common when migrating from classic ATP to ABAP. 4. Primary ownership supply chain solution architect. 5. Supporting SD functional lead. 6. Business ownership global order fulfillment director. 7. Relevant SAP note 2321191, advanced ATP simplifications.
Diagnostic dashboard, symptoms and evidence.
How misunderstood ATP behavior appears during order processing and supply allocation. 1. Symptom: sales orders receive different confirmation dates compared to ECC. 2. Red flag: backorder processing results override previously confirmed orders. 3. Business impact: customers receive inconsistent delivery promises. 4. Detection: compare availability checks between ECC and S/4HANA using identical order scenarios. 5. Technical proof: ATP supply allocation rules alter confirmation logic during order evaluation. Insight: if order confirmations change unpredictably after migration, ATP behavior was not designed properly.
Why this happens, scenario analysis and root cause.
1. Organizations assume classic ATP behavior will remain unchanged in S/4HANA. 2. Design workshops focus on configuration replication instead of supply chain architecture. 3. Business stakeholders are unaware of new allocation and prioritization rules. 4. Testing does not include backorder processing or supply allocation scenarios. Availability behavior changes when supply chain architecture evolves.
Why this is a migration, exclusive failure.
1. ECC availability checks were primarily order-driven. 2. S/4HANA introduces supply allocation, product substitution, and advanced backorder processing. 3. Confirmation logic is influenced by prioritization rules and supply segmentation. 4. Legacy availability assumptions no longer reflect real supply chain logic. ATP transforms availability checks into a strategic supply allocation engine.
Financial and customer impact.
1. Customers receive inconsistent delivery commitments. 2. High-priority customers may lose allocation due to incorrect rules. 3. Supply shortages increase due to misconfigured backorder processing. 4. Customer trust declines when confirmed delivery dates change unexpectedly. Availability logic directly influences customer satisfaction and fulfillment reliability.
Governance and accountability, RACI model.
In ECC to S/4HANA programs, Ownership follows a RACI model where authority and execution are clearly separated across functional and technical work streams. 1. Accountable supply chain solution architect. The person who owns availability architecture and gets fired if incorrect allocation rules disrupt enterprise order fulfillment. 2. Responsible SD functional lead. Configures availability checks and order confirmation logic. 3. Consulted logistics integration architect. Ensures availability rules align with supply chain planning. 4. Informed global order fulfillment director. Oversees customer delivery commitments. Availability governance must align technology design with supply chain strategy.
Ownership, who actually fixes it.
Resolving this issue requires designing availability architecture using the capabilities of ATP. 1. Supply chain solution architect defines enterprise availability strategy. 2. SD functional lead configures availability check rules and allocation logic. 3. Logistics integration architect validates integration with supply planning systems. 4. Global order fulfillment director approves availability governance policies.
Who gets blamed versus who owns it.
1. Blamed SD functional team. Sales assumes order confirmation errors come from incorrect configuration. 2. Blamed logistics planning team. Supply shortages are interpreted as planning failures. 3. Actual owner supply chain solution architect and SD functional lead, responsible for availability architecture design. 4. Root cause advanced ATP behavior was not analyzed during Explore. Availability failures usually originate from misunderstood supply allocation rules.
How this is actually fixed, the right way by a role.
1. Supply chain solution architect designs enterprise availability strategy using ATP capabilities. 2. SD functional lead configures allocation rules and confirmation logic. 3. Logistics integration architect validates interaction between supply planning and order management. 4. Global order fulfillment director signs off on customer delivery prioritization policies.
What not to do, common wrong fixes.
1. Replicating classic ATP configuration without redesigning allocation logic. 2. Ignoring backorder processing during testing. 3. Allowing supply allocation rules to evolve after go live. 4. Treating availability behavior as a minor configuration topic. Availability architecture must be designed intentionally to protect fulfillment reliability.
Follow-up 1. What is the biggest difference between classic ATP and ATP?
Answer: Classic ATP focused on simple stock availability checks during order creation. ATP introduces advanced capabilities such as supply allocation, product substitution, and advanced backorder processing. These features allow organizations to prioritize customers and allocate limited supply strategically.
Follow-up 2. How do experienced architects validate availability architecture?
Answer: They simulate order fulfillment scenarios that include supply shortages, customer prioritization, and backorder reallocation. These tests verify that confirmation logic aligns with business fulfillment strategies. This validation ensures the system supports real-world supply chain behavior.
Follow-up 3. Curveball. What happens if ATP is activated without redesigning allocation rules?
Answer: Activating ATP without governance can produce chaotic order confirmations where lower priority customers receive inventory before strategic accounts. Backorder processing may reallocate supply unexpectedly. This disrupts fulfillment commitments and damages customer relationships.
Exclusive pro tip.
Before activating ATP, define supply allocation policies for high-priority customers, regional distribution centers, and promotional campaigns. Availability logic should reflect business fulfillment strategy rather than simply checking stock levels.
Scenario 73. Delivery split logic not revalidated.
In the Explore phase of ECC to S/4HANA migration, organizations assume that delivery split logic will behave exactly the same as in ECC. However, delivery determination interacts differently with transportation management integration, route determination recalculations, and enhanced logistics processing in S/4HANA. If delivery split criteria such as shipping point, route, delivery date, and partner data are not revalidated during design, the system generates unexpected delivery documents or consolidates deliveries incorrectly.
Scenario classification and relevant SAP note, if applicable.
1. Complexity medium, logistics execution behavior risk. 2. Phase explore. 3. Frequency common in high-volume logistics environments. 4. Primary ownership SD logistics design lead. 5. Supporting transportation management architect. 6. Business ownership global logistics operations director. 7. Relevant SAP note, not applicable process design gap. This is a logistics process redesign failure where delivery split criteria were not revalidated during S4 HANA migration. Reference SAP Note 2227014 for SD simplification context only.
Diagnostic dashboard, symptoms and evidence.
How delivery split problems appear during order fulfillment and logistics execution. 1. Symptom: sales orders generate multiple delivery documents unexpectedly. 2. Red flag: delivery documents are split based on new route or shipping conditions. 3. Business impact: warehouse operations face increased picking complexity. 4. Detection: compare delivery creation behavior between ECC and S4 HANA. 5. Technical proof: delivery split criteria evaluate route, partner, and transportation attributes differently. Insight: if identical orders create different delivery structures after migration, delivery split logic was not revalidated.
Why this happens, scenario analysis and root cause.
1. Organizations replicate ECC logistics configuration without analyzing behavioral differences. 2. Transportation management integration introduces additional delivery determination criteria. 3. Logistics workshops focus on configuration rather than operational simulation. 4. Delivery creation testing does not include realistic multi-item order scenarios. Delivery behavior must be validated through logistics simulation rather than configuration replication.
Why this is a migration, exclusive failure.
1. ECC delivery logic relied on simpler logistics determination rules. 2. S4 HANA integrates delivery creation with transportation management and route recalculation. 3. Additional attributes influence delivery grouping and splitting decisions. 4. These differences appear only when logistics execution processes run in the new system. Delivery determination evolves as logistics architecture becomes more integrated in S4 HANA.
Financial and customer impact.
1. Unexpected delivery splits increase warehouse processing costs. 2. Customers receive multiple shipments instead of consolidated deliveries. 3. Transportation costs increase due to fragmented logistics planning. 4. Operational efficiency declines in high-volume distribution environments. Delivery structure changes directly affect logistics efficiency and customer satisfaction.
Governance and accountability, RACI model.
In ECC to S4 HANA programs, ownership follows a RACI model where authority and execution are clearly separated across functional and technical work streams. 1. Accountable SD logistics design lead. The person who owns delivery architecture and gets fired if incorrect split logic disrupts warehouse and transportation operations. 2. Responsible transportation management architect ensures delivery determination aligns with logistics planning rules. 3. Consulted solution architect validates delivery architecture across logistics and transportation modules. 4. Informed global logistics operations director oversees distribution efficiency and shipment governance. Delivery governance must align system behavior with logistics execution strategy.
Ownership, who actually fixes it.
Resolving this issue requires validating delivery grouping and split criteria through logistics simulations. 1. SD logistics design lead reviews delivery split configuration and grouping logic. 2. Transportation management architect validates integration between delivery and route determination. 3. Solution architect analyzes logistics architecture dependencies. 4. Global logistics operations director approves the redesigned delivery governance model.
Who gets blamed versus who owns it.
1. Blamed warehouse operations team. Increased delivery volume is often interpreted as operational inefficiency. 2. Blamed SD functional team. Delivery creation behavior is assumed to be misconfigured. 3. Actual owner SD logistics design lead and transportation management architect responsible for delivery architecture validation. 4. Root cause delivery split behavior was not analyzed during Explore. Delivery problems usually originate from logistics architecture assumptions, rather than simple configuration mistakes.
How this is actually fixed, the right way by a role.
1. SD Logistics Design Lead reviews delivery split criteria and grouping logic. 2. Transportation Management Architect validates route and shipment determination dependencies. 3. Solution Architect evaluates logistics architecture impacts. 4. Global Logistics Operations Director signs off on delivery execution policies.
What not to do, common wrong fixes.
1. Assuming delivery split behavior will remain unchanged in S/4HANA. 2. Testing delivery creation with only simple order scenarios. 3. Ignoring transportation integration during logistics design. 4. Treating delivery splits as a minor configuration issue. Delivery execution behavior must be validated early to protect warehouse efficiency.
Follow-up 1. What determines delivery split behavior in S/4HANA?
Answer: delivery split behavior depends on multiple attributes including shipping point, route, delivery date, partner data, and transportation planning attributes. When these attributes differ between order items, the system creates separate deliveries. Integration with transportation planning may introduce additional split criteria.
Follow-up 2. How do experienced architects validate delivery behavior?
Answer: architects simulate complex order scenarios with multiple items, routes, and delivery dates. These tests verify whether delivery grouping aligns with logistics planning expectations. Simulation results are used to refine delivery split criteria before design freeze.
Follow-up 3. Curveball. What happens if delivery splits are discovered after go live?
Answer: unexpected delivery splits after go live often overload warehouse operations and increase transportation costs. Correcting split logic may require redesigning shipping conditions, route determination, and transportation integration rules. These changes can be highly disruptive in active logistics environments.
Exclusive pro tip.
Before design freeze, simulate multi-item orders across different routes, shipping points, and delivery dates. Validate delivery grouping logic under realistic logistics scenarios to ensure warehouse operations remain efficient after migration.
Scenario 74. Intercompany redesign gaps.
In the Explore phase of ECC to S/4HANA migration, organizations fail to redesign intercompany order-to-cash processes according to the new S/4HANA architecture. ECC intercompany flows relied on classic SD billing documents and simplified financial postings. S/4HANA introduces advanced intercompany integration with improved accounting transparency and universal journal postings. If these process differences are not analyzed during design, intercompany billing, revenue postings, and logistics coordination behave differently than expected.
Scenario classification and relevant SAP note, if applicable.
1. Complexity high, cross-company process integration risk. 2. Phase Explore. 3. Frequency common in multinational enterprise deployments. 4. Primary ownership intercompany process architect. 5. Supporting SD functional lead. 6. Business ownership global intercompany operations director. 7. Relevant SAP note 2503673 Advanced Intercompany.
Diagnostic dashboard, symptoms and evidence.
How intercompany design gaps appear during cross-company transactions. 1. Symptom: intercompany billing documents fail to generate correctly. 2. Red flag: financial postings between selling and delivering entities become inconsistent. 3. Business impact: revenue recognition and cost allocation between company codes becomes unreliable. 4. Detection: execute intercompany order-to-cash scenarios comparing ECC and S/4HANA results. 5. Technical proof: universal journal postings show unexpected intercompany accounting entries. Insight: if intercompany transactions produce unexpected accounting results, the process design was not aligned with S/4HANA architecture.
Why this happens, scenario analysis and root cause.
1. Organizations assume ECC intercompany flows will behave the same in S/4HANA. 2. Design workshops focus on SD billing rather than cross-company accounting architecture. 3. Finance and logistics teams design processes independently without integration validation. 4. Testing scenarios do not include complex cross-company supply chain flows. Intercompany design requires coordination between logistics execution and financial accounting architecture.
Why this is a migration exclusive failure.
1. ECC intercompany billing relied on traditional SD billing structures. 2. S/4HANA introduces enhanced intercompany integration with real-time financial postings. 3. Universal Journal architecture changes how intercompany revenue and cost are recorded. 4. Legacy process assumptions no longer align with the integrated accounting model. Intercompany architecture evolves in S/4HANA to provide better financial transparency.
Financial and customer impact.
1. Intercompany revenue postings become inconsistent across company codes. 2. Financial reconciliation between entities becomes complex. 3. Logistics operations experience delays due to billing dependencies. 4. Executive reporting for intercompany profitability becomes unreliable. Intercompany process failures disrupt both financial reporting and logistics coordination.
Governance and accountability, RACI model.
In ECC to S/4HANA programs, ownership follows a RACI model where authority and execution are clearly separated across functional and technical work streams. 1. Accountable intercompany process architect. The person who owns cross-company transaction architecture and gets fired if intercompany processes fail across enterprise entities. 2. Responsible SD functional lead. Configures intercompany sales and billing procedures. 3. Consulted finance integration architect. Validates universal journal postings for intercompany transactions. 4. Informed global intercompany operations director. Oversees enterprise intercompany governance. Intercompany governance must align logistics execution with financial accounting architecture.
Ownership, who actually fixes it.
Resolving this issue requires redesigning cross-company order-to-cash flows with finance integration. 1. Intercompany process architect redesigns enterprise intercompany transaction architecture. 2. SD functional lead validates intercompany order, delivery, and billing scenarios. 3. Finance integration architect verifies universal journal accounting postings. 4. Global intercompany operations director approves final intercompany governance policies.
Who gets blamed versus who owns it.
1. Blamed SD functional team. Sales assumes billing configuration errors caused the issue. 2. Blamed finance team. Accounting discrepancies are interpreted as financial configuration failures. 3. Actual owner intercompany process architect and finance integration architect, responsible for cross-company architecture design. 4. Root cause intercompany process architecture was not redesigned during Explore. Intercompany issues usually originate from architecture design gaps rather than simple configuration problems.
How this is actually fixed, the right way by a role.
1. Intercompany process architect redesigns cross-company order-to-cash architecture. 2. SD functional lead validates intercompany logistics execution scenarios. 3. Finance integration architect reviews accounting postings in Universal Journal. 4. Global intercompany operations director signs off on the intercompany process governance model.
What not to do, common wrong fixes.
1. Assuming ECC intercompany processes will work unchanged in S/4HANA. 2. Designing logistics and finance flows independently. 3. Testing only simple intercompany order scenarios. 4. Ignoring universal journal impacts on financial reporting. Intercompany processes must be validated as integrated logistics and financial workflows.
Follow-up 1. Why does intercompany behavior change in S/4HANA?
Answer: S/4HANA integrates logistics and finance processes through the Universal Journal architecture. This integration improves financial transparency, but changes how intercompany transactions are posted and reconciled. Organizations must redesign intercompany workflows rather than simply replicate ECC processes.
Follow-up 2. How do experienced architects validate intercompany design?
Answer: architects simulate complete intercompany order-to-cash flows including sales order creation, delivery execution, billing, and accounting postings. These tests verify both logistics execution and financial reconciliation. This validation ensures cross-company processes behave correctly in the integrated architecture.
Follow-up 3, Curveball. What happens if intercompany processes fail after go live?
Answer: intercompany failures disrupt revenue recognition and financial reconciliation between company codes. Logistics operations may also stall because deliveries depend on correct billing flows. Fixing these issues late requires coordinated changes across finance, logistics, and configuration layers.
Exclusive pro tip.
Before design freeze, execute full intercompany simulations covering cross-company sales orders, deliveries, billing, and financial postings. Intercompany architecture should be validated as an integrated logistics and finance workflow rather than treated as separate configurations.
Scenario 75. Advanced returns design incomplete.
In the explore phase of ECC to S/4HANA migration, organizations underestimate the redesign required for returns processing when adopting advanced returns management. ECC returns processing relied on simplified document flows and manual inspection decisions. S/4HANA introduces structured return order types, inspection workflows, and refund determination processes. If the new architecture is not designed during blueprint, returns processing behaves inconsistently, and warehouse inspection flows become operationally inefficient.
Scenario classification and relevant SAP note, if applicable.
1. Complexity high, reverse logistics process risk. 2. Phase explore. 3. Frequency common in retail, manufacturing, and high return environments. 4. Primary ownership, reverse logistics solution architect. 5. Supporting SD functional lead. 6. Business ownership, global returns operations director. 7. Relevant SAP note 2267324, advanced returns management.
Diagnostic dashboard, symptoms and evidence.
How incomplete returns design appears during reverse logistics operations. 1. Symptom: return orders fail to trigger inspection or refund workflows. 2. Red flag: warehouse inspection processes do not align with return document types. 3. Business impact: return goods remain in limbo without proper disposition decisions. 4. Detection: execute end-to-end return scenarios comparing ECC and S/4HANA behavior. 5. Technical proof: returns document flow lacks inspection and follow-up decision logic. Insight: if returned goods cannot be processed efficiently after migration, returns architecture was not redesigned.
Why this happens, scenario analysis and root cause.
1. Organizations assume ECC returns processes can be reused in S/4HANA. 2. Design workshops focus on sales order flows instead of reverse logistics. 3. Warehouse teams are not involved in returns architecture discussions. 4. Testing scenarios do not include inspection and refund workflows. Reverse logistics requires dedicated process architecture rather than simple configuration reuse.
Why this is a migration, exclusive failure.
1. ECC returns processing relied on simple document types and manual decisions. 2. S/4HANA introduces advanced returns management with structured workflows. 3. Inspection, refund determination, and follow-up actions become system-driven. 4. Legacy process assumptions no longer match the new reverse logistics architecture. Returns processing evolves into a structured reverse logistics workflow in S/4HANA.
Financial and customer impact.
1. Customer refunds are delayed due to incomplete inspection workflows. 2. Returned inventory remains blocked without clear disposition decisions. 3. Warehouse operations experience increased manual intervention. 4. Customer satisfaction declines due to slow returns processing. Returns efficiency directly influences customer trust and inventory accuracy.
Governance and accountability, RACI model.
In ECC to S/4HANA programs, ownership follows a RACI model where authority and execution are clearly separated across functional and technical work streams. 1. Accountable, reverse logistics solution architect. The person who owns returns architecture and gets fired if reverse logistics operations collapse after migration. 2. Responsible, SD functional lead. Configures return order types and refund determination logic. 3. Consulted, warehouse process architect. Ensures inspection workflows align with warehouse operations. 4. Informed, global returns operations director. Oversees enterprise returns governance. Returns governance must align warehouse inspection workflows with financial refund policies.
Ownership, who actually fixes it.
Resolving this issue requires designing structured reverse logistics workflows. 1. Reverse Logistics Solution Architect designs enterprise returns architecture. 2. SD Functional Lead configures return order types and refund determination rules. 3. Warehouse Process Architect validates inspection workflows and goods disposition logic. 4. Global Returns Operations Director approves the final returns governance model.
Who gets blamed versus who owns it.
1. Blamed Warehouse Operations Team. Delays in processing returns appear as operational inefficiency. 2. Blamed SD Functional Team. Refund processing failures are interpreted as configuration errors. 3. Actual Owner, Reverse Logistics Solution Architect and Warehouse Process Architect, responsible for reverse logistics architecture. 4. Root cause, returns processes were not redesigned during Explore. Returns problems typically originate from incomplete reverse logistics architecture, rather than system errors.
How this is actually fixed, the right way by a role.
1. Reverse Logistics Solution Architect defines enterprise returns architecture. 2. SD Functional Lead configures return order types and follow-up actions. 3. Warehouse Process Architect designs inspection workflows and goods disposition rules. 4. Global Returns Operations Director signs off on the returns governance framework.
What not to do, common wrong fixes.
1. Replicating ECC returns configuration without redesigning processes. 2. Ignoring warehouse inspection workflows during design. 3. Testing only simple return order scenarios. 4. Treating returns processing as a minor extension of order processing. Returns architecture must be validated as a dedicated reverse logistics process.
Follow-up 1. What makes advanced returns management different from ECC returns?
Answer: Advanced returns management introduces structured workflows that guide inspection, refund decisions, and follow-up logistics actions. Instead of relying on manual warehouse decisions, the system drives return processing through predefined steps. This improves transparency, but requires careful process design.
Follow-up 2. How do experienced architects validate returns architecture?
Answer: Architects simulate full reverse logistics scenarios including return order creation, warehouse inspection, refund determination, and follow-up actions such as scrapping or resale. These tests verify that returns workflows align with operational expectations before the system goes live.
Follow-up 3. Curveball. What happens if returns workflows fail after go live?
Answer: Returns failures create immediate operational disruption because returned goods accumulate without clear disposition decisions. Refund processing delays also frustrate customers and increase service workload. Fixing returns architecture late often requires redesigning warehouse workflows and refund logic simultaneously.
Exclusive pro tip.
Before design freeze, simulate multiple return scenarios including defective returns, warranty claims, and customer dissatisfaction returns. Returns architecture should be validated as a structured reverse logistics workflow rather than treated as a simple sales document reversal.
Scenario 76. Third-party processing redesign gaps.
In the Explore phase of ECC to S4 HANA migration, organizations assume that third-party order processing will behave exactly the same as in ECC. Third-party processing involves direct shipment from a vendor to the customer, while the selling organization manages billing. S4 HANA introduces changes in logistics integration, purchase requisition creation, and billing coordination. If the third-party workflow is not redesigned during blueprint, purchase documents, delivery confirmations, and billing processes become misaligned.
Scenario classification and relevant SAP note, if applicable.
1. Complexity medium, cross-module process integration risk. 2. Phase Explore. 3. Frequency common in distribution-driven business models. 4. Primary ownership SD logistics process architect. 5. Supporting procurement integration lead. 6. Business ownership global order fulfillment director. 7. Relevant SAP note, not applicable process design gap. This is a process redesign failure where third-party order workflows were not revalidated during S/4HANA migration.
Diagnostic dashboard, symptoms and evidence.
How third-party processing gaps appear during order-to-procurement integration. 1. Symptom: sales orders do not trigger purchase requisitions correctly. 2. Red flag: vendor shipments occur but billing documents are not generated properly. 3. Business impact: customer deliveries are delayed due to procurement synchronization failures. 4. Detection: execute end-to-end third-party order scenarios from sales order creation to billing. 5. Technical proof: purchase requisition generation and order fulfillment steps occur out of sequence. Insight: if vendor shipments and customer billing become disconnected, third-party processing design was incomplete.
Why this happens, scenario analysis and root cause.
1. Organizations replicate ECC configuration without validating process behavior. 2. Procurement and sales teams design workflows independently. 3. Third-party order scenarios are not included in testing cycles. 4. Business assumes vendor fulfillment logic remains unchanged. Third-party workflows require coordinated design between sales and procurement processes.
Why this is a migration, exclusive failure.
1. ECC third-party processing relied on simpler purchase requisition triggers. 2. S/4HANA integrates procurement and logistics processes more tightly. 3. Document flows and confirmation logic may behave differently. 4. Legacy process assumptions no longer reflect the integrated architecture. Third-party order flows evolve as procurement and sales integration improves in S/4HANA.
Financial and customer impact.
1. Customer deliveries are delayed due to procurement synchronization issues. 2. Billing documents may not reflect vendor shipment status. 3. Operational teams spend significant effort resolving order fulfillment gaps. 4. Customer satisfaction declines due to unreliable fulfillment commitments. Third-party process failures disrupt both procurement coordination and customer delivery reliability.
Governance and accountability, RACI model.
In ECC to S/4HANA programs, ownership follows a RACI model where authority and execution are clearly separated across functional and technical work streams. 1. Accountable: SD logistics process architect, the person who owns third-party order architecture and gets fired if vendor fulfillment processes fail after migration. 2. Responsible: procurement integration lead, ensures purchase requisition and vendor order integration works correctly. 3. Consulted: solution architect, validates cross-module design between sales and procurement. 4. Informed: global order fulfillment director, oversees enterprise fulfillment performance. Third-party governance must align procurement integration with customer delivery commitments.
Ownership, who actually fixes it.
Resolving this issue requires redesigning third-party workflows with coordinated sales and procurement integration. 1. SD logistics process architect redesigns third-party order workflows. 2. Procurement integration lead validates purchase requisition and vendor order generation. 3. Solution architect reviews cross-module integration between SD and procurement. 4. Global order fulfillment director approves the final fulfillment governance model.
Who gets blamed versus who owns it.
1. Blamed: procurement team. Delays in vendor fulfillment are interpreted as procurement inefficiency. 2. Blamed: SD functional team. Sales assumes order configuration errors caused the issue. 3. Actual owner: SD logistics process architect and procurement integration lead, responsible for cross-module workflow design. 4. Root cause: third-party processing was not redesigned during Explore. Third-party failures usually originate from missing integration design rather than configuration mistakes.
How this is actually fixed, the right way by a role.
1. SD logistics process architect redesigns third-party order workflows and document flows. 2. Procurement integration lead validates purchase requisition creation and vendor order integration. 3. Solution architect evaluates the cross-module architecture. 4. Global order fulfillment director signs off on the final fulfillment governance model.
What not to do, common wrong fixes.
1. Assuming ECC third-party configuration will work unchanged in S/4HANA. 2. Designing procurement and sales processes independently. 3. Testing only simple order fulfillment scenarios. 4. Ignoring vendor shipment confirmation logic. Third-party architecture must be validated as an integrated sales and procurement process.
Follow-up 1. What is the biggest risk in third-party order processing?
Answer: the biggest risk is misalignment between sales orders and procurement fulfillment steps. If purchase requisitions or vendor orders are not triggered correctly, customer delivery commitments break down. This creates operational confusion between sales and procurement teams.
Follow-up 2. How do experienced architects validate third-party workflows?
Answer: architects simulate complete third-party scenarios from order creation through procurement, vendor shipment, and billing. These tests verify that purchase documents, delivery confirmations, and invoices remain synchronized. This validation ensures reliable vendor fulfillment integration.
Follow-up 3. Curveball. What happens if third-party processing fails after go live?
Answer: failures cause a disconnect between vendor shipments and customer billing. Orders may appear fulfilled while billing documents are missing or delayed. Correcting the workflow often requires redesigning procurement integration and document flow logic.
Exclusive pro tip.
Before design freeze, simulate full third-party order scenarios including vendor purchase orders, shipment confirmations, and customer billing. Validate the entire document flow to ensure procurement integration behaves correctly after migration.
Scenario 77. Free goods redesign gaps.
In the explore phase of ECC to S/4HANA migration, organizations assume free goods determination will behave exactly the same as in ECC. Free goods logic in ECC relied on condition techniques tightly coupled with pricing and delivery processing. In S/4HANA, pricing simplifications, real-time document updates, and logistics integration introduce subtle changes in how free goods are calculated and applied. If these scenarios are not redesigned and validated during blueprint, promotional orders behave unpredictably.
Scenario classification and relevant SAP note, if applicable.
1. Complexity medium, promotional pricing process risk. 2. Phase explore. 3. Frequency common in consumer goods, retail, and promotion-driven industries. 4. Primary ownership SD pricing architect. 5. Supporting SD logistics process lead. 6. Business ownership global trade promotion director. 7. Relevant SAP note, not applicable process design gap. This is a process design failure where promotional free goods logic was not revalidated during S/4HANA migration.
Diagnostic dashboard, symptoms and evidence.
How free goods redesign gaps appear in promotional order processing. 1. Symptom: promotional orders fail to generate free goods items correctly. 2. Red flag: free goods items appear but do not align with expected promotional quantities. 3. Business impact: customers receive incorrect promotional quantities or missing items. 4. Detection: execute promotional order scenarios using historical promotion rules. 5. Technical proof: free goods determination logic behaves differently under the new pricing model. Insight: if promotions behave differently after migration, free goods logic was not redesigned.
Why this happens, scenario analysis and root cause.
1. Organizations assume promotional logic remains unchanged in S/4HANA. 2. Design workshops focus primarily on pricing calculations instead of promotional scenarios. 3. Testing scenarios exclude complex promotion combinations. 4. Business teams assume historical promotions will function automatically. Free goods logic is tightly coupled with pricing behavior and must be revalidated.
Why this is a migration, exclusive failure.
1. ECC free goods determination relied on legacy pricing execution logic. 2. S/4HANA pricing simplifications change how promotional conditions are evaluated. 3. Real-time pricing recalculation introduces subtle behavioral changes. 4. Legacy assumptions about promotional determination no longer hold. Promotional logic must be revalidated under the new pricing architecture.
Financial and customer impact.
1. Incorrect promotional quantities reduce promotional effectiveness. 2. Customers receive incorrect or missing promotional items. 3. Promotional campaign reporting becomes unreliable. 4. Sales teams lose confidence in automated promotional pricing. Promotions are revenue drivers, and incorrect free goods logic damages both revenue and customer trust.
Governance and accountability, RACI model.
In ECC to S4HANA programs, ownership follows a RACI model where authority and execution are clearly separated across functional and technical work streams. 1. Accountable SD pricing architect, the person who owns promotional pricing behavior and gets fired if promotions fail after migration. 2. Responsible SD logistics process lead, ensures promotional items flow correctly through delivery processing. 3. Consulted solution architect, validates promotional pricing logic against the S4HANA pricing model. 4. Informed global trade promotion director, monitors enterprise promotion performance. Promotional governance must align pricing determination with logistics fulfillment.
Ownership, who actually fixes it.
Resolving this issue requires redesigning promotional pricing scenarios. 1. SD pricing architect redesigns free goods determination rules. 2. SD logistics process lead validates promotional item delivery behavior. 3. Solution architect evaluates alignment with the S4HANA pricing data model. 4. Global Trade Promotion Director approves the final promotional governance framework.
Who gets blamed versus who owns it.
1. Blamed sales operations team. Promotions appear misconfigured during order entry. 2. Blamed pricing configuration team. Promotional condition logic appears incorrect. 3. Actual owner SD pricing architect and SD logistics process lead, responsible for promotional process redesign. 4. Root cause, free goods logic was not revalidated during Explore. Promotion failures usually originate from incomplete pricing redesign, rather than configuration mistakes.
How this is actually fixed, the right way by a role.
1. SD pricing architect redesigns promotional pricing conditions. 2. SD logistics process lead validates delivery processing for free goods items. 3. Solution architect ensures promotional logic aligns with the S4HANA pricing model. 4. Global Trade Promotion Director signs off on the promotional governance design.
What not to do, common wrong fixes.
1. Assuming ECC promotional logic will behave identically in S4HANA. 2. Testing only simple promotion scenarios. 3. Ignoring complex promotion combinations. 4. Treating promotional logic as a minor pricing extension. Promotions must be validated across pricing and logistics execution.
Follow-up 1. Why do promotional scenarios often fail after migration?
Answer: promotional pricing relies on multiple condition combinations and delivery behaviors. Even small changes in pricing evaluation logic can change the resulting promotional quantities. Without testing historical promotions, these differences only appear after go live.
Follow-up 2. How do experienced pricing architects validate promotions?
Answer: they replay historical promotional campaigns using real order data and verify free goods determination, delivery creation, and billing behavior. This ensures promotions behave consistently under the new pricing architecture.
Follow-up 3. Curveball. What happens if promotions fail during a major campaign?
Answer: incorrect promotional items or missing free goods quickly create customer complaints and distributor disputes. Sales teams lose confidence in the system and begin manual corrections, which quickly destabilize the pricing process.
Exclusive pro tip.
Before design freeze, test the top 20 historical promotions including complex combinations and high-volume campaigns. Promotions stress both pricing logic and logistics execution, making them a critical validation point in the explore phase.
Scenario 78. Billing block workflow redesign incomplete.
In the explore phase of ECC to S4HANA migration, organizations fail to redesign billing block approval workflows. In ECC, billing blocks were often released manually through operational supervision or simple authorization checks. S4HANA introduces flexible workflow capabilities and Fiori-based operational control for billing approvals. If this workflow architecture is not redesigned during blueprint, billing documents remain blocked without clear approval processes, disrupting revenue cycles.
Scenario classification and relevant SAP note, if applicable.
1. Complexity medium, billing governance and revenue risk. 2. Phase explore. 3. Frequency common in organizations with strong financial controls. 4. Primary ownership order to cash process architect. 5. Supporting SD billing lead. 6. Business ownership global revenue operations director. 7. Relevant SAP note, not applicable process design gap. This is a workflow governance failure where billing approval processes were not redesigned for S/4HANA operations.
Diagnostic dashboard, symptoms and evidence.
How billing block workflow gaps appear during billing execution. 1. Symptom billing documents remain blocked without clear release ownership. 2. Red flag finance teams manually intervene to release blocked invoices. 3. Business impact revenue recognition is delayed due to unresolved billing blocks. 4. Detection execute billing scenarios involving credit checks, pricing issues, and delivery inconsistencies. 5. Technical proof. Billing block statuses exist without workflow-triggered approvals. Insight. If invoices remain blocked without automated approvals, billing workflow architecture was not redesigned.
Why this happens, scenario analysis and root cause.
1. Organizations assume manual billing block releases will continue after migration. 2. Workflow governance discussions are delayed until testing phases. 3. Billing teams are not involved in process redesign workshops. 4. Project teams underestimate the impact of flexible workflow capabilities. Billing approval governance must evolve alongside new workflow capabilities.
Why this is a migration, exclusive failure.
1. ECC relied heavily on manual supervision for billing block releases. 2. S/4HANA introduces flexible workflow for automated approval routing. 3. Fiori-based operations encourage structured approval governance. 4. Legacy manual release assumptions no longer support scalable operations. Billing governance transitions from manual supervision to structured workflow automation.
Financial and customer impact.
1. Invoices remain blocked, delaying revenue recognition. 2. Finance teams perform manual corrections to release billing documents. 3. Month-end closing cycles become unpredictable. 4. Customer invoicing delays create disputes and payment delays. Billing workflow failures directly impact revenue realization and financial reporting.
Governance and accountability, RACI model.
In ECC to S/4HANA programs, ownership follows a RACI model where authority and execution are clearly separated across functional and technical work streams. 1. Accountable order-to-cash process architect. The person who owns billing governance and gets fired if billing workflows collapse after migration. 2. Responsible SD billing lead. Configures billing block logic and release procedures. 3. Consulted solution architect. Validates workflow architecture alignment with S/4HANA capabilities. 4. Informed global revenue operations director. Oversees enterprise revenue governance. Billing governance requires alignment between operational workflows and financial controls.
Ownership, who actually fixes it.
Resolving this issue requires designing automated billing approval workflows. 1. Order-to-cash process architect defines enterprise billing approval governance. 2. SD billing lead configures billing block conditions and release procedures. 3. Solution architect designs flexible workflow routing for approvals. 4. Global Revenue Operations Director approves the final billing governance framework.
Who gets blamed versus who owns it.
1. Blamed finance operations team. Billing delays appear as financial processing inefficiencies. 2. Blamed SD billing team. Configuration errors are assumed to cause blocked invoices. 3. Actual owner order-to-cash process architect and SD billing lead. Responsible for billing workflow design. 4. Root cause billing approval workflows were not redesigned during Explore. Billing delays usually originate from missing workflow governance rather than configuration errors.
How this is actually fixed, the right way by a role.
1. Order-to-cash process architect defines enterprise billing approval architecture. 2. SD billing lead configures billing block determination and release logic. 3. Solution architect implements flexible workflow approval routing. 4. Global Revenue Operations Director signs off on the billing governance framework.
What not to do, common wrong fixes.
1. Replicating ECC manual billing block release procedures. 2. Ignoring workflow automation capabilities in S/4HANA. 3. Testing only simple billing scenarios. 4. Treating billing governance as an operational detail instead of a process design requirement. Billing workflow governance must be designed before operational testing begins.
Follow-up 1. Why do billing blocks become problematic after migration?
Answer: billing blocks are often triggered by pricing inconsistencies, delivery issues, or credit checks. In ECC, supervisors frequently release them manually. In S/4HANA, organizations expect automated governance, so missing workflows create operational confusion.
Follow-up 2. How do experienced architects design billing approval workflows?
Answer: architects define approval tiers based on risk categories such as pricing overrides, credit exposure, or compliance checks. Flexible workflow is then configured to route approvals automatically. This ensures billing blocks are resolved efficiently without manual supervision.
Follow-up 3. Curveball. What happens if billing workflows fail during month-end closing?
Answer: blocked invoices accumulate rapidly and delay revenue posting into financial reporting. Finance teams scramble to release documents manually, increasing the risk of incorrect billing. The result is delayed closing cycles and significant operational stress.
Exclusive pro tip.
Before design freeze, simulate billing blocks triggered by pricing overrides, credit limits, and delivery mismatches. Validate that flexible workflow routes approvals automatically to the correct roles. This prevents revenue delays after go live.
Scenario 79. Down payment clearing logic redesign incomplete.
In the explore phase of ECC to S/4HANA migration, organizations fail to redesign down payment clearing logic between SD and FI. In ECC, down payments were often processed through tightly coupled accounting postings and manual clearing controls. S/4HANA introduces more integrated financial document handling and changes in billing integration with accounting. If the clearing logic is not redesigned during blueprint, billing documents fail to clear customer down payments correctly, creating reconciliation inconsistencies.
Scenario classification and relevant SAP note, if applicable.
1. Complexity high, financial integration and revenue risk. 2. Phase explore. 3. Frequency common in project-based manufacturing and capital equipment industries. 4. Primary ownership SD billing architect. 5. Supporting FI integration lead. 6. Business ownership global revenue accounting director. 7. Relevant SAP note 23333948 down payments in S/4HANA.
Diagnostic dashboard, symptoms and evidence.
How down payment clearing gaps appear during billing and accounting reconciliation. 1. Symptom: billing documents do not correctly clear existing customer down payments. 2. Red flag: finance teams perform manual clearing adjustments after billing. 3. Business impact: customer account balances become inconsistent with invoice totals. 4. Detection: execute billing scenarios with advance payments and verify accounting postings. 5. Technical proof: accounting documents show open down payment balances after invoice posting. Insight: if down payments remain open after billing, clearing logic was not redesigned.
Why this happens, scenario analysis and root cause.
1. Organizations assume ECC clearing logic will behave identically in S/4HANA. 2. Billing design workshops focus on invoice creation rather than accounting clearing. 3. Testing scenarios do not include advance payment situations. 4. Finance teams are not deeply involved in billing architecture discussions. Down payment clearing requires coordinated design between billing and accounting.
Why this is a migration, exclusive failure.
1. ECC handled down payment clearing with legacy accounting document relationships. 2. S/4HANA integrates billing and accounting more tightly through the Universal Journal. 3. Financial document structures and posting logic have evolved. 4. Legacy clearing assumptions may not align with the new accounting architecture. Down payment clearing behavior must be revalidated under the S/4HANA financial architecture.
Financial and customer impact.
1. Customer balances become inconsistent due to incorrect clearing. 2. Finance teams spend additional time reconciling invoices and payments. 3. Revenue reporting becomes inaccurate during billing cycles. 4. Customer disputes increase due to incorrect outstanding balances. Incorrect clearing logic disrupts both financial reporting and customer account transparency.
Governance and accountability, RACI model.
In ECC to S4 HANA programs, ownership follows a RACI model where authority and execution are clearly separated across functional and technical work streams. 1. Accountable SD billing architect, the person who owns billing integration and gets fired if down payment clearing fails after migration. 2. Responsible FI integration lead, designs accounting document clearing logic. 3. Consulted solution architect, ensures SD and FI integration aligns with S4 HANA architecture. 4. Informed global revenue accounting director, oversees financial reconciliation governance. Down payment governance requires tight alignment between billing and accounting.
Ownership, who actually fixes it.
Resolving this issue requires redesigning down payment clearing integration between SD and FI. 1. SD billing architect redesigns billing document integration with advance payments. 2. FI integration lead configures accounting clearing logic and reconciliation rules. 3. Solution architect validates integration behavior within the universal journal architecture. 4. Global revenue accounting director approves the final clearing governance framework.
Who gets blamed versus who owns it.
1. Blamed finance operations team. Reconciliation errors appear as accounting mistakes. 2. Blamed SD billing team. Billing logic is assumed to be incorrect. 3. Actual owner SD billing architect and FI integration lead, responsible for billing and accounting integration design. 4. Root cause down payment clearing was not redesigned during Explore. Clearing failures usually originate from missing integration architecture rather than configuration mistakes.
How this is actually fixed, the right way by a role.
1. SD billing architect redesigns billing integration with advanced payment scenarios. 2. FI integration lead configures clearing rules and reconciliation procedures. 3. Solution architect validates financial integration architecture. 4. Global revenue accounting director signs off on the final clearing governance design.
What not to do, common wrong fixes.
1. Assuming ECC clearing logic will work unchanged in S4 HANA. 2. Testing only invoice scenarios without advance payments. 3. Leaving clearing reconciliation to finance teams after go live. 4. Treating down payment integration as a minor accounting detail. Down payment clearing must be validated as a core billing and accounting integration scenario.
Follow-up 1. Why are down payment scenarios risky during migration?
Answer: down payment processing involves tight integration between billing and accounting documents. Even small differences in posting logic can leave payments open or incorrectly cleared. Without testing these scenarios, reconciliation issues appear immediately after go live.
Follow-up 2. How do experienced architects validate down payment clearing?
Answer: architects simulate full advance payment cycles including payment receipt, billing document creation, and final clearing. These scenarios verify that accounting postings and customer balances remain accurate across the entire process.
Follow-up 3. Curveball. What happens if down payment clearing fails after go live?
Answer: customer balances remain incorrect and finance teams must manually reconcile invoices and payments. This increases operational workload and introduces the risk of incorrect financial reporting. Fixing the problem later often requires redesigning billing integration.
Exclusive pro tip.
Before design freeze, test at least 3 advance payment scenarios including partial payment, full advance payment, and milestone billing. These scenarios expose integration gaps early and prevent reconciliation issues after go live.
Scenario 80. Route determination recalculation not validated.
In the Explore phase of ECC to S4 HANA migration, organizations do not revalidate route determination behavior. In ECC, route determination relied on transportation zones, shipping conditions, and delivery priorities defined through static configuration. In S4 HANA, transportation integration and logistics simplifications can influence how routes are recalculated during order and delivery processing. If this behavior is not validated during blueprint, deliveries may follow incorrect routes or fail to determine routes at all.
Scenario classification and relevant SAP note, if applicable.
1. Complexity medium. Logistics planning and delivery execution risk. 2. Phase explore. 3. Frequency common in organizations with complex shipping networks. 4. Primary ownership logistics solution architect. 5. Supporting SD shipping lead. 6. Business ownership global distribution operations director. 7. Relevant SAP note. SAP note 2267317. LETRA to TM simplification.
Diagnostic dashboard, symptoms and evidence.
How route determination gaps appear during delivery processing. 1. Symptom deliveries fail to determine routes automatically. 2. Red flag shipping teams manually adjust route assignments during delivery creation. 3. Business impact delivery planning becomes inconsistent across distribution centers. 4. Detection, execute delivery creation scenarios across different shipping conditions and destinations. 5. Technical proof. Route determination logic produces different results compared with ECC. Insight. If delivery routes appear inconsistent after migration, route determination logic was not revalidated.
Why this happens, scenario analysis and root cause.
1. Organizations assume ECC route determination logic will behave the same in S4 HANA. 2. Transportation teams are not included in process design workshops. 3. Delivery testing scenarios exclude complex shipping combinations. 4. Integration with transportation management is not evaluated early. Route determination logic must be validated across the full logistics network.
Why this is a migration, exclusive failure.
1. ECC route determination relied on traditional logistics configuration. 2. S4 HANA encourages tighter integration with transportation management. 3. Transportation zones and route logic may require redesign. 4. Legacy route assumptions may not align with modern logistics architecture. Logistics planning behavior changes when transportation architecture evolves.
Financial and customer impact.
1. Incorrect route determination increases shipping costs. 2. Delivery delays occur due to incorrect transportation planning. 3. Distribution centers spend time manually correcting route assignments. 4. Customer delivery commitments become unreliable. Logistics accuracy directly influences delivery reliability and transportation cost control.
Governance and accountability, RACI model.
In ECC to S4 HANA programs, ownership follows a RACI model where authority and execution are clearly separated across functional and technical work streams. 1. Accountable logistics solution architect. The person who owns delivery routing architecture and gets fired if logistics planning fails after migration. 2. Responsible SD shipping lead. Configures route determination logic and shipping conditions. 3. Consulted. Transportation integration architect. Validates transportation management integration. 4. Informed. Global distribution operations director. Oversees enterprise logistics performance. Route governance must align logistics configuration with transportation planning strategy.
Ownership, who actually fixes it.
Resolving this issue requires validating route determination across logistics scenarios. 1. Logistics solution architect reviews enterprise route determination architecture. 2. SD shipping lead revalidates shipping conditions, transportation zones, and route configuration. 3. Transportation integration architect evaluates integration with transportation management. 4. Global distribution operations director approves the final logistics routing framework.
Who gets blamed versus who owns it.
1. Blamed warehouse shipping teams. Manual corrections appear as operational mistakes. 2. Blamed SD shipping configuration team. Delivery configuration is assumed incorrect. 3. Actual owner, logistics solution architect and SD shipping lead, responsible for route determination design. 4. Root cause, route determination logic was not revalidated during explore. Routing failures usually originate from missing logistics design validation.
How this is actually fixed, the right way by a role.
1. Logistics solution architect reviews transportation architecture across regions. 2. SD shipping lead validates route determination rules for shipping conditions and zones. 3. Transportation integration architect ensures compatibility with transportation management. 4. Global Distribution Operations Director signs off on the final routing governance framework.
What not to do, common wrong fixes.
1. Assuming ECC route determination will work unchanged in S/4HANA. 2. Testing only simple shipping scenarios. 3. Ignoring transportation integration during design. 4. Leaving route corrections to operational teams. Route determination must be validated before operational logistics testing begins.
Follow-up 1. Why is route determination sensitive during migration?
Answer: route determination relies on multiple logistics factors including transportation zones, shipping conditions, and delivery priorities. Even small configuration differences can produce completely different routing outcomes. Without testing these combinations, delivery planning becomes inconsistent.
Follow-up 2. How do experienced logistics architects validate routing behavior?
Answer: architects simulate deliveries across multiple plants, shipping points, and customer locations. They compare ECC and S/4HANA routing results to verify consistent transportation planning. This ensures routes remain accurate across the logistics network.
Follow-up 3. Curveball. What happens if route determination fails after go live?
Answer: shipping teams begin manually adjusting routes during delivery processing, which increases operational complexity. Over time, inconsistent routing decisions lead to higher transportation costs and unreliable delivery commitments.
Exclusive pro tip.
Before design freeze, simulate route determination across at least 10 shipping scenarios including cross-region deliveries and high-priority shipments. This exposes configuration gaps and prevents delivery routing failures after go live.
Scenario 81. Export control and embargo logic redesign incomplete.
In the explore phase of ECC to S/4HANA migration, organizations failed to redesign export control and embargo compliance logic. ECC systems often used legacy foreign trade configurations to validate restricted countries, sanctioned parties, and export license requirements. In S/4HANA, foreign trade functionality has been replaced by the International Trade Framework with redesigned classification and compliance checks. If this architecture is not redesigned during blueprint, sales orders may bypass compliance checks or incorrectly block legitimate shipments.
Scenario classification and relevant SAP note, if applicable.
1. Complexity high, regulatory compliance and export risk. 2. Phase explore. 3. Frequency common in global trade and export-driven industries. 4. Primary ownership global trade compliance architect. 5. Supporting SD logistics compliance lead. 6. Business ownership chief compliance officer. 7. Relevant SAP note. SAP note 2267310. Foreign trade deprecation and international trade framework.
Diagnostic dashboard, symptoms and evidence.
How export compliance redesign gaps appear during order and delivery processing. 1. Symptom: sales orders bypass embargo checks for restricted destinations. 2. Red flag: shipments are blocked unexpectedly due to missing compliance classification. 3. Business impact: export compliance violations expose the organization to regulatory penalties. 4. Detection: execute international order scenarios including restricted country shipments. 5. Technical proof: export compliance checks are not triggered during order processing. Insight: if export compliance checks behave inconsistently after migration, the International Trade Framework was not redesigned.
Why this happens, scenario analysis and root cause.
1. Organizations assume ECC foreign trade configuration will behave identically in S/4HANA. 2. Compliance teams are not included in blueprint workshops. 3. Export control testing scenarios are not included in integration testing cycles. 4. Project teams underestimate the impact of the International Trade Framework. Compliance processes require redesign when foreign trade architecture changes.
Why this is a migration, exclusive failure.
1. ECC relied on the legacy foreign trade module for compliance checks. 2. S/4HANA replaces foreign trade functionality with the International Trade Framework. 3. Compliance classification and embargo logic must be reconfigured. 4. Legacy export control assumptions may no longer function. International trade compliance must be redesigned when migrating to S/4HANA.
Financial and customer impact.
1. Export compliance violations can result in regulatory fines. 2. Legitimate shipments may be blocked due to incorrect compliance logic. 3. Customer deliveries are delayed due to compliance verification errors. 4. Legal exposure increases when embargo checks are bypassed. Compliance failures create both financial penalties and operational disruption.
Governance and accountability, RACI model.
In ECC to S/4HANA programs, ownership follows a RACI model where authority and execution are clearly separated across functional and technical work streams. 1. Accountable Global Trade Compliance Architect. The person who owns export compliance architecture and gets fired if regulatory violations occur after migration. 2. Responsible SD Logistics Compliance Lead. Configures compliance checks within sales and delivery processing. 3. Consulted Solution Architect. Ensures integration between SD and International Trade Compliance Framework. 4. Informed Chief Compliance Officer. Oversees enterprise regulatory governance. Export compliance governance must align regulatory requirements with system architecture.
Ownership, who actually fixes it.
Resolving this issue requires redesigning export compliance architecture. 1. Global Trade Compliance Architect redesigns international trade compliance processes. 2. SD Logistics Compliance Lead reconfigures embargo and export control checks. 3. Solution Architect validates integration with the S/4HANA International Trade Framework. 4. Chief Compliance Officer approves the final compliance governance framework.
Who gets blamed versus who owns it.
1. Blamed logistics teams. Shipment delays appear as operational failures. 2. Blamed compliance teams. Incorrect checks appear as regulatory configuration errors. 3. Actual owner Global Trade Compliance Architect and SD Logistics Compliance Lead. Responsible for export compliance design. 4. Root cause export control processes were not redesigned during Explore. Compliance failures usually originate from missing architecture design rather than operational errors.
How this is actually fixed, the right way by a role.
1. Global Trade Compliance Architect redesigns export compliance architecture. 2. SD Logistics Compliance Lead configures embargo and restricted party checks. 3. Solution Architect validates integration with international trade compliance logic. 4. Chief Compliance Officer signs off on the Enterprise Compliance Governance Framework.
What not to do, common wrong fixes.
1. Assuming ECC foreign trade configuration will work unchanged. 2. Ignoring compliance scenarios during testing cycles. 3. Allowing shipments to bypass export control checks temporarily. 4. Treating compliance redesign as a minor logistics configuration task. Export compliance must be validated before international shipments begin.
Follow-up 1. Why does export compliance change during S/4HANA migration?
Answer: S/4HANA replaces the legacy foreign trade module with the International Trade Framework. This change affects how embargo checks, export classifications, and compliance validations are executed. Without redesigning these controls, regulatory verification may behave differently.
Follow-up 2. How do experienced architects validate export compliance logic?
Answer: architects simulate international order scenarios including restricted countries and regulated products. They verify that compliance checks trigger correctly during order creation, delivery processing, and shipment release. This ensures regulatory safeguards remain intact.
Follow-up 3. Curveball. What happens if export compliance fails after go live?
Answer: shipments may bypass embargo checks or legitimate shipments may be blocked unexpectedly. Both situations create major operational disruption and potential regulatory exposure. Correcting compliance architecture after go live can become extremely complex.
Exclusive pro tip.
Before design freeze, simulate export scenarios including restricted countries, sanctioned parties, and regulated product classifications. This ensures compliance architecture functions correctly and prevents regulatory exposure after migration.
Scenario 82. Intrastat default value redesign gaps.
In the Explore phase of ECC to S/4HANA migration, Organizations fail to redesign intrastat default value determination for European Union trade reporting. ECC relied on legacy foreign trade fields and configuration to populate statistical values, commodity codes, and reporting attributes. S/4HANA replaces foreign trade with the International Trade Framework, introducing redesigned classification logic and reporting structures. If these changes are not redesigned during Blueprint, intrastat reports generate incomplete or incorrect trade data.
Scenario classification and relevant SAP note, if applicable.
1. Complexity medium, regulatory reporting and compliance risk. 2. Phase explore. 3. Frequency common in organizations operating within the European Union. 4. Primary ownership global trade compliance architect. 5. Supporting SD international trade lead. 6. Business ownership head of regulatory reporting. 7. Relevant SAP note. SAP note 2267310. Intrastat simplification and international trade framework.
Diagnostic dashboard, symptoms and evidence.
How intrastat redesign gaps appear during trade reporting. 1. Symptom intrastat reports contain missing or incorrect statistical values. 2. Red flag commodity codes and partner country data do not populate automatically. 3. Business impact regulatory reporting becomes inaccurate or incomplete. 4. Detection execute cross-border order scenarios and validate intrastat report outputs. 5. Technical proof. Trade classification fields remain empty in delivery or billing documents. Insight. If intrastat reports generate incomplete data after migration, international trade configuration was not redesigned.
Why this happens, scenario analysis and root cause.
1. Organizations assume ECC intrastat configuration will continue to work in S/4HANA. 2. Trade compliance teams are not included in Blueprint workshops. 3. Testing scenarios do not include cross-border shipment reporting. 4. Project teams underestimate the impact of the International Trade Framework. Intrastat reporting requires redesign when trade classification architecture changes.
Why this is a migration, exclusive failure.
1. ECC relied on the legacy foreign trade module for statistical reporting. 2. S/4HANA replaces foreign trade functionality with the International Trade Framework. 3. Commodity classification and reporting logic must be reconfigured. 4. Legacy reporting assumptions may no longer function. Intrastat reporting must be redesigned when migrating to the new trade architecture.
Financial and customer impact.
1. Incorrect intrastat reporting exposes the organization to regulatory penalties. 2. Trade compliance teams must manually correct reporting errors. 3. Cross-border shipment reporting becomes unreliable. 4. Audit findings increase due to inaccurate trade declarations. Regulatory reporting accuracy is critical for organizations trading within the European Union.
Governance and accountability, RACI model.
In ECC to S/4HANA programs, ownership follows a RACI model where authority and execution are clearly separated across functional and technical work streams. 1. Accountable global trade compliance architect. The person who owns intrastat reporting architecture and gets fired if regulatory reporting fails after migration. 2. Responsible SD International Trade Lead configures intrastat determination rules and trade classification logic. 3. Consulted Solution Architect ensures integration between SD documents and international trade reporting structures. 4. Informed Head of Regulatory Reporting oversees enterprise regulatory compliance reporting. Trade reporting governance must align regulatory requirements with system architecture.
Ownership, who actually fixes it.
Resolving this issue requires redesigning intrastat determination logic within the International Trade Framework. 1. Global Trade Compliance Architect redesigns the enterprise intrastat reporting architecture. 2. SD International Trade Lead configures trade classification and statistical determination logic. 3. Solution Architect validates document integration with international trade reporting structures. 4. Head of Regulatory Reporting approves the final regulatory reporting governance framework.
Who gets blamed versus who owns it.
1. Blamed regulatory reporting teams. Reporting inaccuracies appear as operational mistakes. 2. Blamed SD configuration teams. Trade classification logic is assumed incorrect. 3. Actual owner, Global Trade Compliance Architect and SD International Trade Lead, responsible for intrastat design. 4. Root cause, intrastat reporting logic was not redesigned during Explore. Reporting failures usually originate from missing trade architecture design rather than operational errors.
How this is actually fixed, the right way by a role.
1. Global Trade Compliance Architect redesigns intrastat reporting architecture. 2. SD International Trade Lead configures commodity classification and statistical reporting rules. 3. Solution Architect validates integration with international trade document structures. 4. Head of Regulatory Reporting signs off on the final reporting governance framework.
What not to do, common wrong fixes.
1. Assuming ECC intrastat configuration will work unchanged. 2. Ignoring cross-border shipment scenarios during testing. 3. Manually correcting intrastat reports after go live. 4. Treating regulatory reporting as a minor configuration task. Intrastat reporting must be validated before international trade operations begin.
Follow-up 1. Why does intrastat reporting change in S4 HANA?
Answer: S4 HANA replaces the legacy foreign trade module with the international trade framework. This changes how commodity classifications and statistical reporting fields are determined. Without redesigning this architecture, regulatory reporting behaves differently.
Follow-up 2. How do experienced architects validate intrastat reporting?
Answer: architects simulate cross-border shipments between European Union member states and validate that commodity codes, partner country information, and statistical values populate correctly. This ensures regulatory reports remain accurate.
Follow-up 3. Curveball. What happens if intrastat reporting fails after go live?
Answer: regulatory reporting teams must manually reconstruct trade data from shipment records. This increases audit risk and regulatory exposure. Correcting the design later requires redesigning trade classification and reporting integration.
Exclusive pro tip.
Before design freeze, simulate cross-border shipments between multiple European Union countries and validate intrastat report outputs. This ensures commodity classification and statistical reporting fields populate correctly.
Phase 2 Category 3 Wrap-up. Process design risks. Behavioral delta.
The final category of Phase 2 reveals one of the most dangerous misconceptions in S4 HANA migration programs. Many organizations assume that if configuration and master data are migrated correctly, business processes will behave exactly the same as in ECC. In reality, S4 HANA introduces subtle behavioral changes across pricing, logistics routing, billing governance, and international trade compliance. If these behavioral deltas are not analyzed during the Explore phase, the system may appear technically correct, but operational processes will behave differently from business expectations.
Phase 2 Wrap-up. The Explore phase and the hidden design risks.
Phase 2 of the migration journey is where the majority of architectural and process design mistakes are introduced. During Explore, organizations must redesign data models, master data structures, and core business processes for the S4 HANA architecture. This includes pricing simplifications, business partner conversion, international trade compliance, and logistics process changes. If the Explore phase is rushed or treated as a simple blueprint exercise, the downstream phases will inherit structural design flaws that are extremely difficult to correct later.
Part 1 Wrap-up. Blueprint and design failures.
In Part 1 of this series, we analyze the most critical blueprint failures that occur before a single line of code is written. We examine scope definition risks, architecture decisions, data model simplifications, master data redesign challenges, and process behavioral changes. Together, these incidents represent the foundation of an S4 HANA migration program. If these decisions are incorrect during the Discover and Explore phases, every subsequent project phase inherits instability.
What comes next in this series?
In Part 2 of this series, we will move into the technical execution phase of the migration. We will analyze custom code remediation failures, data migration risks, conversion window incidents, and testing gaps that prevent systems from stabilizing during implementation. In Part 3, we will focus on Day 1 operational failures, including order-to-cash behavior changes, logistics disruptions, and cross-module integration breakdowns that impact the supply chain. Finally, Part 4 will examine financial risks, performance issues, analytics redesign challenges, and the unpredictable post-go-live incidents that appear only under real production workloads.
Continue the series.
If you want to continue this deep dive into S4 HANA migration failures, check the video description below. You will find direct links to Part 2, Part 3, and Part 4 of this series. Each part explores a different stage of the migration journey, from technical execution and data conversion risks to operational failures, financial impacts, and post-go-live incidents. This series is designed as a complete reference guide for understanding where S4 HANA programs succeed and where they fail.
Please check description or comment section of this video. I have given a lot of links for downloading 7 or 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked system design, most asked implementation project-related interview questions and answers, most asked support project-related interview questions and answers, required for your SAP functional modules interviews jobs like SAP MM consultant jobs, SAP FICO consultant jobs, SAP SD consultant jobs, SAP PP consultant jobs, SAP Ariba consultant jobs, SAP Extended Warehouse Management EWM consultant jobs, SAP Plant Maintenance PM consultant jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem-solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section, these questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people also for your interviews. You people can download all 7 or 8 PDFs in a single zip file from below given links.
For more exciting tips, tricks, and more importantly, for valuable insights of interviews, please share, like, and subscribe to my channel. It has a lot of valuable information about various insights of interviews. It has a wide range of real-world portfolio projects of various technologies for interviews, and it has wide range of most asked interview questions and answers of various technologies like data science, SAP, AWS, DevOps, and full-stack web development, and more. That will be useful during interviews. It has a wide range of most asked interview questions and answers and real-world portfolio projects of various technologies for freshers, for 2 to 3 years, experienced candidates, and for 5 or above years, experienced candidates to test their skills by knowing most asked interview questions and make themselves ready for interviews.